Thanks for joining us, Randall.
Well, thanks for having me, guys.
No problem. I think we should start off like big, high-level stuff. Like, what got you interested in Atlantis, and what sort of is your definition of Atlantis?
Oh, what is my definition of Atlantis? What got me started in it? Which one should I take first? We'll go. The definition of Atlantis was just essentially taken directly from Plato's dialogues, which is the prologue to Timaeus and Critias, where he talks about Atlantis. It's where the Atlantic Ocean get its name, right? If you pronounce the last letter of the word Atlantic, the C, instead of a hard C, a soft C, it's literally phonetically Atlantis. And you go to Encyclopedia Britannica, and it'll say, yes, put up the Atlantic Ocean. I don't know if they still do this, but in the older ones, they weren't afraid to say it, that, Atlantic Ocean gets its name from, Atlantis. So Atlantis, the question really comes down to, was it exclusively a contrivance of Plato, or was there some historical authenticity to the idea? And there's basically two schools of thought on that. One is that, and has been the predominant point of view in most academic circles for many decades, and that is that it was a metaphor. Plato invented this metaphor to give some form to his concept of the idealized civic structure, the idealized society, the way he envisioned it. So that was pretty much the dominant academic view, but then there were those who deviated from it and said, no, behind that legend, there is some authentic reality, some history that actually happened. And that's been the two schools of essentially. The school that, the historiographic school, was the one that basically came up with various locations based upon a reading of Plato.
Right.
And there have been many places, and probably the most well-accepted explanation amongst the academic circles is that it was the eruption of Terra, the volcano Terra on the island of Santorini.
Yeah.
Yes, which would have been about 3,500 years ago, and that this would have been roughly 900 years before Plato's time. And, in Plato's dialogues, he mentions the chronology of Atlantis and the 10 kings and the demise of Atlantis after this great war between the imperialistic Atlanteans and the proto-Hellenic defenders of the Mediterranean area. And after this tremendous battle, tremendous war, which is placed at 9,000 years prior to Solon's exile in Egypt, which, given that that's roughly 600 BC, give or take a few decades, puts us right at about 11,600 years ago, or 9,600 BC. And which is interesting these days, because if you follow the whole question of the Younger Dryas, the transition from glacial to interglacial age, from Pleistocene to Holocene, you know that the termination of the Younger Dryas, the catastrophic termination of the Younger Dryas, climatic anomaly or excursion, whatever you want to call it, catastrophe, the end of that, the termination, is dated at about 11,600 years ago. And it's also associated with a huge meltwater pulse, glacial pulse of meltwater into the North Atlantic that is called meltwater pulse 1b, which I find to be a correlation. It may be more than just fortuitous. The fact that those two dates match up so perfectly.
Yeah. And that was about 400-foot sea level rise when that took place?
Well, no, not that. The 400-foot sea level rise was the totality. And it took about 5,000 years for the whole 400 feet from its sea stand low, which was about 400 feet lower than it is right now. However, within that rising of sea, there was at least two pulses of drastically accelerated sea level rise. Short-lived, but very rapid, 10 times to 100 times more rapid than the average. If we go from full glacial maximum, Glaciers are their biggest. Sea level is then at its lowest. In round numbers, 400 feet lower than now, right? Okay, so in order to get sea levels up to modern, you have to melt off about 6 million cubic miles of glacial ice. Now, that glacial ice did not all melt at one time. Okay, it took 5,000 years roughly for that ice to melt away for the most part. But within that 5,000 years, it was not a continuum. It was not the average didn't prevail throughout that entire 5,000 years. In fact, during the Younger Dryas, it slowed down, if not even reversed a little bit, because when the Younger Dryas cold event came on at 12,900 years ago, glaciers started to grow again. Well, you know what that means. If the glaciers start growing, what's that going to do to sea level?
Yeah.
It's going to start dropping again. So the sea level had already been rising, and in fact, the current dating of meltwater pulse 1A is at about 14,600. So there's about a 3,000-year span between meltwater pulse 1A and meltwater pulse 1B, 14.6 to 11.6. Right in the middle of that, between 12.8 and 12,900 years ago, is the Younger Dryas boundary. And what happened there was you had from full glacial maximum, 15 to 18,000 years ago, when the glaciers were at their most humongous extent, there was a massive pulse of meltwater at about 14,600 that seemed to kick off the melting. The next, from 14.6 until about 12.9, about 1,400 years right in there, the climate began to gradually warm. That gradual warmth can be explained pretty much by the changing geometry between the Earth and the Sun. What are the so-called Milankovitch forces? Because the Earth's tilt changes, the obliquity of the ecliptic changes, the precessional axis changes, and those three combined produces periods where it's somewhat more warmer because the Earth, say, is getting more thermal energy from the Sun. For example, if the northern hemisphere is tilted towards the Sun, as it does every 13,000 years, the Earth is tilting because it's going around like this. And that whole cycle takes 25,900 years roughly. So 13,000 years ago, pole star Vega, now pole star Polaris. So you got to picture this is happening. So the northern hemisphere is alternating between pointing towards the Sun, pointing away from the Sun. Right now, the northern hemisphere is pointing towards the Sun, and that gives us one season. It points away from the Sun in the opposite direction 13,000 years from now. So all of that is getting to this, that there are well-established gradual mechanisms of warming. And we can see those operating at the end of the last ice age. However, at 14.6 and at 11.6, that was interrupted because sea level rapidly rose for a short period of time.
Do you have a time period there to bring context to the current climate situation? Like, is there a way to narrow it down that 50 feet in 100 years or 100 feet in 500 years, or is there? At
rates sometimes exceeding 10 times faster than the modern rate.
Okay.
That's conservative.
Yeah, right. 10 to 100 is basically what you meant there. Yeah. Then the average. Yeah.
Right. So we might be talking about, since the late 1800s, sea level has risen about a foot.
Right.
Right. Okay. So imagine in that same period of time that it might raise 10 to 15 feet.
Yeah.
That's the kind of rates we're looking at.
Okay. That makes sense.
Right. Because for one thing, you might have, in the case of because again, remember, that sea level raise is because of glaciers melting. So there has to be a direct connection between the rate of glacier melting and the rise of sea level. So let's get back to Atlantis.
Yeah,
this kind of gives
that's a good time.
So you're putting Atlantis because sometimes I've thought Atlantis as being like this whole global civilization before the Younger Dryas.
If you take Plato at face value, that's what you have to assume. Yes. In fact, having gone through multiple times through about 4 or 5, maybe 5 different translations of Plato, as well as struggling through the original Greek with a Greek lexicon next to me so I could look up the words, because I couldn't find an interlinear. I wished I could have. It would have been nice to find an interlinear version of the dialogues, where you got the Greek and then you got the English. So I had to go through keywords and phrases to try to understand. Like, I didn't take the whole, every single sentence. But what I did was I went through and pulled out the key sentence where specific information is given. Is Atlantis a continent or is it an island? Well, a lot of the critics say, well, we know the geological evidence disproves the idea of there being any continent in the middle of the Atlantic Ocean. But, when you go into the Greek, it was not continent, it was island, the word for island. So, and that's pretty important when you start talking about all the various places that Atlantis could have been. But so if you want to look at it this way, we're only going to be able to scratch the surface here in our conversation tonight. I mean, if you want to get more into this, we can do it again. Or, I would encourage people to jump over to cosmographia.com because I think the first 5 episodes we did was diving deep into the Atlantis, going through Plato line by line and looking at the geology and the geography and the astronomy and all of that.
Well, maybe what we should do is in 6 weeks, in 5 or 6 weeks, we should do a wrap-up episode.
Sure.
Because I wouldn't mind going because you're one of the people we know pretty good. We've got a pretty good relationship with you. We've hung out with you. Yep. We have an immense amount of respect for your vast knowledge base. And it might be fun to wrap this specific series up with going over what we learned. We're going to do some Tartaria episodes.
Some Hyperborea. I want to get into that. Some DNA stuff, some giants and bloodlines. These are some of the different topics we're going to explore in this series.
So it might be fun to start it out with you and to wrap it up with you here in 5 weeks out and see what you think about some of that stuff. Depending on how far we get tonight, I suppose.
So mid-March, okay.
So did the timing of the 9,000 years and your knowledge of the Younger Dryas lead you down towards more of a historical aspect of Atlantis instead of the other school of thought?
No, in fact, it was the other way around. I heard of Atlantis. I knew of Atlantis even as a kid. I remember in 1959 maybe or 58 going to see this really cheesy movie on Atlantis that when I was 7, at 7, I thought it was cheesy. That's how cheesy it was. If a 7-year-old thinks it's cheesy, it's cheesy. But then there was The Time Machine, which actually came out in 1959, probably, based on Jules Verne's novel, The Time Machine. Not The Time Machine, back up. Journey to the Center of the Earth.
Right.
Right, okay, so they go down. It was James Mason and Pat Boone. I remember, and I think I was 8 years old then, and it was pretty exciting. I was excited about that whole movie. Going to the Saturday picture shows back in the 1950s was a really big deal. And in that movie, they had they go to the center of the Earth and they discovered that Atlantis is there. I don't know if you remember that movie. Have you ever seen it?
I think I have a long time ago. I don't remember.
Long time ago. Yeah, well, you might remember that towards the end they discovered that Atlantis is sunk and now it's in the middle of the Earth or something. So that is kind of I think maybe, right in there, one of those 2 movies is where I can probably first remember learning or hearing the word Atlantis, as a kid, because it was, pervaded the popular culture. Heard about it, but wasn't that interested in it because I, we just figured it was a story or something. And, maybe I was prejudiced because that first movie I saw was so damn cheesy. I thought, anyways, so I guess by the time I got to be an adult, I'd been through the whole late 60s thing, and they were, every conceivable weird and fringe idea was being imported into the discussions, right? So Atlantis was quite prominent, and, there was people talking about Atlantis this and Atlantis that. And it was about that time, I think, that, maybe it was more like the 70s when the whole Terra eruption of Terra was first proposed. But
and where's Terra?
That's Santorini in Greece.
In Greece?
The number 3 sunsets in the world.
So that can't be far from Pompeii then.
No, that's in the Greek, the
Greek islands, really. Yeah.
That motherfucker's got a habit for ruining civilizations.
Yeah.
I can pull up a map here in a minute of the region, but I think what really got me first interested in it was because even as a kid, I was very interested in mythology. So mostly what was accessible to me to read as a kid was things like Greek mythology and Norse mythology mostly. Now in Norse mythology, there was the stories about the wars of the gods and Ragnarok and all of that, Thor and the Midgard serpent and the Fenris wolf and all of those images. And then Greek mythology again is full of imagery of catastrophism and so on. But then probably I must have been early 20s. So I became aware of Ignatius Donnelly. Ignatius Donnelly was a congressman from Minnesota, which was my home state. And so he wrote 2 books on Atlantis back in the 1880s. And he's usually the one who's blamed for the revival of sort of the modern interest in Atlantis. And I remember one of them was called Ragnarok, the Age of Fire and Gravel. And so I think I probably still have the original paperback version that I had gotten of that early 70s, 72, 73, 74, somewhere right in there. And it was Ragnarok, the Age of Fire and Gravel. And then the other one was Atlantis, I think, the Antediluvian World. I think there was two of more. The Ragnarok dealt with the catastrophe that was associated with Atlantis. And so from that respect, Ignatius Donnelly was certainly ahead of his time because he was clearly interpreting that the transition from the glacial age to the interglacial was a catastrophic affair. And interestingly, you know what he invoked as a trigger for the catastrophic changes that occurred? What do you think?
Cometary impact?
Yeah.
Wow.
1883.
Wow.
Came out proposing that, yeah.
What did he, I wonder why he did that.
Well, yeah, I mean, he goes into it in his book. I mean, and it, he, I mean, the evidence was there even then.
Wow. Yeah.
Problem is catastrophism in any shape or form pretty much got pushed onto the back burner because of the dominance of gradualism and uniformity.
Yeah.
You can't invoke forces or processes or scales of change or rates of change that are really much different than what we're experiencing today. Because if you do, you're pseudoscientific, you're trying to bring back biblical literalism, if you start talking about big floods and all of that kind of stuff. But, it all goes together.
Yep.
All over the world, we have ancient myths about catastrophes of always involving flood or fire, and sometimes combinations of the two. So can't get away from it. So we either ignore it or we come up with some kind of convoluted explanation to explain it away. That it has something to do inherent in human psychology, that people diversely spread across the globe with no contact with each other will come up with almost exactly the same scenarios. So you have the biblical account of Noah and the ark coming to rest on the mountains of Ararat, and then you come to the North American continent, and you have dozens and dozens of Native American legends about a great world-destroying flood. They talk about the Great Canoe, et cetera, et cetera. How does that happen? Well, usually the way around that is to say, well, obviously there were some missionaries that came in, before this, this fur trader or whoever it was, or ethnographer, whoever it might have been. That was, George Catlin, the Indian artist, who spent time with over 100 different Indian tribes for over a period of decades and decades, reported in his book, Last Rambles, very interesting book, because what he did was he started collecting stories from the Indians. And at the conclusion of his book, he says, well, for all their different customs that they have and languages and traditions, they all seem to have one thing in common. They're all descended from, their ancestors who were survivors of a great world-destroying flood. Over and over and over again, hearing that. Now, of course, a lot of those tribes that he was the first, Caucasian, first European descended person they saw. So clearly, it's not a case of some missionary coming in there telling them the story of Noah, and then they decide that they're going to graft that into their, into their whole theological tradition. So, no, they had those traditions from somewhere. And then, of course, what we now know and what I've been demonstrating over and over again, overwhelmingly in the recent episodes of Cosmographia, is that the entire North American continent was, in fact, subject to a tremendous diluvial event or series of events that were associated with the ending of the Ice Age. And this pretty much drenched the North American continent in huge amounts of water. Now, that water is going into both the Pacific Ocean and the Atlantic Ocean and the Arctic Ocean. The northern rim of the Great Ice Complex melted and created what is now the Mackenzie River Valley that carried catastrophic floods into the Arctic Ocean. You had catastrophic discharges into the North Atlantic via the Hudson River, the Connecticut River, via the St. Lawrence Seaway, through the Fox Channel. You had multiple channels by which huge amounts of meltwater were discharging into the North Atlantic. Now, what is interesting is if we get back to the idea that, let's go back to what Plato actually said about Atlantis. And if you take at face value, what he's saying, he's, 9,000 years before Solon's journey to Egypt, where he heard from the elderly priests the story of Atlantis and the Great War. Okay, so according to the priests, and this date is given 3 times in the dialogues, 3 times, 9,000 years prior to Solon's exile in Egypt, which again, we established the date, gives you 11,600, which correlates with the end of the Younger Dryas, which is now the date officially given for the end of the Pleistocene epoch, which lasted 2.5 million years, and the beginning of the Holocene, which is the climatic period we're in right now, which is now have been in it for 11,600 years. Well, if Plato's taken at face value, what he's describing is a island civilization west of the Pillars of Heracles in the Atlantic Ocean. Now, almost all the details we get about Atlantis come from Plato. Now, we get the commentaries on Crantor by Proclus, which has a few comments about Atlantis, several others, very obscure, but would lead one to believe that perhaps the sailing distance was 3 to 5 days to the west. And if you sail west from the Pillars of Heracles, you run into first Madeira and then the Azores. And when sea level would have been 400 feet lower at 15,000 years ago, right? There's going to be more islands and they're going to be much larger just because of that changing in sea level, right? Now, there's another factor that I get into extensively in the discussions on Cosmographia, which is the isostatic adjustment to the crust itself by that redistribution of surface mass that happened because of the tremendous amount of weight removed off the continents and
right.
and sent into the oceans. So, you have continental drift, which is basically describing this motion of the crust. Isostasy describes this. See, we have a perfect mechanism, theoretically, for talking about how you could have not only the rise in sea level, but a major subsidence of the ocean bottom, particularly along the zones of least resistance. And if you look at the bathymetric charts of the Atlantic Ocean,
Yeah.
What do you see? You see that hinge point, which is the mid-Atlantic ridge.
Wow. Do you have a map of where that is compared to the Pillars of Hercules and all that? Do you have a map?
Well, I actually do, Graham. So I could if you'd like, I could actually pull that up.
Yeah, let's look at the map. I love maps, so especially around that area, the Mediterranean, and all the history that goes back.
Oh, me too.
Darren and I were arguing over whether that flood how much it affected the Mediterranean.
We weren't arguing over that. We were arguing over where the coast used to be, and I said it was at the continental shelf.
In some places, yes. Typically, the continental shelf will vary from 400 foot up to 1,000 foot deep. So, in some places, yeah, the continental, the water level was at pretty much exposed most of the continental shelf. Yes, it did. Okay, let me see. All right. Oh, there we are. Okay, we'll do a share screen. Host disabled participants.
Okay, we'll fix that right away.
God, Darren. So this is the way it's going to be, huh?
Yeah, we got to make you host.
Did we figure out what was going
I
on?
think you got to make him host, and then that'll fix it.
Yeah, you got to make me host.
That's what we did last time, wasn't it?
Yeah.
We just gave up and
Under
made him
participants, probably we gave up. We tried different things, but
allow to record, but that's not what we need.
there you go. Okay, let's try that. Yeah. All right, there you go. You should have access now.
You got the keys, Randall?
The keys to the kingdom?
Keys to the kingdom. It's not much of a kingdom, but
Keys to Grimerica.
that's what we got.
All right. Here we go.
There we go.
You like this map?
Yep.
I do. I love this map. Okay, so what we have right here is the Straits of Gibraltar, the Strait of Gibraltar, flanked by the pillars.
Okay, that's what I thought. Yeah.
That's the Pillars of Heracles, which mark the gateway between the Atlantic over here to the west, the Mediterranean over here to the east. And there were actually islands in here that are now sunk.
Wow.
Yes. So anybody sailing west through here would have come to islands. Now let's go to this next. Let's see. Well, yeah. So right here, here's from Plato himself. And there was an island situated in front of the straits, which are by you called the Pillars of Heracles. The island was larger than Libya and Asia put together and was the way to other islands. And from these you might pass to the whole of the opposite continent,
Wow.
which surrounds the true ocean. For this sea, which is within the Straits of Heracles, is only a harbor, having a narrow entrance, but that other is the real sea, and the surrounding land may be most truly called a boundless continent.
Wow.
Yeah, right there. Let's look at this next slide here. Let me back up right here. When we look at this one, Strait of Gibraltar, Madeira is right in here. There's Madeira. And here's the Azores. So there was a collection of islands right in here.
That's
are like halfway,
That's a great map to show just the elevations under there too.
Oh yeah, right. And I've actually I think I've got some better ones even on this program. So let me look what I've got here. Let's see. Yeah, here's a good one.
So Doggerland's much later.
Well, Doggerland is up by
The UK.
It's up by
It's
the
between.
UK and stuff,
Yeah.
right?
yeah. But take a look at this one.
Oh, yeah. So is that the Azores up in the top there that's actually poking out a little bit?
Yes, the Azores
Wow.
is this cluster of islands that are actually part of a whole microcontinent.
So you could picture basically all that sort of light blue being above the water.
This light where Kurt, can you see
Yeah.
my
Yeah,
cursor?
yeah.
That's the Azores Plateau. And
Wow.
here's the Pillars of Heracles, and all in here are a group of sunken islands. So
And then they jumped from those to the middle ones, and then they're saying you can get over to the other continent from there.
yes, there it is. I mean, right there. That's what I'm talking about. The geography checks out. Now, you know,
I mean, that could have been how they all got around before the Ice Age.
well, you know, here's the thing. If during the Ice Age, if you were going to look for ideal real estate for the emergence of a rather advanced culture, and I'll say rather advanced because, you know, immediately you say Atlantis, people start thinking, oh, you're talking about, you know, crystal flying machines and, ray guns and all of this kind of stuff, which, of course, Plato never talks about. What Plato talks about, he creates a scenario, he creates an image of an advanced maritime culture, maybe like you would picture the Minoans or the Phoenicians, but even on a grander scale. So basically what we're talking about here is could a maritime culture have existed during the Ice Age? That's the question.
Right.
Is it completely out of the question that could have been a possibility? Well, depending on how much time we have to go through some of this, if you were going to look at prime habitable real estate during the Ice Age, the Azores right here would have been a great place to live, actually. And let's see here. I might be able to actually even.
So you could go sort of up and down, dotted sort of island chains there when the sea level was lower. It kind of almost looks like you've got a whole
ridge there.
Ridge you can sort of go up and down without ever having to come into contact with the mainland.
Oh, yeah, without coming into contact with the mainland. Now, you're looking at this map. Again, over here is the Pillars of Heracles. What did Plato describe? He goes that there's a group of islands. You come to islands. Beyond those were the other islands. And here's the Azores right in here. And this is the Azores Plateau. Now, guess what? Empirical evidence suggests very strongly that the Azores Plateau recently sunk as much as a mile or two. And I can show you some of that.
From what you were talking about before, about the
isostatic depression?
Yes.
Wow.
That's exactly it. And I go into a detailed analysis of this whole question in the Cosmographia series.
So at a mile or two, you're basically talking about everything you can see there being exposed.
For the most part, like right here in this, we're looking north along the mid-Atlantic ridge. Here's the Azores Plateau.
Oh.
You could picture that all of the orange would have been above water.
Wow. So how deep is that now then? That's because you think it's sunk. It's like 1,000 feet, 1,500 feet in that area? Or
yeah, the peaks of these mountains are sticking above the waves, and that's the islands of the Azores, are the peaks of these sunken mountains.
Yeah.
And they are sunken mountains, yes. That's not some pseudoscience. That's well established by marine geology and studies.
But what about the whole ridge of the green down that whole sea there? Would that all have been exposed, or
all of this? Probably not. Probably not. Somewhere this would have been like here. Probably was Florida a peninsula.
Yeah, right.
Reaching
so
out.
So if we're looking where your cursor is now, say from left to right across up. Sorry. Like the actual part that would have been exposed, the orange part, what's the scale of that across there, roughly? From east to west?
400 to 500 miles, maybe.
Oh, wow, that far, eh? Wow, so that'd be like 800 kilometers.
Yeah, maybe not that
600
much.
kilometers, 700 kilometers.
That Atlantis was bigger than Libya and Asia combined.
Oh, right.
Where I think that's a little misleading is because it's just like if you look up what is the area of Polynesia. Well, if Polynesia is dozens of islands. So are you talking about just the
as the crow flies, or
or the whole area that's occupied by the islands?
Yeah.
And I think that's the way one should probably interpret Plato here. Because Madeira was probably part of an Atlantis kingdom.
Is there any evidence of any civilizations in the sunken area there, or the Azores? Or like, what are the Azores like now? Can you go hang out there? Is it like?
Yeah, there's some islands there you can tourist islands. Yeah.
Yeah. Here's the map of the islands, and you can see
yellow's above water.
The yellow's above water, but you can see that if you drop, like, there's 1,000 feet right there. So if you drop sea levels 1,000 feet,
I could almost see that up there as being an old bay.
Yeah.
Where, up here?
Yeah, as being the old bay where people like drop stuff off. And
yeah. Well, I mean, Plato says that there was ships coming day and night, in and out.
Wow.
It was like the hub of a trade network.
And there's also a volcano there?
Oh, yeah, they're volcanoes, yeah. It's pretty much a volcanic complex because, see, it's right along the mid-Atlantic ridge. And this is one of the thinnest crustal places on the planet. And interestingly, if you look at, I kind of use oftentimes the example of Iceland, because if you were to lift the Azores Plateau above sea level, it would be about the size of Iceland. And the mid-Atlantic ridge, the fracture zone runs right through Iceland, and that's why there's so many volcanoes in Iceland. And you can see the ridge actually runs through the Azores Plateau as well. So part of it is on the west and part of it is on the east, although most of the islands are on the east side of the actual ridge.
Yeah, yeah.
And there would have been a super popular, like, you can see how, like, because in my opinion, there's clear evidence for intercontinental travel back in the day. You've got,
that's what I was thinking. That's the jumping off point where they all
build
go.
the same stuff. So it makes sense that you'd have this.
That would be the
have the
highway
civilization be in the middle, and they'd be getting the best of both worlds all the time.
Yeah,
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 yeah. So, yeah, we're kind of talking here as if, you know, we're accepting the fact that Atlantis was real. And in my lectures and in the presentations and stuff I do, I say, well, I'm not necessarily saying that we haven't proven that Atlantis was real. What we have done, though, is we've established a very credible basis for saying that it could have been real. Yep. And until we can come up with some other documentary evidence or some kind of objective evidence that, you know, like what you were just asking, Darren, is there any evidence of, well, possibly. There's some, but, you know, the subsidence of the plateau would have undoubtedly been a catastrophic affair.
Can we take a look at some of that evidence for its subsidence?
Well, I don't see why not. Since you asked so politely.
And then also once you get that up, like how far or how long do you think it'll take before they get real evidence of searching in the waters and the LIDAR and other means to...
Does LIDAR work underwater?
I thought it did, yeah. I thought they could map the details of the ocean floor in those shallower areas.
We should get a LIDAR for the cruise ship.
Let's just cruise around LIDAR.
Then we could get a grant. Yeah, we're LIDARing. LIDAR love.
Okay, we're going to go back to 1948. This was the first
Israel
scientific excursion
thing too.
Okay, well, that would be getting off on a tangent there.
Yeah, let's not go.
For now.
Next season.
So this was in the National Geographic magazine, 1948. This was the first scientific expedition exploring the mid-Atlantic ridge. So 1948, this was Maurice Ewing, who is considered one of the founding fathers of the modern science of oceanography. Okay, so he wrote this, quote, "We're over the ridge, exclamation mark. All hands were tense as the word spread through the little research vessel. Get this, the name of the research vessel, Atlantis. For it meant we had reached our goal. A mile or so beneath our keel stretched the gloom-shrouded peaks, valleys, and ridges of the longest mountain system on Earth, the mysterious mid-Atlantic ridge, which we had come to explore. Though our ship was named Atlantis, we had no illusions of solving that age-old mystery. But a rather wild idea had led us to devote 4 hours to a particular rock dredging. So they're dredging, they've dropped this dredge down to the bottom, right? And on the flanks of these sunken mountains, these mountains whose peaks are the Azores Islands, they're dredging up some material, right, from a mile down. 3,000. Okay, a rather wild idea had led us to devote 4 hours to a particular rock dredging. Our hypothesis was that these long level terraces, right? Now, you have to bear in mind that terraces are frequently a byproduct of an ocean level eroding a shoreline. And so, for example, you've got a shallow pitched coast. The sea level is here. If the sea level goes down, it'll cut a terrace. If the sea level comes back up, you'll now have a sunken terrace.
Yeah.
Right? Our hypothesis was that the long level terraces with sediments ranging up to 3,000 feet in depth were submerged shorelines. If so, the steep cliffs rising from them should have boulders at their bases, as do wave-cut cliffs on our shorelines today. It is, of course, extremely radical speculation to identify these level stretches more than 2 miles below the sea surface as former beaches. Such a theory would require the obvious but almost incredible conclusion that the land here has subsided 2 miles, or else the sea has risen by that amount. Much work will have to be done before this startling theory can be proved or disproved. In any case, we were encouraged to find that at the bases of the cliffs above such terraces, rocks could in fact be readily obtained.
Wow.
So in other words, exactly the evidence that they were looking for to say, well, are these submerged shorelines? There it was.
And he gave 2 options, but it could have been both.
Well, it was both.
Yeah.
Because the dominant one I would say was subsidence, which is isostatic, and then the rising of sea level is called eustatic, E-U-S-T-A-T-I-C. So you have isostasy and eustasy. Eustasy is the sea level rising and falling, generally because of the fluctuating glacier masses worldwide. And then isostasy is the vertical movement of the Earth's crust. So when you have
then the fact that it's a giant volcano that we know erupted, can be erupting at that time, that would also, in my head, I picture that as just helping and drive it down.
Sure, and there undoubtedly was volcanism because you would have had extreme pressures and stresses generated along the mid-Atlantic ridge because of an isostatic depression, right? You could almost picture this, that as the glacier masses grow, the weight is being removed from the ocean, right? Which allows vertical movement upwards. Glacier masses shrink, dumps trillions and trillions of tons of water back into the oceans. Bottom of ocean sink. So now you can almost picture there that as the glaciers wax and wane, sea level is going down and up and down and up and down in tandem. And I think that there's actually evidence that is now pretty much pointing in that direction. There's certainly evidence to show that there was massively fluctuating glacier masses, probably cyclically over the hundreds of thousands of years. Then corresponding with that, it could be that, this could lead us into the idea that, hey, if we went into another ice age, Atlantis might rise again.
Mm-hmm.
You just find some monolith there.
Wouldn't that be something? Yes.
I thought I heard you talking recently about how there's evidence in Hudson Bay for how far the Canadian sort of continents come up.
Yeah, I think it varies between 1,200 and 1,500 feet, roughly.
And that has to go somewhere. If the country of Canada can come up 1,500 feet, that something somewhere has to go down.
Because the geoid, the planet as it's rotating, the geoid is not a perfect sphere. It's the actual shape of the planet with the equatorial bulge. The spreading at the equator, the compression at the polar axis, right? But the geoid is always trying to maintain relative stability. It's trying to, stabilize its mass about its center of rotation. Well, what happens if you remove, 100 billion trillion tons of ice mass from the continent and dump it back in the ocean, or vice versa? See, what that does is it changes the geoid. And it would require, just the physics of it would require that there be changes in the Earth's rotation to accompany that, right? So not only changes in the rotation, but also compensation this way. If you think of it this way, you got a beach ball, right? And if you sit, if Graham, you come and you sit on that beach ball, right? You're going to compress it this way, and the pressure will push out this way, right? So if the stresses are evenly distributed around it, you'll have a uniform radius. The axis will be uniform in any direction. You compress it this way, now you've got a shorter radius, you've got a longer radius, and a bunch of stuff in between. So, in a sense, what's happening is the geoid is changing shape because of the redistribution of surface mass, right? So think about now, if you compress the beach ball, which is the huge mass of glacial ice forming, compressing the North American continent. Now what you have to have is, as you get below the crust into the asthenosphere, you now get into this ductile plastic mass. So what does it have to do? It has to move laterally. And the pressures from beneath the mid-Atlantic ridge are going to be pushing it upward, right? At the same time that the weight of the ocean water is being diminished, you see? So you've got this bimodal process going on. You're removing the weight from the ocean basins, and you're creating more pressure on the bottom of the lithosphere that's going to want to push up those areas as the glacier mass grows. As the glacier mass melts, the exact opposite's going to happen. The continent's going to be rebounding. As it rebounds, you're going to have a movement of material towards that area that's rebounding, which is now going to create voids where during the ice age you had this pressure out here. Now that pressure is being relieved, you see. So that's what we have to be able to picture. And then if you look at the Azores, they are very auspiciously placed to be highly affected by any kind of isostatic and or eustatic changes.
And now with the technology, these maps that you're using, like what was that one that you were using with the orange peaks and the different colors?
That was a digital relief map.
Yeah.
Produced probably even now back 15 years ago.
Okay. Yeah.
Is there an equivalent to the Azores in the Pacific where there's that sort of Pacific hedge point, the mid-Pacific ridge?
I don't really know of anything.
Is that like Hawaii?
Well, Hawaii is along a volcanic zone. Yeah, I mean, it's the whole succession of islands was produced by magma coming up through the crust.
Because you think of like the Hawaiian Islands and the Easter Islands. I'm kind of picturing that as all just one big circle now that was all much.
See, I haven't done any studies in terms of isostatic adjustment in the Pacific like I have in the Atlantic. But one thing is certain, you certainly would have had the 400-foot change in sea level, which means that there are islands now that are totally submerged that could have been above the sea level, and islands that are now above sea level would have been much more extensive when you drop sea level 400 feet.
What about in the Mediterranean then? How did that rise of 400 feet affect the Mediterranean? And does that map that you looked at show anything around Santorini, or is there anything in the Mediterranean that could also be Atlantis?
Well, if again, taking Plato at face value, Atlantis had colonies, and it had outlying, trade networks, which clearly implied we're in the Mediterranean.
Right, right.
So that's how I tend to interpret it. And also, when you begin to look at mythology of the Western Hemisphere, there's plenty of stuff in there that could be consistent with a migration from the East.
Yeah.
Now if you want to just hypothesize that there was a civilization that rose up on these islands during the Ice Age, the first sea level pulse may have begun a process of destabilization. In fact, what Plato describes is how, the Atlantean kingdom went from being this virtuous and, beneficent place to being corrupted with power and imperial ambitions. And this is what led them to try to come in and subjugate the cultures within the Mediterranean that led to the big war, right? Well, if I was going to try to imagine a scenario, I would picture that, meltwater pulse 1A at 14.6 probably caused a lot of seismic and volcanic response, which would have directly affected anything that was going on in the Azores. And that could have been the beginning of the decline of a culture, a civilization that had established itself there during the previous 4,000 or 5,000 years, right? Or longer.
Yeah, it
right?
could introduce a lot of struggle too, hardship.
Yes, and the motive to become imperialistic, especially if you look at what other cultures have done when faced with rapidly rising sea levels, is to build seawalls. So, nothing explicitly mentioned by Plato about importing slaves for that purpose, but they were being imported for something. That was one of the things that Atlantis was doing, was capturing people and enslaving them, according to Plato, you see. So I could envision, there being a necessity for some means of that. Others, may have seen the handwriting on the wall as sea levels continued to rise. And then at 12,900, there was probably a rapid rise in sea level. I haven't seen the studies from the Atlantic, but there was certainly evidence that there was a gigantic influx of fresh water into the Arctic Ocean at that time, as well as probably into the North Atlantic. One of the major drainages of Glacial Lake Agassiz now seems to be falling around the Younger Dryas boundary. Then we have 11,600 year ago event, Meltwater Pulse 1B, and that could have been the coup de grace. That could have been the thing that finally caused enough of a seismic response along the mid-Atlantic ridge that it pretty much wiped out any culture that was living on that island group there.
Which lines up with Plato's timeline as well.
And what?
And that lines up with Plato's timeline. If that's the killing blow.
Perfectly. Lines up perfectly, yes.
And how much of that would have went into the Mediterranean? Like, was it destroyed the same level? Did the sea level come up that high there, or was that somewhat isolated?
Well, it would have been a 400-foot rise in the Mediterranean.
Same thing, eh?
It was connected with the Atlantic.
Yeah, I'd say the Mediterranean wouldn't have been affected by isostatic depression so much because it's
connected to the continents and all that, yeah.
Yes, that's correct. And there's not the evidence. See, we could go on here. I mean,
do you have that type of map of the Mediterranean that shows the what it was like 400 feet below, or?
Well, yes, I do.
Because is there a Suez Canal then? Like, is the Suez Canal man-made?
No, that's the.
No, that's no, Darren.
No, so that was around. So does that canal still there?
The Straits of Gibraltar?
Less water. The Straits of Gibraltar on the east end, right? I'm thinking at the west end. The west end's the
northeast. No, other way around. You're thinking
the east end. The other way around.
Let's see what I can pull up here to.
Because the east end's the Suez Canal, right?
I think so.
Asked about maps. Okay, let's see. I think I can come up with something here that you'll find of interest, as long as I don't take too long to find it.
Yeah, that's okay.
Let's see. Okay.
Like even the Straits of Gibraltar with 400 feet less, like would it have been way easier to cross? I mean, if the pillars of Hercules.
They must have been impressive with 400 feet less water.
Yeah. Oh yeah. Yeah.
I mean, connecting two continents, basically, right there, that little point.
Yeah.
Okay.
Imagine how they
it's still hard to believe how close Africa and Europe is at that point.
Okay.
What is it? A few miles?
I don't know how long it is. Technically, I feel like it's shorter than that, but.
See, I don't know if this is or not. Let's see. Might be the one. Let's see. Yeah, I've got some great maps here that I can pull up. If you give me just a second here.
Yeah, no problem.
Okay. All right.
It says 2 continents are separated by 13 kilometers of ocean at the strait's narrowest point between Point Maraquai in Spain and Point Ceres in Morocco. The strait's depth ranges between 300 and 900 meters, 980 and 2950 feet, 160 and 490 fathoms, which possibly interacted with the lower mean sea level of the last major glaciation 20,000 years ago, when the level of the sea is believed to have been lower by 110 to 120 meters. Ferries cross between the 2 continents every day in as little as 35 minutes. Part of the northern coast of the strait lies within Spain's El Estrecho National Park. Huh.
That'd be a cool spot to go check out.
Yeah. Well, this is why I'm wanting to do an Atlantis tour.
We'll need a boat.
Yep. So, is that something you can get on, Darren?
I'll start working on the boat. I've kind of been working on a boat already, so could work out.
Okay, good. Yeah. All right. I think I got the.
So it's still quite wide then, 13 kilometers now, and I guess if there was less water, it would have been narrower back then, with 400 feet less water.
Oh yeah. It would have been definitely narrower for sure. Okay,
if they can cross it now on a ferry in 35 minutes, I mean, you could probably
swim across
take a canoe. Yeah, maybe swim across it.
You could probably take a canoe across. I don't know about swimming across.
Okay. I think I got something here that'll be. Yeah, I think we got it. Here we go. So let me just get my back here, and
you can almost picture if that was destroying the islands, they would have fled maybe to the Mediterranean. I mean, that's maybe the war that you're talking about. When that catastrophe happens, they're scrambling over,
Well, take a look here, Graham. Okay, now this map shows very clearly the continental shelves. Look around the UK, United Kingdom here.
Oh, yeah, that's right. There it is.
Now, here's the thing. During the Ice Age, these weren't even islands. This was all a unified landmass here.
Wow.
And, for example, look at the Baltic is pretty much closed off, but you can look at the Mediterranean. Now,
oh, I see. So the darker is the deeper area there.
Yes.
Yeah. So when you look at the Mediterranean, there's that shelf above Libya and Egypt, maybe, or what would that be there?
Pull in
Morocco.
there.
Morocco's on the west.
Yeah, Egypt is right here.
Yeah.
Right here's the Nile coming up, and here's the Nile Delta. The Suez Canal is right here. Now, a lot of this was above ground, but not all of it. I think the depth of the shelf in here is 800 or 1,000 feet. So what it meant was that the Mediterranean was much smaller than it is now, because, again, it would have been 400 feet lower.
Mm-hmm.
Because
even east of Greece and west of Turkey there.
Yes, in this area.
That looks like it might have been somewhat connected.
Yes, it maybe was. I haven't really seen the absolute depths here.
Yeah, but it's a great visual.
Gives you an idea. Gives you a visual. And let's see.
And then and then go to the left to the Azores on this map. It shows all those islands. I mean, now you see all those islands from.
Yeah, let's pull back in there then. There's the Azores Plateau right there.
Yeah.
Wow.
Right there.
And Medina.
Madeira is right here.
Yeah.
And then the Canaries are here.
Oh, yeah.
Let's see what this is. Okay, this is basically the same view, a little bit different. Let's see, we can go back here. Let's go back to North America here and take a look. So largely the coastlines of the world roughly coincided with that line. Right. Although not always. because like I said, there was sometimes this drop off was like 1,000 feet deep, so it would have still been under 400 or 500, 600 feet of seawater.
Yeah.
But yeah, overall, the continental shelves, I mean, the continental shorelines were much further seaward during the Ice Age than they are now.
North and South America might have been connected more through the Central America.
Well, watch this now. I'm gonna toggle between this map and the next one that shows sea level, I think 350 feet low. So it's a very conservative, but you'll still be able to get a sense of. I particularly look up here.
Okay. Yeah.
Right up there by Alaska,
Yeah.
and look.
Yeah,
what
you got to focus on one area. Wow. Yeah, you got to focus on one area when you toggle back and forth. So do that again a couple times.
And Greenland too.
Yeah. Well, what we'll do.
Oh, it looks like it's connected right there between South and North America down the Baja.
It's pretty darn close. Now watch. We're going to take a closer look at North America. Okay, so here's the present coastlines. Now watch this.
Jeez.
Yeah.
Yeah.
Yeah, it connects up north even. I mean.
Yeah. Look at this.
Yeah.
And then all of this area, which was not glaciated. This was a whole. You want to talk about?
Oh, that wasn't glaciated over there?
No.
Is that what they say Hyperborea is up there?
I don't know.
I'm fascinated by that too. I mean that.
Yeah,
So that, on looking at it from the other side, would be northeast Russia then?
yeah, Siberia.
Siberia.
This is Beringia. Now, Beringia is a lost world.
Which seems to also have evidence for the quickest temperature drop up there too.
Yeah. And, look at down here in the Caribbean. Well, let's toggle back and forth. Look at the width of the Florida Peninsula.
Yeah.
That's where Bimini Road and everything is.
Yeah. Yep. Look up here. You see the islands of Nova Scotia and New Brunswick. Look at this.
Wow. Yeah, that's amazing. See, this is the map I've been looking for years. Like thinking, what do the coastlines look like? What do the coastlines look like before? Yeah.
Now here's into China area, all of this, here's Vietnam, Cambodia, Thailand, Sumatra, and all of this down here that's so volcanically active. There's Australia. Okay. We're going to drop sea level 350 feet. And again, so since it's not 400 feet, this is a conservative.
Right. Wow.
Jesus.
So now, where's Florens, like Hobbit Florensis?
Yeah. They were down in this area.
Yeah.
And they were probably living there when it was this.
Yeah. Just connected to everything. I mean, it's not hard to imagine getting around by water when it was like that. It's so hard to imagine it nowadays because, the distances are so vast through the oceans. But when you really connect all these little things, there's almost a way around the whole world.
Yeah.
Without traveling too far on sea.
Yeah.
There you have it.
Let's look at Europe. Here's Scandinavia and United Kingdom. Here's Ireland.
Oh, yeah. I want to see this one.
Up here.
So Doggerland is going to be there. But
Doggerland would have been this area.
And then you get those huge, giant northern plains, too.
Yeah. Now let's jump back 15,000 years.
Wow. Yeah.
That's craziness.
Yeah. It doesn't even look like the same map, does it?
No.
And that fills in the Mediterranean a bit there too. So it also that.
You can see right there.
Yeah.
You could scoot across North America, no problem.
Oops. Yeah. So, and here's Iceland. And then here's this whole plateau that Iceland is on. And then, of course, if you drop sea level 400 feet, almost the whole plateau is above water.
Yeah.
So.
Huh. Well, I think we figured out where Atlantis is anyway.
Well, you guys haven't seen anything yet. I mean, how long have we been going? An hour? We got 14 more hours just to catch up what we covered on Cosmographia.
So are they making headway at the Azores then with researching the stuff? I mean, I thought Graham Hancock was saying that they were underwater, they're looking around, or was that you that we were talking?
Yeah, I mean, I don't think there's anything official with any serious money behind it.
Right.
Like,
what would you do if you had a bit of money? What would the first thing you could do to try and research this a little deeper?
Oh, a submersible.
Submersible? Just checking out the plateaus, looking for what? Like man-made pillars and shit like that down there?
Yeah, look for anything that would suggest that it was man-made. Yeah. And if you remember the quote there was like in one case 3,000 feet of sediment. So you got a picture that in the subsidence of the island, it probably happened in a series of spasms, right? Major earthquakes. And you might have had subsidence of hundreds of feet at one time, which totally could be plausible given, the nature of the crustal movement and the isostatic depression and rebound and all of that. So, one of the things that is going to induce is instabilities, particularly in any mountain slopes.
They're going to be hard to
and
find
as the water is moving up, and saturating the ground, you're going to have all kinds of mass wasting events, landslides and material. So a lot of what might have been there down on the lower, near the bases of the mountains, could be buried under hundreds of feet of sediment.
Yeah.
But, maybe the sediment might have preserved some stuff.
Yeah, or maybe you got to go further off the coast, or.
Why, are you going to get us some money, Graham?
One day. We'll get a boat with a submarine. We'll go check it out.
LiDAR that shit up.
So where can people go if they want to? You mentioned you did like a full deep dive on Atlantis. If our viewers want to go and decide they want to go enjoy that, where can they find that?
At cosmographia.com. Just go to randallcarlson.com. It's the podcast that we do. We're up to about 60 episodes now. The first 5, I'm pretty sure it was 5, are devoted to the whole in-depth discussion of Atlantis.
Wow, that's fantastic. So is that also on video or is it mainly audio?
No, it's video as well.
Yeah. Video as well, yeah.
It's a YouTube channel.
All going
YouTube
up on
channel.
HowTube.
All right.
It's all going up on HowTube, which is going to roll out this coming week, I think.
Oh, wow, nice.
Yeah, some changes are afoot.
I love it.
Changes.
Yeah, that's great. Yeah,
I love
here
it.
too. I mean, it's been a great primer for Atlantis, and just
it's perfect.
looking
And
at
we encourage everyone to head over and do the full deep dive for sure. It's a great team over there.
I like those guys a lot.
Yeah, they're fantastic.
Yeah.
Well, speaking of guys we like a lot, we like you a lot too, Randall, and we appreciate you taking some time out of your Saturday to do this with us.
Oh, my pleasure. Yeah. What is it? What does this mean? That it's all over now?
Well, we can do another one in a few weeks if you want.
Yeah, we could. We could. Yeah, we could. Yeah, because I mean, look, we barely touched upon anything here.
Yeah,
but what we looked at it's pretty cool, isn't it?
It is cool.
Yeah,
I really like
fantastic.
the maps where you can drop and raise and lower the sea level and stuff like that.
Yeah, isn't that great? Yeah,
that's something else.
There's amazing stuff happening. And I think, as this network of us guys and people who are into this grows, and we start sharing more research and resources and stuff, I mean, I think it's going to be game changing.
I agree. It puts context as well into what's happening in our contemporary society with all the fear mongering and the climate change and all that other stuff. When you talk about stuff like this and that islands are disappearing and sea levels rising hundreds of feet, it should put some context on what's happening now, I think. I think it's important to learn that.
It is. And the problem is that there's been a huge hijacking of the science, and it's emphasizing only one interpretation of the science to the neglect of other interpretations. And the narrative now is that human beings are pretty much the sole cause of climate change. And that is about as far from the truth as you could possibly get. we have tons of evidence that there are many factors.
Yeah.
When we talk about, when you talk about melting away 6 million cubic miles of glacial ice. Now think about this, guys. Where you're at now, up there, you were under a mile of ice.
Yeah.
Where you guys are sitting right now, there was a mile of ice.
Yep. That map that I got you from you a few weeks ago shows that North American ice, and it was going all the way down into the States.
Yeah.
That ice sheet. The two ice sheets.
That ice sheet is bigger than the one that now covers the South Pole.
Yeah.
So it's not at all any kind of hyperbole or exaggeration to say that, half of North America, the only modern analog for the climate of half of North America is the South fucking Pole.
Mm-hmm.
Yeah. And somehow it went from a climate like the South Pole to the climate it has today within a few thousand years, and nobody can explain why. And yet there are factions of people who say over and over again that the debate on climate change is over, the science is settled, and we should all just sit back like good little gullible citizens and just eat whatever propaganda we're spoon-fed, no matter how selective it is, no matter how cherry-picked it is. And,
or no matter how there's also lies, and some of it's 180 degrees away from the truth. I mean, when they talk about the melting in places like the Arctic and all, I've seen people show the graphs of the ice, and it hasn't changed in 15, 20 years. And they're making it seem like things are, going the opposite.
We'll get into that next season, hopefully.
Yeah,
we'll do a little special, deep dive. That's what we're planning on doing after this.
Yeah.
We could get into talking about a lot of things.
Yeah.
We could talk about sea level fluctuations. We could talk about the role of the sun. We could talk about geomagnetism. We could talk about the effects of cosmic rays. We could talk about volcanoes and
underwater
their appreciated roles. Yes, the list is long, and there's a lot of stuff that mainstream science is deliberately, I'll say mainstream politicized science is deliberately ignoring.
Yeah.
Mm-hmm.
Deliberately.
Well,
because it does not fit the narrative.
Well, you're going to do that on Cosmographia, so you can come here and warm up with us and get your feet wet in there and practice.
Guys. I love hanging out with you guys.
Awesome.
All right, Randall.
And can't wait till May.
Absolutely.
Yeah, right on.
Neither can we.
God,
We're looking forward to it. I think May will happen for sure. So
I think so too. That's going to be. We're going to have a great time.
Yeah.
Absolutely. Well, this has been a great time, Randall. Thanks for helping us out with episode number 1.
My pleasure and my honor, gentlemen.
Thanks, buddy.
Bye for now.
All right.
Ooh, and that was our chat with the fabulous Randall Carlson. What'd you think, buddy?
Oh, yeah. Fantastic. Those are the maps I've been waiting for.
Those are?
Yep.
Absolutely.
I love it.
And do we know what one we're doing next yet? Do we know what next week's
No,
episode?
we don't know. It's probably going to be like either Giants and Bloodlines or Tartaria. Not sure exactly which one yet, but another one will be coming out soon.
All right, guys. Thanks for listening. See you next week.
All right, welcome to Grimerica Goes Deep. This is a series on climate change, Chapter 2, a realistic perspective on changing climate with Randall Carlson. Thanks for joining us, Randall.
Well, thanks for having me, Graham.
Yes, we really appreciate your time and to explore this important issue right now. Put some common sense perspective on what's happening.
Well, it is an important issue, and it does lack for common sense, as a matter of fact. So,
yeah,
I can't say that I've got the final word on the matter, but it's something that's been an interest of mine for decades, literally decades. In fact, it goes back to an obsession with weather as a kid.
Wow.
That kind of morphed into an interest in climate and climate change way back in the 70s when I started getting obsessed with ice ages and things like that. So, I've had a little bit of study into the matter. So, just enough, I would say, so that when I hear some of the various things being said out there, I have enough knowledge of the matter under discussion to realize that it's a very slanted discussion at present, that most of the emphasis is on anthropogenic climate change, that is, human-driven climate change. And it seems to me that there is a neglect of the natural forces that have been driving climate since the world began, that have not ceased to be operational. And so, that's kind of my perspective on it. So we can look at a lot of different things. I mean, there's a lot of angles we can come at this subject. We can talk about the history of recent climate going back, say, to the last few thousand years. We can look at climate from a bigger perspective going back hundreds of thousands or millions of years. We can talk about the origins of modern climate science and some of the founders of modern climate science, what they believed. We can look at some of the things that the early scientists from the 19th century believed when they began to see evidence that the climate had changed quite profoundly over and over again. There's a lot to talk about. There's more than we'll be able to talk about in an hour, but we can always do it again, and we can get into some of the highlights within an hour.
Well, I think the one that always stuck out to me is like how everyone's always freaking out about the climate changing, and then when you really look at it, the last 10 or 11,000 years have really been the most stable out of the last, few 100,000 or maybe ever.
Mm-hmm. Well, when you talk about the last 10,000 years, we're referring to a geological time called the Holocene, which is in the geological system of classification is an epoch. And an epoch is a subset of a period. So within the Quaternary period, we have various epochs. The one that just preceded the one we're in now is called the Pleistocene. And the Pleistocene is now usually given as starting about 2.6 million years ago and ending only 11,600 years ago, which raises an interesting question. Is the Holocene, the last 10 or 11,000 years, truly a unique epoch that is so unique it should get its own name and should be completely separate from the Pleistocene that preceded it for 2.5 million years? And that's an open question.
How did they decide to separate that out? Because of the Younger Dryas?
No, because of the Younger Dryas hadn't really been identified yet. It was just because of the fact it was recognized as being a major change in climate and a major faunal turnover, because you had a mass extinction episode that occurred at the end of the Pleistocene, 11, 12, 13,000 years ago, when you had, maybe about 100 species or so of megafaunal large mammals, that is, go extinct. And this extinction event coincided more or less with the changes of climate that occurred from the Pleistocene into the Holocene. And a major shift that occurred that allowed for a much more precise understanding of these changes was the invention of radiocarbon dating in the early 1950s by Libby, Willard Libby, I believe. I forget his first name, but Libby was the inventor of the
radiocarbon dating. Yeah.
Thank you, radiocarbon dating. And with the advent of radiocarbon dating, it became apparent that some of the earlier estimations of time spans were too long, and it was previously assumed that, for example, the transition out of the Ice Age was something that took tens of thousands of years, 50,000, 100,000 years, based upon studies of the rates of modern glacier recession. Now, it's important to emphasize this point. because there's a lot of talk about glacier recession around the world today, and as being evidence for anthropogenic climate change. Well, it's important to understand that the glaciers began receding in the early 18 to mid 1800s. And this was basically coinciding with the beginnings of climate science, with the beginnings of geology, the beginnings of a lot of science that was occurring in the early 1800s. So what happened was the founders of geology and the founders of some of the like glaciology, people like Louis Agassiz and James Geikie, others like this, who were studying the recession of the glaciers during the mid 19th century, looked at the rates at which glaciers were receding, and were and then extrapolated from that. Now, what you got to understand is that the Little Ice Age was a period that evolved over several phases. The first phase of it began in the early to mid 1300s. It was not uniform all over the world. In some places, it began sooner than at other places. In some places, it was more severe. But we can basically say that from about early 1300s to the mid 1300s, the climate shifted fairly dramatically from what had the previous 3 or 4 centuries that had been referred to as the medieval warm period. Now, the medieval warm period was when Scandinavians were colonizing and farming West Greenland. And for 300 to 400 years, there was a farming community that prospered on West Greenland. And come around, and this was during this period of the so-called medieval warm period, which came to an end in the early 1300s. Now, one of the other things that's associated with the medieval warm period was, and it's important to emphasize this, it was a time a very prosperous time, and it appears to have been a prosperous time worldwide. And one reason we know that, let's take a look at what was going on in Europe. From about the mid 500s up until somewhere between around 950 AD was the so-called Dark Ages. Well, it's well known now that the Dark Ages was a time of global cooling. And in some of the research, it shows that the Dark Ages was really not a misnomer. It was a literal time of extended dark because of apparently heavy particulate presence in the atmosphere, probably as a result of volcanism. Major volcanism spewing a lot of particulate matter into the atmosphere, and then that particulate matter increasing the opacity of the atmosphere, which reflects more solar energy and causes a global cooling. So the global cooling that was a part of the Dark Ages was also a time of, reduced solar energy and actually a reduction in visible solar light because of the presence of material in the atmosphere. It was preceded by the Roman warm period, right? And so we had the Roman warm period, then we have the Dark Ages cold period. That gave way to the medieval warm period. Now, in the medieval warm period, what happened was that because of the warmer climate, 1 to 2 degrees warmer, you had a major shrinking back of glaciers. You had an extension of the growing season. You had a shift of the latitude, the viable agricultural latitude north by up to 300 miles. You had, like I said, an extension, a lengthening of the growing season by up to about a month. So one of the things that did was it allowed for agricultural surpluses. Whereas in the preceding Dark Ages, there was a lot of, because of the cold weather and the damp that was associated with it, it was not, they were not able to cultivate crops.
A lot of scarcity, yeah.
Yes, that's exactly right. With the onset of the medieval warm period, though, we can see things happening that are reflecting what's going on in the environment. For one, we see that lifespans are increasing during the medieval warm period, which of course would make sense. When you have agricultural abundances, people are getting a lot more to eat. Therefore, they're becoming, more nourished, right? We see a reduction in infant mortality because fewer babies are dying as a result of the increased health and lifespan of the people. We also see an increase in human stature, particularly in Europe during those centuries, because people are eating more. They're getting their nourishment. So now, as a result of the agricultural surpluses that you had for, say, beginning around 1000 AD, after about a century, up to a century and about a third, what happens is Europe became quite wealthy. And with the expansion of population that occurred, you now had a massive labor force available that you did not have, say, in 700 or 800 AD. Now you've got this massive labor pool available because there's a lot of people and they're basically healthier and more robust. And then what we see is the beginning of the great cathedral building era. Now, when you consider the fact that those cathedrals, there was about, when we're talking about cathedrals on the scale of Notre Dame and Lyon and Chartres and Bourget and Amiens, Reims, all of those, we're talking about these huge, magnificent structures that when you look at so there was about 80 of those, right? Roughly on that scale. There's about 500 lesser scale, but still nonetheless impressive churches and cathedrals that are all being built during this roughly 1 century, up maybe a century and a half, depending on how you define it. But the result is that you have huge numbers of workers, craftspeople. You have to have, when you think of one cathedral, you have to think about the amount of stone that has to be quarried. Okay, you have to think about the raw quarrying of the stone. Then you have to think about the dressing of the stone. You have to think about transporting the stone to the building site. You have to think about the hewers, the truers of the stone. Once you get the raw stone, it has to be shaped. When you look at if you look at a Gothic vault, all of those stones are very carefully shaped with a very intricate geometry, right? So now you've got the stone carvers that are not only shaping the stones for their emplacement into the edifice, you've got sculptors, and you've got this vast program of sculpture in all of these cathedrals, these magnificent sculptures, right? Now you've got these stained glass windows that are, again, magnificent and, have a transmission of light that has really not even been duplicated to this day. The sort of the internal qualities of the refractance of the light coming through the stained glass. You've got the engineers, you've got the carpenters, armies of carpenters, because you don't build a Gothic vault 120 feet high without erecting this enormous complex
formwork kind of thing.
Formwork first, right? So you've got that. Then you've got, it goes on. Now, bear in mind that we're looking at tens upon thousands of people being employed in this. Well, these are people now that are those sculptors, those glaziers, those carpenters, the engineers, the astronomers that were involved. All of these people, they're not farming. Somebody else had to be farming and growing the food that's feeding these armies of workers.
Created a whole economy almost.
The whole economy essentially is oriented around this enterprise.
Wow.
Right? Now, when we look at how it unfolded from, the first Gothic cathedral at Notre Dame Saint Denis was begun in 1830. The wave of building construction basically lasted until the 1300s, early 1300s. And what we see is that with the onset of global cooling, between about 1314 and 1340, there was a succession of agricultural failures, crop failures, food shortages, which led to famine. That famine then led to the malnourishment. People got weak, their immune systems became compromised, and they became susceptible to pandemic diseases.
And less resources to feed all the people, less people building stuff,
Yes.
less all that, just trickle on down.
So we see that the Gothic building era basically ends with the onset of the Little Ice Age. And then the coup de grace was the bubonic plague that came along. I think it was around 1344.
Yeah. So you talk about this last 1,500 years or so, maybe 2,000 years, where the temperature was rising and falling during these, couple century long periods of 1 degree, 1.5 degrees, something like that. But I've seen that, these graphs put out by the alarmists that look more like a long extended Michael Mann hockey stick that shows this really low sine wave of all the fluctuations for the last couple thousand years, and then this spike at the end.
Well, so what you have to do in order to accomplish that is, and it's fairly complicated, but you basically have to flatten the curve. So that means you have to flatten out the medieval warm period. You have to make the medieval warm period cooler, and you have to make the Little Ice Age warmer.
And this is what they're doing? Yeah.
It goes from medieval warm period up here, Little Ice Age here, flattening it out like this. And then you stick basically instrumented records, which are subjecting to adjustments, onto a proxy record. So that really the blade of the hockey stick is the instrumental record, which has a lot of uncertainties and questions about it. Like, for example, we could talk about the urban heat island effect and the failure to fully account for that in looking at the modern record. We could also talk about the sun.
Sorry, I just want to, before we go too far past that, is that urban heat island, is that the idea that all these thermometers were sort of set up at airports and places that were rural in like the 30s and the 40s and the 50s? And then, now it's like urban centers?
That's exactly right. Now, urban heat island can't account for the full 1 degree, 1.25 degrees of the last century, but it might account for a good third of it, maybe more. But I think it's conservative to say that maybe a third of the temperature rise, the assumed temperature rise of the last century or century and a quarter, at least century, is due to urban heat island effects. Obviously, 100 years ago, we didn't have airports, but this is when our records go back to. And then when we really started getting extensive database of climate change was more like the 50s and 60s. But what we see from the 50s and 60s, 1950s and 1960s, is that, yes, many of the temperature data stations were positioned at rural airports that have been engulfed by urbanization. And so obviously if you have a thermometer recording temperature changes and it's sitting out next to in a more rural environment, and then you have acres of pavement built around it and buildings and air conditioning condensers and all of these things, then what happens is it's going to have a different, it's going to read higher than, say, somewhere in a rural area 20 miles away. And there's a lot of research that does suggest that is it's a realistic part of the apparent temperature change of the last 100 years. Then there's the role of the sun, which has been downplayed because going forward with the models, the assumption was all based upon, when I say the models, I'm talking about the climate change models that yield up the projections that are being used to generate the fear and the hysteria about anthropogenic catastrophic climate change. But the thing is that when this whole anthropogenic climate change thing was being first proposed back in mostly in the early 90s. At that point, they were making this assumption. Their operational assumption was the solar constant. The assumption that the sun was so constant in its radiative output that you could essentially ignore it. Because if the sun wasn't changing, then it's not a factor in the changes that we see, the terrestrial changes that we see. Well, we've learned a whole lot about the sun in the last 30 and 40 years, all of which is pointing to the sun being the dominant player in global climate change, cooling and warming. So those two alone, and in fact, some studies would suggest a third to half of the warming of the 20th century is solar related. So if we factor that in, then we could say, well, if 2/3 of the apparent climate warming of the last century are due to urban heat island effects and solar effects, that only leaves a third for anthropogenic.
And what if there isn't that much warming? I mean, we've had people on that have shown that they're looking at the warming from certain periods, and they're selectively taking some data and leaving some data out. And, I'm not convinced that it is really warming as much as they say. I mean, what if we're going into an ice age, like what some people say we're still there? We're going into a deeper ice age.
Well, let's see. Let me... While
you look for that slide, I'm going to read something from the IPCC in 2001. So this is 20 years ago now. Yeah. And this is what I don't get is how they can just flip-flop. They can officially say one thing and then, now they're just fear-mongering constantly for the last 20 years. But it says, in climate research and modeling, we should recognize that we are dealing with a coupled, nonlinear, chaotic system. And therefore that the long-term prediction of future climate states is not possible. And there's a survey of these modelers, and it shows that this tuning that they do to these models is often unavoidable but a dirty part of climate modeling. And this is right from the IPCC.
Right. So, I mean, somebody in there has enough integrity to actually, put the circumstances out there. And
yet they just ignore that part.
Well, yes, they do. That's pretty much the problem as I see it. So what we'll do here is
because a lot of the stuff we've seen is they leave the 1930s out when it was warmer. They try and leave, like you were saying, the medieval warm period out. They try and flatten the curve and then show that there's this warming happening. But if you look at the trend longer, it flattens out itself.
So let's see. I was going to show you, I had a graph here of, for example, the warmest periods of the, say, the last century. And yeah, here we go. Let's see here. So let's do a screen share. And we'll look at this. All right. So are we seeing this? Okay, U.S.
Yeah, we're in your president. There you go. Yeah.
High temperature records by state. And we can start the state, in alphabetical order, starting here. And here's your record high temperatures.
There we go. That's what I was talking about. So 1915 to 1940, that kind of thing. 1950 is the latest. Oh, no, there's one in 94 there in Arizona.
And 96.
And 95, yeah. But most of them are...
Or 95, yeah.
Well, yeah, Connecticut, you had the record set in 1995. But yeah, look at the rest of them.
Yeah.
1925, 1915. You had Arizona in 1994, Arkansas, again, 36, 1913, 1888. This is going down to Illinois. If we continue on here, starting with Indiana, again, 36, 34, 36, 30, 36, 1911, 1936, 1975, 1936. You see there?
Yeah.
What this is. Now we got Nevada, 1994, New Mexico, 1994, Oklahoma, 94, but all the rest of them, when you look at it, I put it in the form of a graph here. And
there we go. Yeah.
State high temperature records by decades. The last record set was Connecticut in 1995. In 2006, South Dakota tied its all-time record high up from 1936. As of November 2009, no state high temperature records have been broken for 14 years, and that still holds true today.
So I know that there's a manipulation of stats, and you can pretty much take, I mean, that's just the highest temperature record. So are they taking maybe some averages or some, I mean, you can slice it and dice it and find almost whatever you want in there. I mean, they can probably say, oh, well, there's an average seasonal high, or average overall is lower or higher than it was.
Well, yes, but to me, this is just pretty much stark depiction of
the highest one. Yeah.
It's highly unlikely that you're going to have the repeated setting of, particularly during the 30s, of the highest. In other words, half of the 50 states had all-time high temperature records in the 1930s.
Yeah, right. So that's what kind of scares me. I mean, why they're talking about blocking out the sun right now and net zero. I mean, there's all these long-term plans that they're seriously considering, and yet, if you look at those things, it looks like it's not getting hotter from at least 100 years.
Well, yes, that's exactly what it looks like, and I think I'll do another share screen here because this is one of my favorite graphs. Which takes us back. This one is the first one I'm going to show you is a sea surface temperature graph, which is a proxy for global climate change. And what it does is it displays a regular succession of glacial and interglacial ages throughout the Quaternary. So let's go to that graph, and then we'll go to the ice core graphs. Share screen. There we go. Share. All right, so if we go back, the time times 1,000 years, this is 400,000 years ago.
Okay.
And this is the present. Now, This is an older graph, but it's somewhat smooth because there are a lot of smaller oscillations that are not showing up in here, but the overall trends hold true. And what we see here is the troughs are basically full glacial ages, and the peaks are interglacial ages, such as we're in right now. And you can see that the climate here is constantly oscillating back and forth.
So can you explain what that 25 and the 30 is then? Is that degrees Celsius?
Celsius, yes.
So that's what is that number when it's like at 100,000 years ago? That's at an average temperature of that, or where does that come from?
Well, this is from the ocean. This is from sea surface temperatures.
Yeah.
Now, sea surface temperatures are going to be an indication of the overall temperature.
Yeah. So is that an average sea surface or a max? Or
an average.
Okay.
Average sea surface temperature.
Okay.
The red line is the present warmth.
Okay.
So what you see here from 400,000 years is that really our modern day warmth is exceptional. And it's interesting that the end of the ice age, which, this would have been the last ice age right here, this trough. And we're going to look at another graph, which will show us in greater detail, and we'll see with a much finer resolution. Now, this is from Greenland ice cores, which were extracted between 1988 and 1993. And let me explain what we're looking at. Relative oxygen isotope ratios, as it shifts to the negative, that essentially means that it's getting colder, because it's looking at oxygen 16 and oxygen 18. Oxygen 18 is the heavier isotope. So or oxygen 16 is the lighter isotope. So what happens is in periods of warmth, you will have more oxygen 16 evaporated from the ocean and more will stay back. When it cools down, even more so, even that changes even more the ratio, the balance of O18 to O16 that gets evaporated into the atmosphere and then gets precipitated out as rain or snowfall. In this case, it's snowfall. So the snowfall entrains the ratio of oxygen 18 to oxygen 16. And so climatologists can look at that and understand that changing oxygen isotope ratio is a proxy for changing temperatures. And this has been more or less correlated and proven by proven by correlation with other proxies. For example, when we talk about the Younger Dryas, we're talking about a polar wildflower, Dryas octopetala, that, for example, existed in Northern Europe during the cold of the Ice Age, and then it disappeared. Right now, Dryas octopetala is a cold-loving plant. It doesn't do well in warm weather. So you can look at the fact that there's pollen produced by Dryas octopetala, extensive pollen. That tells you then that that was a cool period of climate. Now you have another layer on top of that where there's no pollen from the Dryas octopetala. What that tells you is now is the climate has become too warm for that cold-loving plant, right? So that's an example of how you can now correlate proxies. If you look at the oxygen isotopes suggesting, this suggests that the northern hemisphere became colder. And then you're looking at the same time, you see an expansion of Dryas octopetala, that sort of correlates and confirms. So what the climatologists do is correlate a lot of different proxies to come up with a record of global climate change. This one is based upon ice core records that were extracted, fully extracted and analyzed by 1993. And this was one of the first reports that came out. And if we go down the right-hand side of the column here, this is thousands of years before present. So it goes down and it ends at 10,000 years.
And it looks like it's really fucking off to the colder there at 10,000 years.
Yeah, see how it's shifting to the left? Yeah, because it's what's happening here is the planet is coming out of the ice age right here. But I want you to notice a couple of things. Let's see if I go back here. You'll notice that the amplitude of these oscillations during the Holocene is increasing as we move towards the present. I don't know if you can see this here.
Yeah,
I think it'll
a little,
it looks like
bit.
it's getting a little more
bit.
erratic every millennium.
Okay, here we go. So let's put a line in there just so we have a reference. You'll notice that coming out of the Ice Age, the planet was actually somewhat warmer. Let me put there. I put the line at the modern level. So what you see here is that the early Holocene was called the climatic optimum.
Oh, it was a little bit warmer. You can see that. Yeah.
Yes. There was one exception right here, this 8,002 to 8,300 cold snap, where the climate, this represents about a 3 to 4 degree drop in global climate right here.
Over what kind of time frame do you think?
Oh, probably 2 to 4 centuries.
Yeah.
Wow.
And then
where are they
I-
getting this data from? Is this from ice cores? That's from
Yes, this is
oxygen
from
isotopes in ice cores?
This is the summit of Greenland.
I see. Okay.
It's two a European team and an American team both extracted these long cores that reached to bedrock between 1988 and 1993. They were pretty close to each other. They were in the center of the ice dome of Greenland because previous ice cores had been taken too close to the margin and where the ice flow was more dynamic. And so it was harder to get the kind of precise resolution needed to come up confidently with inferences about climate change. So the idea here was to extract these ice cores from the stable part of the ice sheet. And the earlier ice cores had, in fact, suggested that there had been some very rapid fluctuations in climate, much greater than had been previously recognized or assumed. And the problem, again, though, was the problem of resolution. And so part of what this program was, the GISP and the GRIP programs, Greenland Ice Sheet Project and GISP, GISP, Greenland Ice Sheet Project. I don't remember the exact terms for the acronyms, but it was the European and American teams. They each extracted cores, and then the analysis of those cores is still ongoing. But by 1993, enough had emerged to begin to compile a graph like this, what you see here. And of course, what you do see here is repeated oscillations of about a degree or two throughout the entire Holocene. You don't look at this is not a flat, smooth curve. This is constant oscillations.
Right.
Now, the critics would say, well, this is just Greenland. Well, which is true. However, Greenland is not going to be something that's, changing and fluctuating in total isolation from what's going on in the rest of the Northern Hemisphere. And there is enough evidence now to show that, yes, there's a very strong signal of the Younger Dryas in the Southern Hemisphere. Right? So we're actually looking at a regional effect, but it's part of a global phenomenon. So you can see there, though, that as the trend is downwards, as the climate is getting cooler, the oscillations are increasing in magnitude. You can see that? It's pretty obvious.
Yeah.
If you were to smooth this 8,300 year ago event out, you could see it very clearly. And then right in here at about 4,000 years ago, which is actually a period, it varies depending on where you are in the world, but somewhere between 4,000 and 5,000 years ago, there was a climate shift that is referred to as the Neoglacial.
Right.
And so you had the hypsothermal, which was the climatic optimum, which is generally conceded by those who are studying it to be as much as a degree, 2 degrees, even 3 degrees warmer than now.
What's the green line right now again? What's the green line?
The green line would be is the modern temperature.
Okay, yeah.
Okay. So basically what you've got now is as the climate is cooling, the magnitude of the oscillations is increasing. But where it gets really interesting is when you take this graph and you go back to the beginning of the Holocene, and then you extend it back a couple of 100,000 years.
That's what I want to see, yeah.
This is where it gets crazy.
You look at the magnitude of these climatic oscillations compared to what of the last 10,000 years. And yeah.
Wow. See, that's a great way to just cover that up until you see this is what we're talking about.
Okay, so yeah, now here's the problem. Nobody is yet able to explain what's going on here. Now, given that 200,000 years of pre-Holocene climate change is occurring at inexplicable rates and magnitudes, and we can't explain it, to me, it just underscores the lie that the debate is over.
Exactly. When you look at that and you look at where we are right now, how can you ever say what is causing anything in our age? I mean, it just doesn't make any sense. So what's the 3,000 then? That is, how far back does that go? 250,000 years? Is that what you're saying?
250,000 years, yeah. That's pretty much to the bottom of the ice core. So,
wow, look how warm it was like 120,000 years ago. What's that, like 10 degrees warmer than it is now?
Yeah, I mean, that's some phenomenal. That was a period called the Eemian, which was often considered to be an analog for the modern warm Holocene, except what is now known of the Eemian is that, yes, it was a warm period, but it was extremely chaotic. And within the 10,000 to 15,000 years of the Eemian, there were these, it was very much warmer. And as you can see right here in this graph, but within the Eemian, there was some enormous climate spasms and oscillations as well.
Is there any evidence to what was happening in our culture way back then? I mean, I know they're finding, humans that go back farther and farther now to 180,000 years, I think they're saying. Yep. So I wonder what happened, with the fauna or us as,
Well, the faunal extinctions occurred.
Yeah, way over there.
Right in here.
Yeah.
I think I've got a...
But I mean, I wonder what it was like back then where it was so much hotter.
Okay, so here was the end
of
the
ice
age. Now, notice this is the first warming event, which occurred about 14,600 years ago. It was followed by the Younger Dryas cold event, which is this right here. And then there was a second warming event, and that brought the planet up out of the Ice Age into the Holocene warmth.
Right.
So right in here is when the mass extinction took place. It also was the disappearance of the North American Clovis culture. And it's right in here at about 12,800 to 12,900 years ago that the impact proxies are being found. the nanodiamonds and the magnetic grains and microspherules and iridium layer and platinum layer. Osmium has been found there. All of these are extraterrestrial metals that have been deposited right here, pretty much at this cooling period right here. Well, right here at this bracket right here, you see.
Yeah. So
there were two extreme warming events, and the Baaling Alarod was at about 15,000 years ago. Then there was this first warming spike, which was, I would conjecture that this was associated with the first great catastrophic melting episode of the great ice complexes that yielded the first big mega flood events. And then, see, at 11,600, here's the Younger Dryas, and then at 11,600 years ago is what we now consider the beginning of the Holocene. Now, notice if you look at the trend here, down here, and up here, if we were to take this out,
it was headed that way anyway.
You can see, yeah. So it was headed into global warming naturally, and then that got interrupted by this whole thing right here.
What do you think would have happened? So let's assume none of that happens and it just progresses naturally. Where do you think the ice sheets are right now without those massive spikes? Do you think they would be in the same place, or do you think they'd be bigger?
Oh, the ice sheets? That's, it's hard to speculate on that. I think that what would have happened is the ice sheets were already beginning to retreat here. And then that retreat was interrupted first by a massive meltwater spike, and then returned almost full glacial cold, which terminated the reduction in ice mass. And then that was followed by a second period, a second episode of warming. And then you had residual ice masses after this that probably lasted till 7,000 or 8,000 years ago. That it took that long for the residual ice. The ice, you see, if you understand here, there were massive collapses of the ice sheet because of all of this going on. And normally glaciers are going to be, you could think of living glaciers and dead glaciers. Living glaciers, there is an accumulation zone where the snow is falling, it's becoming impacted. It
shifts seasonal, it shifts up and down.
Yeah, seasonal, it shifts up and down. The glacier ice is like almost a living thing. It's flowing, it's accumulating, it's flowing. There's a zone of ablation where the ice lobe is melting back. And like Graham just said, there will be a seasonal oscillation from year to year, but then there will also be greater oscillations superimposed upon that, because if the climate is warming, glaciers are going to shrink back. And, the climate now, there's also the, what are referred to as the Milankovitch forces,
cycles,
which you're familiar with that, right? It's the changing orbital geometries between the Earth and the Sun that will cause greater amounts of thermal energy, sometimes lesser amounts of solar energy, due to the obliquity of the ecliptic, the precessional cycle, the ellipticity of the Earth's orbit. Those three parameters are constantly changing, which is bringing the Earth sometimes closer, sometimes farther away to the Sun. Sometimes the northern hemisphere is tilted towards the Sun, sometimes away. And all of these factors interact, and sometimes they'll produce a gradual warming and sometimes a gradual cooling. That's probably what we're seeing right here.
Right. And now there's more evidence that those warmings do align with possible impacts. So, I mean, the one takeaway I would get from looking at that, if we work on the assumption that those were caused by impacts, it seems like it's pretty hard to shake up the climate from what it wants to do. I mean, if we take that those two spikes are impact related, then even a couple of big rocks from space couldn't really shake the climate off where it was headed anyway.
Well, we don't. The evidence for impact is right here at the Younger Dryas. But at this point, there's no evidence for impact, for example, at the Baaling Alarod, the beginning of the Baaling, which was 14,600, when that first meltwater spike occurred.
Okay.
Could there be an impact? Maybe, but maybe it is because if there was an impact here, the proxies that were preserved in the sedimentary record maybe got more or less erased by what followed.
Yeah.
Have you heard them talk about the missing ice problem at all in sort of contemporary climate change narrative? The missing ice problem?
I don't think I'm familiar with that.
Okay.
What is that?
I'm not sure. I just heard about it tonight, and I think it's something to do with the oceans didn't empty as much as they thought with the glacial change or something.
Okay.
But I don't really understand where that's coming from.
I'd have to look into that more. So here is from an editorial in Nature, April 1993 by
okay.
Richard Fairbanks with Lamont Doherty Earth Observatory. Now you got to bear in mind that half a century to a century earlier, they're thinking 50,000 years. And what has happened is it's continually shrunk the amount of time that it takes to shift the planet from full glacial mode to interglacial mode. And now here's where it's gotten to by 1993. From measurements of annual ice layer thickness over the past 15,000 years, the authors find that Greenland's climate, emerging from the last ice age, twice shifted from glacial to interglacial conditions over an astonishingly quick 3 to 5 years.
3 to 5 years?
3 to 5 years, yes. So you're looking at a 3 to 5 year event here. This is the twice that they're talking about right here. The two extreme global warming events.
Oh.
Over an astonishingly quick 3 to 5 years.
Oh, wow. So that shift is very fast then, yeah.
Oh, yes. Okay. Now, this is from a completely separate body of data. This is studies from the ocean level rise, sea level rise, from the time of the late glacial maximum, say at 18,000 years ago. If we look at this time graph at the bottom of the x-axis on the bottom, the 0 is the present. Based upon Milankovitch forcing, this dashed line would represent an acceleration of glacial melting, of sea level rise, which of course is a measure of glacial melting, right? So the idea here is that, so the insulation curve based upon Milankovitch forces is this dashed line, smooth curve rising and then peaking at about 10,000 years ago and then slowly coming down and then reaching the modern levels at basically a century or two before the present. However, the actual curves of sea level rise look like this. So you have meltwater pulse 1A, meltwater pulse 1B. Now, the green and the purple basically represent the time range.
Possible time range.
Right. So meltwater pulse 1A is dated from 14,500 to about 13,000 years ago. At the time that this graph was compiled, this is going back to the 1980s. But these two meltwater pulses would be almost certain to correlate with these two warming spikes, which would make sense.
And it lines up with the Milankovitch cycle too, that's the sun, right?
Well, this is the Milankovitch cycle. This dash line. So
here. We would expect to see melting, but probably
we would expect to see melting,
not that erratically.
Right, and there's no right. You would have had a smooth curve of sea level rise over a period of over a period of about 7,000 years here. And then over a period of about 10,000 years from then to now. So a smooth rate of sea level rise. So over here on the left side is the apparent discharge rate in cubic kilometers per year. So in other words, the amount of ice is melting. It's increasing steadily, slowly until about 11,000 years ago. And then it starts, tapering off. But what really happened was that there was these massive spikes of meltwater.
What about the cycle before that, the Milankovitch cycle before that?
Well, I don't have anything on that. And I think there have been studies done, but they're extrapolations, and I don't know how precisely they have been correlated with actual proxy records of what was going on. Like, for example, I know there's been studies looking at the Eemian and that period of extreme warmth that we saw around 115,000 years ago on the previous graph. I haven't looked at those studies, so I don't really know what they've come up with. But
it's interesting nonetheless. I mean, it's interesting to see that mapped over the cycle.
Right, and see the solar insolation curve in calories per square centimeter per day would be a function of the Milankovitch cycles. And so what you see here is that the sea level is rising as the solar insolation is rising, you see. But what you really see, this is a theoretical curve, but this is the actual curve that doesn't look anything like this nice smooth increase and decrease.
Right.
And the solar insulation is, I guess, insulating us from losing heat into space, or vice versa?
That's the amount of sun's heat falling upon the Earth.
Getting into the Earth, okay.
As a result of the changing Milankovitch.
Which has a combination of angles and this and that and everything else.
Yes, the idea that the elliptical shape of the Earth's orbit means that sometimes it's farther away from the sun. Like right now, the Earth is actually closer to the sun on January 2nd. Right? So if it was reversed and the Earth was farther away from the sun on January 2nd, that means we'd have colder winters than we do now.
And warmer summers.
And then also the fact that, when the northern hemisphere is tilted towards the sun, there's more land relative to ocean. This has a because the land has a higher albedo than the ocean, it's going to be reflecting more.
So that would be the same idea as almost like the urban whatever thing, is the land has that effect.
Yeah, the idea of the Milankovitch is that you're going to have these gradually shifting amounts of solar radiation impinging upon the Earth. And the amount of solar radiation getting from the upper atmosphere down into the lower troposphere where it can warm and warm the oceans and so on. And those cycles are changing very, very slowly. The precessional cycle is, 26,000 years. As an example, I think the obliquity of the ecliptic is over 100,000 years. So
wow.
What that means is that these are going to be gradual changes. The gradual changes of the Milankovitch cycles do not explain spikes like we're seeing here.
I think I've seen you show graphs before going back even further. Like, do you have any that have the ice ages through the millions of years at all handy? Or
well, that was pretty much what we just saw.
Right,
I mean, going back to 250,000 years, there's evidence now that there was, ice ages like 4 million years ago. The last big surge of ice was probably 40 to 50,000 years ago, and then it shrank back quite considerably until about 26,000 years ago. And at that point, which is called the late Wisconsin, the ice began to rapidly expand for the next 5,000 or 6,000 years. Then it began to gradually contract, and with certain interruptions. And then that gradual contraction was interrupted by the Younger Dryas.
Is there anything showing what the carbon dioxide levels were like during these cycles or during this timeline? That
Yes, two sources. One would be the.
Unless you want to show us that graph first,
Well, we can talk about your question.
Okay.
The carbon dioxide is generally assumed to have been around a couple of hundred parts per million, which is based upon ice cores. Now, again, the amount of carbon dioxide trapped in bubbles in ice cores, which is assumed to be a proxy for the ambient concentration of carbon dioxide in the atmosphere. And let's see, I could actually address that.
I thought there was a time when the temperature was much higher and the carbon dioxide levels were lower. Or was it or maybe it's opposite. They were higher, the CO2 levels were higher and the temperature was lower.
Yeah, I think that's what you're talking about. But let's see here. We could pull up, see what I've got here.
Well, carbon dioxide's not even the biggest greenhouse gas. It's
Water
vapor, right?
According to NASA, the global climate is greening still. I mean, you see the NASA's graph on it greening, right? That we are getting more green on the Earth.
This is trouble. They don't want that.
They don't want that.
No.
They don't want net zero. Get to net zero. What happens when we get to net zero?
There's too many guys already, and now it's going to get nice again. And
Okay. Well, okay, so this is a graph taken from an Antarctic ice core called the Sipple core, carbon dioxide in the Sipple core. Here's your x-axis down here is the depth in meters. And what you see here, this is your curve is your parts per million of carbon dioxide. And over here is the pressure in bars, which is the pressure of the overlying ice. Now, what you see here is as you go down, you're down here to about 325 parts per million here at this depth of 70 meters depth. When you get down to 180 to 200 meters depth, you're at about 275 parts per million. And that's this from this one ice core. So based on the ice cores, you can look here, 275 to 375. But what this is suggesting, here as it says in the caption here, the concentration of CO2 in the ice core from Sipple, Antarctica, decreasing as a function of depth and load pressure. Note that the right axis scale is negative. It is adapted from Neftel et al. 1985 and Jaworowski et al. 1992. Let's go on here. Here's two sets of CO2 concentrations in gas recovered from the Byrd ice core, also from Antarctica. And we go back again, here's your depth, your assigned age, 1,000 back to 40,000 years ago, right here. And here it shows the assumed fluctuation in the amount of carbon dioxide. Now, what's really interesting here about this is when you look at this, you're looking here, over here, you're looking at 20,000 years ago. You follow this over. You're looking at carbon dioxide down to 180 parts per million. Now, you know what happens at 180 parts per million? Basically, photosynthesis is in the process of shutting down.
Where are we at right now? 400?
400.
Yeah.
We're right, 400. But now, see, and here's the thing. Look at the ranges of the error bars on some of these analysis here. Look at the error bar on this. And where it's now, this is going back to 2,500 years ago. And here's the mean of that. And look what it's suggesting. Over 400 parts per million. Like for whatever reason, there was a major spike in carbon dioxide into the global atmosphere.
Does that correspond with the volcanic eruption or anything like that back then, or
maybe, or some outgassing from the ocean? I don't know. I don't know what would have caused that. But again, and then you go back to like 4,000 years ago. If you see again, here's your assigned age at the bottom. Mm-hmm. Come up here, look at this here. Now here's the mean at 300 and about 310 parts per million. But the error bar goes all the way up to 400 parts per million. In other words, what that's saying is that the amount of CO2 could have been anywhere within this vertical line here. So, I mean, if you look at this, what you're seeing from this ice core itself is that the amount of carbon dioxide is changing quite dramatically.
And what was happening when it was down to 180 about 15,000 years ago?
Well, that probably was not a very pleasant time to be alive.
Like the megafauna, was that when the megafauna got?
Megafauna were
a little after that?
Prospering at that point,
yeah.
But at that was when they began to decline.
Yeah.
And then they were pretty much wiped out by the Younger Dryas. So here from 1999, century-scale shifts in early Holocene atmospheric CO2 concentration. And this is talking about another way of determining how much carbon dioxide is in the atmosphere here. The inverse relation between atmospheric carbon dioxide concentration and stomatal frequency in tree leaves provides an accurate method for detecting and quantifying century-scale carbon dioxide fluctuation. Stomatal frequency signatures of fossil birch leaves reflect an abrupt carbon dioxide increase at the beginning of the Holocene. A succeeding carbon dioxide decline matches the pre-boreal oscillation, a 150-year cooling pulse that occurred about 300 years after the onset of the Holocene. And that pre-boreal oscillation, we saw that in the graph, that spike, that downward spike, right? Remember?
Yep.
Okay, in contrast to conventional ice core estimates of 270 to 280 parts per million by volume, the stomatal frequency signal suggests that early Holocene carbon dioxide concentrations were well above 300 parts per million. So what this is that the stomatal density in plants is a function of how much carbon dioxide is in the air. So if there's a lot of concentration, if there's a let's say a decline in carbon dioxide, plants, their stomata open up to bring in more carbon dioxide because carbon dioxide is the fuel of photosynthesis. Without carbon dioxide, there's no photosynthesis, right? If there's no photosynthesis, the whole bottom of the food chain basically goes extinct, right? When you get to 180 parts per million, we're talking about a major deficit in carbon dioxide, if that is in fact accurate. But when we get to the stomatal density, which is another way of determining ancient carbon dioxide concentrations in the atmosphere, this is to be compared with the the proxies that have been derived from ice cores. So on the one hand, you've got the ice cores and the bubbles entrained within those ice cores, and you look at the amount of carbon dioxide that is in those ice cores, and then you extrapolate from there. Now, bear in mind that these ice cores are about 5 inches in diameter. And if you go down 1,500 meters and you pull up an ice core and you take one layer and you go, okay, this was X number of thousand years ago, let's take this air bubble from that, and then we'll look at how much carbon dioxide is in that air bubble, and then we'll assume that that's the same amount of carbon dioxide in the entire globe.
Yeah.
So it's a big leap. Right?
Yeah.
Now, when you get to the stomatal density in leaves, you can, and I'll show you some pictures here. You'll see in a second. Okay, but it paints a different picture. So this was a study done from 1939 to 1941. The CO2 concentrations in Germany, and this is based upon stomatal densities. And look here. Here's your CO2 in parts per million, right? So now if you go back in days and decades, so this is basically the period of 2 years, right? And look at the concentrations of CO2 is not holding steady. It's quite dynamic. Mm. And then we actually look at this peak right here that would have occurred around 1940, come across 550 parts per million. Was that the global average? Probably not. But in this one particular area, it's way above the presumed global average, and you'll see that it's look you follow
5
this
years
here.
later. 5 years later, it drops significantly, almost in half.
Yeah, down to 340 parts per million.
You think that's got something to do with the end of the war?
Comes back up here to 460 parts per million. Here's another study based upon leaves that were dated from 1863 to 1864. This is in the Baltic Sea area. And again, what we see here is the carbon dioxide concentrations are fluctuating pretty wildly. And we see this peak up here is showing 400 parts per million, which supposedly we did not exceed until within the last decade. But here it is showing back in 1863, 1864, that you've got numbers up there equivalent to what we assumed late 20th and early 21st century.
And then the temperature graph in the bottom right-hand corner shows that it doesn't look like there's a correlation between temperature and CO2 levels?
Yeah, this is the temperature of the IPCC, and this is showing at 1860 right here and 1880. So, yeah, so you can see that the graph from the IPCC is very smoothed off and does not show these dramatic oscillations here. Here's CO2 concentrations in the Northern Hemisphere from 1812 through 1961, determined through chemical analysis of the actual atmosphere. This is hundreds and hundreds of chemical analysis. In other words, taking actual atmosphere and analyzing the amount of CO2. And
this is the average of all the different measurements?
Yes. So we go back, look, when we go back to 1820, they were measuring 450 parts per million in the atmosphere.
Wow.
And then it goes down, comes back up a bit, goes down, but then comes up again in the early, from the 1930s to the 1950s, and then declines again, and then, of course, would rise, presumably, into modern times. But this graph ends at 1960, so we don't know. Here's another one, CO2 concentrations in the Northern Hemisphere from 1920 through 1961, determined from chemical analysis of the actual atmosphere, contrasted with ice core data from the same period. So here's the actual, in other words, taking actual samples of the atmosphere from 1920 to 1961, right? And you'll see here, look at here, again, you have like that same period in the early 1940s showing up to 470 parts per million, right? So, and then it drops, then it comes up again in the late 40s to 430 parts per million. Now, the amounts of CO2 in the atmosphere from the ice cores at the same time is this graph right here. So in other words, look at the difference. Going back, looking at the bubbles taken from the ice cores during the period from 1920 to 1961, this is what the ice cores are showing for CO2 concentrations. But so there's a major discrepancy here.
Yeah.
And I don't know the explanation, the final explanation of that discrepancy. However, what we can say without any qualms is that this discrepancy could be very significant in terms of, declarations about, the status of carbon dioxide in the atmosphere.
Affecting temperature.
Yes, exactly.
Yeah.
And why, and also it should bring into question the accuracy of the ice cores. If we go back to here, this first graph that I showed you, what this is showing is that the amount of CO2 is related directly to depth, which is related directly to the amount of pressure. You see, so it could be that in the ice cores, you go down, and once you get down to a depth of about 180 to 200 meters, the pressure is such
it starts to level off or something. Yeah.
It starts to level off.
Yeah.
Right, at about 260, 270, 275, 280 parts per million. So these are all legitimate questions that the IPC chooses to ignore, and most people are totally unaware of the fact that these studies have even happened. Good question.
Do you think Go ahead, read that, yeah.
Well, has the amount of carbon dioxide in the atmosphere changed significantly since the beginning of the 20th century? Well, it all depends on which proxy you use.
And it seems like either way you look at it, it's hard to say that now in our contemporary recent levels of 400 parts per million has anything to do with increased temperature, right? Would you say that it's fair to say that? Yeah,
that's fair to say, yes. Yeah. As this study says here, there are processes which may deplete the increased concentration of CO2 produced by combustion, and others which may be more important than combustion of fossil fuel in increasing the concentration, at least temporarily. Calendar, upon whose work a lot of the IPC bases their assumption, does not consider them relatively important. But it seems logically tenable to suppose that a relatively slight increase in the rate of biologic absorption of CO2 might nearly or even more than compensate for any increase in its evolution from other sources, such as industrial combustion.
Can you decipher that for the layman?
Yes. What it's saying is that slight increases in the amount of biological uptake of CO2, a slight increase in the amount of CO2 taken up by plants and trees and vegetation could easily compensate for the increased amount of CO2 put into the atmosphere by other sources, including industrial combustion.
Right.
That's what it's saying.
So what is your thought about the net zero push? I mean, they're really trying to get to net zero, like no more carbon in the atmosphere.
I think that's totally insane, personally.
Yeah. Is it scary? Does it make you wonder about the intention? I mean, and then what about Bill Gates seriously talking about like his symposium or whatever it was, his trial in Arizona was kind of disrupted, I believe, by a bunch of protesters. And now he's moving it to Sweden to do tests on spraying I mean, they're still talking about it now to get rid of the sun for a bit. Not get rid of it, but to block out the sun enough to try and cool the planet. I mean, doesn't that seem insane if it's not really a problem?
Yes. Yes.
I mean, what are they like? How are they getting away with this? I mean, isn't the ramifications from that completely disturbing? I mean, what if we're not really warming as much as they think, and we slip into deeper cooling? What if it works and it does cool? I mean, it's just mind-boggling to me that they're getting away with this.
Well, what we just in a little bit we've looked at here, you've seen that the natural climate changes are extraordinary.
Yeah.
And, when you decide that you have basically what the IPCC has done, it's a thoroughly politicized body that's convened to support a preordained conclusion, which is that humans are causing climate change, right? And so the whole process is flawed right from the beginning. You have scientists, right? But the science is totally subordinated to the political agendas involved.
Yeah.
I've written a whole discussion on that. I can actually quote from it here if we want.
Yeah, sure. But I mean, what about I mean, I agree with you. This is happening, but it's hard for me not to go to why are they doing this? I mean, it just feels like there's an ulterior motive that's way more evil than just carbon credits and taking over the global economy with some kind of organized structure.
Yeah.
It feels a little risky for that, Yeah,
I think that I'm going to stop share for a minute. Yeah, clearly there's an agenda here, and I think it's basically an agenda about control. And we can really already see the correlations being drawn between the lockdowns of, the COVID pandemic with, because a lot of claims are now being made about how, CO2 emissions have been reduced because of the lockdown.
Yeah.
What a great thing this is.
We need a couple lockdowns a year.
Yeah, so I tell you what, if we can reduce CO2 emissions by 6% in the last year, which is I think what the number is, well, gosh, why don't we just lock down permanently?
Or rolling lockdowns every month or every month a year or something.
Yes. I mean, this is what they're actually looking at, these ideas now, which you really, I mean, it's a fair question what you're asking. What is the agenda? And I think it's just the agenda amounts to total social control, a centralization of dictatorial authority. There's an agenda. If you look at the specifics, like the Green New Deal, it's basically a Trojan horse, and it's about using the climate crisis in order to impose a collectivist system on America.
Yeah.
And
the world.
Even the world. Yeah.
I mean, Canada's at the spear. I mean, our guy just pushing straight forward, build back better. I mean, that's what he wants. That's what they want. But the fact that that so many people are on board with this, and they keep talking about climate change, and every little weather event, every little migration problem is blamed on this extreme climate change, and we got to lock down, we got to stop flying, we got to do all this stuff. I mean, it's mind-boggling.
Well, the idea is to basically shut down Western civilization in order to save the planet from a non-existent climate crisis.
Yeah.
I mean, if we want to put it in bald-faced terms, that's it right there.
And that's not saying that we don't agree with pollution, like the problem with pollution and the environment and all that. I mean, like this is the thing. I mean, we all think that we need to take care of the environment, and
we absolutely have to be good stewards of the environment. And I mean, when you think about the millions of tons of plastic that are in the ocean, for example, that's a very real problem that can actually be seen. It's a tangible problem. It doesn't depend on Byzantine abstract computer models, right? That can be pretty much programmed for whatever outcome you want.
Yeah.
Right. So, yeah, the whole thing it's really not ultimately about saving the planet. It's about imposing an agenda, and I think it'll have the exact opposite effect. In fact, we're going to need our industrial civilization to prevent the things. See, when we start looking at these proxies, well, what makes that possible? Well, what makes that possible is the fact that we have an infrastructure in place that's based upon real science, that's based upon, our industrial economy that allows us to mine the metals, to build satellites, to put satellites in orbit around the Earth that we can now monitor changes in sea surface temperatures, in vegetation, in all of that. Without industry, none of that exists because we have no basis for creating the infrastructure of modern civilization. And so what this whole Green New Deal is saying, well, we can, shift over to wind and solar, but, hey, how are we going to mine the metals that are needed for the tremendous wind turbines that are, using toxic metals like cobalt and, that require huge, you're not going to mine the materials to build solar collectors and the battery components for storage of energy and the great, the tremendous amount of metal in the wind turbines without heavy equipment to dig in the earth and mine that material. It's like, don't you guys that are promoting this ever think about that and how much fossil fuels it's going to take just to extract the material from the earth that's going to build the wind generators? It doesn't even seem like that's on the radar screen.
I heard there was a new study on solar power farms, where, obviously they gather a lot of heat, but transmitting the heat is a different story. They're not very efficient at doing that. And they're gathering this heat around and creating this sort of hotter climate in that area, which is causing more plant growth, and they're causing some sort of jungle desert kind of phenomena around there.
Jungle desert?
Yeah.
Sounds great.
Yeah.
That's a new one
Burning
for me.
Man 2.
Jungle desert. But we can certainly talk about, the evidence for the greening of the earth. But I thought I would show you an interesting graph here. Let me pull it up, and then we'll go back to screen share. This is carbon dioxide concentrations.
Oh, yeah, that's the one I was thinking of, yeah.
Yeah, I thought you might be thinking of this one. This is a good one. This is millions of years before present.
Yeah.
So we're going way back. And what you see here is your temperature is the blue line, and your carbon dioxide is the purple line. So as you see here, there's very little correlation between the two.
In fact, it seems like it's so all over the place that there can't be. I mean, it's low when it's high, then it's low when it's high, then it's the same. I mean, it's really all over the map.
Yeah, that's exactly it. And some of these CO2 concentrations, really back in the day, were up to 7,000 and 8,000 parts per million. 7,000 and 8,000 parts per million, and in fact, when we look at this particular graph, what you see here is that the CO2, other than this period right here, from about 290 million to 245 million, what you see, look at the purple graph. What this is telling us is that in the last 4.5 billion years, the lowest concentration of carbon dioxide has been in modern times.
Oh, wow.
So when you talk about, the carbon dioxide is higher than it's ever been now, well, it all depends on your time frame, your perspective. You see, if you're looking at the long view, No, it's lower now than it has ever been.
So why? So let's just break that down a bit. So the low area at the very back of the scale in the Cenozoic, how high is that in parts per million?
Where back here?
No, farther back in the Cenozoic there. Right there where you're.
Well, this is modern times right here.
Oh, okay. I see. I'm looking at it backwards. Right. So what you're saying is that's the lowest. All the way back, it's been higher, higher, higher. Yes. And when it was very high in the Precambrian, the temperature was very low.
Yes. There you go.
And I mean, even just looking at
correlation at all.
And even just looking at one or the other. So the purple one is all over the map. And then look at the blue temperature one. I mean, going back and look at this fluctuations over the years. And then in our little modern time there, I mean, it's mind blowing. Mm-hmm. If you look at that, how can you say that we can measure what we're doing to affect it properly at all? I mean, and I'm not saying we're not affecting it either, but I just feel like I don't like the measures that are happening, the measures that are taking place.
Yes, and as I wrote here, one thing that becomes apparent from studying this graph is this. Throughout the Pleistocene epoch on Earth, the period encompassing the past 2.6 million years of ongoing glacial ages, carbon dioxide concentrations have been at their lowest in all of Earth history since Precambrian times. Only since the end of the Great Ice Age, 11 to 12,000 years ago, did concentrations begin to rise from their depressed Pleistocene state. And only within the past century have they risen to more normal amounts when looked upon within the larger context of Earth history. The information presented in this graph inexorably leads one to surmise that the amount of carbon dioxide in the Earth's atmosphere has been preternaturally low throughout the Pleistocene, and that by releasing a small but significant amount into the global atmosphere, we human beings are in fact stimulating a revival of an impaired biosphere, an impairment resulting from a planetary disruption occurring 2.6 million years ago that initiated the cycle of increasingly erratic climatic and environmental behavior, which has continued to manifest as the repetitive lurching into and out of glacial ages.
Nice.
So
good summary. Do you have any questions, Darren?
Well, I was wondering, because you've been around and looking at this for about 40 years now, and I was wondering, so were you clicked onto this when the cooling scare was going on in the 70s? Were you?
Well, yes, because there's two things that you have to be cognizant of there. Number one, the cooling. There was an actual cooling of the Earth's climate from 1940s to the late 1970s. After that extreme warmth of the early 20th century and that peaked in the 1930s, the climate began to cool. So you had 30 years basically of a cooling episode, right? Now, what's interesting here is because this is occurring exactly when carbon dioxide concentrations are significantly increasing in the atmosphere, supposedly from fossil fuel consumption, right? Well, one would think that as the fossil fuel consumption is going up and there's increased release of carbon dioxide into the atmosphere, we would see warming consistent with that, when in fact we actually see cooling. So now that's one thing that was, and that's been verified, is still credible to this day, that yes, from the 40s to the 70s was a period of global cooling. Now, at the same time, radiocarbon dating has come on board, and they're beginning to realize that glacier periods come on a lot faster than anybody had previously imagined could happen, and a lot more frequently, right? So then the other thing that came as a result of radiocarbon dating is that the periods of warmth, interglacial warmth, such as we now see, it was becoming apparent. Now, bear in mind, in the 70s and 80s, we've got ice cores. And the problem, as I explained earlier, with those ice cores is the lack of precision. Yet, still the signal was present in those ice cores of enormous climatic changes. So one of the motives behind the enterprise of GRIP and GISP in the late 80s, early 90s was to confirm whether or not those apparent climate oscillations in the earlier cores were real. And in fact, as it turned out, they were real. Okay, so now with the ability to go back and begin reconstructing past paleoclimate, it became apparent that the interglacial periods, and this is still a fact, this hasn't changed, the interglacial periods were short-lived. Just as we saw in that first graph that I showed you from changing sea surface temperatures, what you saw was, you know, these very short-lived periods of interglacial warmth, such as the Holocene. Well, by the 70s, mid to late 70s, it was becoming apparent that there was no obvious interglacial period that lasted as long as the Holocene. And that is still the case today.
Yeah.
So now you could almost begin to see and understand why, okay, you're looking, climate's begun cooling while concentrations of CO2 are going up. So that's not jiving. At the same time, we're seeing that ice ages come on a lot quicker and go away a lot quicker than anybody imagined. And then at the same time, we're also seeing that the Holocene seems to be a period of unprecedented extended warmth, and that no natural period of interglacial period prior to this appears to have existed as long as the Holocene. So putting all that together, are we headed into another ice age now?
Thus, Dr. Spock on the TV show talking about the scientists wanting to spray shit on the glaciers to start melting them. I mean, this is the sort of the stuff they were talking about in the late 60s and the 70s. Now they're talking about the opposite. I mean,
yes.
Which is scary when they start jumping to conclusions like that.
But I would say that at this point, given what we know, the return to glacial cold really is much more of a concern.
Right.
We still don't know why
Yeah.
these previous interglacial periods came to an end when they did. We don't know why. What changed that? And I think, we need to be looking at the sun, seriously looking at the sun and other things. I mean,
what about volcanoes under the water?
Yes, volcanoes under the water. Even earthquakes are known to outgas huge amounts of carbon dioxide, right? I think that perhaps impacts are a much more important player in global climatic and environmental history than has been recognized until very recently. There may be far more impacts. Another possibility is the accretion of cosmic dust that could cause global cooling. An impact into the ocean that lofts tremendous amounts of water vapor into the atmosphere could cause a very short-lived global warming. Changes in the Earth's geomagnetic field, changes even on a galactic level, perhaps. There are many, many factors. The ocean currents naturally are changing because of things like plate tectonics and continental drift, and changing ocean currents have a dramatic effect on climate. Changing wind patterns that have really nothing to do with the amount of carbon dioxide in the atmosphere. Now, here's one way to think about this. If you're talking about parts per million, let's say we go back to the beginning of the Industrial Revolution and we say that carbon dioxide, let's say in the late 1800s, early 1900s, 300 parts per million. Now it's 400 parts per million. So we're looking at that the assumed increase, even in the worst case computer models, is 100 parts per million as a result of industrial activity. 100 parts per million. That means basically for every 10,000 molecules of air, the amount of carbon dioxide in the air has increased by one molecule. So think of it that way.
Yeah.
Now, is that one molecule increase of carbon dioxide, which is totally 100% necessary for plant health and photosynthesis, is that one carbon dioxide molecule relative to 10,000 molecules of air really going to cause a global catastrophe?
Or like Darren was mentioning, the other greenhouse gases, like the carbon dioxide being a very small percentage of the overall greenhouse gas.
Mm-hmm.
Yeah. And is that gonna,
water vapor, changing amounts, small fluctuations in the amount of water vapor, totally overwhelm the thermal capture ability of carbon dioxide.
Yeah.
So there's so much to this that, you know, the purveyors of the climate crisis and all of this and the agenda that goes along with it, first of all, most of them don't know this. I mean, Alexandria Ocasio-Cortez, I guarantee you, she doesn't know any of this stuff we're talking about. She's just taking what she's being spoon-fed by big government-funded science, right? And pretty much all of those on the left that are, you know, crying crocodile tears for the state of the planet, right? Because of nefarious humans' activity, basically don't know any of the science behind it. And we've just, barely touched upon.
Yeah, but it's not, I mean, I know they're the mouthpieces for the agenda, but what about the scientists that are all part of this? I mean, that's what worries me more is it's the scientific establishment and academia that are going along with this or pushing this because of their funding requirements whatever they want to keep things going.
That's where all the grant money is going, and there are plenty of dissenting scientists.
That's what I was going to ask you. So what do you think is there enough dissenting scientists to make a debate, an argument come to the public a little bit more? I mean, is this going to get to the point where people start to wake up?
I think it has to. I certainly hope it does, because we really need to have an honest discussion about this.
Yeah.
No question. We need to have an honest discussion because a lot of things are being pushed aside in order to put this agenda out there that, you know, that creates this false narrative that somehow everything was nice and stable, you know, pre-industrial, which it's complete fiction. What can I say? It's complete fiction. So if I go back to some of the founders, like, let's see.
That's a good idea.
Let's go back to some of these guys. Here's Hubert Lamb, wrote this in 1981. Now, he was one of the godfathers of modern climate science, and he wrote a book called Climate in History.
In history and history?
Climate and History.
Okay, yeah.
And this was the title of the chapter of the article in there, An Approach to the Study of the Development of Climate and Its Impact on Human Affairs. So, as I commented here in writing about this, I said that the work of Hubert H. Lamb is never referenced by proponents of anthropogenic greenhouse warming, since his views are so clearly incompatible with their assumption of climatic stasis prior to the advent of human influence. To the extent that they are now faced by the evidence to admit the reality of past non-anthropogenic climate changes, they must attribute such changes to some small, virtually non-discernible trigger that nudges the global climate across a hypothetical tipping point in order to justify the argument that a trivial increase in the CO2 concentration of the atmosphere is going to hurl the planet into an unprecedented climate catastrophe. Now, here's what Lamb said. Around 1880, 1900, it was apparent from the first 100-year series of weather observations that the climatic averages of that time were similar to those of a century earlier, and it therefore became conventional to treat climate as essentially constant. Accordingly, study of the development and possible changes of climate was given a very low priority, or more generally neglected altogether. Given these circumstances, it was natural that the general public and workers in other disciplines also ignored the possibility that climate might not always be so stable and climatic change might affect their affairs. Of course, this did not apply to occasional extreme events, but the incidence of these, it was generally supposed, could be treated as random. By 1950, however, it was obvious that the climate had been changing significantly even during the 20th century, though in ways which made things easier for most human activities in most parts of the world. Now, what he's saying back in 1981 is he's saying that the 20th century warming actually made it easier for most human activities in most parts of the world. There had been a general rise of prevailing temperatures with the recession of the ice on the Arctic seas and increasingly rapid recession of the glaciers almost everywhere. Now, this is in 1950. Now, remember, the glaciers have been receding for more than a century at this point. So it's not until World War II and up until about 1950 that it is even conceded that the amount of carbon dioxide introduced into the atmosphere by human industrial activities would have been significant enough to even show any signal at all of anthropogenic warming, right? Until 1945 or 1950. So he's making the point here that prior to 1950, there had been a general rise of prevailing temperatures with recession of the ice on the Arctic seas and increasingly rapid recession of the glaciers almost everywhere. So he's talking about a phenomena that's been going on already for a century. Yeah. So the recession of the glaciers now is nothing new. It's a continuation of what's been going on for 200 years. He goes on to say that there are fewer failures of the monsoons in India and West Africa, and rainfall had increased in continental interiors. A scientific explanation of global warming in terms of the effects on the radiation balance by carbon dioxide, which man was adding to the atmosphere, an end product of the fossil fuels burnt, won wide acceptance. This left it possible to believe that climate had been essentially constant until the Industrial Revolution. If we will demonstrate the influence of the climatic development and the shocks produced in the course of this on human history, we must first look at extreme cases. For this purpose, the record of the last 1,000 years is well suited because it seems to have included a notably wide range of climatic regimes. The High Middle Ages evidently saw persistently warm climatic epoch, which lasted until about 1300 to 1310 in Europe and affected about 2/3 of the Northern Hemisphere in the previous 1 to 200 years. A peak of warmth seems to have been obtained in a few centuries earlier in Greenland and much more of the Arctic. And cooling in those regions may have been responsible for an increase of storminess affecting the North Sea and perhaps much of the Atlantic and Europe after 1200 AD. Now, what's interesting there is he's seeing a correlation between the increase in extreme weather and storminess associated with global cooling and not the other way around. And then he says the following centuries brought a series of changes, some of them abrupt, leading to the so-called Little Ice Age, when the extent of ice on the Arctic seas and of ice and snow on land seems to have been greater than at any time since the last major glaciation. So think about that. When we talk about glacier recession, as it's going on now, our context is basically the last 100 years, 150 years. And our baseline is the Little Ice Age. And what he said what Hubert Lamb said in 1981 has been confirmed over and over by subsequent studies that the mass of the Little Ice Age glaciers was probably the greatest on this planet in 10,000 years. So if we're going to be talking about, let's measure, reduction in glacier mass, but our baseline is going to be the most extensive mass increase of glacier ice on the planet in 10,000 years, right there. You see how that begins to bias our assumptions?
Yep. That's a great example, yeah.
Yeah, the changes of winter temperature amounted to a fall of the 50-year means of 1 to 1.5 degrees centigrade between the 13th and 17th centuries. And they appear to have been accompanied by similar changes in other seasons. These changes imply a shortening of the average growing season by about a month and a decline of almost 200 meters in the upper limit of productive cultivation of crops in England and presumably in other places at about the same latitude in Europe. So notice what he's saying there, that the Little Ice Age brought on a global cooling of a degree to a degree and a half. Well, what that means then is that the 20th century warming essentially just been recovering from that climate decline of the Little Ice Age.
Yeah. Back to what it was like 1100, 1200, 1300.
Yes.
Rebalancing.
Rebalancing.
Yeah.
Tipping the scales.
Where would you put your effort instead of something like the Green New Deal? I mean, it seems to overlap with a lot of the other work we've talked to you about. Is I feel like we're at more of a risk than this global warming thing than another volcanic eruption or a massive earthquake or underwater problems with volcanoes or a meteor hitting the Earth. I mean, I feel like these are way more. There's way more of a chance that something like that is going to affect us than.
So clearly what we need is, because I think we can make this assumption that regardless of what we do, climate is going to change. It's going to continue to change no matter what we do. We can shut down the entire global economy.
And it's still going to change.
And all go into permanent lockdown and never come out of our homes and not use heating in the winter or cooling in the summer. Just basically stop all consumptions of fossil fuels and go back to lifestyles of 200 years ago. And guess what? The climate is going to continue to change all by itself.
Yeah.
Right? And sometimes those changes are going to be catastrophic. What we need is adaptability and resiliency. The Green New Deal is not going to give us that. The schemes coming from the left side of the spectrum, from the eco-environmental crowd that basically looks at man as a pariah on nature, they don't have any solutions other than curtailing the activities of humans. And basically, the outcome of those programs is going to be to make human civilization totally vulnerable to natural climate changes. And what we need is adaptability and resilience.
Yeah, that's kind of what I was getting at. Yeah.
Yeah, absolutely. And this is going to come about not through centralized authoritarian dictatorial systems. No, it's not. I'm sorry. Because for one thing, what we already see is that the fear of this imagined climate crisis is now being used to justify draconian policies.
Yeah. Yeah. And the Club of Rome wrote about this in their book in the early 70s. They said, we looked for a common enemy of man and global warming fit the bill.
Global warming fit the bill. It sure did.
Yep. Pollution, all this stuff. And then they said, yes, global warming fit the bill. And that seemed to me like around the genesis or the time when they really started pushing this. So that makes it seem to me like it's been a plan all along and it's finally coming to fruition.
Yeah. And now here's one of the other great climatologists who basically considered one of the founding fathers of modern climatology. This is Hermann Flohn, and he wrote The Climate of Europe, Past, Present, and Future, which came out in 1984. He's written extensively on climate, paleoclimate, modern climate, from all perspectives. Very distinguished scientist in his day, but his perspective is now being completely ignored. Why? Because this is what he says.
What was his name again before you say that?
Hermann Flohn. Hermann, Hermann, Flohn, Flohn.
Okay.
Flohn, I'm presuming Flohn.
Yeah. Flohn.
Okay. Yeah, so this was published in the Atmospheric Sciences Library. The Climate of Europe, Past, Present, and Future. Quote, climate, even under its natural development alone, varies continually. Each year, each decade, each century, each millennium, since long before any question of impact of human activity. It is important to gauge the magnitudes and timescales of these variations, since planning should not be based on expectations of return to some non-existent norm. And the magnitude and extent of any changes attributable to man's activities, or even whether any such effects are occurring on more than a local scale, cannot be determined without knowing the range and the likely timing of changes due to natural causes. Extension of the record to earlier times by systematic use of the numerous historical documentary reports of weather available in Europe, as well as various forms of fossil or proxy data, indicates that the last 1,000 years saw a particularly great swing of the prevailing temperature level of more or less global extent. And this was accompanied by other changes, for example, of the wind and rainfall regimes that are largely determined by the global temperature level and its distribution. There was a long period of more or less sustained higher temperatures in this part of the world between AD 900 and 1300 or later, followed by a period of regression and glacier growth until about 1550 and 1850, when there was probably the greatest extent of mountain glaciers and sea ice in both hemispheres since the last major ice age, confirming again what Hubert Lamb said. He says there are some points of interest about the geographical extent of the warm and cold regimes which respectively affected Europe in the early and middle to late centuries of the last millennium. The medieval warm epoch seems to have extended over nearly all of North America, the North Atlantic, and Europe in the 12th century. At that time, information from the highest northern latitudes seemed to indicate that the Arctic generally was still enjoying a mild regime. Evidence from the southern hemisphere at the time is sparser, but there are indications of warmth in New Zealand, roughly contemporaneous with the warmth in Europe, and it has been supposed that the wave of Polynesian and Maori sea migration coincided with a time of warmth and higher sea level, attributable to some melting of glaciers and ice sheets, giving more water clearance over the coral bars at the entrances to their island lagoons. So, I mean, this is the kind of stuff that's basically being ignored.
Yeah. Yeah.
En masse.
Yeah.
Yeah.
En masse.
Oh, yeah. Yeah. And I mean, I could go on with this. I mean, we've looked at a couple of dozen slides here. I have about 2,000 slides addressing various aspects of the climate question.
Yeah, well, this has been a great chat. Very good.
Oh yeah,
context.
This has been a very well-rounded chat. We'll split it into two parts, and I think this has been, an hour and 50 minutes. Sort of just flew by again as we fly through this. Bullshit, really.
Well, we could do this again. I've got some things coming up. That's going to keep me really busy through May. But then things should calm down, and after that, if we want to do a follow-up to this, we could get into some more of the real evidence about climate change and also a little more deconstruction of the narrative that's being put out there now.
Yeah, exactly. I mean, it does seem like they're just spewing whatever headlines they want to spew, 180 degrees from the truth, predictions, false predictions every day, every week, every year, in 10 years this and 20 years that, and you get to that time and nothing's happened. It's just ongoing fear-mongering.
It is. It's ongoing fear-mongering. And, this discussion needs to take place on a scale that's so wide that it's impossible for them to shut it down.
Yeah.
Absolutely.
Well, we appreciate you going out on a limb like this. I mean, it's not a friendly topic to talk about. You're sort of risking yourself, and we appreciate
5, 6, 7 years ago, I went out on this limb on Joe Rogan and, got a lot of flack for it. But one of the things that was really eye-opening to me is the attacks that were made against me didn't address any of the
arguments,
the evidence or the research that I brought to the table. None of it at all. Just other than I was a climate change denier, which I find to be just absurd. Here I am talking about the extraordinary, dynamic variability of climate, and somebody calls me a climate change denier, which basically just tells me you didn't hear anything I said. You're so engrossed in your belief system in this narrative that you can't even hear when somebody is presenting anything that contradicts this narrative in which you are so heavily emotionally and psychologically invested.
Yeah. Yes, they're using the words and semantics to just demonize everybody who doesn't follow along. It's pretty disgusting. Well, we appreciate you taking the shot again at it. And hopefully we got more, more people like yourself willing to talk about it. That's why we're doing this series here on Rockfin about this, because we think it's one of the most important things to talk about. I mean,
Yeah, Tony
really is.
Tony Heller's work is great.
Yeah, he was our first episode. And I mean, just showing the selective data and the, where they've sort of taken stuff out of the graphs and all, it was really, really good to see that.
Yeah. Well, there's much, much more. We didn't talk about the sun at all. But yeah, I have an entire program here. I'm going to just really quick do a screen share because you can see what we could dive into next time.
Yeah, let's do a little teaser here.
A little teaser.
Ooh, nice.
Now, of course, this doesn't have any effect on Earth's climate that we're bothering about, right?
No.
Not unless you're a conspiracy theorist.
Yeah, so we could get into some of this. And I mean, when you start looking at some of the evidence that's been accumulated, that's what all this is. Yeah, it's impossible to look at this evidence and not conclude that, yeah, the sun is a major player. Looking at this graph
the
right
Maunder
here.
minimum and the Dalton minimum there, yeah.
Yeah, correlate exactly with the coldest periods of the Little Ice Age.
Wow.
So, this is all the kind of stuff we could get into.
Yes.
Yeah. So anyhow, very interesting stuff and important stuff. And, people need to know about this.
Yep.
And for some reason, mainstream media is not, if you bring this up, you're a climate change denier, you're being funded by the fossil fuel companies, you're part of some nefarious, climate change denial front group, Yeah. The stuff that they come with to avoid dealing with the real actual science is crazy.
Totally.
But,
Well, one person who's not crazy, Mr. Carlson, is you. And we appreciate you coming on the show and proving that.
Well, I'm crazy
once
in
again.
my own way, but
Not in that way.
crazy in a good way, I like to think. All right, guys.
Thanks, Randall.
Good to see you.
Yeah,
and
you
I'll
too.
be seeing you guys in May.
All right, we'll see you. All right, Randall, it's good to see you again. We're looking forward to doing a couple trips with you this year. We got the Scablands and the Gorge coming up, but since the eclipse is so close, Darren especially, he loves this celestial mechanics stuff. So I thought we'd chat with you about celestial mechanics and the moon and the sun and all that. So thanks for coming back on. How's it going?
It's going quite well. I've been on the road for a few days, so I'm a little bit shy on my sleep quota. So if I do nod off in the middle of our conversation, it's not because you guys have bored me to death. It's just that,
Darren's low on sleep too, so I'll keep us going tonight here.
Okay, so Darren and I, if we take a break. Hey man, I might only need 20 minutes. We could put this out as an art piece, Randall and Darren sleeping for 30 minutes, and Graham trying to wing it all by himself.
So where do you
Maybe
want to start,
juggle.
Darren? Darren, you're the
Well,
one that
since
sort of, saw some of this stuff before, and then you want to talk about it.
Darren, what? So there's this.
Well-
I've heard there's this eclipse coming up.
there's this eclipse coming up, and the thing that we always kind of, and it's the other thing we should mention, is that we just noticed right before we started is it's been it'll be 10 years this August since our very first podcast with Randall. We went 3.5 hours, episode 65, if people want to go check that out. But that's when we first chatted with you. You mentioned you were coming to Canada, and we ended up hanging out when you did, and we've been doing these events together and everything ever since.
Yeah.
And we always kind of talk about this weird sort of thing with the solar system, and that's where I want to start. And it's I don't know if I've got it exactly right, but it's something to do with 108 or 109 moon diameters between the moon and the earth, and it's the same amount of earth diameters between the moon and the sun. And with the eclipse coming up, I've been thinking about it, and I've never quite been able to articulate it as well as I'd like. So I was hoping to go back and touch on some of that stuff, because it's always good. I mean, well, probably I don't want to spoil it right away, but it points to some things that are pretty apparent, in my opinion, anyway. There's kind of two different ways it can go. One of which being intelligence design, and the other one being some sort of rule-based system that might be more magnetic or electric based than what we're told.
Well, you mentioned the 108 principle, which has always fascinated me, because back, when was it, in 1972, I decided, since I had cleaned up my act and I wasn't doing any dope anymore for a while, and then I thought, well, you know what, I still want to do something to get high, so I'm going to learn how to meditate. So I found this Brahmin priest who was a student of a Himalayan Swami, and he was teaching meditation. So I went in there, and they had this whole system of meditation going back. This guy, the Himalayan Swami, he was from the Himalayas. And let me show you his picture here. I think I got his picture. I did have it right here. If I don't have it, we won't worry about it now. But he was a pretty cool dude. Anyway, so I got initiated into this system of meditation.
I was just going to joke that you were initiated into it, but yeah, I guess you really were.
No, I really was. I went through, it was a whole ceremony, and pretty interesting and pretty involved. So as part of that, for my meditation, I got a set of meditation beads, mala beads, right? And on the mala beads, there are 108 beads on the string, and one of them is larger and slightly in like a different shape than the rest of them, right? And God darn it, I didn't think of this, I could have had this ready and set up to go. I could actually have my beads are somewhere. I still have them to this day. So that's, when did I say it?
1972?
71. It was 71. I was initiated in this form of meditation in 1971. So I got these beads, and what it is that you used these two fingers here, thumb, and what do you call this finger?
Your middle one? Oh, your ring finger. Your ring finger, yeah.
That finger has a name, right?
Ring finger. Your ring finger.
Ring finger, of course, yeah. So you've got this set of beads, and you're holding it. It's going through your ring finger, and then it's about coordinating your breath with a mantra. And you guys certainly know what a mantra is, right?
Yep.
It's a little formula that you internally say to yourself. It calms your mind, and you focus on that, because the idea of the meditation is you're trying to get beyond this incessant mental activity that's always going on in your brain, and sort of like, still the conscious mind, because only when you still the conscious mind do you then click into the unconscious mind, right? And then you discover that the conscious mind is only a small speck within the unconscious mind. And but the how that relates here is that when you've got those beads, you start out, you're holding it so that the larger bead is between these two fingers, and then you repeat your mantra. So my mantra was 7 syllables, and I've never ever spoken it aloud, not once. But you correlate that with your breath. You do the repetition of the mantra, and with each repetition of the mantra, you roll one bead with your index finger. So then, as you go through the whole beads, you know that you've completed a meditation round, when you come back to that big bead again.
Yeah.
You know you've done 108 repetitions.
Yeah.
And so then what's happening is you're coordinating your breath, and then in the advanced stages, you're actually coordinating it with your heartbeat. And I was only really just getting the hang of that when I kind of got sidetracked into the 70s.
Did you get to pick yourself a new name, like Ram Carl or something like that? Or like, what would your new name be?
Well, my new name was given to me by Swami Rama.
Was it? Wow. Okay.
Yeah. Mahajiva.
Mahajiva?
Mahajiva.
Nice.
Yeah. You know what that means? Maha is great. Jiva is life force.
Great life force.
The great life force.
Nice.
I believe it.
Mm-hmm. So 108. Okay. So let's bring this back in. So I've had this number 108 had been impressed into my 7 layers of consciousness for years, right? 108. And then I began to discover how important 108 was in sacred architecture. It shows up in all of these different places. And then that there's a whole set of frequencies based upon the number 8. 100 twice 108 is 216, and twice 216 is 432, and 432 seems to be like a core number. What is it? Is it G in the octave? I think cycles per second is the note G, 432 cycles per second. And then, but the, what is that? In the diatonic scale? I'm not a musician, but I've never studied musical theory, but I think that's in the diatonic scale. And then the scale that we've shifted to is the 440 cycles per second, right?
Yeah, there was the 432, right? 432 to 440.
Yeah, exactly. So the 432, 1/4 of that is 108. So it's in that same frequency. It's the
octave, the same octave, right?
Yeah, a submultiple of 432, and 432 seems to be the base frequency of the whole system. And you find it embedded in all of these different numbers or different systems, right? If you remember, I'm sure, Graham, that you're familiar somewhat with the Vedas, and
a little bit. Yep.
Yeah, well, the yugas, right? The yugas, yep. So the base of the system, it's basically the same system as the Kabbalistic tetractys, which is a sort of it's a triangle with that goes 1, and then it doubles, and then 3, and then 4, right? So you got 4 plus 3, which is 7 plus 2, which is 9 plus 1, which is 10. So the tetractys makes up this 10, and each point on that is then associated with one of the 10 sephiro on the Kabbalistic tree of life. But in any case, it has the same, the yugas has the same structure as the tetractys going. So 432 doubles to 864, it triples to 1,296,000 years, and then it quadruples, is that it, to 1,728,000 years. But then they add up. When you add them up, you get 4,320,000. So now you've gone up like a higher. You basically added some zeros at the end. But then you come like to the Sumerian king lists, which I should have this pulled up and we could look at it. But the Sumerian king lists end when you take the 10 kings. So there's this correlation now between the 10 Sephiro on the tree of life, the 10 the 10 points on the Tetractys, and the 10 kings of Samaria. And then each of those reigns of the 10 kings, of these legendary kings, is one of those sacred numbers within that canon of cosmic numerology, if you want. But when you add them all together, you get 432,000, which to me is interesting. 432,000, you go through, work your way through the king lists, you take that summation, and that total then now is the same number of years as the number of years in the Kali Yuga. And it's almost as if you take those numbers of the king lists, the Sumerian king lists, as a system. The Yugas is just a continuation of that, except on a, I guess you could say, a higher frequency, because now you're going from 432 up to 4,320,000. Then you get to the other interesting thing, which was a much more recent discovery for me, which, well, I say much more recent, but probably, in sometime in maybe the late 80s, when I was really digging down and trying to get, okay, so what's the deal with Khufu's pyramid anyway? So I started looking at all the stuff, and the one thing I kind of honed in on that I felt was really pretty impressive, but that could also be confirmed, was that it was a model of the Northern Hemisphere on a scaling ratio of 43,200 to 1. So if you were to take the Khufu's pyramid as it is now, with its height of right about 482 feet, the length of its base, and there's two ways, remember, there's two ways to have measured the base. You have this, using the stones that are there now, you got 755 feet. Each side's a little different, so it's not exactly the same on every side length. But then there were sockets on these casing stones where it's much closer to 760 feet, right? So you had two ways. You had the pyramid sitting on the sulcal, which was this flat base, and then you had these riveted casing stones. I don't know if you guys have been there to the Khufu's pyramid.
Yep.
Okay, do you remember, at least on the two of the corners, you can still see the slots where those cornerstones were placed?
Yep.
You can still see those slots. I've got photographs of them. If we take a break, I'd be happy to pull that up. But anyways, so you can then, if you take the Khufu's pyramid at present, and you got to basically complete the triangle, right? So now you increase that, enlarge it by 43,200 times, and then the square base of the pyramid would be the same dimension, the same measure as the circular equator of the Earth. So that 43,200 scaling ratio actually shows that the Great Pyramid, Khufu's pyramid, is like a solution of the squaring of the circle. And the height of the pyramid is now the height of the Earth's polar radius.
Oh, wow.
So, and I mean, I'm talking about very, very close, like within a few dozen or maybe 100 or 200 feet maximum. The problem is that the Earth itself is not a perfectly rigid body, but it has a little bit of give to it, a little bit of plasticity to it, or elasticity to it. So, if you measure the Earth to that kind of precision, to where you're measuring an axis of the Earth within a few feet, you're going to be lucky to get the same exact number every time, because things are moving. I mean, think about just a big earthquake. You might have a whole section of the tectonic plate that shifts up or down by 6, 8, 10 feet. So the point is that I'm getting at is, within a very, very small margin of error, you are literally, you can say that, the pyramid is a model of the Northern Hemisphere. I guess you could flip it upside down and you'd have a model of the Southern Hemisphere, but it's a model of one of the hemispheres of the Earth, at a scale of 43,200 to 1. So coming back to, 108 is, is part of that system. 108, 216, and 216, and then you double that and you get your 432. Now, somewhere, let's see, when I'm trying to think back when I realized this, because I was always playing with dimensions of the solar system and discovered how, I would say, I guess by the 90s, early 90s, I had done enough exploration that I realized that with just slight adjustments, pretty much the whole solar system could fall into alignment and be described both in terms of distances, but also in terms of time, the same set of sacred numbers. Now, one of the major discrepancies between the sacred number, which would be 360, and the Earth is 365.25. But you can actually calculate how much of a mistake it is by going 365 divided by 360 and flipping that. So it's 0.986% accurate. Now, the rest of at least the visible solar system, that's the greatest discrepancy right there in the Earth orbital system, in that in the idealized calendar, and there was an idealized calendar of old, you probably know this too, that there were many ancient calendars that ran a 360-day sacred year. I mean, we get if I could pull off my old geometry book here from the 1930s, Geometry for the Practical Man, it opens, where did geometry start? Well, it started with the Sumerians. How did they decide on the 360-degree division of a circle? Well, because they believed that once the Earth's orbit around the sun was 360 days. So think how nice that would work out if we had what's a little off, okay, is that the orbit is a little bit too big, so it takes 5.25 days extra longer. Is it that this axis, the rotation on its axis, is a little faster? If you could tune that thing a little bit, tune the Earth-Sun rotational orbital system just a little bit, and then now you got this nice precise 360 to 1. Every day would be 1 degree transit or 1 degree motion along the ecliptic, 1 orbit of the Earth, one rotation. That's the important difference here. Rotation applies to a body turning around with respect to an axial point within the system, and revolution is outside. So the Earth rotates on its axis but revolves around the sun. Does that make sense?
Yeah.
If you want to get technical. Okay, so so then what you would have is a perfect synchronicity between rotation on its axis and its revolution about the sun. But according to some traditions, and again, I didn't sit down here prepared with my footnotes and stuff and my references, but in some traditions, that shift occurred as a result of a catastrophe.
I was just going to ask about a pole shift maybe back then or something.
Was something like that, yes. And I've gotten a little vague on the exactness of all the traditions, but that's the general idea. And anybody who wants to research can go into that. And I am going to be covering that. I have covered it in a lot of lectures in the past. But so the point is it's a little off. And then you can do the same thing with the other planets between Mercury, Venus, Mars, Jupiter, Saturn. As I recall, the big outer gas giants were a little off. I mean, Jupiter and Saturn turn out to be very, very close. I mean, I bet you could do it here right now. If you took, so Jupiter takes just a little less than 12 years to make its rotation around, right? It's 11 point something. Who's the fact checker on this?
I'm the fact checker.
Okay, orbital period of Jupiter. We want the orbital period of Jupiter, and I'll show you. We'll make this adjustment, and you'll see. The number, unless you're looking for it, you're going to miss the number.
It's 11.86 years.
Okay, so 11, there we go. I should know that by now, years. Okay, so now 11.86 4.86, and we'll go years. So let's turn that into Earth days. So I'm going to go times
4,330.6 Earth days.
Okay, say that again, and I'm going to write that down.
4330.6.
4330.6. Okay, so good. Okay, so check this out. And I'm going to put in 433.0.6. And then I'm going to divide by 4320. And what I'm going to find is that there's my calculator. You can see there, it's 99.7 degrees accurate.
Wow.
So then, okay, so if I subtracted that from 1 minus 1, that means that if you were to adjust the orbit, shorten its length by 0.002, you would now have that the Jovian orbit is 4,320 Earth days.
Holy shit. So that could be like a rounding error.
Yeah, I mean, look, here's the analogy I use. When I build a house, it starts first and I've built many houses, and I've designed many houses, and we've built those houses or other other things, barns, other weird buildings, storage buildings, whatever. But I'm going to use the house. The house it's also it's a real thing, and it's also a pretty interesting metaphor. But so when you build a house, okay, if I'm going to build a house, somebody comes to me and I want a house, and I've got this much property, and here's I say, well, that's the first thing. Let's start with the site. We want the site, because even if you're not trying to do anything cool and cosmic, you still want to orient and know the orientation of your house. And too bad that so many builders pay no attention to that, although we're getting back to that. People are learning, you can orient your house, for example, to the sun, and you can take advantage of that. You can, and that's the one place that I am a believer in solar energy, is in incorporating the energy of the sun, is when you build a house. You should be cognizant of the environment. You should be aware of the terrain. How does the water move over the terrain? You should be aware of, what is the soil, the composition of the soil, how thick is the soil, where's the water table. You also want to know, oriented on the site, where is the sun going to rise, where is it going to set, etc. All those kind of things. You take that into account when you're forming this conception in your mind. So now it starts with a conception. And then what do you do? Well, in the old days, it went from mental, a model in your brain, a mental conception, to a set of blueprints, a set of working plans, right? Now, what you're doing is you're translating your thoughts into an idealized form onto those blueprints. You put down, like I would do, and most good builders will have, typically will work to like eighths of an inch. When if you're out framing house, now you guys use imperial or you guys use metric?
We use both. Use both. I mean, I'm an iron worker, so we do like half inches. It's within a half inch.
Yeah, within a half inch. Okay, good. Yeah. So that's the imperial. Inches, feet, yards, all that. Okay, that's imperial. That's what I'm talking about so let's see, I lost my train of thought.
So you put it out on paper, you're trying to idealize it. Yeah.
Yeah. So now you translate from the paper. So I was going to add in that I used to draw plans by hand in the old days.
Yeah.
I don't do that anymore. I haven't done that.
CAD, of course. Yeah.
At least 10, 15 years now. Now I build digital models.
Yeah.
And of course, those digital models can be extremely precise. You might put exact numbers into those digital models, and I can program it where I'm like, there's no point in programming it to 1,000th of an inch. That would be meaningless in building a house. So what I do is I set it up to a 16th. So if I divide 1 by 16, that's 0.0625. So I'll set it up so it's accurate within 0.0625 of an inch.
Right.
And because I know that in the field, we ain't even working that precise.
Yeah.
Typically our steel tapes, we've got our smallest unit on a steel tape, a measuring tape, is 1/16 of an inch.
Yeah.
But when you're framing a house, you don't do the same degree of precision as if you're building a fine piece of furniture, right? So yeah, so you kind of have to determine, okay, what's my allowable margin of error? Now, the difference between the idealized model and the actual structure when it's finished, its accuracy is really a measure of the level of craftsmanship. Really good craftsmen, like my team, are top notch. So we can lay out a house that's 50 feet wide, and it will be accurate when you run those diagonals from one side to the other. It'll be accurate within 1/8 of an inch, which is
would be which would be a 1.25% margin error.
Yeah, so 1 divided by 8 is 0.125 inch.
0.125, yeah,
0.125, right. So, well, okay, so here's the point that I'm getting at, that I'm making here. The way I've come to conceive it is this: when we look at the universe, when we look at the real the world of time and space, we're looking at something that has been rendered in matter, in the material realm, based upon a template. And in that translation from the template, the idealized perfection of the template rendered into a real world structure or system of time and space, there's going to be discrepancies, right? So we just learned that
including in our ability to measure them,
including in our ability to measure them even. And of course, our ability to measure is getting better all the time. But if you've ever studied calculus, you know that the basic idea, the fundamental idea of calculus, is that of a limit. And a limit is something which you can determine with a degree of precision. But like, for example, if you're trying to find a line that's tangent to a hyperbolic curve, it's only going to be 1 point. But how close do you, now I could say a hyperbolic or an elliptical curve, because all planets and they're all, basically all orbits are ellipses of a greater or lesser degree of eccentricity. We don't find any orbits that are perfect circles, right? Just like when we look at getting back to the moon, we have the perigee and the apogee. The perigee is the closest, and you can fact check me on this. I think perigee, Darren, we're looking at about 221,000 miles. And at apogee, I think we're looking at about 252,000 miles. That is the difference between the moon's closest and the moon's furthest distance from the Earth.
Mm-hmm.
I think is it close to 200? Is its perigee close to 221?
Oh boy, I'm fact checking. I'm looking at.
Darren looks at that.
So while Darren is looking at that, yeah.
I want to bring something up quickly, because I'll never forget when Darren asked you a question. It's had me thinking about this ever since. When on our earlier podcasts, does that template that you talk about, like, is that unique for each solar system? It seems to be like built into this, our solar system maybe only, and another system way over there has a completely different template.
Well, given this, okay, the positions, the architecture of the solar system is appearing to me like it's whatever it's optimum for the generation and evolution of higher sentient life. Because, for example, I think if you look in the models of exobiology, and I definitely lean in that direction, I think the evidence is becoming overwhelming that life was actually, the precursors to life anyway, were introduced from outside into the Earth system at the appropriate time when the temperature and the ratio of water to land and all of these other factors are optimum, life is seeded. Now, of course, that gets us into the question of that we won't necessarily get to here, whether like, the theory of panspermia, that life is seeded, for example, throughout the universe. And I think there's some interesting new research along those lines showing the importance of organized plasmoid systems in that, being actually the way that these microscopic precursors of life could be channeled through space. But then there's also the probability of things like comets, even asteroids, having the raw materials of life being delivered to Earth. Now,
Right.
after the creation of the solar system, and however that occurs, if you take the nebular hypothesis, you have the sun consolidating as the center of the system, the center of mass of the whole system, and then all of the outer planets are gravitationally cohering based upon their distance from the sun. And I mean, there's so many mysteries and it's so complicated, I'm not going to even attempt to get into that, explaining the origin of the angular momentum of the solar system. Okay, is that's that's a mystery. I don't think anybody's really solved that, why everything is spinning, and it's spinning in the same direction, right? And rotating and spinning, rotating and revolving in the same direction.
Except
Except Venus?
for the moon?
What?
Except Venus?
Except, well, Venus is revolving in the same direction, but it's rotating in the opposite direction. And damn it, I wish I had here I am totally unprepared. If I don't, I have, when I've got a globe, I can demonstrate this, but I'll try to demonstrate it anyway.
Well, before you do that, so in 2021, the closest perigee on December 4th was 221,702 miles, and the apogee on May 11th was 252,595 miles.
Okay, so I was close enough.
You were close enough. Yep.
221 to 252. Okay. So that's a measure, that difference is a measure of the ellipticity, the eccentricity of the moon's elliptical orbit. But so like I've got this, let's say this is the Earth's axis, or any rotating body, and let's say it's rotating like this. Okay. Then what happens is if I flip it over, turn it upside down, now it's going to be rotating in the opposite direction. So otherwise, how else do you explain the fact that Venus is rotating? To me, that just something caused Venus to flip over physically on its axis.
Well, isn't the moon in a unique position to not be spinning as well then? I mean, it's going around but not spinning.
Okay, now let's clarify that. So hold that thought.
Yeah.
Let me complete the other thought, which is that and you raised an interesting question. Does that template as it stands now hold only for our own solar system or others? And I would say here, and of course it's totally speculative, I would say that yes, if you want to introduce life and then prompt that life to evolve to a higher level of self-awareness and consciousness, you probably need to be working from that template. We could do the same thing like with Saturn, Jupiter, Saturn, right? Show that Saturn is within an extremely close, and you could do the calculation on your own, or we could do it here after the break. We saw how close Jupiter was in that synchronicity between the sacred number 432 showing up in the ratio, right, of the Jovian orbit to the number of rotations in the Earth. So there seems to be that 432 link. Okay. I think if we do the Saturn, we're going to find out that the number is 10,800. There we go. There we go. Look at that. So now I'm going to take 10,800, and there's our number, 108, right?
So for people listening at home, it is 10 that we pulled it up, a screen share, and it is as per Cool Cosmos, .com or edu, it's 10,755.7 Earth days.
Right. So the correlation between Earth days and the number of days in the Saturnian orbit is 99.6% accurate.
Huh.
So now you would have 10,000. If you tune the system just a little bit, by, let's see, so -1.
And
So
again, I'll emphasize that could again be an inability to measure.
it might be,
Or maybe the system's tuning
We're
itself
trying to
all
measure
the
it all
time.
from we're trying to measure it all from Earth,
Well,
Couldn't we be out in our measurements by that same percentage as they could be out and making it?
no, I think we're more precise than that.
Okay.
It doesn't matter because we're 0.004% being dead on, where the ratio between the number of days in a Saturnian orbit and the number of days, the number of
Earth's orbit.
Earth's orbit is. So in other words,
So what would the equivalent of that be on an inch?
by 0.004, you'd have an exact synchronicity.
Yeah.
Between 4,320, I'm sorry, 10,800 Earth days and the number of years. Sorry, what am I trying to say?
I get it, but so it's within, so correct me if I'm wrong on this, that's 25 times more accurate than your 1/8 of an inch.
Yes, that's right. That's a good way to put it. Thank you. So that's my point. Is what I'm trying to get to is when you begin to look at the architecture of the solar system, it displays in a very, very precise manner with a little bit of adjustment. You see that the template has determined the ratios. Now we're talking orbits here. We could also do distances. And there's in my advanced, I guess you could say, sacred geometry classes, we actually go through and draw out the whole geometric exercise that yields the positions and ratios of the planets in terms of spatial relationships. But interesting work going back, 10, 15 years ago, showing that the delivery of comets from the Kuiper disk to the inner solar system was totally dependent upon the masses and spacing of the outer planets. And if you were to change that at all, the delivery of comets from the zone outside of Neptune to becoming Earth crossers wouldn't happen.
Wow.
I could pull that up if we take
And
a break.
so that gets in again to this mechanism that allows for life to propagate potentially if you're following span
And that goes all the way down to the moon and the Earth.
Yeah, and so when we get to the moon, how we find that spacing? Well, okay, so do this. If take the 221,000, Darren, 221,000, add to that, go plus 252,000, and you don't have to be precise. I think that's going to be close enough. Take the total, then divide that by 2 to get the average. I come up with about 236,500. The average
236,500. That's the same number I got.
Yeah. Okay. So now, 236,500 being the average. Okay. Now, divide that by 108.
Divide that by 108.
We're going to be a little big, so it's going to be closer to perigee. So let's go. You said at perigee, let's go 221,000.
Okay.
Go that times 108.
Multiplied.
Let's see.
108.
I'm sorry, 221,000. Divide by 108.
Divide by 108.
Yeah.
2046.29.
Okay, so now we're on the low side. Okay, so here's what we can do. Go 2,160, the diameter of the moon, and go that times 108.
2,160 miles times 108.
You get 233,280.
233,280, almost right in the middle of the perigee and epigee.
Yeah, almost right in the middle. So it's almost the average distance. So if you're just in conceptual terms, you could then say that the distance from the Earth to the moon, and of course, all of this is constantly changing, right? It's constantly, because the moon doesn't stop, it keeps moving. So it's constantly adjusting. So you can say that there would be a point within its orbit around the Earth where it would be exactly
Right.
8 times its own diameter from the Earth.
Oh, that's interesting. I wonder when that time is. Has anybody ever like measured that exact time? Like,
Not that I know of. I may have attempted it once upon a time. I
like
don't.
it would be interesting to know if there's any strange or not strange
It'd be
happenings.
crazy if it was on a solstice, right?
But see, the complication, the wrinkle there is that those aren't fixed points.
Yeah,
Those
right.
points are constantly shifting.
Yeah.
So the lunar perigee, against the backdrop of the stars now wouldn't necessarily be in the same position a month from now or a year from now.
Well, what's that 18? Do we want to get into that 18.6 year cycle you're talking about the moon, or do we have more to?
One more thing, though.
Yeah.
One more thing. The diameter of the sun generally, and that's you can quibble about, what's the sun's diameter. Problem is the sun doesn't have a solid surface like the Earth that you can measure. You've got, you got the chromosphere. Do you include the chromosphere? Just like if you were going to measure the Earth, presumably you would measure the solid surface, but you could include the atmosphere, right?
Yeah.
But the sun's is much more complicated than that. So, if you include the chromosphere, it's closer to 865,000. But if you don't include it, then it's closer to 864,000 miles. And that's, I think, the traditional number that's been associated with the sun, 860, which is very close to the sun's actual diameter. Now, of course, what happens when you divide 864 by 2? You get 432,000. So that's interesting, isn't it? That the number of miles in the radius of the sun is 432,000. Let's see, you divided by, yeah, there you go. What'd you get there?
8,000 when I divided the diameter of the moon by 108.
Sun.
That's the
Diameter of the sun, sorry.
Okay, that's interesting. Okay, but now multiply the diameter of the sun times 108.
864,000 times 108 equals 933,120,000.
There's your 93 million.
Oh, that's how far away it is, right? 93 million miles away. And so this is the one I talk about on the show all the time, is how the moon has the weird thing where it's 27.3% the size of the Earth, and it's 27.3 days of rotation.
Mm-hmm.
And the Earth is 365% the size of the moon, and it takes 365.25 days to do a rotation. And that's all by like NASA's own numbers. So to me, it's either it got made, it's intelligent design, or the numbers were like made up to fit some occult something or other.
And you could also point out that now this is it changes all the time, right? Because when you talk about the moon's orbital velocity, that's going to be taken relative to the Earth. That's going to be different at perigee than it is at apogee, right? But you can say, and just like there's going to be a certain point within the moon's orbit where it is moving precisely in 1 hour, in one of our hours, a distance equal to its own diameter.
Man,
that's interesting, isn't it? So it is when you get into it, okay, so here, yeah, I mean, this is where my mind starts to just sort of boggle into incoherence. Is that, well, you brought it up, Graham? I mean, or Darren? I mean, is this intelligent design, or is it out of all possible world systems, this happens to be unique, and by whatever cosmic accident, it's just the right arrangement here in order for us to be sitting here having this StreamYard meeting tonight.
Well, I would offer you one more, and that it could be like some weird law that just like, because if gravity doesn't work the way we think it does, and it's, we've got other pretty smart people who thought it was magnetism, and some other pretty smart people who think it's electric, but maybe it's just held in place by these ratios somehow. It's some weird law that we don't understand. Is that a possibility?
Well, if you start talking weird laws that we don't understand, I suppose we could say, yeah, that's a possibility. I don't know. I don't know. I don't know. And there's Malcolm calling me. I should have turned this off. I'm sure he's got some big news about the plasma technology developments.
Want to bring him on the show? Huh?
Here's a question from the chats. I wanna. This is a pretty good one from Mike. Mike, that's probably Wix. The sun also rotates around its axis in the same time it takes the moon to go around the Earth.
Yeah, that's about right. I'm pretty sure that's about. You could, if you have it all pulled up there, Darren, I bet you can see the sun's rotational period. Interestingly, the sun's rotation, like it varies depending on latitude from the solar equator. But I think overall, you said his name is Mike.
Yeah, I'm pretty sure Mike UU is our buddy Mike Wicks. He's been on a couple of trips. You would know him to see him for sure. I might have just probably
access once in about 27 days.
And of course, the rotational period of the moon around the Earth is 27.3 or 27 or something like that.
So there again, we've got that little bit of discrepancy, but and 27 is 1/4 of 108. So 27 times 4 is 108. Nice. And 108 times 4 is 432. So
have you looked into the Tycho stuff at all? So let me just put it to you this way. Is it crazy to think that the Earth and the moon could be at the middle of this thing still? Is that like definitely out of the question? Because I've seen some evidence that kind of has me leaning in the other direction. And I'm going to this conference this summer to look at this Tycho's thing because they seem to explain some things and predict some things that we have to come up with like retrogrades and stuff for. And maybe those make more sense to you than they do to me. But, so I'll present it to you that way. Is it out of the question that the Earth is at the center of this thing?
In other words, geocentric?
Yes.
No, well,
is that what you're saying?
Geocentric in a binary system with with Mars in the sun, though, Darren, I think is the key.
Yeah, that's what it is. Yeah, right. There's more to it than that.
Well, I haven't looked into it. I haven't at this point encountered anything that would make me question the heliocentric, and I can explain retrograde motion relatively easy, or at least I can demonstrate it. And yeah.
I'll send you the book. And
what's the name of the book?
The Tychos model, I think. I've got it on PDF. I'll email it to you.
Yeah, actually.
I think we might have showed you on one of the trips because there's a few people that have been with us that have loved, like, they're really into this whole model. And
yes, I don't send me the book. I have it. Okay. And from my scholarship days, I recall that Tycho was actually pronounced Tycho.
Yeah. I can't get away from Tycho.
It's hard, right? You want to say Tycho.
Yeah.
Yeah, it's I remember when I was a kid, I was maybe 6 years old, just learning to read, and we had classical music around my house, right? My mother was sort of into classical music, and so we had records by, orchestra of the great composers and stuff, and so I can remember I hadn't quite learned how to read yet, but it was the three composers. The first three that I learned were Beethoven, Mozart, and Bach.
Yeah.
You remember Bach?
Yeah.
And then only later did I learn Beethoven, Mozart, and Bach.
Yeah.
But no, actually, it was years before I went from Bach to Bach.
Yeah, exactly.
I think I finally, now in my 7th decade, got it down. That's how you say it. Johannes Bach.
Yeah.
So that's cool. Now 108. So now we have the other thing is that. So let's talk about the plane of the ecliptic, which is why we have the plane of the ecliptic gets its name from eclipses. Which came first, the ecliptic or the eclipses? I think it would be the eclipses, right?
I would have thought the other way, but I guess that would have.
Chicken and egg question. Which came first, eclipse or did the plane of the ecliptic? Okay, so I think eclipses would have been first. Is that what you're thinking, Darren?
I was thinking the other way. The ecliptic was there, and the eclipse is just a consequence of it.
Well, it is. But if you're, let's say you're a.
Depends on where you're looking at it from, isn't
But
it?
you're not looking into the eclipses until you're not looking into the elliptical to discover it until the eclipse is what triggers that.
So if you're a Paleolithic man, Darren, and you're standing out there and you're seeing an eclipse, well, obviously that would be something that someone without instrumentation, just using naked eye observations, you would see an eclipse. Probably before you figured out what the plane of the ecliptic was, or not. I don't know.
No, you're right. I agree with that.
Well, it's an interesting academic question, but the point.
Well, polymathing in the chat says the plane of the ecliptic is a human concept. Eclipses just happen.
Well, let's see. Do I agree with that? The plane of the ecliptic just happens, but it's a structure of the solar system. I mean, it's the plane that is swept out. If you were to take a giant rubber band, attach it to the center of the sun and the center of the earth, and the earth revolving about the sun is going to sweep out that plane. It's there. It was not an invention of ours. It was a discovery through observation. Right?
Yep. I like that.
I would look at it. Unless I'm not sure that polymath meant that. But in any case, I don't think it matters which came first, the chicken or egg, the eclipse or the ecliptic. But that would be an interesting thing to research. Anyhow, so let's define the plane of the ecliptic then. I just defined it. It's the plane that's swept out by the earth and the sun. It's if you were to connect the center of the sun to the center of the earth, that line would lie in the plane of the ecliptic. And then all the other bodies in the solar system are defined, their orbital elements are defined relative to that plane, the plane of Earth's orbit around the sun. Right? So all of the other planets lie within the zone, but none of them lie exactly. Their orbits are all tilted, and I don't know those off the top of my head. I do know that off my top of my head that the moon's orbit is tilted 5.145 degrees off of the plane of the ecliptic. Right? 5.145. So what that means is that for half of its orbit around the Earth, it's above the plane of the ecliptic, and for half of its orbit, it's 5.145 degrees below the plane of the ecliptic. And there is that intersection point that's in its own way kind of analogous to the intersection of Earth's equator, the equatorial plane, and the plane of the ecliptic. And just as because of Earth's precessional motion, like this, the intersection of the Earth's equatorial plane and the plane of the ecliptic is moving, basically at the same rate, 50 seconds of arc per year of this. Okay, so at this point, it would be a good idea to pull up the graphic and we can actually see. Is that you? There we go. So here we see the moon is above. Here's the nodal point where the moon is crossing the plane of the ecliptic. And it's going down, coming back around, and coming up here again. Now it's crossing from southern latitude into the northern celestial latitude and spends half of its time. And so an eclipse can only happen when the moon is at one of the nodes where the two planes are intersecting. Does that make sense? Can you see what it is from this?
That does. So basically on that red line, on those red lines, it's the only time it's on the same level as the sun. Otherwise it'll be high or low.
When the moon is up here where this graphic is showing, you're not going to have an eclipse. Now, if it's close to the nodal line, you might have a partial eclipse. But in order to have a total eclipse, it needs to be right there at full moon. I mean, at new moon. New moon has to coincide with the lunar position right on this red line. Now, here's the thing. This red line isn't fixed in space. It's moving. It's rotating. And it takes 18.6 years to make one complete revolution.
Oh, that's the cycle you're talking about.
That's it right there. Yep.
And the ancients knew about this cycle.
Well, yeah, they did. They sure did. And that's, they set up monuments, sacred structures to memorialize that relationship. I think what I will do is try to go to, let's see, I'm going to go over here and I'm going to try to pull up my other screen and show you an example of how they, let's see, how they did that. Here we go. Maybe this is, well, we did Chimney Rock together, didn't we?
We did, yeah.
We did.
Yeah, that was our first sort of trip together. We did it in near the Four Corners in Durango there.
Let's see. I'm going to stop sharing my screen for a second.
Sure.
Okay.
Yeah, that would have been May of 2019 when we were down in Durango and
Okay.
Chimney Rock.
Yeah, I remember seeing that. We looked at that spot where they saw the moon coming through.
Yeah, that's what I'm going to pull up here.
Yeah.
Okay, so I'm just rolling ahead here. My moon presentation has swelled out to 329 slides.
Is it still headed in the same direction?
Pretty much, yeah.
Yeah.
Yeah, some interesting, the more we learn about the moon, the mascons are particularly interesting. And what the hell are they? The one-to-one spin orbit coupling, that's interesting. The overall low density is interesting. The slow decay of seismic vibrations, lunar transient phenomena.
What's a mask on? It sounds like a COVID thing.
It sounds like what?
A COVID thing, mask on, mask on.
Stands for mass concentration.
Okay.
And mass concentration is are these extraordinarily dense zones under the Maria that are so they're so strong that they actually deflect. In the early days, they were when the lunar orbiters would fly over a mascon, they would actually be deflected in their orbit because of this something really strong under the surface of the center of the mascon.
Have they mapped those? Do they have you seen a map of them? Do they look does it look fake or organic?
No. I've mapped them. I mean, I haven't mapped them, but I have showing the maps of the mascons. I've got it in my 329 slideshow, right? Okay, so
are they all on the same side?
Are they all on the same? Most of them are on the near side because most of the mascons are on the near side, right? There's one mascon, I think, on the moon's far side. And I'm trying to remember if there's a mascon. Most of the Maria have these mascons under them. And again, I wasn't really necessarily prepared to get into that. But if you wanted to, I could get it set up. We could take a little break or something, and then we could come back to that. But we were going to focus more on the eclipse. Where am I here? Come on, damn it. Slide 29, 30. Okay, in fact, do you want to, hey, well, since I've got it right here, you want to do share screen?
Yep.
Yeah, let's do it.
Okay. So this is a lunar gravity map, and the contour lines show the gravity strength above the mean value of moon in units of 100 milligals.
I think you got to click on it still. We don't see it yet. Yeah.
Can you see it now?
No.
I can't see. You got to click present again.
Oh, right. Of course. Yeah, sorry. Share screen. Share screen. Should be the same window, but I got to select it again. Screen 2. Yeah, there we go. You getting it now?
Yep.
Yep, we got it.
Okay, so these are these extremely dense regions underlying the lunar surface, mass concentrations. And this is the near side Maria, which are the big, the seas, the dark blotches. When we look at the moon and we see the man in the moon face, that's because of the Maria that we're seeing, right? So the Maria, all of the near side Maria have these gigantic, we don't know how big they are, but whatever they are, they're extremely massive and extremely dense. And that's an anomaly. The reason it's an anomaly is because they are so much more dense than the surrounding material would be implied, that they should have eons ago sunk to the center of the moon. Just like if you put a little lead pellet on the top of a surface of a bowl of Jello, what's going to happen? It's not going to drop. It, of course, depends on the viscosity. You put that lead pellet, and if it's water, it's going to go really fast to the bottom of the bowl. If it's
Yogurt,
it's going to go right. If it's Jello, it may take a couple hours, but it's going to sink through. Now if you took a green pea and put on there, it probably wouldn't sink, right? But the lead pellet would sink.
So is this a density then, or what is that brown dot then?
It's density. That's exactly what it is. And let's see here if I got something. So here's another, vertical acceleration at the lunar surface for the LP165P gravity field. Acceleration of the radial component at the lunar surface sphere with radius 1738.0 kilometers. So 1738 kilometers times 1.62. Okay, so the near side on the left includes coefficient to degrees and order 110. We don't need to explain all that, but this is again showing these large density anomalies. Here we can look at this quote: "The discovery by Muller and Sogren of mascons in the moon is of great interest. My investigations allow a calculation to be made of the size and depth of the mascons in terms of the size of the mare formed by low velocity impact of an iron meteorite." Now, the problem with that theory early on is that at whatever velocity you bring that collision to occur between meteorite and the lunar, the meteorite is going to basically vaporize. So I am currently completing an analysis of penetration and cratering of concrete and soils by steel projectiles. He goes on, let's see here.
Yeah, but even if it vaporizes, wouldn't it just maybe push or squash it all together to concentrate the mass somewhere?
Probably. So these results suggest that the lava-filled Maria were formed when very large iron objects struck the surface of the moon at a velocity so low that there was no immediate fracture of the object, but that raises problems. The impact produced by a very large crater, and the object penetrated to such a depth that deep material was melted by pressure release and flowed to the surface to fill the crater. The interior of the moon must have been solid when these events occurred, because otherwise the dense iron meteorite would have sunk into the molten material, right? So was the moon molten or solid all the way through here? The suggestion by Muller and Sogren is very reasonable. However, the depth of the mascons, which they take as 50 kilometers, seems to be considerably underestimated. The depth of an impact crater measured to the bottom of the shattered material in the crater is approximately 1/4 of the crater diameter, right? That's a good rule of thumb that you can use. Now, okay, so this means that if the Maria are filled craters, the depth of Imbrium should be about 300 kilometers. That's 60, that's 180 miles. But it sure ain't. In fact, it ain't, it's not any deeper than about 3 or 4 miles. And the depth of Humorium was about 100 kilometers, which would be about 62 miles. If the mascons are deeper, as I suggest, then they must also be more massive to produce the observed gravity anomalies. So in other words, the deeper they are, the more massive they have to have that corresponding deflection of something flying over it. Now, if they had all sunk to the center, right, then
it'd be equal.
An anomaly. It's, you're not going to have it. So it has to be close to the center. The closer to the center, the less the
surface.
Closer to the surface. Thank you. Closer to the surface, the less the mass. Let's keep going here. So here, yeah, Muller and Sogren, this is isostasy on the moon. This is all research done back in the Apollo days. Muller and Sogren have performed the astonishing feat of providing a relatively detailed, though preliminary, gravimetry of much of the front surface of the moon. The data from which they worked is in no sense marginal. The perturbations of the orbiter satellites which they used are so large as to have been an operational nuisance before they were understood. The interpretation suggested to Muller and Sogren by the papers of H.C. Harold, that would be Harold C. Urey, and tentatively adopted by them, attributes the mass excesses in the Mare regions to mass concentrations, perhaps remnants of colliding asteroids, on the order of 100 kilometers in diameter, buried under the lunar surface. On the other hand, both observation and experiment indicate that impact at normal meteor velocities leads to the scattering of the impacting mass as a result of shattering and vaporization. Even if it is supposed that the circular maria were made by bodies already in orbit around the Earth, and hence having relative velocities of only a few kilometers per second, there remains a difficulty in supporting the mass. The pressure exerted by such a body on its base would be the order of 8 kilobars, which is 110,000 pounds per square inch. And this exceeds the crushing strength of granite. It is reasonable that a mass of this kind would crush its way to the center of the effing moon. Okay?
Makes sense.
Yeah. So Muller and Sogren have concluded that there are very massive objects in certain locations at the surface of the moon. Now, we see these are anomalies. These are things that raise some very interesting questions. So yeah, if the Mare Imbrium situation is taken as a prime example, because it exhibits a maximum effect, we come to the conclusion that the viscosity of the moon must be higher than that of the Earth by a factor of 10 to the 4th.
So that'd be, whoa.
Difficulties we're running into here. And it is difficult to devise a lunar history which provides the low temperature required to account for the lack of isostasy and the low electrical conductivity, and at the same time for melting processes required to produce the basaltic material on the surface of the moon. So here you have these huge maria, the 100 to 300 kilometers in diameter. They're extremely shallow, relative to what theoretical calculations suggest their depth should be. And then right at the center of them, you have these enormously dense masses of something.
So it sounds like it was already dense mass, and it just whatever impacted it couldn't go down any further because it was so dense. So it has to be shallow.
So, but see, the density is not a uniform thing over the surface. Then you have to assume that if the density was already there, then all of the impacts that produced the Mare had to have impacted directly into that anomalous dense area. In other words, go back to the lunar map we were looking at.
So, are all the craters that have the same ratio of depth to length?
No, but what they do have is they have a limit in depth. So they reach the depth. They're typical cratering ratios up until you get about 3 miles deep, 4 miles deep.
Okay.
Then the craters keep getting wider without getting any deeper.
Interesting. Wow.
Yeah. So the assumption would be if a meteor or an asteroid hit the moon where this density is, did not vaporize, and somehow, for whatever reason, did not sink to the center of the moon, right? So the question is, if the mass con was already there, then what was the mass con? You see what I'm saying?
Mm-hmm.
So let's see. Yeah. At one time, however, as the thinking.
So the mass cons must be why it's tidally locked with us too, then.
Well, yes, because it's tidally locked to us, because the crust apparently is so rigid that yeah, I'll show that in just a second. I think I can kind of explain that. At one time, it was naively believed that mass cons are remnants of the dense projectiles responsible for the excavation of the basins, right? But it was soon realized that they would have been totally vaporized. Furthermore, the largest mass cons only occur in those basins which were filled with Mare basalt. But if mass cons are simply layers of Mare basalt lying on top of low-density crust, how is this excess mass brought to the surface in the first place? Well, if a planet is in isostatic equilibrium, the overburden pressure will be constant at any given distance from the center of the planet. Terrestrial continents are much thicker than the oceanic crust on Earth simply because granitic-type rocks have lower densities than oceanic basalts. The large mass cons of Imbrium and Serenitatis would certainly not have survived on a moon in isostatic equilibrium. They would have sunk without a trace. So perhaps the most remarkable aspect of mass cons is their very survival. The fact that they still exist today implies that the moon's crust must have been remarkably rigid for a very long time. So, yeah, you can see here, this is just one of the anomalous things that are difficult to explain that we can add to the mystery of the moon. Let me see if I can. There was one. Yeah, here we go. Even though we have computed both masses and depths for the largest mass cons, nevertheless, our present quantitative data require further refinements. One may easily compute approximate masses from an assumed depth, say, such as 50 kilometers, which would be about 30 miles. The Mare Imbrium mass con yields numbers on the order of 20 times 10 to the 6th minus 6th lunar masses. So that would be about one over 20 with 6 zeros. A spherical nickel iron object about 100 kilometers or 60 miles in diameter would be a rough equivalent. So if this thing was 30 miles under the surface, it would be the equivalent to an nickel iron object.
Which would be one of the heavier, would that be one of the heavier?
The size of a city.
Well, yeah, except you got to figure this thing is, I mean, this thing, yeah, but if you picture this is a solid object. It's, if you had a spherical object, it would be 60 miles in diameter. And this thing is down, just below the surface of the moon. And it ain't supposed to be there. So does each of these mascons represent an asteroidal-sized body which caused its associated mare by impact? If not simply the original impactor itself, by what processes were they formed in the lunar interior? Is the presence of these objects consistent with a molten lunar interior? Well, there's a question. I mean, if it's a molten interior, there's no question they're going to sink, aren't they?
100%.
100%. And the deeper they get to the center, the less effect they're going to have. And then, once they've gotten to the center, they would have no effect at all. They would just they're going to affect any lunar orbital module just as a point source that's associated with the center of the moon's center of the moon's mass. So, yeah, it's so a study of local accelerations on the spacecraft resulted in a gravipotential map of the lunar near side, which has revealed very large mass concentrations beneath the center of all 5 near side maria. The largest rate of change in the accelerations over these mascons reveals their relatively small physical extent, 50 to 200 kilometers. So, whatever they are, they're relatively small, not over. So this would be 30 miles to 120 miles in diameter, if you want to talk about it in miles. So what the hell are they? What are these gigantic, or I say gigantic, I mean relative to a person standing next to it. What are these gigantic, huge masses of something that would be the equivalent of a nickel iron sphere, 60 miles in diameter?
Is there a chance they're pulling the Maria in because could they be pulling the surface down because of their density?
Well, no, they're not, because in fact the surface of the Maria are convex upward. So they're domed upward. So like you could be, the Maria are ringed by mountains. But if you're standing at the center of some of the larger Maria, you don't even see the mountains because they're below the horizon because of the convexity of the crater floor.
Is there any evidence of tunnels or catacombs leading down into those dense areas?
Well, no, that's an interesting question to ask.
I mean, we all know what the elephant in the room is, like underground moon bases, but
where do you come
I
up
don't want to
with
be the one to have to say it, but
I'm going to stop sharing for a second, if I can get out of.
There we go.
You got to stop sharing, don't you?
Yeah, I did. Yeah.
Okay, so let's see now. There should be, for whatever reason, I'm not being able to navigate from my presentation screen to my editing screen, which is a little annoying. Yeah, because I haven't quite got this.
The three screens figured it.
This is, by the way, is the first time I've used StreamYard in a podcast like this.
Okay, well, it's going pretty good. So
it's going pretty good, yeah. But I like to have things right at my fingertips here. So what I'm going to do is I'm going to go and show you something very interesting here with respect to your question. Here we go.
All right.
We're just about there. Okay, I think we're about there. Let's see. Okay. Let's see. This should be it here. Okay. So this goes back.
Click share too again. Click share.
I'll read this and then I'll
okay.
do a share screen. Yeah. Okay. So July 12th, 2010. This was let's see, this was, I believe, on the NASA's website. Yeah, okay, so a whole new world came to life for Alice when she followed the white rabbit down the hole. There was a grinning cat, a hookah-smoking caterpillar, And maybe later, Graham, you could explain what that means to Darren. A Mad Hatter, and much more. It makes you wonder what's waiting down the rabbit hole on the moon. And then it's quoting from NASA's website. NASA's Lunar Reconnaissance Orbiter, or LRO, is beaming back images of caverns hundreds of feet deep, beckoning scientists to follow. They say hundreds, but they don't actually know how deep they are. And then Mark Robinson of the Arizona State University, who is the principal investigator for the LRO camera, said this: they could be entrances to a geologic wonderland. We believe the giant holes are skylights that formed when the ceilings of underground lava tubes collapsed. Japan's Kaguya spacecraft first photographed the enormous caverns last year. Now the powerful Lunar Reconnaissance Orbiter camera, the same camera that photographed Apollo landers and astronauts' tracks in the moon dust, is giving us enticing high-resolution images of the cavern's entrances and their surroundings. So I am going to do a screen share now. Share screen, select window or screen, screen 2, there we go. This pit in the moon's Marius Hills is big enough to fit the White House completely inside. And here's another one. It's almost twice the size of this one.
That seems a weird thing to use for scale. Who knows how big the White House actually is?
Well, okay. I don't know. We got a fact checker.
Okay.
How big is so this one?
Twice the size of one of the Marius Hills. Huh.
Yeah, this one could big enough to fit the White House completely inside. But how deep?
55,000 square feet.
Okay, well, okay, so
Can
okay,
you do that in kilometers? Can you make that in kilometers?
well, I'll do 50. What did you say? 55,000 square feet. So
Yeah.
the square root of that's 234. So if the area of the White House was a square, that square would be about 235 feet on a side.
Okay.
Okay. So if the entire White House can fit in here, what I'm guessing, though, however, is that the White House isn't a square, it's a rectangle.
Probably.
So I'm guessing
rectangular. It looks like about a 3-to-1.
3-to-1.
Yeah,
So
conservatively.
55,000 square feet.
So say 700 feet or something on the one.
Yeah, around 700 feet. So then I'm assuming that's how I would interpret this. So let's say this one has got to be, to fit it in, it has to be a little bit bigger. So somewhere between 700 and 1,000 feet in diameter. This one then it's a somewhat, look from this photograph, looks to be not perfectly circular. It looks like it's elliptical. But if it's twice the size, then it's going to be what, 1,500 feet, 1,800 feet, something like that in diameter.
Yeah.
Large enough that I would imagine that, a good pilot.
A good size ship could come out of there.
Yeah, that's, yep, a good sized ship could come out of there, couldn't it?
The Empire State Building could almost come out of that thing.
Yeah. Which leads you to wonder, where does that lead?
What's that little inside the radius there underneath the lip? Is that just like a part of the inner structure there? You can see on the left. On the left, there's right down a little bit. There seems to be like
This?
it's not a yeah.
Yeah, I don't know, but I'm like to get more images, higher resolution images, which, with the Artemis, I wonder if that's going to be something that comes out of the Artemis missions or some of the other missions that are, Japan is flying back to the moon. China's going to be going to the moon. We're kind of sitting on our asses. They've already, you know what, and I got to throw this in, they're already scaling back the Artemis missions that were planned 3-stage to, we did the first stage. Second stage was to actually the first stage was just send the orbiter around on it without astronauts. The second stage would be send the orbiter around the moon with astronauts. And the third stage would be send the orbiter, and then there would be a lander that goes down and ferries astronauts to the surface, which the timetable was roughly one a year. So basically, probably by the end of next year or 2026 at the earliest, the U.S. would now have a return to the moon, a manned landing on the moon. However, NASA's budget's being cut way back in order to be able to send $60 billion over to Ukraine. Literally, that's what's happening. There's money is being taken from all these other places. We can't afford to, complete that program now because we have to send another $60 billion down the rat hole of the Ukraine war and the rest of it that it's probably going also to continue
climate change and military
all of the bullshit. Yeah, all of the bullshit that there's completely wasting. Well, yeah, I mean, look at the Inflation Reduction Act has billions and billions of dollars to address a non-existent climate crisis. I'm sure that, the best case scenarios in the aftermath of that orgy of pointless spending, we are able to, salvage some use or value out of it. But for the most part, it's just money down a gigantic toilet is what it is. But as long as they have the power to, print money willy-nilly and tax all of us people that are making an honest, working honestly to make a living, they're going to be able to continue to throw money down into the cesspool.
And not to go to the moon.
Not to go to the moon. But so this is very interesting stuff. So let me then, we'll stop share again, and I'm going to go back so we can get to, the question of eclipses. We kind of we digressed there, but I hope it was an interesting digression.
Oh, yeah.
It was.
Okay, good. Yeah, so I'm flying back to my ancient observatories here. I got to tell you, man, I got some interesting stuff in this program here that I've decided that we've got to have more. People have been bugging me for years, and I've been a little bit wary about releasing this prematurely. And then when I found out we were going to be doing the Artemis program, I thought, well, okay, so I'll do a 3-stage disclosure coordinated with the Artemis missions. And then now with the question as to whether the Artemis missions will proceed as planned, I don't know. Tell you what, though, we got to get that Biden administration out of there down here, and you guys need to get Trudeau out from up there.
That's right. It seems to be trending in that direction.
I hope so. Okay. So now I'm going to go back to screen share, share screen, screen 2, allow. All right. So for anybody who wants to do this kind of research, this is one of the best, the work of Alexander Thom. And this is his work. He spent, decades. He was a surveyor, and he spent decades. He was also an engineer who was also an expert in surveying. And so he spent decades surveying what he calls the megalithic lunar observatories, which shows, his work along with the work of many others at this point now. This is from 1971, as you can see. So this is over 50 years old now, but his surveys are still accurate. That the implications of them are still valid. But what he did show was that there were many people in the ancient world that were obsessively watching the moon and observing the motion of the moon. And then he uses, here's Stonehenge. Now this is from, not from, Tom's work, but Tom's is the essential work that anyone wanting to dive into this should probably start with. But so this is the lineup showing the alignments of Stonehenge, and you can see here you've got most southerly moonrise. You've got the sunrise in there. Over here is most northerly moon set and most southerly moon rise there. And you've got, it's primarily solar, but they've also got the lunar alignments in it. Let's see here. If we go to the next one, let's see. Here we go. Yeah, here, this is the one I was looking for. So here, the red line is the midsummer sunrise. And then through these two apertures, again, if you're at the position of the altar stone here and you're looking out, the midsummer sunrise is lined up with the heel stone. But then through these two apertures, you have the major and minor lunar rising positions. Now, one of the things you got to picture is, the moon swings on the horizon, just like, how during the course of the year, the positions of, let's take sunrise on equinoxes, sunrise is rising due east. Now, as you go from spring equinox towards summer solstice, what's happening is each day the sun is going to rise a little further north on the horizon, right? And then it's going to reach its most northerly limit on the horizon, which is going to be, which you would tweak it for your latitude of observation. And then on solstice, it'll pause for a few days. At summer solstice, it'll swing backwards. And then on fall equinox, it'll be rising due east. And then each successive morning from there, it'll be rising further to the south on the horizon. And it swings back and forth like that, right? Now, that angle of swing between the most northerly and most southerly is going to be pretty well fixed with respect to sunrise. But with respect to the moon, because of the fact of that 5.145 degree tilt, it actually affects the limits of the moon's rising and setting. So there's a minor rising. So in other words, imagine if the sun one year would come to the north and pause, shift back to the south, but the next year would move a little further on the horizon. So now that would be the major rising point and the minor right. Well, so this is what happens with the moon. There's a minor and there's a major. But in order to complete that whole cycle, that's where the 18.6 years comes in. So from Stonehenge, you can see that, here we go. Look at over here. Here's your major midsummer moonrise, and here's your minor midsummer moonrise. Here's your midwinter, and here's your midwinter moon set, major and minor. So built into Stonehenge, it's not only a solar calendar, it's also a lunar calendar. And then here's Newark, and you know what, something that we should consider is putting together a monumental earthworks of the Ohio and Mississippi Valley tour and have a 4, 5, or 6 day immersion into learning all of these, the principles and so on that are built into these ancient earthwork monuments. Now, of course, a lot of them are, what we have today in America is no more than probably 10% of what was here 1,000 years ago, right? But there's enough that one can still do a tour and come away with a pretty comprehensive understanding of the system. Now here, this is Newark, and here you can see the long axis of the structure. You've got this perfect circle surrounded by a larger circle, and then it goes into this flattened octagon, and the whole thing is laid out on an axis. And you'll notice in the flattened octagon that there are apertures in the perimeter, right? And then you can also see that there's a causeway. There are causeways going down here leading to other geometric earthworks. And notice the causeways. You've got these long causeways here. This was a magnificent monumental structure in its heyday. But this is where it's interesting. Now this is, okay, so here's this circle. Here's the aperture, I guess you'd call it, even this short, it's probably still be a causeway that leads from the circle to the octagon. So here you have it, and here's the long axis pointing to the maximum northern moonrise. And that's, in this artist depiction, that's what's being shown right here. Here's the maximum northern moonrise. So if you're facing north, Yeah, yeah. So you're facing north here. So this is maximum. So then on other uh, rising points, it's going to be here.
So if you were using a 13th month, 28-day calendar, then you would always be able to know where exactly you were in that, right?
Good question. Well, maybe I would have to think that through.
Like in those days, they might have used, like, not the Gregorian 12-month calendar, but 28 times 13 is a year, right? So
Yeah, let's see. So 28, I think what's that? 364, 28 times 13.
I mean, some people say they were using that calendars or late as like the late 1800s, early 1900s. People showed evidence of a 13-month calendar,
Oh,
but
yeah, there's definitely lunar calendars that have been in use.
yeah.
Um, but check out the alignment. They got every alignment of relevance incorporated into the design of this earthwork structure. And it all depends again to if you know where to position yourself for the observations, you got it all. You can see the minimum. You'll know when the minimum northern moon set, the maximum southern moon rise,
Wow.
maximum northern moon set, the minimum southern moon rise. Minimum northern moon rise, check out this angle here, is determined by the side of this flattened octagon. And then maximum northern moon rise. So what's going to happen is if you're watching the moon rise throughout the course of a month and then the course of a year, and then through the full cycle, that's when you're going to see these positions on the horizon are changing.
That's fascinating.
How come they're so curious about that?
About the moon?
Would this have been for a calendar? Would this be for calendar purposes or?
Yeah, this is. I mean, I'm not going to say that was its ultimate purpose, but it certainly served as a lunar calendar. If you just knew where to go and the proper position, vantage point, yeah, you could track with a high degree of accuracy the motion of the moon through the full cycle. And
over 18.6 years, though, right? So that's over the 18.6 year cycle.
Yes. And then here's, if you look at the Pueblo Bonito, the alignment of the wall here is midpoint of the lunar cycle.
Fascinating. Huh. Did we go there? Did we go to that Pueblo Bonito? I think so, eh?
On one of our tours?
Yeah.
Well, it's in New Mexico.
Oh, maybe not. I don't know. I thought that might have been near Chaco, the one that we went to the one that you're about to show next, actually.
Yeah, Chimney Rock.
Chimney Rock, yeah.
This is in Chaco Canyon.
Right, we didn't go there, no.
Yeah, we went to Mesa Verde.
We did go to Mesa Verde, yes, which is in Colorado. Or do we cross
that's right.
Yeah.
No, we were Colorado.
Yeah. All right, so here's Chimney Rock. Here is the Kiva, and you can't see it now because it's not there, but there was an observatory tower that they had built right here. And when you were in that observatory tower, we determined that this is looking east, right?
Yep.
Yep. Mm-hmm. So what we're seeing here is the sun setting in the west, casting the shadow here to the east. Now, interestingly, as the sun migrates along the western horizon throughout the course of the year, this shadow will be migrating back and forth. Now, let's go and look at it from the vantage point of the ridge here. And here you can see the major standstill of the moon's path, the summer solstice sun, and the minor standstill of the moon path. So what's happening in 2024 is the major standstill of the moon's path. So right from the vantage point, right through, yeah. So basically you're here at full moon. You will see the full moon rising between the two pillars.
Wow, this year?
Yeah.
When?
I can get the dates. I was
Oh,
thinking,
yeah, it's okay. It just once, right? At the one time.
it you know, for a full year, it's it's in this, it's rising in this region.
Oh, I see. Okay, okay. Yeah.
So you're going to have multiple, you're going to have probably 6 months where just by positioning yourself a little different from your vantage point, you're going to see the moon rising pretty much right there between the two pillars.
That's right, because it's like 9.3 years down to that minor, right?
That would be about right. Yeah.
Interesting.
Yeah. So that is Chimney Rock. So getting back to our diagram, the point is that I think we probably should pull that up again. So I'll stop sharing. And I wish I had better navigation here. I'll figure out, if we do this again, I'll have it figured out how to navigate a slideshow in StreamYard. But I can get us there in a second. Okay, that is slide number 57. Okay, not bad. Okay, so let's just go. There we go. All right, so again.
Share.
This, oh,
Yeah,
share.
Yeah.
Yep. All right. There we go. So this is rotating. So what's going to be happening in what's the date of it, Darren? The eclipse?
The eclipse is April 8th, 2024.
April 8th. Okay, so on April 8th, what's happening is the moon is going to be right on this spot right here, right at the intersection, because it's a total solar eclipse. So it's got to be right, almost dead on this position at the time of full moon. I'm sorry, back up. I said it again, at the time of new moon.
New moon.
In other words, this node has lined up with the sun. So if you were to draw a line, a straight line would intersect the Earth, the moon, and the sun on April 4th. Is that what you said, April 4th?
April 8th.
April 8th, yeah. So on April 8th, you can draw, if you imagine this red line extends, shift the moon around, put the moon right here, and then continue the line on out, and that line would then intersect the sun. So basically, you've got the lineup of the Earth, the moon, and the sun, and it's right on the node. And then next month, the full moon will not be aligned with the node. So it'll have to go make its trip around and then align with the node on this side. But again, it also has to be full moon. You know, the moon every month crosses the node, but you don't have the alignment with the sun.
Mm-hmm. And that's like every 375 years the eclipses repeat or close to.
Oh gosh, I don't remember the number off the top of my head, but that sounds about right.
The ancients, it seems like most of the ancient cultures thought the eclipse was some kind of omen or some kind of portent of change, you know? Is there, do you think there's anything to that at all? Or was that just a superstitious thing for them when they see the,
You know, I think there could be something to that. I sure could. Because look, to me, when you start studying from this vantage point of, you know, the sacred cosmology, it seems like everything, it's all part of a fine-tuned machine, and everything is intrinsic to the operation of that machine. Now, as far as what happens during eclipses, one thing that comes to my mind is this. You're putting, like under a total solar eclipse, you're putting large regions of the Earth's surface under shadow. All of a sudden, the incident solar radiation has been interrupted, right? Now, if that is over a major, like what is the area of the cone of the shadow when it hits the Earth?
180 kilometers, I think.
How many?
180 kilometers, I think.
That could be about right. So,
So
yeah.
I did clarify it's total solar eclipses repeat every 360 to 410 years.
Okay. Okay. And then the cycle would begin over. And then we're talking about this nodal point relative to the fixed stars is basically what's happening is every 360 to 400 and whatever years, this is lining up with the same stars again.
The 100 to 123 miles is the width of the solar eclipse.
Yeah. So now you've got
Oh, at some point it'll be 108.
well, yeah, probably so. Well, okay, so you've got this shadow that's interfering with the normal absorption of thermal energy by huge masses of rock. Now, if there is, say, a fault line that is, somewhere close to failure, could that rapid cooling and rapid warming again affect seismic activity, volcanic activity, tectonic activity? And I think the answer is that's very plausible. It could. So that might be one way that one might translate into actual, like there in terms of geophysics. Now, could it have other roles to play, like in biological life? I know there's studies that are out there that I haven't even accessed yet that probably are going in that direction. And that'd be a very interesting thing a research area to undertake. But yeah, I can't say, I don't know for sure. But damn, now I want to go look that up.
Yeah, exactly.
Yeah.
Well, so many of them, I mean, almost all the ancient cultures thought it was an omen or a portent of disaster, and they would do ceremonies or rituals to cleanse negative energies or sacrifices, even to appease whatever gods.
Yeah. I wonder if this is purely speculative. I wonder if those alignments, like between Earth, Moon, and Sun, could somehow affect the orbits of near Earth asteroids, or, I don't know. That I'm getting into some very rarefied speculative territory there, but you never know. Again, there's so much interesting science and research and discovery going on. It's hard to keep up with it all.
Yeah, yeah.
Although it's very fun and interesting to do that.
Well, we're supposed to maybe get a sneak peek at a comet or something this time. They were saying there's like a chance. I don't know how big the chance is, but that there could be a comet that becomes visible at the time of totality.
Really?
Let me fact check myself.
Yeah, that's probably a good idea.
Yeah, somebody mentioned in the chat there. That's kind of what I was thinking.
There's a chance that comet Pons Brook, which is prone to volcanic outbursts, could be seen during the total eclipse. Washington Post.
Wait, which comet?
Comet Pons Brooks.
Pons Brooks. Okay. Huh.
Yeah, Catastrophic New England in the chat says, what will all those high energy particles do to biological life when the magnetic field goes down for a bit?
Mm-hmm.
Turbocharged evolution, that kind of stuff. I mean, that's the other thing. You're kind of
who made that comment? That's an interesting point. I mean, yeah. Well, what effects is it having on the geomagnetic field?
Yeah.
I mean, it could. I mean, I would think it has to have effects, and those effects have to be connected, I would think, with why so many presumably independent peoples, even into Paleolithic times, were obsessively watching. I mean, why would you do that? Why would, if you're a hunter-gatherer society, foraging or hunting or whatever, or even agricultural, why would you need to erect gigantic structures and monuments in order to track lunar motion with that degree of precision? I mean, there would be no apparent practical reason for undertaking such a thing. And if one culture did it, you could say, well, whatever, these guys this was idiosyncratic, this was a tribe of weirdos, so they did all this. But then you've got this happening all over the world.
That's a great point. I mean, that might be the way to why Darren asked that question before, whether it was solely calendar or not. But that might be the other thing is so they track, the rituals and the ceremonies that they do when the moon's in certain phases.
Well, for one thing, the position of the moon, you know, for example, full at new moon, right? Even there's no eclipse during the day of new moon. You can't see the moon, right? Because you have to go out there and you look directly into the sun, and then whatever 3, 4, 5 days later, you see that thin crescent, right? It's showing up in the sky, but there's a difference, an angular difference between the position of the moon and the position of the sun. Now, if you're trying to calculate the exact position of the sun, but how do you do that, right? You can't look directly at the sun. You can't track its position in the sky relative to the constellations, could you? Because you can't. I mean, you couldn't look at the sun. I mean, now we can using instrumentation, but if you're using the naked eye, however, if you know that angular separation between the sun and the moon, you can extrapolate from that, mark your position of the new moon rising and extrapolate from that. And now you're going to be able to get the position of the sun with a pretty high degree of accuracy. So it might be involved ultimately with solar observations and being able to calculate with precision where is the sun relative. But I don't know. Then you've got, I mean, you could do, I mean, it's amazing what you could do with simply a stick in the ground, right? You put a stick in the ground, a vertical stick, and I'll stop share for a minute. You put this vertical stick in the ground and you draw a circle around it. Well, you can, from there, you can then generate your 4 cardinal directions in one day, one reasonably sunny day, right? And then, of course, you could refine it with a higher degree of accuracy by making multiple observations over the course of, say, a year. Then you could get it really, really precise. But yeah, you could get a north, south, east, west quadrant laid out on the ground with a high degree of accuracy just by putting a pole in the ground and drawing a circle around it and tracking the motion of the shadows of the rising and setting sun on the pole. And one of the things that I've done, and I never did record it, but I want to do this again and record it, is show how ancient peoples could have used a gnomon pole, set it up vertically, drawn the circle around it, and then determined your north, south, east, west axes. Well, once you've got that, I mean, what else do you need? I mean, if you want to know when to plant crops, why would you need the rising position of the sun, to fractions of a degree?
Well, I think you might want to
You
know
also
when
don't
the
need to be
season's
tracking
starting.
20-year cycles.
You what?
You also don't need to be tracking nearly 20-year cycles.
No, and you certainly wouldn't need to be tracking this precision lunar motions. What practical reason would there be for that, just from the standpoint of a farmer? I mean, I grew up in Minnesota, and all our neighbors were farmers, and as far as I know, none of them had monumental earthworks or megalithic temples on their farms that they used to know when to plant their alfalfa.
Lycanthropy, maybe?
And what?
Lycanthropy, maybe?
Lycanthropy? Well, okay. Perhaps in Darren's case, yeah. Hey, look, I went through a phase in my youth where I wanted to be a werewolf. So it was just a phase, though.
Hey, the kids are doing it these days too. So, lycanthropy is back, but they don't call it that. They have these other names for it.
Really?
Transgenderism.
Well, you got to
yeah,
get rid of the lichen, because that goes back to the Greek myth, right?
Yeah.
There's a Greek lichen gave us lycanthropy. Yeah, I loved monsters as a kid, and the werewolf was my favorite monster.
I could picture you as a werewolf.
Well, my name, Randall, comes from Rand Wolf.
Randolph Tours.
Randolph Tours. Yeah.
Randall and Randolph, which came from Rand Wolf.
Do you have any Randolph Tours coming up? I mean, that's probably a good segue into that.
Let's see. Well,
you got one with us May 13th to 18th.
Yeah, what do we call that one?
That's the Scablands.
Yeah, I know that. I know where we're going. I mean,
Well, that's what we call it too, the Randall Carlson Scablands tour.
oh, okay. Which you don't like call it the Grimerica Scablands
Well,
tour?
it's the contact at the cabin. Yeah, that's
Contact at the
the
cabin,
yeah.
of course. I knew, yeah.
Yeah.
So maybe we should bill it as, contact at the cabin and Randwolf tours or something like that.
Yeah, we should.
And then we've got the Gorge in September with you as well. That'll be fun.
Yeah, that'll be fun. Yeah, that's going to be. Yeah, we haven't done that yet.
Oh, and you're going to Cosmic Summit as well. Right?
Well, the Cosmic Summit's in June.
Yeah.
I'm looking. Yeah, I was on a conference call with George Howard today, and some of the gang that's going to be showing up there. What an interesting, eclectic group of really smart people that have incredible information to share. Oh, well, okay. There's a reason for that. Okay, let's not go there. I generally we have a room. You go down in my basement every full moon, and we've got a cell down there with thick steel bars. Every full moon, my wife locks me in. So I keep a cot
You should
in there.
stream it one time. You should stream it one time.
Just let her let you out one like episode. Just do an episode for us. Just try being let out.
Oh, real. Okay. Did you guys ever see? I can remember actually my first introduction to horror movies was they had released in 1958. They released all the old classic Universal monster movies to television. And, that was the famous Boris Karloff, Frankenstein and Bela Lugosi, Dracula.
Godzilla, maybe too in there.
No. Your timeline is way off there, Graham. Godzilla is the 50s.
Okay.
Okay. We have, there's a major conceptual shift that occurred between the 30s and the 50s. 30s, we call that Gothic horror, like Bram Stoker, Mary Shelley, Interestingly, Mary Shelley wrote Frankenstein in 1816, The Year Without a Summer. Did you know that?
I knew it was in the early 1800s. I didn't know it was The Year Without a Summer.
It was The Year Without a Summer. There was a succession of huge volcanic eruptions that preceded that year. And so that year was shrouded in darkness.
And you know what they say in alchemy about being in darkness, right? That's when things grow.
Well, interesting. Okay. I don't know if that's what Mary Shelley had in mind, but they were her and Percy Bythe Shelley, and who was the other one? They were sojourning in the Alps, I believe it was, and because of the severe cold, agriculture collapsed that year. For example, in New England, they were having July 4th celebrations, and it was snowing.
They must have not been paying their carbon taxes back then, Randall. I mean, what was going on?
That was obviously it. So anyways, people were dying. And, she was seeing the carts with the dead, bring out your dead. And it's been referred to as the last great subsistence crisis of Western civilization, 1816. So she wrote that book, and it was inspired by being holed up in this castle, seeing all of this stuff going on in 1816. So anyways, because of that, that early stuff, was referred to from that time, say up until the late Victorian times, all of that is kind of considered Gothic horror. So that would include H.G. Wells' The Invisible Man. It would include Bram Stoker, Dracula, and all of that. Now, if you look at those early horror movies, they were all those Gothic movies. And then that sort of declined in the 40s, and then after World War II, starting in 1950-51, the movie shifted, and now instead of, vampires being raised from the dead, going back, lycanthropy, the ancient story, because werewolves go back to ancient Greece and way earlier than that, right? Instead of going back, they were now, like when you brought up Godzilla, remember Godzilla was an atomic mutant monster.
Right.
And in the 50s now is when you start seeing aliens and flying saucers and sci-fi going to other planets and all of there was too many to count atomic mutant type monsters, right? So what these movies were doing was they were an expression of the collective consciousness of the time, see? And so I do remember this sitting down, and weirdly, I don't know why they did this. You guys are old enough to remember Saturday morning cartoons?
Oh yeah.
Yep.
Yeah.
Yeah, when did that end? 90s? 2000? I mean, for my generation, it was a big deal. You got up Saturday morning, like at 7 o'clock, and you watched cartoons until noon.
Mine
Right.
too. In like in the 80s and the early 90s, it was still a thing.
Yeah, it was still
And
a
I
thing.
would think it probably was right up until on demand took over.
I think you're right. Yeah. Now, what might have changed is when I was watching cartoons, that was before the days of political incorrectness. So a lot of those cartoons I was watching were pretty wild. If you don't believe me, pull up and watch an old Heckle and Jekyll cartoon. Okay. So, anyways, weirdly, one of the local stations in Minnesota started airing those Universal classic monster flicks at noon, right after the cartoons. So I'd watch the cartoons, and then the next thing, all of a sudden, it's Frankenstein coming up, or Bela Lugosi Dracula. And from the first moment, I was addicted to horror movies. 6 years
Wow.
old, 7 years old, but the first one I ever saw, the first horror movie I ever saw, was The Werewolf of London.
Nice.
You ever heard of that or seen that?
Oh yeah, yeah, of course. Yeah.
It's
Yeah, because they remade it, I think, right?
well, they made
Or
American
maybe it's
Werewolf
Paris
of
now.
London
Yeah.
in the 80s, and that was inspired by Werewolf of London. But the tale was very interesting. The protagonist was a botanist, and he'd heard about the rare moonflower. So he went to Tibet to get the Mariphasa plant, I think it was called, it only bloomed under the full moon. But it turns out, you find out later in the film, that it was also the only antidote for lycanthropy. But he's going there on this expedition, and they're going up the trails, up the mountains, and the closer they get to this place where the legend has it the Mariphasa plant grows, the more superstitious the porters get, until finally they freak out and they won't go any further. They run away, and he's there with his assistant, and they're climbing up, and then they start getting all these weird magnetic field effects on them where they can't walk, and then his assistant gets afflicted by this and he can't walk anymore. So the hero of the story pushes on. It was the actor Henry Hull. He pushes on, and he finally gets up to this place, and there's this big boulder, and down in front of the boulder is he sees the Mariphasa plant. And then as he's going up to it, he's going to get a specimen of that to take back to his laboratory in London. And as he goes up there, he's kneeling down. The full moon is rising over this rock, and the plant begins to, open up. And then as he's sitting there kneeling down, you see the big rock, and then over the top of the rock, you see the werewolf's head come up. And that was the moment. That was a pivotal moment in my life,
I like it. What a great story.
because as soon as I was like addicted, and so that was it. That was my first.
Did the werewolf kill him? Did he?
Well, okay, so the werewolf jumps down, and they have a big fight, and I think, if I remember right, the hero pulls out a knife and stabs the werewolf, and it runs off, except he's been bitten. Right?
Nice,
That's
nice.
how lycanthropy is passed on from one to another. You got to get bitten by it.
Yeah, yeah.
So he
Nice.
gets bitten by it, and then goes back to London and doesn't know that he's a werewolf. However, it turns out that the werewolf that attacked him, the man, followed him back to London, right? Because he was apparently in there looking for the same thing, right? He was looking for the same plant, except now the full moon rose and he turned into the werewolf, right? So this guy follows.
In this vicious cycle.
Yeah, so he goes back to London, and he's trying to cultivate the plant in his laboratory, and then it turns out that there's this, this doctor or whoever it is, the other scientist comes to him and explains to him, well, you're a werewolf now, and you're going to on the full moon, you're going to turn into a monster. And of course, he doesn't believe him, and then the full moon does come, and so he turns into a werewolf. And it's a fun movie, and the way they handled the special effect. I think it was 1930. I think it was 34 or 35. It came out, the movie Werewolf of London, and I think you can. I think it's free to download online.
It's probably on YouTube.
It's probably on YouTube. Yeah. But that was the first ever, to my knowledge, that was the first ever werewolf movie. And then they did a new version of it in the updated, maybe the early 40s, with Lon Chaney as the Wolf Man.
Yeah, there's some classics in the 30s: Dracula, Frankenstein, The Mummy, Dr. Jekyll and Mr. Hyde, and The Black Cat.
Yeah, and The Invisible Man.
Yeah.
Yeah, I saw so every Saturday they would show those horror movies, and I was right there, made sure I was plunked in front of the TV. I wasn't going to miss any of them.
Me too. But, well, Randall, I think we've created another entertaining and epic Grimerica and Randall Carlson podcast. Is there anything you think we didn't get to?
Oh yeah, there was more that we didn't talk about than we did talk about. So, but that's the never-ending dilemma.
I guess we'll have to keep doing these shows then.
Yeah, but yeah, I mean, we ended interestingly with lycanthropy. So,
absolutely. So where can people find
interesting tales connecting, with the cycles of the moon?
Yeah, exactly.
I'm sure there's some hidden gems of research waiting to be discovered in that. All right, I'll shut up now.
Where's the best for people to find your stuff? We know it's Cosmography on YouTube. Is everything just at randallcarlson.com now?
That's probably going to be the best, but because of the difficulty of the four of us, myself, Brad Young, and the Snake Brothers, getting together every week, where we realized, when we first started Cosmography like 4 years ago, our schedule were such, it was pretty easy for the four of us to get together every week and churn out regular content. But then it's gotten more and more difficult. So to fill in the gap, I'm launching Squaring the Circle podcast. And I'm going to cover a whole lot of stuff in there, and it's going to come out more frequent. I'm going to try to get out like a couple episodes every week, because there's so much going on and so much to report on and so much to talk about. So Squaring the Circle, in fact, when we're done here tonight, I'm working up. We've got about 5 episodes in the can right now, but I don't have a good introductory episode yet, where I'm kind of laying out the game plan, and here's what we're going to be doing. Here's what we're going to be focusing on, what we're going to be talking about, investigating and stuff. So I'm working on that. In fact, when we finish our podcast, that's probably what I'm going to shift gears on and finish polishing up the script, if you will, where I'm talking about, I've got it's all bulleted now, but I want to get it into a more like a narrative. So yeah, we'll be doing Squaring the Circle, and then let's see, I'm going to do Earth Origins with Robert Dakota in April, and that's going to be in Sedona, and there's going to be kind of an interesting lineup there. And then that's the next thing I have scheduled. And then after that, it's the Cosmic Summit in June. And I think that's
exciting news about the podcast. A lot of people are going to be excited about that. When do you expect that to drop then? Probably pretty quick if you already got some episodes in the can.
Before the month is over. And then it's going to be hosted on Rumble. It'll be pushed out to all the social media. So, yeah, it's kind of exciting, and that's why we've gone through this evolution of the studio here, because a year or two ago I just had one webcam, one monitor. Now I've got 3 monitors. I've got more cameras, more microphones, more lights. I've got my audio mixer, my video switcher. So it's upgraded. I'm still learning. I'm still climbing that hill. Hopefully within the next month or two, I'm not necessarily master it to the point like I'm an audio-visual professional, but at least where I can handle everything here. So we recorded Sean Webb, who is working with the Monroe Institute and has written
Wow.
a number of books. Yeah. He was my first interview, in-house interview. And then he and I drove up to Nashville the last 3 days ago. We left on Monday. I came back Thursday morning and interviewed with Sean Ryan. You know,
How'd
Sean.
that go? How'd that go? Did you do it like an all day thing with him or?
Well, it was 3.5 hours.
Okay.
Yeah, I mean, yeah, we started at 8:30. Well, we met for breakfast at 8:30. I think we started recording at 10. And then, we took a couple of breaks and I think we finished around 4. But we talked about a lot of stuff there. Yeah, I liked Sean a lot. He was good interviewer. He would ask good questions. We would listen. Yeah, and I liked the guy. So that should
Well,
be.
all that stuff must cost money. Where's the best place for people to support you? Is it Patreon? Is that the best place?
For now, yeah. And then
So-
remind you, the same old thing has been going on, with Sacred Geometry International. Since he's starting to get called out now, he's trying to go on the offensive, and he's going online calling me a bunch of names and stuff.
Yeah, me and him got in a fight. Yeah, we had it out.
Oh, really? Recently?
Yeah, he found my new Twitter account. I haven't blocked him. I've only muted him, so he might still be yelling at me, but I can't see it, which is kind of how I like it. I don't like to block people. I like to mute them so that they don't know that I can't see them.
Right.
But yeah, we should mention that of course Sacred Geometry International does not support Randall in any way, shape, or form. You have to go to
It
randallcarlson.com.
sell my work and monetizes my content, but I haven't seen a penny from any of it in going on 5 years now. And he posts a bunch of stuff that's total nonsense that I just want people to know that I'm not associated with the nonsense being posted by the webmaster on that
You
site.
are on Twitter again, though, right? I think it's Randall W. Carlson.
Good question. Well, if you go to randallcarlson.com or howtube.com, that'll get you, you'll find the links to all of that. And yeah, I got the new website that's going to be launched very soon. Laura Clapp has been working on it, but of course she got sidelined by a month in Egypt. So
I heard there's a rumor that we might get you out to Egypt yet.
well, I've always wanted to get back there. I mean, 2 weeks was not nearly enough time to take it all in. But I'm looking at an Azores trip, an Atlantis trip, and a couple of buddies of mine. Nick Spratt. You probably don't know.
Yeah, he's there now. I talked to Nick. We're buddies.
Yeah, good, cool. So Nick Spratt and Rob Reinhardt did. Rob Reinhardt, based on, I think he was inspired by my Atlantis lectures, and he went last summer he spent like 5 weeks exploring Madeira, the Canaries, and the Azores. So he came back from that, and then Nick Spratt was talking to me, this is before Christmas, and that he wanted to go explore the Azores. Again, kind of looked for, with the Atlantis connection. And I said, well, my buddy Rob Reinhardt has already been there. I haven't been there yet, but I should get you in contact with him. So we had a Zoom meeting. I introduced the two of them, and they ended up going to the Azores just recently. Came back like a month ago.
Yeah, that's right. I was looking at some pictures on Instagram.
Yeah. So they've been over there scouting for setting up Atlantean tours. And some of the stuff they've found, let me tell you, some juicy, interesting stuff. And made some great contacts. So
It's all happening.
And what? Yeah. And then if we can get it together after that, I did the Grail tour in 1989, and that was amazing. And I want to do a repetition of that. Now I did the Grail sites in continental Europe. So I went, from Chartres to Amiens to Reims to Montségur to Rennes-le-Château to Andé, to those sites. But then you've got all the sites up in the British Isles, which would comprise another segment of the Grail tour, hitting all of the sites that are associated with the Grail there. you know. But that would be a very interesting tour to undertake. So we should look at that as sometime in the future. But right now, the Azores thing is looming large. You know, they've the flights now fly
You can
directly
get
out
there
of,
direct, right? Yeah, you
yeah,
don't have to go all the way over and back now.
all the way over to Portugal and then back.
Yeah.
So
Well,
so
let
the
me know. Keep us posted on that because that's something I want to come along on for sure. So
well, what you could do in the meantime is read Plato's two dialogues, because that's going to be our field guide. Timaeus and Critias. How cool is that? Because
Yeah.
we should narrate those, guys.
he gives the clues in there. Um, so yeah, that'll be a lot of fun. So I guess that's about the main thing. Well, I'm sure they'll think of something else after we hang up. But yeah, so definitely in the can is the Scablands tour, the Earth Origins Conference, the Cosmic Summit Conference, and the Gorge. I should mention that the Gorge is part of the Great Pacific Northwest Floods Tour.
Yeah.
That's right. That's right. It's going to be great. People can get that over at contact@thecabin.com. I think there's about 6 or 7 spots left. It's selling out fast. So if people want to come on that Scablands trip in May, do not hesitate to get a spot. Other than that, Randall, this has been fantastic. It never gets old. Thank you very much for
Can
coming
I ask
back on the
one more
show.
quick question? Are we reserving the Soap Lake Lodge again for this one?
Yes.
We
Yep.
are. Okay.
Yep. And they got a new breakfast thing going on. We're changing up a little bit this time. So we're not going to go all the way to Soap Lake the first day.
Okay.
We're just going to go to the casino the first night, check in at the casino by the airport, head out, have dinner, and then head out to watch the sunset at
Steptoe Butte.
Steptoe Butte, head back to the casino, stay the night there, and then do the falls and everything as we make our way to Soap Lake.
Got it. Oh, that's
That's
great.
about 4 hours of driving out.
Okay.
So,
And we'll have the comfortable passenger vans with the viewing windows and
yep.
all right.
Lunches, picnic lunches. We'll have some jams in the night. We'll have some presentations. They just keep getting better. So if people want to check that out, contact@thecabin.com. Other than that, Randall, we'll let you get back to that intro so you can get this new podcast out because I'm sure people will be pretty stoked to hear it.
Yeah, I'm stoked to be doing it. All right, gentlemen, as
All
always,
right, buddy.
it's been a pleasure and an honor and a lot of fun.
Thanks, buddy.
All right,
Awesome.
man. We'll see you in a couple weeks, couple months,
Got
I
it.
guess.
Yeah, exactly. Maybe in a couple of weeks.
Maybe in a couple weeks. Can't rule it out.
Can't rule it out. All right, so I'm going to click the little red button.
All right. Ciao.
Bye.
And that was a chat with Randall Carlson. What'd you think?
Oh yeah, that was a classic Randall, but well, I mean, it was good. We
Bring
got
the
into the
moon.
moon a little bit.
Did you do your moon background to try and just instigate some moon teasers?
No, did it seem like it?
Well, it worked. So that's further into the moon than we've managed to get with them yet. And I
Yeah.
can tell you from experience off the record, it gets a lot deeper than that. I mean, people could check it out on their own. You know, the great book to start with is Who Built the Moon. I mean,
Well, I mean, you know what's interesting is maybe now he'll do it now that he has his own podcast and he can do it on his own time a little bit without scheduling 4 other guys in there or 3 or 4 other people. That maybe now because with the derailment of NASA's mission and all that, because he was
NASA?
waiting for that. Now
Yeah, that's right.
maybe he should just do it like a 3-part presentation, just get it out on video for everybody. You know?
Absolutely. Hey, if you liked our little podcast here, if you're getting some value from these podcasts we put out, these shows we put out for free, 600 and some episodes now, Grimerica.ca/support, guys. It's real important that you send us, we're on YouTube. We can't make any money here. We're banned. We can't get super chats anymore. We're demonetized, but you can head over to Grimerica.ca/support. You can sign up for a monthly. You can make a one-time donation. That helps us keep coming out with these podcasts. If you guys want some more free value, you can head over to adultbrain.ca where we've got 120 audiobooks. If you're a Spotify premium member in the US or the UK, you get those for free. You get all the audiobooks for free and we get paid. A bunch of them are on Audible. If you just type in Adult Brain Publishing, they'll all come up. But you can get them for free as well on YouTube. with some ads in them that supports us that way. And there's a podcast where you can get them to at adultbrain.ca. The Grimerica Outlawed podcast, where we do controversial stuff. GrimericaOutlawed.ca is another great way to support us, where you can sign up for a membership over there. And that's all the sort of ways we can keep ourselves afloat here, so that we can try and keep ourselves coming out with great content. Spamgram, at Grimerica.com. Anything else to get to before we wrap this up?
I think that's it.
I think that's it. All right. Spring is sprung in the Great White North.
Well, did you mention the eclipse event, the big eclipse event?
Oh, yeah, we have the big eclipse event that Randall might have just teased that he might show up at. So a couple of weeks, we're having a big eclipse event on the path to. How do we not mention the eclipse event on the eclipse? Contact at thecabin.com. Hit that menu button at the top. Go to Eclipse the Canyon, where we'll be having a music festival for 2 days and 2 nights before the eclipse, and partying. I think if you get the VIP, you get the 2 nights. The other one might be just one. Check it all out. It's all on the website. But basically, you're going to camp. We're going to have a stage. We're going to have some food trucks. And we're going to all watch the eclipse together with us, the Brothers of the Serpent, Ben from Uncharted X, a bunch of other great people. I mean, I can't mention them all, because if I mention more, I'll have to mention them all, and I can't. But, I mean, sounds like someone just might hinted that I might see him in a few weeks, and that's the only place I'm going in the next few weeks. Other than that, we love you guys. Thanks for listening, and we will see you next week.
All right, we're back for this very special episode with an old favorite of the show, Randall Carlson. And we've also got Cyrus here to help us out with this one. He's a friend of Grimerica. Oh, I'm losing my voice all of a sudden.
Good timing.
Good timing. So Randall's been here before. He's a rogue scholar. We talked about sacred geometry, catastrophism, geology. We're going to be getting into climate change. He's going to be on Joe Rogan again coming up on May 16th. That should be a really interesting show. And before we lose our chance to plug some of his stuff, go to Sacred Geo International. Put links in the show notes. They've got sales on the DVDs and their classes. And it's Cosmic Patterns and Cycles of Catastrophe. And there's 33% off with the coupon code Grimerica. Now, they're raising money for a podcast. They're going to be launching like a Gnosis series of nice little tidbits, 20, 30 minutes of Randall. You'll get like all the Randall you can handle soon as they raise enough money. So everybody head to the site, Sacred Geometry International, and help out these guys. So anyways, before too long there, Randall, it's good to have you back. Thanks for all your patience getting all set up here.
Well, it's great to be back, and thanks. I think we've got a new tagline here: all the Randall you can handle.
Yeah,
I like that one too.
That works for me.
I think this is
It
episode
replaces
5.
Randall the Vandal, anyway.
Right on.
So yeah, I mean, how many times? What is this? The 3rd time on your show? 4th time?
This is
4th?
5.
5.
That's right.
And 2 are in studio.
2 are in studio, right? Yeah, I got good memories of that. Being up there, hanging with you guys.
Absolutely.
What was that? Summer before that? When was that?
That was the summer before last. Yeah.
Oh, wow.
Yeah. Summer before last. So 2015, right?
That's
Yeah.
right. That was a fun little
Yeah.
trip.
And lots
was a
happened
great-
since then. Like you've, I meant to mention at the beginning here too that you've your work's been mentioned in Graham Hancock's book Magician of the Gods since that trip.
Since that trip, right?
Yeah, and you've
Yeah,
done
because I guess, let's see, was that before or after I spent a couple of weeks with him on the road? He was doing
After.
research on the catastrophism and the floods and stuff. So I think that was
Yeah,
just
that was
before I
after.
was-
No, that would have been after.
Oh, after. Okay.
Because it was the summer
But you
right
were
after
on
the
before
paradigm.
though too.
Yeah.
Yeah, he was on before too. That's right.
And actually,
hopefully we can do it again later this summer, because there's still a lot of work to do up in that area, putting the pieces together, especially since it's getting out there a little bit more now. It's, I'm sure it's gonna get challenged by some of the mainstream defenders. So, I would like to make sure that I've got all the pieces in place, although that probably will never happen because it's such a complex, massive scenario to try to decipher. But and plus, not only the interest of solving a mystery like this, but just being in that country is just, it makes it for me.
It's just psychologically, I'm like a different person when I get out of the city and I'm out there in the big sky country and the mountains and the rivers and the forests and the meadows. Yeah, that's element right there.
I've been back and forth to Lake Louise 6 times in the last 2 weeks.
6 times in 2 weeks.
No, maybe 3 weeks.
Yeah.
But, yeah.
Oh yeah, because you guys were putting up that canopy over there on the
Yeah.
Is it making you realize how beautiful it is out here, Darren?
You know, by the last time I was sick of it.
Really?
The last trip I was just like, oh my God, it's so far. But yeah, the first year, I mean, you can't really ask for a better commute.
The problem is the road, the speed limit between Banff and Lake Louise is 90 kilometers and there's lots of cars.
brutal,
It's really painfully slow.
That's slow, yeah.
So we've been hearing a lot about this in the news lately. There's been those carvings that people were like, it was going all over the place, and it seemed to match exactly what you've been talking about.
Well, yeah, and I haven't really had a chance to go through the whole analysis to see how credible it is. I mean, certainly I've seen the gist of it, and it certainly does support the scenario we've been working on. But, you know, again, until I've gone through it myself, I don't know, whether the connections are spurious or whether it really, is believable. I'm just going to have to go through it. I have the article. I've printed out that appeared in the Mediterranean Archaeology Journal, and again, like I said, I've not yet gone through it. I will. I've been focusing lately on just trying to understand the controversies surrounding the Younger Dryas impact hypothesis, because that has ignited a storm of controversy since it was first proposed in 2007, which is an idea that I've been working on for probably close to a quarter of a century. But even that trip I did out there when I was in Canada in 1999 was looking for field evidence that the melting of the ice was possibly triggered by some type of a cosmic impact. So I was working on that at least by then. And I had actually formulated, I think the idea initially in the late 80s or early 90s, but didn't start getting out in the field until the late 90s to actually see if there was anything in the field that could verify or refute the idea. And everything that I found convinced me that, the melting, the scale of the melting was phenomenal. The scenario of a big lake in western Montana, Lake Missoula, being held in by an ice dam, I found increasing amounts of field evidence that were inconsistent with that scenario. So, again, the conventional scenario being that there was this huge lake somewhere between 525 and 600 and some cubic miles in volume, depending on whose research you look at, held in by an ice dam. It was 2,100 feet deep in the area right there at the border of Montana and Idaho in the Clark Fork Valley. Somewhere in there was the glacial ice dam lake water interface, according to the conventional theory. And at that point, the water in the Clark Fork Valley was over 2,000 feet deep, which in my readings and discussions with civil engineers and with glaciologists and so forth, seems to me to be a thoroughly untenable idea, because when we look at modern examples of ice-dammed lakes, they're utterly minuscule compared to, the scenario of Lake Missoula. Now, some people apparently have listened to some of the things that I've said and misconstrued, saying, well, what are you saying, that there was no lake because there were shorelines there? And I've seen those shorelines, 100 times, photographed them. I've followed the shorelines throughout the basin of Lake Missoula. But, the question is when it goes back to the original research in the 1920s and 1930s by J. Harlan Bretz, most of the objections, in fact, all of the objections to the megaflood theory was that, you can't provide a source for the water on the scale required for this erosional complex that you're looking at in Washington called the Channel Scabland. And since you don't have a source for the water, then the floods didn't happen. what happened, of course, eventually was that J.T. Pardee, who worked for the U.S. Geological Survey, was surveying these mountain basins in the Clark Fork River watershed in western Montana. And, first of all, found way back in 1910, found the shorelines on the mountainsides, particularly the ones around the Missoula Basin. You can actually see the shorelines quite prominently from the University of Montana campus. And he also looked at the sediments on the valley floor throughout the basin, and they were, typical alluvial deposits, thick alluvial deposits, which led him to believe that there had been a lake. He drew upon the idea first put out by geologist T.C. Chamberlain back in about 1896, I think it was, that there had been, who had also seen the shorelines and theorized that there had been a great glacial lake held in by an ice dam somewhere to the west. And so J.T. Pardee picked up on that idea. And this was in the, like I said, 1910. It was his first ever scientific paper that he published as a young geologist. The last paper he did as a professional geologist, 1942 or 43, right in there, was the follow-up paper on Lake Missoula. It was entitled Unusual Currents in Glacial Lake Missoula, which I find an interesting phrase to use, unusual currents, because what made them unusual was because in the interim between 1910 and the early 1940s, he had discovered the gigantic ripple fields that he didn't know about back in 1910. So this is what led him to coin the phrase unusual currents, because when you have a ripple field that's 10 miles long and current ripples that are, composed of boulders that are 30, 40, 50 feet in height and 200 to 300 feet in wavelength, the current that would create such current ripples could be characterized as unusual. So, basically, I questioned this scenario. I questioned, is it possible that there could be that much water held in by a 100% stable glacial ice dam? And the more I looked at it, the more implausible the scenario seemed to me. And because as I learned about glacial ice, I realized, well, you've got basically a continuum of glaciers that go from a very solid, stable polar glacier all the way to a temperate glacier that's riding upon a layer of water that's literally on the base of the ice sheet. And the temperate glaciers themselves are, filled with fractures and cracks and apertures that reach from the surface all the way to the base of the ice that are called moulins. There's interstitial network cavities. So, water, glacial ice is not a material that would be conducive to retaining water at any significant pressure. So, but in order to fill a basin to a depth of 2,100 feet, that works out to be about 960 some pounds per square inch at the base of the ice dam. And if you think about that, that's in the north. Think about 900, and it works out to be, I think, right around between 60 and 70 tons per square foot, which is about the weight of a Sherman tank. So imagine that you've got a cubic block of ice, and you set the weight of a Sherman tank on it. How which is going to win, obviously. So that was my point, is that, wait a second, you guys are just, you've accepted this idea that there was an ice dam. It's been perpetuated and repeated over and over and over and over again. Nobody has really gone into the question, is this even a plausible scenario? And when you go to look in the field, what you discover, here's what I think they did. They took the source of Bretz's floodwater, put it into western Montana, and said there was this big lake here, 500 to 600 cubic miles of water. Right. Okay. Now, at the same time, you've got this ice mass, which has to be 100% stable in order to retain the water to that kind of pressure. Right. But in order to have that stable ice mass, you have to have a polar climate. But if you've got a polar climate, then where the hell is all this water coming from? The water can only be coming from rainfall or meltwater. There's no other source, rainfall or meltwater. Either one of those or any combination of those implies the climate that's quite warm, which is completely inconsistent with the idea of a stable polar ice mass. the implication is that you have to have a temperate glacier, and a temperate glacier is going to be completely incapable of holding water back to any significant pressures. And then when we look at modern examples, that's exactly what we see. We see glacial outburst floods up in British Columbia, Alaska, Iceland. They're very prominent. And what you see there is that these reservoirs of water that are literally less than a 1,000th the volume of Lake Missoula will break through their ice dams when they get to be between roughly 100 and 300 feet thick or deep. And at that point, the ice can no longer retain the water in that pressure. It forces its way through the ice. The ice fails. The water flows out in an outburst flood. In the Icelandic term, it's Jökulhlaups. And then the lake drains. Sometimes the ice will reseal, the lake will refill, and then they call them self-dumping glacial lakes. So what the geologists have done is they have taken that scenario of modern glacial lakes, modern outburst floods, and scaled up by 3 orders of magnitude and said, well, yeah, we understand it's a big extrapolation, but that's the model we're going to invoke here to explain this. I'm coming along and I'm saying, well, what you guys have done is you've put all of this water into western Montana. So you said, okay, first of all, Bretz's floods couldn't happen because you didn't have a source of the water. Then here comes the idea of a glacial lake, and they say, oh, okay, good, great. Okay, now we have a modern example, a uniformitarian, consistent with the uniformitarian principle, which is that we try to explain all past geological change by reference to modern phenomena. All we got to do is extrapolate it up by 3 orders of magnitude, and boom, we've got an explanation. But what they have really done, you see, is they have just pushed the can, they've kicked the can down the road, so to speak. Because while Bretz couldn't come up with a source for the water, Pardee comes up and says, okay, here's this lake. So everybody jumps on okay, here's this big lake in western Montana. But nobody's asking the question I've been asking for a quarter of a century: where the hell did that water come from? You see, and so in the travels that we've done, and in the things that we did together summer before last, what I was doing was documenting irrefutable evidence that the water came out of British Columbia, that it flowed down these north-south trending valleys, such as the Rocky Mountain Trench, which we crossed together, the Columbia Valley, the Purcell Trench, all of these valleys that anybody listening who wants to look on Google Earth, you could see those valleys. They were all filled with huge volumes of ice. That ice is now gone. There was no place for it to go when it melted except to drain south into western Montana and over eastern Washington. So then the question becomes, when you begin to understand the scale of these floods, the phenomenal, unbelievable scale of these floods, is that, well, if they're produced by sudden, catastrophic, rapid melting, then we have to have some kind of an agency that can provoke that kind of melting. And that's where you come into, well, what terrestrial source of energy is? There's not volcanic, because, that kind of energies would not exist in the area of the Cordilleran ice sheet over southern British Columbia. But the thing is that at the same time that this was going on, you had massive melting of the Laurentide ice sheet as well, that's centered over eastern Canada and Hudson Bay. And so in a lot of the other journeys that I've done, I've visited or traversed various river valleys that have headed onto the ice sheet, such as, the Missouri and the Mississippi and the St. Croix and the Ohio and the Mississinewa and a number of others. And in every single case, you can see the evidence of catastrophic meltwater flows completely submerging these valleys. And so these were going on at the same time that the Missoula floods were going on. And to me, it's like, you got to find a common explanation for all of this. And this is what seems to have eluded a lot of the guys that are doing this work, because they're still clinging to this. Because for one thing, once you begin to look at the vast scale of the erosion and sedimentary features that were left in the wake of these floods, they're so vast and they're so complex that the original scenario of one gigantic flood coming from a point source, which was the mouth of the Clark Fork River in the area of Lake Pend Oreille in northern Idaho, could not explain the vast scale and complexity of these. So they began to add more and more floods to the to the whole model, until now it's up to like 89 floods, which they're saying basically, okay, so 89 times the ice dam formed, filled the lake, and then the lake broke out. And I'm saying, well, no, the scenario of even one lake filling to 2,100 feet deep is implausible. 89 times is ridiculous. And they basically are doing that by looking at varves, backflood varves that are backwash varves that are found in some of the contiguous valleys like the Sanpoil River and the John Day River and others. And I've studied those and looked at those. And I think that basically we have to understand this melting is actually, there's two regimes. There is this catastrophic rapid meltdown, which created literal freshwater tsunamis gushing off the ice sheet. In the wake of that, there was substantial climate changes that brought the planet out of the ice age, which is part of the mystery we're still trying to figure out. But you basically have to get rid of a total of about 6 million cubic miles of ice mantling North America between 14,000 and about 8,000 or 9,000 years ago. And I think it was done basically in two scales of events. Once or twice, you had this massive instantaneous melting of huge volume, maybe tens of thousands or even several 100,000 cubic miles of ice converted instantly into water. Then, in the aftermath of that, you had a bunch of residual ice that melted away over the next couple of few thousand years. And I think that what's happened is the mainstream looking at this has not been able to, has not differentiated between these two flood regimes. That you have one where you might have literally, like in the Camas Prairie region of western Montana, that's where you've got this ripple train that's almost 10 miles long, and you've got these massive current ripples that are 30 to 50 feet in amplitude and 200 to 300 feet in wavelength. There, the water flow through Camas Prairie, and anybody listening to this that wants to go look on Google Earth, I'll pull up some images here in a minute. You'll be able to see this, what I'm talking about, this massive ripple field. Here's what you got to picture, and this is the thing that's virtually impossible to picture, but when you're standing there in the field, that's the best way to try to get some sense of what we're talking about here. But you would have a river. Picture this. You got a river that's moving 50 to 60 miles an hour. It's 10 to 11 miles wide and 1,400 feet deep. Now, there's nothing even remotely close to that happening on Earth today, not even remotely close. So when we're talking about events like that, the uniformitarian principle only can go so far to explain that. Clearly that level of melting is something beyond anything in our modern experience.
Yeah, regardless of what caused it, right? That image that you guys have on the screen, so for people that are watching on video or whatever, that looks like an image of what the ice was like back then, like say 14,000 years ago over North America and Europe. Yeah. So, just and look Europe, at no matter what caused that twice, like melting it in two stages, that puts everything into perspective for sure as far as, climate change nowadays compared to climate change back then. Look at how most of North America is covered and most of Europe. Where does that go down in Europe to to France
It covers all of Scandinavia, and it reaches down into what is now the British Isles, which of course at that time was not the British Isles because the North Sea didn't exist. Wow. Because with that much ice accumulated on the land surface, it dropped ocean levels worldwide about 400 feet. 400 feet. And this is why there was this is why North America and Asia were a continuous landmass during this time. And click to the next, I'll go to the next image here, and you can see there, you look up there, you'll see Alaska, and you'll see that the land bridge is actually more massive than the state of Alaska. It's not some narrow little strip of land. It's a massive, huge swath of land that is now underwater. And that was also highly densely populated with megafauna. There was a lot of woolly mammoths and Columbian mammoths and Mammothus imperator, these great, proboscideans that lived during the end of the Ice Age, which of course now they're completely extinct. So yeah, when you realize that there was that much ice, and then at this point there is no agreed upon explanation for what happened to that ice, how the world could so quickly transition from the ice full glacial age into the interglacial age that we're in now. And when you go back in Earth history and you realize that this has happened multiple times throughout the entire Pleistocene, which is a little over 2.5 million years in length, you got to go, well, wait a second. If we don't understand climate changes of that magnitude and that severity that have happened regularly in Earth history, how can we possibly say that the debate on climate change is now settled?
Exactly.
Simple question. That's the question I ask, and I never get an answer to it. Usually what it is usual response is to ignore me, run out of the room, or call me a name, come up with some insults. You're just a climate change denier. You're a Trump-supporting climate change denier.
Well, they're intellectually impotent. They can't keep up, so they start yelling and they start name-calling it, and then they overtalk you. They don't let you get your information out there because your information's threatening.
It is threatening. It's threatening to some agendas that are now being pushed with a lot of people trying to get this idea out there that now the sole cause of climate change is human activity. And
Bill Nye, the science guy, and his butt stuff song that he's got out now.
Yeah, listen, Bill Nye, I tell you, I don't know even what to think about that guy. He's really a joke.
Well, I grew up in Seattle. He was an actor on a local TV show here called Almost Live. And he had a character that was called Speed Walker. That was his superhero power. He speed walked and caught his villains. And he stopped a guy from stealing the Space Needle once. But that character never really caught. But Bill Nye, the science guy, kind of caught on a little bit. And then he just took that ball and ran with it. He's not a scientist. Never was a scientist. He was an engineer at Boeing, yes. But scientists, no. He's just shooting off propaganda because it signs his check for him.
Yeah, for sure. He's in with the group now, and you'll hear him say things like, "Oh, I guess was it one of the interviews he did recently, maybe with Tucker Carlson or somebody, where he was saying, yes, well, we scientists, we believe this." Like he's now a spokesman for this, completely consistent authoritarian body where everybody is in, omniscient body of scientists that are all in agreement. And anybody who questions, any portion of that agreement, is now a climate change denier or in the payroll of the fossil fuel industry. And, I am waiting for my first check. When it comes, I will probably have some very interesting things to spend it on, but I'm not going to hold my breath. When Cameron and I actually went to a coffee house presentation, 6-7 years ago by one of Al Gore's public relations guys, right, was here in Atlanta. And it was so funny because, we're sitting in the audience and Cameron, then when it kind of came to the questions and comments, Cameron raises his hand and he says, well, now, do you understand that, Al Gore's company, Generation Investment Management, stands to make a lot of money if cap and trade is put in place? And immediately somebody was sitting right up there next to the speaker, obviously fawning over this, speaker that worked for Al Gore, immediately turns and says to the whole crowd, well, we obviously have a ringer in the audience. By that, he meant, that obviously Cameron was a plant and was getting paid off by fossil fuels. Yeah, that was the fellow who runs this desmog blog. But that just kind of shows the mindset of how they get around anything. They didn't answer or even address the question Cameron raised. It was just like, oh, he's a ringer, obviously a ringer. So let's not pay any attention to that guy. And I thought I found that so amusing. And I'm thinking, Cameron is a ringer? Okay. Yeah, well, you never told me, Cameron, that you were on the payroll of the fossil fuel industry. But I'm afraid that's just all too typical. And so the whole strategy is to shut down debate because, there is many questions, unresolved questions about climate change. And, I've been for years advocating the idea that, the climate changes profoundly over and over again. That's why I find it so ridiculous that somebody calls me a climate change denier, because I've been, I got interested in climate change literally about 1975. And I began to do research, which was known, what was known at that point, particularly about paleoclimatology. I was very interested, even from the time I was a kid. And, growing up in Minnesota, right where we lived was near the margin of the Great Ice Sheet, the Laurentide Ice Sheet, the southern margin. So the geomorphic effects of the glacier age was everywhere about where I grew up as a kid. And so I got really fascinated by that whole phenomena very young. And by the time I was in my mid-20s, it almost became an obsession. So I began going through the literature. In my archives, I've got probably somewhere between 3,000 and 4,000 articles on various aspects of climate change that I have and read the lion's share of them. That's why I find it quite amusing when somebody says, well, what do the real scientists think? Well, which scientists do you want to talk about here?
Exactly. So what are some of your big questions? What are some of your big questions that you have for them then?
Who, me?
Yeah, like you have a couple, you said you have a couple big questions for the climate changes that aren't being answered. Like, do you have some information there too with you, like presentation wise, as far as like some of the outstanding sort of issues that aren't being dealt with?
Well, the outstanding thing to me is this oscillation between glacial and interglacial ages, which I'm, feel is extremely important for us to understand, because when we look at the paleoclimatological record that goes back a couple of 100,000 years now, based upon oxygen isotope analysis of ice cores extracted from Greenland and Antarctica, from mountain glaciers, from deep sea cores, from speleothems in caves, from palynological studies, which is the study of pollen, studies of biological and vegetation changes. All of these things put together suggest that there are basically two regimes of change that this planet, that describes the totality of change on planet Earth. And one is the kind of degree of change that we've seen in the last 7,000 to 10,000 years in the post-Ice Age era, which is called the Holocene. And then that's punctuated on a fairly regular basis by change that is orders of magnitude greater than the background pace of what we would consider normal change. And it's that, those discontinuities, those points of discontinuity, those event nodes, if you will, that have intrigued me for so long. Like, what is it that suddenly kicks the planet into a whole new mode? Because when you begin to understand how dramatically different the planet was during the late Wisconsin period, from 14,000 years ago down to about 25 or 30,000 years ago, and you begin to understand how vastly different the planet was and how quickly it changed from that to what it is now. Yeah. You go, okay, well, there's something going on here, and we haven't identified it yet, and it seems to happen repeatedly throughout the history of the planet. And when we begin to reconstruct the paleoclimatological record, and we look at these periods of interglacial warmth, such as we have enjoyed for the last 10,000 years, what soon becomes apparent is that, that periods of interglacial warmth, as long as the one we're in now, are the exception to the rule.
Yeah.
Most of them are 5,000, 6,000, 7,000 years, and then there's a major climate spasm. So, to me, it's like, okay, well, do we just go merrily along, assuming that, this is the way it's going to always be? Or are there times, when things shift quite rapidly, and it seems that there is. So then the question is given that the period of the Holocene that we're in now is basically a duration longer than virtually any other period of interglacial warmth we've seen, then it seems to me the prudent thing is to ask, well, why? What is this mechanism? And until we understand what the mechanism is, we're not going to be able to predict. And so, see, the thing is I'm not against us learning about the effects of human beings on climate, not by a long shot. And somehow people think that, they get that impression. On the other hand, what I'm trying to do is to say, well, yeah, humans are one variable in a very complicated equation. Carbon dioxide is one variable in a very complicated equation, but it's not the thing driving climate. And if we come back here and we start looking at some of the graphs that I have, you'll be able to see some of the things that I'm talking about.
Isn't it true, though, a lot of these models that are going for the climate change people who are promoting the fact that mankind's killing the planet, they're going off the fact that we've only been keeping track of the temperature for less than 200 years, right?
Yeah, the instrumental temperature. Yeah, and even there, you go back to the 19th century and our access to temperature data was very sparse, because and it's very difficult to go back to like 19th and early 20th century temperature data and extrapolate to the planet as a whole. Really, the temperature data we've got that we can rely on, it gives us the planet as a whole is basically since the late 70s and the 80s when we started getting satellite data in.
I remember that being a big point to me when the first time I heard you start talking about it. I never thought about that and never really, I guess I never even knew when we started keeping track of the temperature. But you could study back thousands and thousands of years in the Greenland ice cores, and they're telling us that this ball that we live on is constantly changing. It flows up, it goes down. In the 70s, like when you said you started getting really into this stuff, didn't they think we were going into another ice age?
Yeah, and in a way, you almost could understand why they would think that, because number one, radiocarbon dating came along in the early 1950s, and by the early to mid 70s, there was enough. The database of radiocarbon dates was extensive enough. But looking at it, it became obvious that the time frame for these changes was a whole lot quicker than anybody had imagined pre-radiocarbon dating. Whereas pre-radiocarbon dating, the assumption was that you had 30 or 40 or 50,000 years in order to come out of an ice age or get into an ice age. Once you had radiocarbon dating, it became apparent that no, it was much, much faster than that. Rather than 30 or 40 or 50,000 years, you're looking at 4 or 5 or 6,000 years. And even within that framework of 3 or 4 or 5,000, 6,000 years, there were periods, very short periods of maybe a few centuries or even a few decades where the bulk of the change was concentrated. And I've got up on the screen here now the oxygen isotopes in Greenland. And let's look at that. Can you guys see that?
Yep.
Yes.
Okay, so you've got relative oxygen isotope ratios, and I won't necessarily get into explaining how that works, other than the fact that when you look at this squiggly line, shifts to the left mean the temperature is getting cooler, shifts to the right mean that the temperature is getting warmer. Down the right side of the scale, you see the numbers 0, 1, 2, 3, 4, 5, and then it jumps down to 10. That's the time in thousands of years before present. So at the bottom where you see that number 10, that was 10,000 years ago. Over on the left, you see 0 at the top, 1,500 at the bottom. That's the depth of the ice. So at 1,500 meters, which is close to a mile in depth, you've gone back 10,000 years. Oxygen isotope ratios are an indication of the ambient temperature. If you look at that squiggly line, what it's doing is it's showing constant fluctuations in the temperature of 2 to 4 degrees, right? Back and forth. If you look down, which would actually at about 8,200 years, what you'll see is that there's a pretty major spike off to the left. Mm-hmm. That was a cooling period of about where the climate suddenly cooled about 4 degrees, minus 4 degrees. I'm going to go to another slide here, and you can see if you go down, you'll
dive at like 10,000 years too.
Yeah, and we're going to come back to that. You see the 8,200 year ago cold event? I've got an arrow pointing right to that little squiggle that comes off to the left. That's about a 4 degree. Then if you go down just below that, along that vertical yellow bar, you see that's the climatic optimum, first phase. The vertical line represents the modern day temperature. And what you're going to see is that this graph shows the temperature of the northern hemisphere. And even though this is Greenland ice sheet, it's likely that it does represent a hemispherical shift in temperature. You're going to see that the climate is oscillating back and forth around that line. You'll also notice that towards the bottom during the climatic optimum, it's actually warmer. And now I'm going to take that same graph, I'm going to flip it horizontal. And let's see. Okay, so here I've done a green line, which is, here's the green line, which is roughly modern day temperature. And what you're going to see is if you go back almost to that 10,000 years, you're going to see that the squiggle, if you took out that spike pointing downward, which is the 8,200 year ago cold snap, it's pretty much above the green line. And then as it comes down towards like at 5,000 years, 4,000 years, you see the numbers up at the top. Those are thousands of years. You'll notice two things. You're going to notice that the trend line is decreasing. So I'll go here. This graph shows the trend line, and you can actually see the green trend line. What we've had is a steady cooling throughout the last 10,000 years. As the climate has cooled, you'll also see from this graph that the magnitude of the oscillations back and forth has increased. It hasn't decreased, it's increased along with the cooling. So getting back to the question that I think Cyrus was posing about, is that when you look at this, what you realize is that the temperature has been cooling, and this became apparent when radiocarbon dating started coming online in the 50s and 60s and early 70s. And, there was evidence that's coming out showing that, well, wait a second, 40 to 50,000 years ago, when we thought that Canada was completely buried in ice, there were forests growing where the ice was 10,000 years later. So what that did was it constrained the duration of this whole process, going from an interglacial to an ice age and back to an interglacial again. And so at the same time that they realized that, there was what's called the little 20th century, mid 20th century cooling. Now, when we come into the 20th century, we're coming out of the little ice age. We'll go to that in a minute here, and we'll talk about that little ice age, because the baseline for the measuring modern temperature change is one of the coldest periods throughout the entire Holocene. But so what happened is you had the little cooling that lasted from the 50s and 60s and the 70s. And maybe it cooled as much as a half a degree after the initial warming of the early 20th century. You know that the warmest decade of the whole 20th century was the 1930s, not the 1990s.
That's when we had the Dust Bowl?
Yes, when we had the Dust Bowl. That was the warmest decade of the 20th century.
We had Dr. John Easterbrook on, and he actually maintains that his original graphs from the 60s and 70s still show the 30s as being hotter than even anything to date. But he says they have been manipulated, and they're not showing the real information anymore.
Yes, and Don Easterbrook is completely correct on that.
We'll link to that episode in the show notes if people want to go back and brush up on that one.
Yes, and Don Easterbrook is a very distinguished scientist who knows what he's talking about.
And if you are listening to the audio, you got to see these graphs. So as soon as you can, watch this on YouTube.
Yeah,
for sure.
Yeah,
like most of Randall's stuff.
Yeah, they really tell the story.
Yeah, you can see there's a heating trend around 2,000 years ago. There's that spike on the right as well.
I wonder if they were complaining about fossil fuels then.
Yeah, well, when did they start driving SUVs? It was somewhere, 5,000 to 6,000 years ago?
Yeah, I think Jesus had one.
Noah had one.
Yeah, that's right. Okay, so the thing to understand here, to sum it up, is that you had the mid 20th century cooling between the 50s and the 70s happening at the same time they realized that interglacial periods were really short-lived. So it was natural to speculate, well, let's see. We've already exceeded what appears to have been the length of all of the earlier interglacial periods, and the climate is cooling. What does that mean? Of course, here's the big difference. When the 80s came along, then we started warming again. Now, whether that warming is totally natural, totally human, or some combination of both, nobody can say for sure because nobody knows. Even the scientists of the IPCC, if you get them in a corner, they will say, well, we don't know what percentage of the warming since the 80s up to roughly 18 years ago when the climate more or less began to stabilize, because it hasn't really gotten much warmer in the last 18 years. They will not be able to tell you, well, let's see, it's 45% natural and 55% anthropogenic. They don't know, and they can't say. I do think that there is a human contribution, which was probably the result of increasing the carbon dioxide concentrations from, 280 at the end of the last ice age parts per million down to about 350. But the thing you got to understand about carbon dioxide is that
plant life, no?
Yeah, yes. When you get down to a couple of hundred parts per million, you're talking about photosynthesis shutting down. And if you read the article I've got online, Redemption of the Beast, it's an extensive analysis of the carbon cycle. It's like 92 pages, and it's fully referenced going back a century or more, studies on the carbon cycle. And people need to read that and realize that this is one side of the story that nobody's hearing, and it's up online.
Better if you supplement
plants
CO2.
absolutely grow better. Yes.
Well, my dad, I grew up in one of those houses where my dad liked to grow plants inside with these really big bright lights.
Yeah.
And he used to bleed CO2 canisters into the room.
Yes.
And they would explode. They grew way faster, way bushier, way healthier.
Yes, and yes. So I really would encourage people to bite the bullet, go on there and read this entire article.
Where is that again?
It's an essay. It's called Redemption of the Beast.
Okay.
And beast is just a metaphor for carbon dioxide that I use because, carbon is 6 protons, 6 neutrons, and 6 electrons. So it's kind of cool to think, here's a metaphor. The beast.
Almost like it's for a reason.
Yeah. Okay. So, anyways, let's go on and look at this graph, because this graph really shows us some pretty dramatic things here. So now what we've seen is basically temperature changes over the last 10,000 years. And when we look at the vertical version of the graph, as you said, I think, Darren, you see it kind of sweeping over to the left as you get right to the bottom. Because what we're seeing there is the temperature coming out of the ice age, right? So now what I'm going to do is I'm going to take that graph and I'm going to extend it down so you can begin to see what happens pre-Holocene.
Holy
Jesus.
Yeah. So, whoa. Yeah, that's an appropriate response right there. And what I'm trying to get people to realize is that whatever's driving the climate pre 10,000 years ago, we don't know. We don't know what that is. Now, here's one thing to consider. Is that carbon dioxide driving it? I don't think so.
Hell no.
No, it can't be. And even if it was, what that's implying is that there must be some gigantic reservoir source of carbon dioxide outgassing that we completely don't know about. If that's the case, then how can we say the science is settled? On the other hand, if it's not carbon dioxide, which I don't think it is that's driving that, we look at that graph and we go, how in the world can we say that the climate change debate is settled when we can't explain that degree of change?
I was not expecting that. When that hit the screen, oh my God.
Yeah, because I was just thinking that I wanted to see that. I was going to ask him for what happened before.
I was thinking the same thing.
So you've got this huge variance as well from like 15,000 years ago to 100 and something thousand years ago, and then it even gets way, way hotter at that point. So I mean, it's just all over the place. I mean, look at how steady it's been actually over the last 10,000 years.
Yeah, you're right. It's all over the place.
It's
I'm challenging anybody to, who thinks the science is settled to please explain that to me then, because you obviously know enough to say that the debate is over. So would you please explain that to me? I would like to know. I'm curious.
That picture in itself destroys their argument.
Yeah. Yeah. I mean, the only thing I've been able to come up with is that with all of those woolly mammoths farting, then perhaps that had something to do with it.
Definitely. What happened? Do you think they're around like 120,000 years ago? Would that be an impact as well?
I don't know.
That could have been Mount Toba. Maybe that was Mount Toba. Do you know where Mount Toba was on that?
It's about 72,000 years. And it's probably, if you come up, let's see. I'm going to
Oh, yeah, that spike that goes up to like 0. It almost was warm enough to unfreeze water.
Yeah, I was reading.
Yeah, and then it goes back down again. There's like a big oscillation there just below, about halfway between 50,000 and 100,000. That's probably Toba right there. Would be my first
And are we
guess.
going off of Celsius or Fahrenheit here?
This is Celsius.
Okay.
So to get Fahrenheit, you multiply about by 1.8.
And add 32.
So, yeah. So, and if we look at that, the last big spasm coming out of the ice age, you'll notice that there are two spikes there of warming spike. And let's see if I've got a 0. If I can hone in a little.
Yeah, I was reading this book. We're going to have a guest on next week about the into Africa theory as opposed to out of Africa, and he talks about Mount Toba and the changes around that, like the how it fucked up the Earth for weeks afterwards, actually longer than that.
Yeah.
And the sea level rises were incredible. I mean, it's just unbelievable the destruction from one eruption.
Right. Yeah. So yeah, clearly then that what it shows us that there are natural forces that we have to contend with. Now, can you see my cursor?
Yeah.
My mouse cursor. Okay. What I'm doing here is I'm looking here. This is the coming out of the ice age events, and you'll notice that right here, at about 14,600 years ago, there's a massive warming spike. You see that? I'm hovering over it with my mouse. Then it sawtooths back and forth back into full glacial cold. You'll notice here at about 20,000 years ago, you see it's kind of warming, and at the same time it's warming, the amplitude of those changes begins to decline somewhat.
Yeah.
And then all of a sudden, boom, you've got this huge warming spike. It sawtooths back into this period of full glacial cold. And then you have this second warming spike right here. It's almost like the first warming spike was not capable of kicking the planet out of the ice age. And it shot back into the full depth of cold, which is called the Younger Dryas. And then then the second warming spike. I look at the flooding events as being associated with those two warming spikes. Yeah. It just makes sense.
And the comet impact hitting something at the beginning of the first spike kind of to trigger the whole thing.
Yeah, we don't. There's no hard evidence showing an impact at 14.6, but I don't think anybody's really looked. The problem is that the impact proxies show up at 12,008 to 12,900 years ago, and that's right there where you see this where the graph just plummets off down into that spike of glacial cold off to the left. So at between 12,800 and 12,900 years ago, these independent teams have been finding impact proxies such as nanodiamonds, microspherules, magnetic grains. A platinum spike has been found in the Greenland ice core. Several of the sites have iridium spikes. So there's a number of these impact proxies that have been found. And
all over the planet, right?
Well, not yet all over the planet, but all over North America, Europe, as far as in Syria, they've found a black mat, which is a transition, a Younger Dryas transition period, and into Venezuela, Mexico. So it covers a large swath of the planet. But as has been said, no one really knows yet the extent of these materials. they could go beyond what they've already seen. It's just that as they keep extend the field of their investigations, they keep finding this stuff. And of course, it has triggered a major controversy because there are factions that do not want to suddenly take away the possibility that has been promoted for, decades now, that human beings hunted these great megafauna to extinction. We'll come back to that because these megafauna, Frank Hibben, anthropologist from the University of New Mexico back in the 40s and 50s, did extensive research. He was one of the early catastrophists who looked at the extinction level event at the end of the Pleistocene and concluded that it was a major catastrophic episode that happened. And his eyewitness testimony is quite compelling. What he did was he followed these gold miners who were using these high-pressure hydraulic hoses to blast away the permafrost muck up in Alaska, looking for gold veins. And what he was interested in was not so much the gold. He was interested in what kind of fossilized remains that was being uncovered as they blasted away the permafrost. And his eyewitness testimony is quite compelling. And wrote a book, I think it was called The Lost Americans, back in the 1940s, where he describes these remains. And it's so obviously some type of incredible catastrophe that exterminated many of these animals and left them frozen in the Alaskan muck. And it's clear from the descriptions that they had nothing to do with human hunters, because we're supposed to believe again that Paleo-Indian, small bands of roving Paleo-Indian hunters using spears and on foot were able to exterminate somewhere around 40 million animals, large animals, on 4 continents within a geological eye blink.
And then not eat them.
And then no, you couldn't have eaten them. I mean, how is you?
Exactly. Just waste it.
Well, it's pretty clear with that spike that on your graph, it correlates to that extinction, right? I mean, how could you not investigate that?
Right. The extinction happens between warming spike, the lower warming spike and the upper warming spike. The entire extinction episodes happens in between those two warming spikes. So now, there's this faction, like I said, that wants to completely discredit the idea that there could have been something outside Earth that could have been the trigger, right? Because, and here's the reason, is because we're now seeing a revival of this, what is called the human overkill hypothesis, which, and the reason for that is because there are factions now that are really promoting this idea that we're in the midst of the 6th great mass extinction in the history of the Earth, which we have certainly caused extinction of some species. Absolutely. I'm not arguing with that. But what I'm saying is that to say that we are now in a period of mass extinction equivalent to the late Ordovician or the late Devonian or the Triassic or the Permian Triassic or the Cretaceous Tertiary is just silly. It's nonsense, because when you begin looking at the circumstances associated with the 5 great mass extinctions in Earth history, if you take the middle of that spectrum, which is the KT boundary where the dinosaurs became extinct, you had, try to imagine what a 6-mile asteroid the size of Mount Everest slamming into the Earth at 10 to 20 times the speed of a rifle bullet, basically is lofting enough debris into the atmosphere to bring a shroud of darkness around the planet that would last for years, triggering global wildfires, the collapse of probably every fault line on Earth, the triggering of massive volcanic eruptions and outflowing of basaltic lava, and the extrusion of massive amounts of acidic pollution into the atmosphere, and then that followed by the onset of glacial cold in the dark. It's like, wait a second. The last time I looked outside, things were pretty nice. We weren't in the midst of a period of global wildfires, firestorms. We weren't experiencing a cosmic winter or months of endless darkness. So, to me, you just, wait a minute, you're comparing and saying now is comparable to what happened during the Cretaceous Tertiary. transition, I just, you don't further the cause by exaggerating so much, And again, obviously we have to learn how to live in harmony with this planet. Obviously we do. But we also have to understand that this planet has been able to take care of itself for millions of years, and even a small asteroid impact, which the planet has suffered countless thousands of times, is going to completely dwarf anything that humans have yet done. If you look at imagine, if you will, nuclear war using, if we had an all-out nuclear war back in the late 60s and early 70s, when the nuclear arsenals of the superpowers were at their peak megatonnage, we're looking at about 12,000 megatons, right? And that would be, if we were to unleash those nuclear weapons, that would be a catastrophe of unprecedented proportions within history. It would it would clearly bring civilization to an end. Well, even one small asteroid is going to be thousands of times more powerful than every nuclear weapon in the arsenal detonated all at once. And the Earth has repeatedly suffered those kinds of impacts throughout its history. So, we have to have a context. When we start talking about change and what humans are doing to the planet, we have to have a perspective. And the perspective is this planet has managed to survive things that are a lot more severe than anything we have yet done. It's estimated that the KT impact might have released energies in the scale of 100 million megatons. 100 million megatons, for crying out loud. Do you have any idea what that means and what that would do to the environment and the planet? It's almost impossible to visualize. But basically, what you're talking about is more than 1,000 times greater than the entire nuclear arsenal of the superpowers blown up all at once. So, again, we got to put this stuff in perspective and realize that the planet has amazing recuperative capabilities. There's just no other conclusion, because we now know that catastrophes on this scale have happened repeatedly in the history of the Earth. And my point is that what the fragile variable in this whole equation is human civilization. It would not take, if we go back and just look at that spike from 8,200 years ago, a spike like that of cooling would end civilization as we know it. And we don't know what drove that.
Right.
But what's likely is that it was probably the final draining of Lake Agassiz into the North Atlantic that triggered that. But once again, it was a completely natural phenomenon. It was part of this process of deglaciation. So
it's hard to believe that there was human beings surviving through that, past 10,000 years. When you look at that, that is just, it's almost impossible to believe that we even survived it. How old is the oldest skeleton that we know of?
Oldest modern skeletons, have been dated between 150 and 180,000 years old.
And they lived through that.
Yeah. So, yes. And here's the thing. It would be very difficult to establish any kind of a civilization when the planetary environment is doing this. But on the other hand, when you begin to realize the extent of the change that has been imposed on this planet, and you go back before that first warming spike, and you realize, as I've done by traveling, I've lost count, 50, 60, 70,000 miles I've logged up in the field over the last 20 years, documenting these evidence for catastrophic geomorphic change. And what you realize is that, whatever existed on the planet prior to this, lurching out of the ice age, we really wouldn't expect to find much of anything. When you're standing on a landscape and you're realizing, okay, in front of me is a chasm 10,000 or 1,000 feet deep, and this amount of bedrock was probably removed in a matter of 2 or 3 weeks. So you're standing somewhere and you're realizing where I'm standing now, before this melting, was 500 or 1,000 feet below the surface of the ground. How can we say what was up on the surface of the ground before these events happened? We just don't know. And clearly, it brings up really interesting questions to me about the nature of human beings that were living during these times.
Yeah, when was Göbekli Tepe covered up? Can you point that out on that graph at all?
That would have been right
about
there.
the same time.
I mean, the dating of the plaster on the walls is right at 11,600 years. And that's basically right there where that second warming spike is.
Yeah.
Right there. Now, from what I've understand from discussions with Graham and in his book is that, there may be much older portions of the structure that have not been excavated or dated yet. So I'm just waiting to see what.
Oh, there's a lot they haven't even gotten to yet. They're trying to take their time, right? Do it correctly.
Yeah, I think so. So that'll be interesting to see if it does get much older than that.
And if you blew up, if you sort of zoomed in a little bit to more recent times, like the last 1,000 years, like or the Dark Ages and the medieval warming period, I mean, there's even some pretty recent changes that would make us sweat a little bit.
Yeah, and if you look there, I've just scrolled up a bit. If you look at where it's 1,000 years ago, come over to the left and then go down a little bit. What you're going to see is that there's that would be what's called the medieval warm period. You can see that the spikes are kind of on the right side of the green line, and then you see that they shift and they're almost predominantly below. I mean, on the left of the green line.
Yeah.
That was the first phase of the Little Ice Age. Then it got a little bit warm. There was a warming in the middle of the Little Ice Age, and then it kind of got cool again. And then right up at the end, you can see the 20th century warming. I think what I'll do is, since you brought up the question of the Little Ice Age, I am going to go to some interesting stuff here. Let's see.
See, that's the problem when they only talk about 180 years. I mean, all you have to do is go back a few hundred, and you're noticing huge shifts. So
huge shifts, yeah, exactly. There's a lot of paintings and etchings and wood carvings and stuff that were done during the Little Ice Age that show, the Thames River being frozen. They were having ice fairs on the Thames River that they can't have now because of the cold of the Little Ice Age. Showing here the frozen canals of Holland. I'm going to go to the next slide, and what you're going to see is the Mur de Glace, or Glace, in the Alps. And notice this you'll see down here on the right where my mouse is hovering. There's a cabin, a building. There's some people looking, and you'll see that the ice is filling this valley, almost reaching up to where this cabin or little house had been built. Okay, so now we'll go to the next one, and here's two images. One that was taken in the 1960s, and then the painting that goes back to the early 1800s, late 1700s. And what you're going to see is how much the ice had actually receded. You can, if you look at the arrows on the left image, they correspond with the arrows on the right image. And you can see, look at the upper arrow, and you can actually see a change in the coloration of the rock.
Yeah.
Right where my mouse is. Okay, well, that was the depth of the ice during the Little Ice Age. So it completely filled this valley. That's hundreds of feet deep right there. And then it's been receding since, from between like 1820 and 1850, the glaciers worldwide began receding after the depth of cold during the Little Ice Age. Go to the next one here, and let's see what we've got. Okay, here's Svalbard, Little Ice Age moraines. Now here you see this aerial shot, I think, was taken in the 70s. Now notice here, this is the moraine, which is the material, the terminal moraine that was deposited in front of the ice at its Little Ice Age maximum. And you can see very clearly here how much the ice has receded from where it was like during the 17 and early 1800s. It's pretty well confirmed that during the Little Ice Age, this was probably some of the coldest centuries of the last 10,000 years. The glaciers worldwide grew to some of the greatest extent that they've been since the end of the Little Ice Age. So again, putting this in perspective, it's important to realize that when we're talking about global warming, our baseline is some of the coldest centuries of the last 10,000 years and some of the largest ice growth and ice accumulation of the last 10,000 years.
And
Here you
people
see
were
this-
not doing well at that time too, right? Wasn't there like famines and
Oh yeah, there was. Well, yeah. Whenever we see, like when the first phase of the Little Ice Age came on, it was between 1320 and 1340, and what you had was a series of agricultural collapses, which brought on famine, which weakened people, weakened their immune systems, and then in 1342 you had the onset of the Justinian plague.
Yeah.
As a result of the cold. I think you can make a direct line between the cooling, the cold damp that came on, the succession of agricultural collapses, the food shortages that then ensued, the famine that followed that, the weakness that was brought on by people not getting enough nutrition, and then with the weakened people, you now had opportunistic diseases like the bubonic plague that was able to basically take over and wipe out a third the population of Europe. And it took a good century and a half or 2 centuries basically to recover from that. And the Little Ice Age was broken in the middle by a period of a return to warmth, and then the second phase came on again. Luckily, we had progressed enough during that warm interval that we weren't as dramatically affected, but the potato famine in Ireland that killed so many people and triggered a massive emigration out of Ireland was clearly a consequence of the cooling of the Little Ice Age. If we go to the next slide here, you can see the village here, and you can see how massive the Mer de Glace is coming out of the mountain valleys there, swallowing up the trees. You see, and this was would have been around, I think, the early 1800s when this was, maybe late 1700s. Here's the Grindelwald Glacier, about 1775 to 1780. You can see coming down here out of the mountains, about to overrun this church. It is in the process of overrunning a village. Then in the next slide, which is 1966, it's the same valley. I'm toggling back and forth, but here what you see is that the glacier has receded all the way up where it extended down before. Oops, that's now forest growing in there, right in here. See, so all of that recession of glaciers took place between, like I said, between about 1780 and 1966. So what people need to understand is that the glacier recession isn't something that just started since we were driving SUVs. It's been ongoing for 200 years.
Yeah.
And it's just continued doing over the last 30 years what it had been doing over the previous 150 years, okay? It may have accelerated a bit, which could be basically just the fact that there is a lag between warming and cooling, and, air temperatures are going to change, but the effects on the ground are not going to be instantaneous. If we go to the next slide, we'll see the Argentière Glacier as it appeared in 1780. You'll see that it's coming out of the mountain valley, about to encroach upon this little village here. And then in the next slide, which is a photograph taken in 1966, you'll see that the glacier is completely receded off to the left, where you see it right here on the right, on the left here. It's gone, and it's all you see is a
line there.
A line of moraine right there, which has not been reclaimed by forest yet.
Now, isn't there somewhere else on the globe that's getting more glaciers, like the Arctic or something? Isn't that growing? I mean, isn't that sort of a counter
West
argument as well?
Antarctic ice mass is growing. Yes, that seems to be pretty well settled at this point, according to the according to the satellite surveys of the ice mass. Go to the next slide. You'll see there it is. About 1850. Now it's just after this, and between 1850 and 1900, that we begin our first instrumental documentation of climate change. If we toggle back and forth between these two, you see here's a sketch that somebody did showing the massive glacier during the Little Ice Age coming down again, about to overrun this village. Then we see it in 1966. It's receded way back up here into the mountain valley. Forests are now growing where you saw the ice mass before. Go to the southern hemisphere, we got New Zealand. Here's the Franz Josef Glacier in the southern Alps of New Zealand, 1872. Right down here, I've got the mouse. You'll see this, there's a large boulder there, with most likely an erratic boulder or possibly something that has been exposed and denuded by the ice coming over. Okay, now look at the transition that we go through here as we come into the 20th century. I got a line there so you can kind of see 3,200 feet across. Here it is about 1905. Notice that same rock right here is now exposed. The glacier is receding. Now this is, again, before there's any significant fossil fuel contribution to the atmosphere by humans. And we go to the photograph of 1940, and you can see that the ice has receded immensely, and where in the first image that you see here, there's now a lake in front of it. So this has been going on all over the world for the last 200 years. Glaciers have been in recession. And here's showing the recession. You can basically see if you go all the way up here to the top, 1865. This was the height of the glacier depth, and then you can see by ages. Here's 1907, 1930, 1950. It's here. 1965. It's all the way back up here, and really between 1940 and 1950 is when humans began burning significant amounts of fossil fuel, and nobody claims that prior to World War II that the amount of anthropogenic CO2 in the atmosphere was enough to cause major climate change, because it was negligible.
Right.
So, the point of this is that, this stuff, the question you got to ask is, what portion of this is natural and what portion of it is anthropogenic? And here you see that the blue line shows the glacier shortening, the 180-year trend, which went up to the early part of the 21st century. And you see that blue line basically is a record of the glacial shortening. Then you have the angled black line, which is simply the trend line. And what you see is that the trend line has held quite steady since, around 1820. So when we get to that vertical dashed line represents, that now is the point at which humans are increasing the amount of CO2 in the atmosphere to an extent that it could possibly affect the temperature. But what you see is that the glacier recession is continuing, doing basically what it had been doing for the previous century. So,
except for the end there, what was on the end there?
Which end up here?
Yeah.
It almost seems like it's
because
opposite.
right here, this represents that cooling period that I was talking about. That shifted again in the end, because during that cooling period, between 1945 roughly and 1970, glaciers actually started growing again.
It almost looks like it's the opposite in that access to these things like coal, oil, and gas are dependent on the temperature rising. Like it looks like that spike is following the warming instead of vice versa.
Mm-hmm. It does. We'll go to the next graph. This is from Climate Variation, a simple geological perspective that was published in 2007 in Geology Today. And if we look at this graph, which goes back to the late Cretaceous, to about 70 million years ago, and here's departure from present-day temperature. And as we go back to the late Cretaceous, what you're going to see is plus 10 degrees centigrade. So the global average climate, based upon proxy measurements, was up to 10 degrees warmer than now. That dashed line represents right now, right? Okay, so now notice that it falls. There is the beginning of the Cenozoic era. It rises again, then it falls, and it rises. Start of Ice Age conditions during the Eocene. Then it makes this long, steady decline. You see glaciers begin to develop in Antarctica. It comes down to the early Miocene, and then there's a spike of warmth again during the mid to late Miocene, and then it begins to drop precipitously off, and then it begins to decline right down to what they're showing is about 1.6 million years ago, and then boom, it drops down into this period called the Pleistocene, which is this right here, and the Quaternary ice ages. So, when you say, what's the normal temperature for the Earth? Well, then you got to then say, well, what time scale are you talking about? Because when you look at this going back 70 million years, then clearly the glacial cold that we've been in for the last 1.5 million years is the unusual temperature compared to all the rest of the time.
That's basically since the dinosaurs, right?
The dinosaurs ended right here at this line where it says beginning of the Cenozoic era.
Right.
That's the end of the dinosaurs right there.
It almost looks like it's like a uniform pattern.
Mm-hmm.
Well, the step ups definitely seem correlated well. So I wonder what it was like, for the last couple 100 million before the dinosaurs. Like, do you think it's always been that warmer?
No, there have been ice ages. In fact, during the Ordovician, there was a global ice age, probably colder than this one, and carbon dioxide was up to 3,000 and 4,000 parts per million.
Wow.
Which right there suggests, well, wait a second, if carbon dioxide is the sole driver of climate, then how do you explain that?
Yeah.
How do you explain that we were in an ice age in the Ordovician? This is an interesting graph because here you can kind of see there is a regular sort of oscillation. This is from way back in 1973 from Cesare Emiliani, Quaternary paleo temperatures and the duration of high temperature intervals. And it basically charts going back to 100,000 years ago down to the present. And you can see that for the last 400,000 years, the planet has been going into these troughs represent full glacial cold, and the peaks represent interglacial warmth. And right over here on the left is kind of where we're at now. This would have been the what's called the climatic optimum right here. I mean, this would have been the medieval warm period right here. Here was the last phase of the great ice age. So, yeah, what you see here is that it looks like there is kind of a quasi-periodicity to these changes.
So how often are those spikes?
It appears to be roughly about every 25 to 30,000 years.
Like right on a great
year. Yeah.
Yeah, exactly.
Ooh.
So,
And Bill Nye doesn't know any of this. You need to step your game up, son. I don't even think he knows.
Probably doesn't even know what precession is.
He doesn't even know half the words Randall's using, probably. He doesn't know any of these things. It's so frustrating to see this guy he's given a mic and a loud voice and a big, huge audience.
Yeah.
Just to tell them things, to lie to them because he doesn't know anything.
Yeah, but don't forget, Randall's audience on Rogan is bigger than anything Bill Nye's pulling on cable TV.
Yes. I know, but they're not the ones we have to worry about. We need to get the people who are all in, this is kind of the information you try to present to somebody and they don't even want to look at it.
Right. They don't want
because they've already got they're already brainwashed to believe that it's a lie. Like we're trying to lie to them. Randall, this information, if anyone tells you anything different, the conversation's over.
Mm-hmm.
I think it's crumbling down a little bit now. I think things are shifting on a bunch of different areas, and man-made global warming being one of them. I really think the gig is up. It's the start. I think it's the start of the end for them.
Yeah, Randall needs a Netflix miniseries, just like Magical Egypt. We need to get Randall on a big, something with CGI, with visuals, something to get it out there to kind of battle against all this misinformation.
Yeah, and it's the thing is that again, I'm gonna reiterate, humans are definitely influencing the climate. Yeah. There's no question, and we have influenced the climate by releasing another 100 to 20 parts per million of carbon dioxide. If you read my article, The Redemption of the Beast, I make the case that it's really not such a bad thing that we have increased the amount of carbon dioxide a little bit in the atmosphere. In fact, it may be possible we've perhaps ameliorated the climate enough that we'll avoid another little ice age, which to me would be a great thing, because if we had another little ice age and we had 2 or 3 years of major agricultural collapses, we'd be in deep trouble. I mean, even just a cooling of a couple of degrees centigrade, similar to what was occurring during the Little Ice Age, could really bring on some serious trauma. You know, I mean, because even in America, I mean, our food supplies would run out in 6 months. And if we had 2 years of major agricultural collapses in a row, we're in deep shit, people, you know?
Well, Randall, what do you think?
And the thing about CO2 is it is plant food, and plants love CO2. And if you doubt that, then, I mean, I've got reference after reference after reference in this essay I've put online that people can read to get what is being said by a lot of bona fide scientists going back from 100 years down to the present time that is not getting publicized because it's getting lost in the clamor that humans are now the sole driver of climate change and that everything we're doing is bad, and therefore we have to have a whole new level of regulatory regime in place to control our behavior, because if we're allowed to be free, we're going to destroy the planet.
Yeah.
Go look at Agenda 21.
The people that are now going to be in charge are somehow so much more moral and enlightened than the rest of us that if we just do what they say, everything's going to be fine.
Have you ever taken into account the intentional weather modification that's happening? Like, we talk about climate change and weather modification here quite a bit because, I mean, they're doing it in China. They've done it in Russia, millions and millions of acres of cloud seeding and all this stuff that, I mean, I'm not even talking about chemtrails. I'm talking about geoengineering or weather modification. There's 50 programs in the States. Like, eventually that's got to start affecting things.
Graham is an all-in believer in chemtrails.
Come on, Darren. So have you ever thought about the impact of that? Because they don't take that into account at all, right? I mean, there's a company out there that's been doing this for decades, weathermodification.inc, and you can buy them to create fucking clouds or rain or sun or whatever.
You know, I just don't know. My initial thought would be that that's possibly a local or regional effect. I don't know if it's having a global effect.
Yeah.
Well, here's an easy one. Look what happened right after 9/11. Right after 9/11, right? When they put a freeze on flights, and they weren't allowing planes to fly in the atmosphere. Well, go look what happened. It got hotter for a couple of days.
Or did it?
Only because there was no flights.
Interesting. I'll have to look at that.
Oh, Rogan even brought it up on his podcast a couple times. That the science showed that just the fact that there was a hold on flights after 9/11 for 3 days, the temperatures went up.
Okay. Well, and that's interesting because then it implies that the carbon dioxide emissions would have diminished from all the flights, right?
Oh, I think it would be the contrails.
Yeah.
The contrails blocking the sun from hitting the earth. You know what I mean? Like the fake little temporary clouds. Yeah. So the fact that wasn't happening and the skies weren't getting dulled. The sun was able to beat on us, you know. So the temperatures change. So if that can happen just by the fact of them not flying for a couple of days, they also do it on purpose.
Mm-hmm.
You know, China was doing it for the Olympics. Trying to clean the air.
I haven't looked into that to the extent. You know, I've focused primarily on natural climate change. And looking at, basically the research and evidence of the IPCC and the scenarios that they have been putting out. They don't really talk about geoengineering in that. So, but yeah, that's probably something I need to add to the list of things that I'm trying to learn about. But, still, I think in the big picture, it's probably of minimal influence relative to the big picture. I've got an interesting quote up on the screen right here now, which is one of the godfathers of modern climate scientists, Herman Sloan. I remember reading this back when it first came out back in 1979, and this was when that really, these are the kind of things that really got my hair standing on end. But he was talking about this is, in the wake of looking at these new radiocarbon dates and realizing the pace of change. This is what Herman Flown said. He said, from the viewpoint of the climatologist, the most important result of these investigations is the fact that within the human timescale of about 100 years or less, our climate is much more variable than hitherto assumed. Especially important, and indeed disquieting, is the evidence of abrupt coolings within warm interglacial periods, apparently as rare events with a recurrence interval of 10 to the fourth years. In other words, 10,000 years. So he's talking about, these massive climate changes that have occurred in less than 100 years. And of course, what we know now is that they happen in considerably less than 100 years. He went on to say that the problem of abrupt, intense coolings during an interglacial climate, similar to the present climate, resembles to some extent the Damocles sword hanging high above the globe and its inhabitants. Because of its possible consequences for the human race, its study deserves a much higher priority. Wow. Now, this was in 1979. So when in the early 90s, when I heard that the United Nations Framework Convention on Climate Change had been convened and we were going to undertake, this massive study into climate change, I thought, good, yeah, we need to know that. I had been thinking that for more than a decade since I had read this stuff in 1979. Well, within a couple of years, it became apparent to me, and then particularly even when I read the charter of the IPCC, that its mandate was to focus exclusively on anthropogenic climate change and to the exclusion of natural climate change. And so that's when I began to think, well, wait a second here. Now, I've been thinking and advocating, we need to understand exactly what Herman Flown is talking about here, the problem of abrupt, intense coolings. And of course, I would add to this natural cooling, such as we've seen in the paleoclimate record. But then natural climate change was just taken off the radar screen. And now you actually have people out there saying, humans are the sole cause of climate change. So what are you saying then? That all of these other factors that may have played a role are suddenly inoperative? Is that what you're saying? That you've taken the sun out of the equation, you've taken the geomagnetic field out of the equation, you've taken the Milankovitch cycles out of the equation, you've taken cosmic dust out of the equation, you've taken volcanism out of the equation, or at least you've said these things are so minimal that we don't need to think about them. And the only thing really driving climate change now is the anthropogenic influence. And I say, no, we can't assume that these natural forcings that we've seen reflected in all of these proxy reconstructions of paleoclimate have now some reason mysteriously ceased to operate. I think that could be a folly of biblical proportions. So,
weren't they saying, didn't they used to have an argument that the carbon dioxide was a different type, it was a polluted type or a modified type of CO2? I haven't heard that in quite a few years, but I feel like a decade ago or so they were plugging that argument.
Yeah, well, that's because the isotopic signature of carbon dioxide released through fossil fuel burning is different than the signature of natural carbon dioxide that's taken up and extruded during the photosynthetic cycle. However, the heat capturing capabilities of oxygen, of carbon dioxide 12, 13, and 14 are basically the same.
Right.
So I really don't know if it means that much.
Yeah. Huh.
So then we get to jump up here to 1990. And what we see from studies of deep sea cores, the deep sea record shows evidence of abrupt climate change centered on the last deglaciation and resulting in a severe cold spell known as the Younger Dryas period. The origin of this climate catastrophe is not known. And it still isn't. And then a year later, we have this report that appeared in Science News. Ice records drilled previously indicate the climate can sometimes fluctuate with surprising speed. In particular, studies of the GISP-2 Greenland Ice Sheet Project 1 core, drilled from 1979 to 1981 in southeastern Greenland, suggest that the North Atlantic region warmed by a striking 7 degrees centigrade in a half a century. That drastic warming far outpaces what the world is currently experiencing. And then James White, who was one of the lead scientists on the study, said that really surprised us that things could happen so quickly. And yet I hear over and over and over again, in fact, Bill Nye, this is one of his constant refrains, is that, oh, well, the climate has never changed as fast as it's changing now.
Oh, geez.
Now, either the guy is completely dishonest or he's completely ignorant of this kind of research.
Probably a little of
I don't know
both.
which it is.
It's probably a little of both.
Probably a little of both. And then 2 years later, after they had learned even more from really detailed studies of ice cores, we find Richard Fairbanks of Lamont Doherty Earth Observatory writing in the prestigious journal Nature, from measurements of annual ice layer thickness over the past 15,000 years, the authors find that Greenland's climate, emerging from the last ice age, twice shifted from glacial to interglacial conditions over an astonishingly quick 3 to 5 years.
Wow.
And we're talking here about 10 to 12 degrees centigrade, which is going to be 15, 18 degrees Fahrenheit. 3 to 5 years? I'm sorry, Bill Nye. You don't know what you're talking about when you say it's never happened this fast before. And he's not the only one that says that. You hear that over and over and over.
And the main
every time I
thesis
hear
for
it,
the
I just
cause
go,
of these ice age is what? Right?
And say that again?
The main cause of what's putting us into these ice ages, right?
Well, that's the mystery.
Mm-hmm.
See, that's the mystery. That's the thing, we need to find out. And if all of the money is going towards exclusively anthropogenic climate change, we're not going to know. We're not going to know what the answer to that question is.
But most likely, we're getting pelted. And we were getting pelted a lot more frequently, according to your graph. We were getting hit with stuff all the time.
Well, see, that's the interesting, which brings up the next question is if I'm going to put out a theory as to what's driving the climate in that to that extent, I would say we probably are going to end up having to go outside to outside sources, exogenic sources, and realize that planet Earth is part of a much larger ecosystem that encompasses the entire solar system and beyond. And when I say the entire solar system, I'm including the Kuiper belt and the Oort cloud in that. I'm including, solar variations. And here's another interesting point. The sun has been excluded from the models of global warming. They're saying, well, solar variability is too minuscule, so we can discount that, right? And so it's going to be solely carbon dioxide. Right. So carbon dioxide's increased, 100 parts per million in the last century, let's say, just in round numbers. Right. So if you have carbon dioxide increasing by 100 parts per million, and you realize that the amount of carbon dioxide in the atmosphere follows a declining logarithm or declining exponential curve, which means that every incremental increase in carbon dioxide in the Earth's atmosphere only produces half as much as the previous incremental increase. What you basically are looking at is a curve that's declining towards zero with each, say, 50 to 100 parts per million increase. Most of the heat trapping capabilities of carbon dioxide, that capture of that 14, 15, 16 micron wavelength of infrared heat coming off of the Earth, most of that is already being captured by the first 100 parts per million of carbon dioxide, right? Certainly by the 200 parts per million. We could keep increasing the amount of carbon dioxide, but the amount of heat capturing is going to continue to just diminish with each incremental increase, because it's just like you could picture a sponge. You put a dry sponge on the table and you start adding water to it. It'll keep soaking up that water until it becomes saturated, and then what'll happen is that the water will start flowing out of the sponge as fast as you put it in, right? Well, right now the atmosphere is near saturation in that most of the infrared heat in that particular wavelength emanating from the planetary surface is now being captured. Most of the heat that carbon dioxide can capture is now being captured. That's the thing. And that's another one of the issues that they don't talk about.
So you could almost argue that you need that CO2 holding that atmosphere, otherwise we degrade back into the ice age.
Yeah, and this again, go back, read the Redemption of the Beast, because I cover what's going on in there, and the studies that have come out in the last decade or two showing that there are places around the planet, like major places around the planet, that are greening for the first time in living memory. And this was first realized, 20 years ago, and the discussion or debate was what's causing this greening, and what you see now is, if you follow the trend of the research, it's pretty much now concluded that it's predominantly the result of carbon dioxide fertilization. The plants are sucking up the extra carbon dioxide almost as fast as we put it into the atmosphere. And I've got showing studies in there where, if we increase just, a modest increase in the amount of forest coverage over the surface of the earth, and the biosphere is going to be sucking up that carbon dioxide as fast as we put it in. Now, again, I'm not saying here we need just completely, proliferated, carbon dioxide consumption, because I am very much an advocate of moving beyond a fossil fuel economy at some point. Mm-hmm. But again, it's all a matter of putting it into perspective.
We're going to have to use it until we can get there, though.
See, that's the thing. That's exactly right. Because what we have is we have an energy source now that's available. And in that, we need an energy source in order to make the transition. See, and again, I discussed that in this essay that I do hope people go on and read it.
Oh yeah, for sure.
Well, I would like to tell people that they really, if there's a video you did a while back for Geocosmic Rex video,
yeah,
where you go over that old alchemical drawing.
I'm not remembering which one that would be.
The one with the two-headed knight standing on top of the on top of the dragon.
Yeah. Right.
That was a mind-blowing lecture.
Good.
I mean, that picture is that's something I keep on my phone just to show people and talk about it. And I would like to learn where I can get more information, because every time I look at that and I find a piece of, and typically it comes from things I've heard you say, and I go look at that picture and I'm just like, whoa, there's so much there that is just, like you said, like we live on one badass planet. This planet is amazing, and we need to be as responsible as we possibly can. But one of those things is we need to, in order to protect it so we can survive here, maybe we should figure out how to defend it from outside forces.
Yeah, because even those long cycles that you're talking about 26,000 years, you were saying it could be, more. What did you say? It's more of the solar system, or not even including the Oort cloud and the Kuiper belt. Well, we could be going through a part of the galaxy every 26,000 years that's bombarding us and causing all this damage as well, and that could be some of the reason why. They knew back in Göbekli Tepe time or whatever, they knew that it was coming around again.
Yeah, I think that the idea is completely plausible, that there is a periodicity to exogenically driven planetary change. And this is a whole nother topic of discussion. I think it's one of the most important discussions we can have at this point. Because, like almost on a monthly basis now, we're seeing stuff fly by the Earth, where we're getting to realize, unlike a generation or two ago when we imagined we were just in this pristine emptiness of space, we realize now that there are, there's a lot of stuff out there flying by the Earth. And, the question is, are we just seeing it more often? Or is it actually increasing?
Yeah.
And the models that I'm looking at, and the research I've been doing, suggests that the exogenic factor is being seriously downplayed. Whether it's intentional or not, I don't know, but it just seems like it's being de-emphasized because it could be a whole lot more significant player. I mean, going back to that famous 1908 Tunguska event, which to me was definitely a cosmic learning experience. And we're still deciphering the mysteries of that 1908 event, which was probably a member of the Taurid meteor shower, which interestingly has come up as a prime candidate for the possible impacts at the end of the last ice age, and has been found its way into a lot of mythology, during going back centuries. And I will be developing additional essays, and probably even the book I'm writing is going to get into some of that, showing the myths of the celestial bull and the slaying of the bull, particularly in some of the religions like Mithraism, which was one of the main competitors of early Christianity in the Roman Empire. And they have a whole scenario called the Tauroctony, which is based around the idea of the slaying of the bull. And of course, the slaying of the bull is Taurus, the bull. And, the Taurid meteor shower is so called because it's radiant. The point that it appears to be emanating from space is centered right on the shoulder of the bull. And in the Mithraic traditions, what you see is Mithras slaying the bull by driving a sword into his shoulder, which in the classical depictions of Taurus is exactly the radiant point of the Taurid meteor shower. And then in
that quote earlier, you were talking about the sword in the sky.
Mm-hmm. Yeah.
What was that? What was the name? Yeah.
The Sword of Damocles. It's from a Greek myth. You can look it up.
Yeah, it's just fascinating why we should have treated that last one that happened in Russia. That should have been a fire drill or like an earthquake drill. Yep. Remember you used to have to hide under your desk for because the Russians are coming.
Yeah,
the planet should be planning for this stuff.
Yeah, and I think it's going to take a couple of more events. It may take, if that Tunguska, if we had a repeat of that now, and an event like that happened over a densely populated part of the globe.
Don't say Seattle.
That event, you're talking about 150 foot wide, roughly, piece of space debris flying into the Earth's atmosphere, exploding 5 miles up with the force of about a 12 to 15 megaton hydrogen bomb explosion. And that is enough to basically pretty much level any major metropolitan area in the world. Luckily, at the time, it was over a sparsely populated area of Siberia, right up there at the northern limit of the old-growth taiga forest. And it exploded and decimated, if you will, over 800, about 800, I think, 50 square miles of old-growth forest was just leveled. And if you look at any major metropolitan area, like in the U.S., like, say, Washington, D.C. or Atlanta, you look at a map of Washington, D.C., and you look at the perimeter highway, or you look at, like, Atlanta or New York, and you look, many of the big cities have perimeter highways around them. The area I've calculated is the area inside of 285, which is the perimeter freeway around Atlanta, is almost exactly the same size as the amount of devastation caused by the Tunguska blast of 1908. So, if you had just a small little speck of space debris like that come into the atmosphere and blow up over the eastern seaboard or over Europe or something, you'd potentially have millions of casualties.
Is that also going to...
what, guys? That would be a wake-up call for the human species.
Yeah, and is that also going to come with an electromagnetic pulse at all as well? Now that we're all in the digital age and everything is electrical, like when Tunguska happened, we wouldn't have known the electric effect of that.
Yeah, I mean, it could certainly have EMP effects.
So even though it might destroy Atlanta, it could destroy the whole, North America with a pulse.
Yeah.
The telegraphers, the people running the telegraph machines, didn't people get electrocuted
during Tunguska or the Carrington event?
That was the Carrington.
Yeah.
I don't know about that.
That was strictly the solar flare, I think, or the solar maximum or whatever.
Oh, is that okay?
Mm-hmm. Which brings me back to a point I was about to make, and it won't take me a second, which is that the sun is discounted. And then, basically carbon dioxide is considered the sole driver of climate change. But even those promoting that in the scientific community will admit that by itself, and in all of the computer models, well over a dozen, I think 15, 16, 17 computer models, basically what they do is they put in a whole bunch of positive feedback parameters. So you've got essentially the initial warming of the CO2 is admittedly not going to drive this catastrophic climate change. So you have to have positive feedbacks, which take the form of water in additional water vapor in the atmosphere, and water vapor is actually the most effective greenhouse gas. So, in other words, the slight warming caused by the carbon dioxide increase then causes more water vapor into the atmosphere, which captures more heat, and then that triggers this runaway warming. And so it's basically these hypotheticals feedback processes. But of course, the thing is that, a lot of atmospheric physicists and meteorologists and stuff have said, well, more water vapor in the atmosphere means more clouds, and more clouds has a net cooling effect. So, maybe your series of positive feedbacks is irrelevant. But I find it interesting that they're totally willing to theorize that there is a series of feedbacks that amplifies the initial effect of carbon dioxide, but then they completely discount the possibility that there might be positive feedbacks related to the amount of solar radiation coming into the Earth. But again, that just suggests to me that, what you have here is a preordained outcome, and all of the science is basically oriented around this idea that humans are the cause of climate change, and then all of the things that then follow from that, which whether it's a carbon tax or cap and trade or, the control of energy resources by the governments, there's all kinds of agendas tied in with it. And now you have this whole industry, global warming industry, that's on the receiving end of literally of hundreds of millions of dollars. People talk about, Exxon was contributing money. Well, if you read the studies, what you find out is that Exxon contributed a total of about $19 million over a period of 10 years. And this was to over 30 groups, many of whom didn't even do climate change research. And if you extend this, average it to 30 some groups over 10 years, it works out to be about $65,000 per group on average, which would be enough to basically fund some mid-level employee for a year. But then, what did Obama do just before he left office? He gave the second installment to the Green Climate Fund of $500 million, which, was the second installment. So here was $1 billion within the last year or two going towards this, conclusion that greenhouse warming is going to be catastrophic and it's caused by humans. And basically, we need to implement all of these controls on human behavior. I'm all for. Listen, I'm totally for alternate forms of energy, and I want that to happen. But it's not going to happen if the government continues to confiscate hundreds of millions of dollars and put it towards a contrived catastrophe. I think that there will be free market solutions that will bring us to where we need to be a whole lot faster. And what we need is basically to hear all sides without the demonization and all the accusations and all of the ad hominem arguments. We need to say, we're saying, well, a lot of these guys that have raised issues about the so-called consensus are raising legitimate questions. And rather than marginalizing them and demonizing them and calling them names, we need basically an unbiased debate more than anything. What you find over and over ago then is that, the side that's promoting global warming doesn't want to debate. That's why they keep saying the debate's over. But the debate hasn't even begun yet. So how is it can it be over? So,
yeah.
Maybe the debate will start this year.
Hopefully. Yeah. I mean, do you have anybody that you would like to debate, Randall? Anybody specifically that you think you'd, not that they would, but if you could choose somebody.
Well, I think it would be really a lot of fun debate to debate Bill Nye, I have to confess. But,
yeah. It
I'll
wouldn't.
start
he would-
tweeting.
That might be
handle
too
it.
easy.
I'll start tweeting them. Start egging them on.
Hey, why don't you see if you can get Bill on your show?
Yeah.
Well, we had
I'll
somebody.
try.
We had somebody on talking about the planetary missions and stuff like that. Emily Lockdawala. She works for the same organization as him, so we had her on, and we didn't really talk about Bill at the time. So,
So what did you talk?
all the planetary explorations right now, all the different missions going out there. It was a pretty cool scientific chat, just about all the global missions all over the galaxy right now, or not the galaxy, the solar system.
Yeah. Now, that's something I can completely get behind. And, interestingly and ironic, I think that Bill Nye is also a big advocate of that.
Yeah, well, he is. Yeah, that's his whole planetary.org or whatever that organization is. He's the head dude there. So, it's kind of a contradiction in a way.
It is. That's how I look at it. And I would say, Bill, I'm with you on this one, but on this issue, I'm totally behind the idea that we need to listen. If we could stop spending, $1.5 trillion, $2 trillion a year on war and spend it on the exploration and economic development of the solar system, wouldn't that be about 1 million times better?
Yeah, exactly.
Yeah.
And where's his experience to put him in a position like that?
I don't know.
Because he does what he's told. That's why.
But all of these companies that are making the billions off of preparing for World War III, hey, wouldn't you guys rather make the same amount of money, but by moving the human species into the solar system and putting us in a position where we're no longer vulnerable to these kinds of cosmically induced catastrophes? Wouldn't that be worth
And for
pursuing?
every dollar that we put into the NASA program, didn't it produce like $7 into the market?
Something like that, yeah.
Yeah, I heard it was for every dollar we invested into NASA, it produced $7 because of all the things that were invented and commercialized, like Velcro, like Tang. It's
sticky notes.
It's almost like it really does feel like it's our purpose to get out there and explore it, but somebody doesn't want us to do it.
But it seems like, I believe it's our destiny. In fact, I would even go so far as to say this. I think that basically what we're going to see is that when we look at the history of life on this planet, what we see is a pattern of constant interruptions. The old uniform, gradualistic, Darwinian model of natural selection, incremental change through natural selection, playing out smoothly over millions of years, it's just not there anymore. In the older models, what you had was like at any given time, there's maybe 10% of existing species going extinct, being replaced by 10% of new species appearing and filling those vacated niches. But, that model is obsolete. The model now is that, life goes along just fine, and then all of a sudden it's interrupted, and 75 or 90% of all the species on the planet suddenly disappear. And then you've got this hiatus in there, and then suddenly these vacated niches are filled during these events called rapid speciation events, which we still don't know what causes that, really. Mm-hmm. I have a suspicion that the same factors or forces that cause the mass extinctions are also introducing catalysts into the biosphere that can trigger accelerated evolution. But that's
like the Cambrian explosion kind of thing.
Perhaps like the Cambrian explosion. Yeah, one of the things that's interesting that's come out of Russia post end of the Cold War was all their studies on the Tunguska site and accelerated mutations that have taken place in plants and animals in the region of the Tunguska blast. And so that's a very, very, to me, interesting area of research.
Yeah, very.
Yeah.
The Russians have a lot of information that we don't have, I think.
Yeah. And this is why we need to be talking to the Russians instead of demonizing them,
Or is that why they're being demonized?
Maybe so. Well, I think they're partially being demonized because, they want to push this $1 trillion nuclear modernization. And it's not going to go through unless we've got, enemies to justify it. So, basically what they're wanting to do is implement a first strike or preemptive strike capability. And that's what all the new the new generation of nuclear technology is designed to do. And I'm not sure if we need to go there. I think we need to be sitting down with the Russians and saying, hey, look what happened to you back in February of 2014. That's going to happen again. And do we want to go toe to toe and become enemies again? Do we want to revive the Cold War? Or, hey, why don't we collaborate and cooperate on the exploration and economic development of space? Wouldn't that be a whole lot better?
Well, they're all in. We have to hitchhike with them now.
They are in. That's the irony here. They're in. But it's
if we want to go to space now, we have to ride a Russian rocket.
Yeah. And of course, everything, all the signals we get from Russia is that, hey, yeah, we'd rather partner with you instead of, and so then you've got basically this demonization, like, okay, they're not perfect. Putin is not the perfect angelic being. So therefore we will demonize him and demonize the Russians and everything to do their nefarious objectives or whatever. We'll demonize all of these people for purposes of basically establishing global hegemony. And, is that really in America's best interest to try to become the policeman of the world? I don't think so, because it's going to be a never-ending process whose final end can only be catastrophe that we brought on ourselves, or because we're so preoccupied with stuff down here and with each other and trivia, something cosmic sneaks up on us and kicks our ass. And this is why I'm so disappointed in the left, because when I came of age back during the Vietnam War, the left was the primary advocate for free speech and free unfettered speech and anti-war. And now look at them. Look what the left is consumed with. What bathroom we're going to use, and microaggressions and cultural appropriation and white privilege and all of this stuff that really amounts to absolutely nothing except a big distraction from the real stuff. So, I think the left has lost all credibility, and I'm just hoping that somebody on the progressive left finally says, wait a second, our fundamental purpose and our best, the best that we were in the 20th century was when we took a stand against war, when we stood for free speech, regardless of what that speech was.
Well, the problem is
we weren't out there trying to shut down people who disagreed with us.
Yeah, and that's not an organic movement. That's the problem I have with it. It's intentional. Yeah. It's being pushed through certain agendas, and it's all part of, trying to globalize the whole system here. So that's what's frustrating for me.
Yeah. And now they're live action role playing as ISIS characters. It's like they shop at the same clothing store.
Yeah. What's that all about?
They're ISIS LARPers. That's what they are.
That's good stuff.
I never thought about it like that. It does look similar.
Yeah, go look at the people have been doing the Photoshop of ISIS people, standing on top of their trucks or whatever with those leftist flags.
Yeah.
It's like, which one is this?
Hey, Randall, while we have a little bit of a break here, kind of a lull, do you want to talk about, do you want to mention your stuff again here? Like what you guys are doing on your website, and you've got a sale on some of your DVDs and your classes. Can you describe a bit of that for us?
Yeah. Well, we've got this a sale on the new Blu-ray Cosmic Patterns and Cycles of 4 or 5 hours of stuff, and it's got charts and graphs and video clips and high resolution images. It's chock full of juicy stuff.
It's amazing. And I'm actually that's why I asked you, since you have a Blu-ray now, I'm gonna get it because I loaned my copy out a couple times, and this last time I didn't get it back.
Well, you get 33% off. Use coupon.
Yeah, I'm going to go get my 30%.
Yeah, there's a for Grimerica, you're going to get a special deal just because of my good friend and how you guys put us up when we were, about to launch our last expedition up there. And there was 8 of us, and Darren put all 8 of us up in his house.
Yeah, that was an awesome podcast. That was a fun one.
Wasn't that fun? That was a lot of fun. Yeah,
Yeah,
it sure was. And
Oh,
I
yeah,
would
we were
like
just
to do it.
chatting in his garage till the late hours, and yeah, it was great.
The real hero is my
Yeah.
wife for not killing us.
Yeah. So here I want to take this opportunity before millions and millions of people to say thank you to your wife.
Oh, yeah.
What's your listening? What, 400 or 500 million?
Getting there, yeah, about $500 million.
Getting there?
Yeah.
Yeah.
So what about your classes, Randall? You've also got, I took one of those it was probably a couple of years ago now.
Sacred geometry.
Yeah.
Well, and then we're going to be doing podcasts because Cameron is, I'm here in the studio now. He's set up a whole studio here. So we're going to be taking some of these things that we've been talking about and a lot of other stuff. I've got tons and tons of material. And we're going to be putting together a series of podcasts. They're going to be short, little, easily digestible, like I said, 20 to 30 minute segments covering a variety of topics that we've been talking about here, and then a lot of things we haven't been talking about. And we're kind of coming up with a list. And if anybody out there has ideas, if you hear something that you find particularly interesting, you want to know more about it, you can make a suggestion and say, hey, I want to hear more about Mithraism, or I want to hear more about the Holy Grail, or I want to hear
Where do
more
I
about
send my
Earth
list?
Cloud or whatever.
I have a long list, Randall.
Okay.
There's so many things I've heard you talk about that I don't hear the interviewers, like, they kind of just brush over it. And it's like, oh, no, go back. It's the one thing I don't like about podcasts, because I love it. I listen to about 10 hours a day of podcasts.
Uh-huh.
And the one thing is I'm not part of the conversation. Like right now, this is such an honor to be talking to you and hanging out with you guys on here. It's just like, there's so many things I've heard you bring up that I'm like, oh, wait a second. There's something more to what he just said. You're not even getting into it there. So I was so stoked when I heard Cameron talking about the Gnosis podcast. It's just, I've been bugging him on Twitter about it too. He's like, it's coming. I'm like, I want it now.
Yeah,
but
it's
you should tell people why
trying to
they
raise
should
the funds to buy the equipment, and I'm still barely out of the red. My business got hit really hard by the recession, so I went from being relatively prosperous to being relatively poor, and I'm just now kind of coming out of that.
And that's Archetype.
Yeah, that's Archetype Builders, and Cameron's going to be putting up some of that stuff on the website.
Go check it out, guys. It's actually, Randall, you're good. You're really good at it. I dabbled in construction when I was younger, and yeah, it's really good, guys. Go check that out. But as far as like the sacred geometry, have you told people like why they should get those classes? Like what? Because I don't think that most people they hear it like, maybe they don't know what it is, or they don't know what it might do for them, or what the experience they might be getting out of studying something like sacred geometry.
That's a good question.
Yeah. Well, I mean, for me, it's something I got interested in a long time ago in the early 70s when I discovered Buckminster Fuller's work. And I got commissioned. I was part of a group that we were doing a retreat in northern Minnesota, and me and my two younger brothers got recruited to be lead carpenters on building 2 geodesic domes, Fuller domes. So in order to be able to do that, I had to go and study geodesic geometry. And that's how I discovered Buckminster Fuller. And then that led me into the studies of geometry. And I discovered that, geometry was one of the common themes of all of this ancient, particularly sacred architecture. The term sacred geometry, I've seen people online, on some of the comment boards saying stuff like, well, Randall Carlson, he believes in sacred geometry, so that discounts anything else he might say, and of course they have no idea what sacred geometry is. They probably don't know, they probably wouldn't know, the Pythagorean theorem if it came up and kicked them in the ass. But, the thing is geometry has been around since the very dawn of recorded history. The Egyptians were major utilization of geometry. Basically, all the ancient cultures, the megalithic cultures of Europe were using geometry linked with astronomy. The term actually, is I've been able to trace in historical sense, was from the work of George Lesser, who was a early 20th century Freemason who studied the systems of geometry used in the building of the medieval ecclesiastical structures. So he was mainly looking at churches and cathedrals built during the Middle Ages and studying, because they were very much utilizing geometry. I mean, when you look at the ogival vault in a Gothic cathedral, it's pure geometry. You look at the floor plans and how they developed them, it's pure geometry. You know, he called it sacred geometry because it was primarily being used in the design and construction of sacred structures, that is, structures that were ecclesiastical in nature. But then, you know, it began to expand from there. There was another Hans Bruns, who was a Danish, again, a Freemason, who came along after Lesser and published a 2-volume set on ancient geometry and its uses. And he went back not only to the guilds of medieval builders, but back to the classical Greece, the building of the Greek temples and the geometry that they employed, and showed that there was a consistency between what the Greeks were doing and what the medieval ecclesiastical builders were doing. And then, you know, you had people like John Michel and Keith Critchlow, who expanded it beyond that, showed that, you know, at the height of the Islamic Empire, 9th, 10th, 11th century, when they were building these incredible mosques, they were using geometry and basically the same geometric principles that were being used by the Greeks, by the cathedral builders. And then, you know, what both Critchlow and John Michel showed was that you could find the same geometry embedded in the megalithic structures of Europe. You had then scholars coming along showing similar geometries being used by the Mayans in the erection of their temples and cities in Central America. And then some of my own work and a few others have shown that that's entirely consistent with the monumental earthwork architecture in North America, the Mississippian culture, the Hopewellian culture, the Chacoan culture were all utilizing geometry and using geometry to not only to lay out the patterns of the ground plans of these structures and their elevations, but also to link it into astronomical patterns and astronomical movements. So it's a very, and then you've discovered that there's been scholarly research showing that, you know, a lot of the artists, Renaissance artists, and really going back even to Greece, there was a secret system that was passed down that was using geometry to set up grids over which the paintings were laid, so that you, and I've got a PowerPoint show I've put together, and we maybe could do a podcast on this, showing how they set out some of these grids, and some of the great masterpieces of Renaissance art are superimposed upon these grids. Now, there's nothing woo-woo about any of this, but some of these mindless idiots that come on and make their comments who don't know anything, they're saying, I think even on the one of the wiki sites, somebody says, Randall Carlson, he's into that sacred geometry woo. Well, you know, I mean, that's what all you're doing there is you're just basically confessing your stupidity before the world, because the study of geometry throughout history is a very complex, very sophisticated study, and it was utilized. There's no question about it. These people used geometry, and their systems that they used was primarily employed in the erection of structures that had a spiritual purpose. Therefore, the term sacred geometry, right? And there's nothing woo-woo about it. You know, that's just in the imagination of these know-nothings that like to get on and spout off, you know, thinking that somebody somewhere is going to be impressed because they can spout off and call somebody a name. But sacred geometry is really a powerful system. Then of course, it goes from there, because it's not limited to the
physical structures. Yeah.
Right. It also, you find it in nature, you know, and it's embedded in all levels of nature, from the atomic and molecular levels up through, you know, vegetation and plants, right up through the solar system and the structures of the galaxies. We find geometry, and it's a consistent geometry in the human anatomy. In the anatomy of living things, we find geometry. You know, the golden section is probably the most famous of the principles of sacred geometry. And, you know, it's completely embedded or embodied in human anatomy. Anybody can take their forearm from elbow to fingertip, divide it in that special relationship, the golden ratio or the divine proportion, where you divide any length into two asymmetrical units, where the small is to the large in exact proportion as the large is to the sum of the two. And that's the golden section. And it's been somehow utilized by life processes over and over and over again. And anybody who looks at their forearm from elbow to fingertip, and then if you feel, anybody listening, try this, hold your forearm up in front of your face, feel around on your wrist, and you'll find this hollow space in your wrist called the space of Destot. And if you go from the fingertip of your longest finger to that space, that's your short increment. Then from that space to your elbow is the long increment, and it stands in exact relationship as the long increment does to your entire cubit or entire forearm. And then you hold up your index finger out in front of your face and look at the first digit from the tip of your finger to the first joint, and then look at the distance from the first joint to the second joint, and then from that joint to the knuckle. And that increase of expansion is following the golden the golden proportion. And then it goes from there. I mean, if you stand up against the wall, take your total height, divide your total height by your navel height, you'll find that proportion is embodied there as well. So, I mean, this is all geometrically demonstrable. And for somebody to dismiss it because they think it's something woo-woo is just, it's just their ignorance. That's all.
And and if you have somebody who doesn't follow that ratio, it sticks out.
Yeah.
You know what I mean? You're like, well, there's something wrong with that. There's something wrong with that. Well, it's off. Well,
is that what's going on with Darren, do you think?
What the fuck?
I think, Darren, when I get back up there, I think we need to do a detailed analysis of your proportions.
Sounds good. Sounds kinky.
He's way taller than he sounds, isn't he?
Yeah. Well, when you're an infant that's born, your navel, basically the navel of a newborn infant divides the total body length basically in half. And then once you've reached adulthood, what you've essentially done, obviously, if you had a human being walking around at full growth that had the proportions of an infant, they would look really strange, wouldn't they?
Yeah.
But what happens is as you grow up, you're growing into the proportions of the golden section.
Oh, that's interesting.
Yeah.
Wow.
So
if you take the average, if you add up,
and yeah, I think what you're going for, Cyrus, is that everybody deviates a little bit. But if you start averaging lots and lots of people, the more data you have in your sample, the closer it's going to get to being right on the golden ratio, which is roughly 1.618033989 non-repeating.
And the more people you get involved, it's like we're all in this together, people. You know what I mean? It's I don't know. It's one of those things when I think about it, if I go too deep into it, it starts getting mind-bogglingly like it's all for us, it's there for us, and it definitely feels like it's something that's being kind of hidden from us on purpose. Mm-hmm. It's part of us. It's part of some kind of plan out there trying to keep the real information from us. And there's guys like you out there, and there isn't enough. There's not enough people like you out there, Randall, that are trying to get the good stuff out here. Because if you look at it, there's a systematic dumbing down of the education system.
Oh yeah.
Oh my gosh. It just needs the whole thing needs to be blown up and restart. Because if you go look at junior high school text from over 100 years ago, if you give that book to a college student, they're not going to be able to do it.
Right.
And they were doing that in junior high.
Right. Yeah,
go read love letters from World War I that soldiers sent home, and then go read some. It's like, my dearest Clementine, I bestow upon you the greatest love. And you go read one from the Iraq War. It's like, yo, bitch, what's up?
Yeah, I know. Well, that's basically coming from a century of allowing government to run our education system. That's why I'm a strong advocate of the complete separation of government and education.
Yeah, and go look at the people who started it, guys. Go look at listeners out there. Go look at the people who started the education system and why.
Yeah.
The farther back you go, the Prussian education system, the pre-German Prussian education system is what we have now. It's not for making smart people. It's for making
on that too.
Yeah, we do.
Yeah, we'll throw that in the show notes.
Hey, I need to take a quick 1 minute break.
Well,
Can you guys tell entertaining stories until I get back?
Yeah, we could probably wrap it up.
But just talk about you.
And we can go on for another 15 or 20 minutes. I just need to take a break.
Okay,
yeah,
I'll be right back. Okay.
Tell us a story, Cyrus.
Oh, I'm really enjoying myself, guys. Thank you so much for having me on and letting me listen.
No problem.
Like I was more than willing to turn my microphone off and just participate in the eargasm and the oral, the visual aids. Yeah, people, go watch this video on YouTube. You got to see this.
Well,
stuff.
not only that, he has the classes, right? The 4 or 5. He has the 4 or 5 classes going on. 4 or 5 hours worth of sacred geometry classes too, right?
Yes,
so
and there's
that's pretty
can find some stuff on his website. You need to go to Sacred Geometry International, the website, and trust me when I say that there is so much information on there. And if you do the face bags, if you're on the face bags, go sign up for Sacred Geometry on Facebook. You're going to see some fantastic articles, fun things to read, and then Cameron has some people on there that are amazing artists.
Absolutely.
You're gonna see some fascinating stuff, and if you studied sacred geometry, which I'm starting in, and I think I'm gonna go buy that stuff tonight. The rest of it, you'll. If you don't understand sacred geometry, you're not getting that much out of it. It's not only is the art beautiful, but it's actually meaningful. But you need to understand what the artist is saying.
Absolutely. Nice one, Cyrus. That was perfect.
Yeah, good job. Are you back, Randall? Or?
No, can't you see?
Oh, what? I don't know.
The empty chair.
Oh, that's what that is.
If more of you supported the show, I'd be less sick of podcasts.
The blah blah.
Sending out good vibes.
Blah blah.
Yeah.
Good vibes. Good vibes. Good vibes.
108 breaths of deep gratitude and prayers for guidance and protection. And put on a didgeridoo and shamanic drumming track. Shivers or vibrations and stuff like that. 108 breaths of deep gratitude and prayers for guidance and protection. And put on a didgeridoo and shamanic drumming track. Shivers or vibrations and stuff like that. 108 breaths of deep gratitude and prayers for guidance and protection. And put on a didgeridoo and shamanic drumming track. Shivers or vibrations and stuff like that.
If more of you supported the show, I'd be less sick of podcasts.
Blah blah blah. Blah blah blah. Oh man, I gotta get an ISO of that.
I don't remember.
Have you guys ever watched the videos on the Geocosmic Rex YouTube channel that Randall has from old lectures and stuff?
Yeah, there's one actually there that I think you can see me in the background of at the Big Rock, jumping around like an asshole.
Yeah, that's right. And then there's a lot of lectures that he does down there in Atlantis, Georgia.
Atlantis. That was on purpose?
Yeah.
Okay. That's good.
That's what it was named after, right?
Is it? I'd have to take
From my
a look.
understanding. But I might be wrong.
I'll take your word for it for now. Till I hear otherwise.
Actually, I bet you Randall knows.
Okay, just got back in time to hear. I bet Randall knows.
I called Atlanta Atlantis, and I did it on purpose.
I've wondered about that over the years, and I'm not sure if I know what that connection is.
Darn.
Yeah, right. Sorry to disappoint.
There's too much out there for everyone to know everything, but you're coming pretty close, Randall.
I estimated the other day. I think there's 4 things left that I don't know.
Well, didn't you start? You made it a rule to read a scientific journal a day, right? Like a long time ago.
Article. A minimum of 1, yeah.
A minimum.
Sometimes 2, sometimes 3. Depends, how complicated it is and how long it is, 3 or 4.
And how long have you been doing that for?
Pardon me?
And how long have you been doing that for?
Oh, gosh. Since, the mid-70s, I guess.
40 years.
Yeah, so I've
40 plus years.
Yeah, I mean, in my archives, I've got thousands of articles, and and I haven't read every one, but I could say I've read the abstracts of every single one, so I know what's in them. And if I need to, I can kind of go. I've got them all in binders, chronologically ordered by subject, and of course now, with the internet, there's so much you can do on there, and I have borrowing privileges, at a major university, so I have access to that, and then there's Google Scholar, and there's ResearchGate, and if you go onto the websites of a lot of the principals doing research in various areas, they will have links to their articles. So yeah, I mean, it's incredible how much information is out there now, and it's just too bad that we're getting inundated with this trivia and bullshit, that people get so consumed with that is of no consequence whatsoever to our future, other than serving as a distraction from the things we really need to be paying attention to.
And what's the definition of gnosis? Can you tell the listeners
that's the Greek term? It basically means knowledge. And in the early days of Christianity, there was Gnostic Christianity, which was basically suppressed with the rise of the authoritarian church. And the difference was the authoritarian church, the Holy Roman Empire, Church of the Holy Roman Empire, basically said if you want to have a relationship with God, you can only do so through the intermediary of the authoritarian church. And basically, they realized that they could use fear to, subjugate people to submission. And whereas Gnostics, the early first 2 century Gnostics their attitude was, well, no, you can have a direct relationship with God. You don't need the intermediation of the authoritarian
church. They wanted to put God in a box.
Sure.
Right?
Yeah.
So, and remember, last time God was in a box, you couldn't come anywhere near him.
Yeah. So that was the gnosis. The gnosis basically means knowledge, and knowledge of both things seen and unseen. And, so that's kind of where, it's a very useful, broad term to kind of cover what we're trying to do with it.
Do you have access to the Vatican's library? That's what I want.
Yeah, I was in there this morning.
Yeah,
shuffling around. No, I don't.
Were you the one who slipped that letter about that took the that basically said that the Pope wrote a letter during the time of the Templars, basically saying that they never did commit blasphemy and all that stuff.
Oh,
it's like, you guys have that in there, and you never, like, it was just your secretary found it on accident one day. What else do you got in there? I want to know, what books did you steal out of the Library of Alexandria?
Yeah.
You have any of those?
Well, see, yeah, and you bring up a good point, Cyrus. It's the, through the centuries and the millennium, the amount of information and knowledge that has been lost is almost inconceivable, both through deliberate suppression and both just the vagaries of time. The great Alexandrian Library of Egypt, had 400,000 volumes of ancient works in there that was destroyed. The Library of Carthage, very similar.
They wanted every book in the world in there, right?
Yeah.
So they would step above aboard your ship, looking for books.
Yeah.
And if you either gave it to them or you allowed them time to copy it.
Yeah.
Right.
So, and then all of that's lost.
Yeah, let's burn it.
Can you imagine what might have been in those volumes? And this is why I say over and over again, no, look, we can't make any hard and fast conclusions about ancient history because there's so little. There's been so much that's been lost. And, it's just so convenient and easy to come up with this sort of exponential curve of civilization, from thousands and thousands of years of barbarism and pre-scientific illiteracy and, basically hunter-gatherers. And then somewhere, within the last 500 years post-Renaissance, we began on this upward arc, and now we're at the peak of civilization. And,
quit holding us back. You know what I mean?
Yeah.
It's like you're holding us back. You just let us rip. Let us go.
Sure.
We got stuff to do.
Yeah. And I think the real model, not only of, I was kind of getting to this point earlier, is that now the model of life on this planet is one of it's a sawtooth model. Species proliferate, they come to a peak, and then suddenly it's interrupted and the number of species drops. And this is the biological model. It's basically being accepted. Stephen Jay Gould, who coined the term punctuated equilibrium to describe this process. Well, I think the next level of insight that needs to evolve and is evolving is recognizing that the model of civilization is basically mimics that of life as a whole. It's sawtooth rather than this smooth ascending curve. And that just as species have become extinct, civilizations have become extinct. And we really do need to understand that process if we're not going to fall victim to it ourselves.
Well, the thing is that there are groups of people who have this information and they keep it to themselves. They let their kids learn it, but they're not going to let your kids learn it. You know what I mean? And I have 3 boys and they're going to public schools, and this Common Core crap is unfathomable to me. Like they are trying to ruin math. 2 + 2 = 5. No, it does not.
Yeah, I mean it's almost humorous.
Never will.
Really. But see, just think about the term itself, Common Core. The idea that you have to have one system imposed from the top down on everybody. And that's not what we need. We need true diversity. And this is why I've been a homeschooling activist for about 20 years. I taught a lot of classes, tutoring to kids that were being homeschooled. And it was really an eye-opening experience for me to see the difference between kids that were being indoctrinated in public schools and what that did to their love of learning, and then seeing kids that were being homeschooled that basically, look, you can learn whatever you want to learn. It's wide open. What do you love to do? That's what you're going to learn about.
Hey, my kids are getting homeschooled. Will you give them some online Skype courses?
Yeah, I mean, good for you, Darren. Good for you.
Yeah, that's nice, Darren. Could you imagine having Randall as a
I'm going to call you up, Randall, and get you to give him a couple of courses.
Sure. Well, you get the geometry course. It's basically a drawing course, and most kids love it. And when I taught geometry for 15 years, and mostly what I would start math courses by having the kids draw, and it was really for the first few months it was more like an art class, and I would take them through the principles of geometric construction, show them, here's how you erect perpendicular lines, here's parallel lines, here's how you can create an equilateral triangle. Here's how you create a square. Here's a pentagon and other polygons. And here's the relationships in them. Now that you've drawn this right triangle, let's study the 3 sides and their relationships. And it's not something that's totally abstract because they've just finished drawing these images. And they would have, like, at the end of a course, after, 9 months, they would have a whole drawing book filled with diagrams and patterns and stuff that they had drawn. And then from there, I would segue into the more abstract. Well, look, here's a right triangle, and let's call it sides A, B, and C. And now when we say A squared plus B squared equals C squared, it relates directly to this drawing that they had just done. And then basically I take them through that curriculum of geometric drawing and then use that to segue into the higher math. Because it all starts with geometry, basically everything, no matter, getting into the higher levels of, differential calculus or integral calculus, it all ultimately traces back to geometry and some fairly simple geometric principles. And the thing about math is math, if there's any subject that you need to go at an individual pace, it's math. And this is why, again, in the public school system, it completely fails, because they basically get a room full of 25 or 30 kids and they have one pace. And out of that 25 or 30 kids, maybe there's 3 of them where that's the optimum pace. For some of them, it's too slow. They get bored and quit paying attention. For most of them, it's going to be too fast, and you move on before they've grasped the basics. And that's where math gets so frustrating. If you take it one principle at a time, and it's targeted to the individual's optimum learning speed, you can get it. Anybody can get it. But I go, okay, so you've got kids coming out of high school now that have spent 12 years in this government educational system. They can barely read, they can barely write, they don't know math, they don't know history. And so, that 12 years has been completely wasted. And in fact, really all it's done is bring them into a place where they can, get with their peers and basically go for the lowest common denominator.
Might as well.
That and the government can raise them.
Might as well have been sewing sweat shoes.
Yeah, and if you look at history, what you see is that throughout all of cultures in history, you see that once a kid reaches adolescence, it's time to start integrating them into the adult world and being treated like a young adult, not a perpetual kid. But now what you have, when you look at these, these butterflies, these snowflakes, in college, it's like, hey, wait a second, you guys aren't 6 years old. You're supposed, by the time you get 20, 21 years old, you're supposed to be an individual that can stand on your own 2 feet and can take it. What the hell is this business about safe spaces? Because somebody's going to present an idea that traumatizes you. This is a byproduct of the government running the education in this country,
Now I feel triggered.
Yeah, I'm sorry if I triggered you, Cyrus.
Okay, I'm going to go get my color crayons. I'll be right back.
Warning.
What's happened is colleges now aren't like places where you're really challenged. They've turned into this glorified romper room.
Well, I know this might not be a good comparison, but Rogan's always talking about domestic pigs and wild pigs, right? Mm-hmm. We're basically keeping the kids at a baby state, right? We're not allowing them to grow.
Right.
We're not allowing them to become what they're what nature is intended for them. Kind of like when a domestic pig gets fertilized, it physically changes. Its brain changes. It becomes what it was meant to be.
Mm-hmm.
And we're holding our kids back by overprotecting them. Mom and dad, the family, they're trying to kill the family dynamics. By mom and dad both have to work while our kids go get raised by the liberal education system, because you can't even be part of the education system unless you are a liberal and you're on not a liberal, but really, farther left, the better.
Mm-hmm.
You know what I mean? If you want to get into a PhD program, you're probably not going to get accepted if you're not having the same beliefs as the professors there. So these are the people that are teaching your kids, and I've heard politicians say that it is the government's job to raise your kids. The parents serve a secondary purpose, and that's not true.
No, that's not true. And people who buy into that really need to take a time out and do some serious thinking about this matter. Because
when I was growing up in the 80s, they wanted me to tattle on my parents.
Yeah.
With the DARE program.
Yeah, exactly.
If you see something, say something.
Yeah, exactly. When I was growing up, I'm a baby boomer. I was born in 1951. So I was a kid of the 50s and the basically an adolescent and a teenager of the 60s. But I look back, and I realize, God, the things that we would do, I'd be 13 years old. I'd go with my younger brothers or some of my buddies. And, we lived in a rural environment in Minnesota. And I'd say, well, we're going camping for the night. And, my dad would say, well, just be careful and I'll see you tomorrow. And off we'd go. We'd pitch a tent, we'd build a fire, we'd cook food out there in the woods and camp out. I started working on a farm when I was 13, hauling in hay bales.
Me too.
Bending fences, shocking sugar cane, all of this stuff. And the main reason I would do that is because it wasn't for the $2 a day. It was because at the end of the workday, we could saddle up the horses and go riding.
Nice.
But, we lived on a lake. I had a canoe. We had bicycles. I never wore a helmet. I probably would now. Of course I would now. But, somehow we survived, And I knew we had reached a nadir here when about 5 or 6 years ago, I was going to do a series of classes in a building that was being used as a after school program on the main floor. And then there was a upstairs room that was kind of a classroom. So I did a series of classes in that upstairs room. Well, the first time I go there, the parking lot was in the back, and you went through a fence, and then there was the play area for the after school kids. And as I'm going in, I noticed something there. There's some trees in the back there, and they were wrapped in foam. And I had noticed that a couple of weeks. I'm in, and then finally I asked the lady, I said, why are those trees wrapped in foam? And she says, oh, that's a city requirement. We couldn't open until we wrapped the trees in foam to keep the kids from getting injured.
Nerf the world.
And I thought, yeah. I thought, what? What? At first, no, you're joking, right? No, I'm dead serious. They wouldn't let me open until I wrapped the trees in foam.
We need to bring back lawn darts.
Lawn darts, yeah.
I remember lawn darts. When I think of it now, it is pretty fucked up, though. I bet you a lot of people went down with a lawn dart in the back or the shoulder that I could just,
But yeah, I went to high school in Troy, Montana. So I moved out there from Seattle, and it's a whole nother life. I got to experience things out there that I'd never got to experience here. Like what it does for your soul to be out there getting dirty, talking your friends into doing dumb stuff.
Yep.
Jumping off of cliffs.
But the other thing is we learned how to get along with different ages and different people, and leaders would happen, and we'd have to play with everybody. Like, Stefan Molyneux did a great podcast about the difference between growing up then and now. We had so many challenges we had to sort out on our own.
Yeah.
Yep. Yeah, when I was 15, I worked, as a pump jockey in a gas station, right? So I was the guy when the cars pulled in, I would come out and, pump the gas and, check under the hood, check the oil, check the fluids and all of this. And I was 15, and now, at least here in Georgia, they don't even let 16-year-olds pump gas even. They'll have a sign right there on the gas pump, 16-year-olds and under can't pump gas. And it's just every day I get reminded of this dumbing down that's going on.
It's unbelievable.
Yeah, it is. And, we all survived. I came from a family with 4 and then later 5 brothers, and we were roused about rough and tumble boys that played as hard as you could play and did stuff. We all survived, somehow every once in a while we got a few injuries here and there. And, I look back and I knew some kids growing up that did some dumb, really, really dumb things and, didn't survive. But it was interesting in that, like when I was a little kid, there was a boy named Billy who lived nearby, and his older brother they were going to burn some trash, and he thought he was going to throw some, I don't remember exactly, but he threw some gas on the fire and it exploded. And poor Billy, who was my age, got burned up and died a couple of weeks later. But for the rest of our lives, it was almost like every kid I knew around that area had heard about what happened to Billy. And it was like, hey, you better not mess with that. You remember what happened to Billy? And it was almost like I look back and I kind of think, well, that one kid having that thing happen taught all the rest of us, that. And another example is that one time where I was with my dad and we were driving through the Ozarks and we came around the corner, seconds after this horrible multi-car crash had happened. My dad stopped to see if he could render some help. I don't remember if he could do anything, but remember getting out and looking at, bodies laying on the pavement. And I think I was about 12 or so at the time. And somebody now would say, oh, that's awful. You shouldn't let your kids see something like that. But you know what? It made such an impression on me that once I started driving, I had that image in my mind. And I thought to
exactly.
myself,
what if the parents spent all their time hiding that from people?
Yeah. So, you're not doing kids any favor by over sheltering them. And it's just too bad that we've gotten to the point now, like you said, where, families are basically the family unit is being undermined by policy. And, the government is taking a much more active role in raising these kids to just basically submit to authority. That's what it's about. That's the whole purpose of modern education. It's about inculcating submission to authority.
And control, yeah.
And control. And when you see them coming in, when I was in in sixth grade, I was a new kid in school and moved from Louisiana back to Minnesota over Christmas vacation, enrolled in a new school after Christmas vacation. And immediately I became the target of one of the supposed toughest kids in the school. Thought he would elevate his status by beating up the new kid.
A Louisiana boy?
Challenged me to a fight. And we met after school and had a fight. Of course, I whooped his ass. But while I had him down, it was winter in Minnesota. And so I had him down on the ground and was making him eat snow. And the next thing you know, I'm being pulled off him by a cop that was driving by because there was like 100 kids all around us in a big crowd screaming their lungs off. Cop stops, pulls me off, makes us get up, and then he makes us shake hands and go home. Now, if that happened, we'd both been handcuffed,
jail,
and arrested. Yeah.
And that's how you see that kid that got arrested.
Thing has become
fucking tased in the face.
Yeah. It's nuts. So, we could go on and on and on with stories like this. And that's why we need some serious changes in this society of ours. And the respect. I've lost all respect for the left because. When I was, 18, 19 years old and, out there marching against the Vietnam War, I was out there with the progressive left. So we're basically ending the war, promoting free speech. And, even though as I came to learn about their philosophy and their collective ideas of how the economy is supposed to work and stuff, I quickly rejected that. But nonetheless, they still had a measure of respect. And now I'm looking, where is the anti-war sentiment from? And where is the sentiment for free, unfettered speech coming from the so-called progressive left? It's missing in action totally. And I'm hoping that there's somebody there who's going, yeah, you know what? We're ramping up for World War III right now. That's what we're doing. All of these policies being put in place is moving us towards World War III. And by God, we better start doing something to change the direction here.
Yeah.
Because we managed to avoid nuclear catastrophe in the first Cold War. We might not be so lucky the second time around, especially when you have people up there who think that a preemptive strike might be viable.
Yeah.
Well, I suppose that's as good a spot as any to wrap it up.
We didn't even get into the Holy Grail.
No, we didn't. Well,
I'll have to save that for part 6.
Yeah, listeners, go read that article on Sacred Geometry International. It's one of my favorite things I've ever read. And I'm going to go read here. I've already got it copied onto my phone. So it's a 4-part article about the beast.
Yeah, I think Cameron broke it up into 4 parts. It's
Okay.
also on Geocosmic Rex as well. I think it's in PDF form on there.
Yeah, go check out Geocosmic Rex. Go to the YouTube channel, Geocosmic Rex. There is some awesome stuff. There's some little tasters in there.
Yeah, there's a bunch of cool stuff. Check out there's 2 YouTube clips of the drone footage we did our trip last fall.
Yeah.
It's just awesome.
Yeah, it is awesome. You can
And
see
in fact,
it.
earlier, I was talking about that big current ripple field. We have drone footage of that, and people can look at that online and see for themselves the scale of the phenomena we're talking about here.
Yeah, it looks like it looks like the riverbanks after a real hard rain or a flood, and you got the ripples on the side.
Yep.
And take that and exponentially just grow it up to just hills and just spreading out all through the countryside. It's insane.
Yeah, it is.
So you guys
And
also
if you
take.
haven't heard the last 4 episodes with Randall, make sure you check them out. I know it was
Yeah, go back.
129, and 131, and the other 2 were before we started numbering them.
They'll all be in the show notes.
Yeah.
And then, so Randall, you guys also accept donations too, right? So people can go to your site, buy your DVDs. They get 33% off with Grimerica. They can check out classes there as well, and they can just donate to help you guys out as well.
We expect at least 50 of you fuckers to buy the DVDs.
And also, we try to do, once I was doing 2 and 3 research trips every year, and then that slowed down when the recession, but I'm picking up the pace again. And so I'm always looking for team members who want to participate in the field studies and the research and exploring these amazing landscapes. So that's something to consider.
I'm in.
Who said that?
Cyrus.
Cyrus, all right, man.
I got a truck.
It'll be a Sherpa.
You guys, I can haul everything you need.
Okay. Well, you're in Seattle now, right?
Yeah, I'm right off of I-90.
Okay. Well, yeah, it's just a hop, skip, and a jump over the mountains, and then you're basically into the scab lands.
Yes, sir. We go dirt bike riding in Moses Lake all the time.
Oh, do you really? Yeah.
Oh, yeah.
We just
I grew up in the
we
potholes.
stayed in Cheney, right? We stayed in Cheney in October.
Yeah, we stayed in Cheney.
March.
That's
That
where
was
the
in
cabin
March.
was.
Yeah.
So I drove one of the listeners. He's a fan of yours too. Adam Loyal from the Friends to Know podcast. I picked him up in SeaTac, and we drove all the way out to Cheney. I'm like, dude, check this out. And I started pointing it out, and he's like, whoa. I'm like, yeah, this is the stuff Randall's always talking about, dude. I wish we would have had time to go up to Cooley.
We went to Cooley with Brad. That's where I lost my hat.
Yeah.
You mean Grand Coulee?
Grand Coulee, yeah. We went right up to the Dry Falls.
Yeah, that's awesome. In fact,
I think we
since
only missed
mentioned
you
Dry
by
Falls,
like 8 hours or something like that.
What's that?
I think we only missed you by like 8 hours.
Yeah, I think so.
And I couldn't get off work.
Well, yeah. So I'm planning a trip actually in about a month to the Southwest. And I think we got room for 1 or 2, basically because one guy had to cancel because of his schedule change at work. And then later in the summer, hope to be up there near you guys. If you look at I'm going to put one more image up on the screen for people to look at. Dry Falls Cataract from the air. Okay. And you'll see one alcove. And then I've got Horseshoe Falls of Niagara up in the corner at the same scale. So, and basically we're only looking at one alcove, and this feature we're looking at here is over 5 miles wide, 400 feet high. The volume of water pouring over this was about 400 feet deep, moving at 60 miles an hour and just ripping the shit out of this landscape.
And that's to scale. Look how much bigger.
Yeah.
That would have been.
It's huge. You wouldn't even see the little boats that would be down there fishing.
That's ridiculous.
No, yeah, right. You wouldn't even see the boats.
That little
Randall, do you have that picture?
Bottom left is the one that I was climbing over when I lost my hat.
There's Darren's hat down there.
There it is. Make America great again. I see it.
Yeah.
The ironic thing is I probably just lost that hat like 2 days after that footage.
Yeah. Actually, this footage was, well, let's see. I took this photograph in 1998.
Oh, yeah, I was just.
That's not the drone.
I think you were still in diapers then, right?
Yeah, that's right.
Randall, do you have that picture to show the people who are able to watch this on YouTube? The one, the potholes one, the Moses Lake.
You mean
the mudslide, the one that freaked Rogan out? Is that? I don't know if you have that on there.
Did Brad ever post a video?
I have it on my phone.
That fucking army plane ducking down into the coulee any place?
I don't know.
Yeah, that's up. Actually, that clip is up on the Geocosmic site.
Yeah, that's cool.
Yeah.
Oh, yeah, you're talking about Potholes Cataract.
Yes.
Yeah, I probably have it right here. Let's see.
Right. Oh, no, that's not it.
Dry Falls. It's one of the big cataract complexes out there, and yeah, this was the first drone footage that Brad did. Let's see if I can find it here. It's coming up. Yeah, that's.
Wasn't there a Google Earth picture, a satellite picture of that slide?
Yes, there. Yeah, we had a Google Earth. Okay, if we look at this image right here, this is called Quincy Basin, and this entire area was a temporary holding pond for the floodwaters that came out of Grand Coulee up here.
Mm-hmm.
This is Moses Lake, which was a meander of the very final draining of the great floods. But over here on the western rim, you see there are two spillover channels. This is the one you're talking about, Potholes Cataract, and this is Frenchman Springs. And so basically there was so much water that came down here, even though it gushed over this region down on the lower right, which is 10 miles wide. The water flowing through here was 10 miles wide and 400 feet deep. And then over here, it had to raise 400 feet minimum in order to spill over this ridge. But this Potholes Cataract is where we've got the drone footage up on the Geocosmic website. And I think I've got should have it right here. Here we go. So here is the Google Earth image of the cataract. And you can see here, you've got alcoves, extinct alcoves. There's two great alcoves here that are these horseshoe-shaped features. Mm-hmm. And then you've got what's called a rock blade, the central rock thing that separates the two alcoves. And had the flood continued to spill over for, a matter of a few more days or another week or two, that rock blade would have been gone. And see here, here's a geological, U.S. Geological survey map of the feature. If you look at these round lakes, those are the potholes. And basically what you're looking at here is water that was perhaps 600 feet deep and enormous, extreme turbulence in that water. Literally,
like a tornado of just water and rocks and boulders.
Like an underwater tornado that just sweeps up rocks and debris and then acts like a giant circular drill that just bores its way into the bedrock. So here you can see the water came from the right, spilling over the rim, in the left down into the Columbia Basin. Here's an aerial photograph I took of the feature back in '98.
Just ground away.
It's what?
Just ground up by boulders the size of school buses, and
the size of school buses and even bigger. The drone footage we took.
Graham's calves. That's an inside joke.
Oh, okay. Let's see if I've got the. Well, I didn't have the drone picture in this particular slide.
But look at
just
that.
Below it, here you see what's called West Bar, which is another gigantic boulder bar. It's 3 miles long, 200 to 300 feet thick, and it's gigantic ripples. And if you look very close, you'll see right there where my mouse cursor is, there's a 3-story building next to the landing strip that's on this thing scale. And this is similar to the same scale as the feature Camas Prairie that I showed you earlier that's in Montana. This particular feature is in Washington. But basically what it does is it shows you the vast extent of this mega flooding that terminated the end of the last ice age. So these are giant current ripple fields. Here, the cross section where you can see there's a little human figure standing down here, and you can see you can see the ripples here. And then essentially you see that cliff that was sheared off by the massive 800 feet deep water that flowed through at its peak.
Like the Sphinx, that's not wind, people.
Right. No, it's not wind. So yeah, I mean, we could go on and on. We could spend the whole discussion just talking about these amazing floods that terminated the last ice age. But I guess we do need to wrap it up here, don't we?
Right on. Well, thanks, Randall. Yeah, I mean, you'll get into all that in your podcast, I'm sure, too. It's going to be so nice to see you having your own media platform to start getting to people directly.
Yeah, absolutely. I mean, people need to know about this.
Yeah.
You know, this is part of the history, and this isn't something that we're looking at that happened millions of years ago. It happened thousands of years ago during the time that there were human beings here. And, you know, we didn't talk about this at all, but Native Americans have a lot of stories and legends about gigantic floods that happened. And we can actually learn a lot from these indigenous traditions and from the mythic traditions and so forth.
Oh, there's so much stuff that they know that being kept for. Yeah, they're.
Yeah, that's the subject of geomythology, which again, I've seen, you know, comments, you know, dismissing, oh, what's geomythology? You know, more woo-woo, you know, but really what it is, it's the recognition that a lot of these myths and legends and things that have come down to us actually have plausible scientific information embedded in them, if you know how to kind of pry them apart and look into the essence of what initially stimulated the recurrence of these myths and their perpetuation. They're loaded with information, legitimate information. So that's...
And these so-called experts, how can they call themselves experts if they haven't looked at everything?
Right. And I get that all the time, you know, like, well, what do the experts say? And I go...
You're talking to one.
Okay, who might these experts be? Now, I've got in my archives, I've got every article that's ever been written on impacts, on mega floods, on mass extinctions. I can name off 100 of the experts that have worked on this, pros, cons, all the different points of view. So who are these experts? Please give me some names. If there's some that I haven't heard of, I'd like to go access their information. But, you know, people seem to think, again, it's this authoritarian mindset. They don't realize that science is really, it's a state of mind. It's an approach to learning. It's only secondarily a profession. And modern science was not started by quote unquote professional scientists. It was started by people who were using the scientific method, but who themselves nobody was paying them to do science like now. And see, there's the problem, you know. And it seems, well, sure, you can have corrupt science if big corporations are paying you, but you can also and do have corrupt science when the funding is coming from governments, you know? So you have to look through that. And you know, it's like this authoritarian mindset. See all the time people are going, well, what do the real scientists think? Well, who are these real scientists that you're talking about? You can't even name one. You know, you just, in your imagination, you think that there's some omniscient authoritarian body that's got all the answers figured out. And, you know, if they're not this official group, then, you know, you don't even have to pay any attention to it. Never mind if you've studied this stuff for 40 years and have interacted and learned from dozens of hardcore scientists that are astronomers and geologists and paleontologists and archaeologists, people that I've met and interviewed and gone out in the field with, you know. So, you know, but it's an evasive maneuver so that people can, you know, not rise to the responsibility of looking at the critical information. You know, they can basically go about their lives with their heads stuck up their asses and not pay attention.
And they just get away with going 97%.
Yeah. And I say, okay, who
98%.
Name three of these people that are in total agreement. And
99%
so far, not once has anybody able to actually do that.
Yeah.
So all of these people out there that are listening, you know, don't fall for the scams and the hypes. Think on your own, learn critical thinking skills, invest the time, do the homework yourself. And
Randall, do you know the name Scott Adams?
Scott Adams.
I'm sure you're familiar with his work. He created that comic strip Dilbert.
Oh yeah. Okay, that's what I've seen.
Have you heard him talk about the climate change?
No, I haven't.
Guys, I wonder if we should get them in contact. Because
I can't even fucking get in contact with Scott Adams.
How are we gonna do that?
Dude, he goes up against the models, the global climate models, and he's battling it, and he talks about how, you know, the way they set it up is to get a determined outcome.
Yes.
You know,
yeah.
And I think if he had access to like your kind of research, I think that would be a big help for him on his side.
Mm-hmm.
You know what I mean? But he's got a huge audience. Yeah, I've been trying to get him to get in contact with Grimerica too. But yeah, he's got a pretty big following. But he's got a really nice blog that he does that we follow. If you feel like it, go check it out.
Sure.
All right.
I will do that.
Thanks, Cyrus.
Yeah.
And thanks,
Thank you,
Randall.
guys.
Thanks for
This
coming
is
on.
Awesome.
Yeah, man.
Yeah,
it was
thanks
fun.
to both of you. We'll do this again in the future. Absolutely.
Yeah. And I'm sure I'll be crossing paths with you guys. We can hang out in the mountains again.
Yeah,
God,
right on.
So, yeah, absolutely.
Yeah.
What happens in the mountains stays in the mountains.
Yep.
All right. Okay. To see you guys.
Okay. So long, gentlemen.
Bye.
Thank you, Randall.
Okay, guys, making his return appearance to Grimerica this afternoon. Much to delight, we've got a ton of feedback. He's by far our most popular episode, both on YouTube and on the podcast. So, yeah, we're pretty excited. How's it going, buddy?
Hey, not too bad. Doing well. Yeah, I'm excited about this too. Of course, we've been looking forward to it for a while. As Darren said, he's been one of our most popular episodes. And Graham Hancock's even praising him as an unsung genius. So we knew this was going to happen, and we were trying to get him at Paradigm Symposium last year. It looks like he's going to be at Paradigm Symposium this year, but we have Randall Carlson back, somewhat of a renegade scholar. He's been searching for, over 4 decades now, uncovering this secret story and kind of hidden in plain sight about natural cataclysms and stuff like that. They've got a great thing we're going to link to here, YouTube, and a DVD coming out on cosmic patterns and cycles of catastrophe. It's truly mind-blowing stuff. It's got some sacred geometry in there too. And you guys have a webinar coming up as well that we're going to talk about. And Randall's just been traveling around North America with Graham Hancock, and he's got some influence on Graham's new book, I believe. And we got lots of stuff to talk about. So welcome back to Grimerica, Randall.
Well, thanks for having me. Thanks for putting up with me again.
Yeah, we've been looking forward to it. So I suppose we'd love to start with obviously it seems like your work is tying in so much with Graham Hancock's and his work's tying in with yours, and that's going to be pretty exciting. How was the trip and the expedition? I hear the weather wasn't the greatest, but other than that, how was the time spent with Graham traveling across the country?
Oh, it was wonderful. It really was. We had a great time. Yeah, the weather was not on our side. We picked up the rain here in Portland, and it followed us all the way to Minneapolis. So I think we had one day where we had a break. But yeah, so pretty much, all of my photographs are, pretty dark. We got a lot of rain. Sometimes, all day long raining. So it put a crimp in our efforts, but overall it was really good. I mean, we had wonderful encounters with wildlife. I've done a lot of traveling out west and seen a lot of wildlife, but for some reason, I don't know, I guess the encounters with wildlife sort of made up for the fact that it was raining. We had encounters with bears and elk and mountain sheep and several chipmunks. So yeah, we had encounters with a lot of wildlife.
And then some crazy guys from Calgary when you got to the symposium.
Yeah, that was the real wildlife of the trip. We got to Minneapolis. That was
fun times.
So so it was great. I mean, we zigzagged our way from Portland east up the Columbia Gorge, across the Channel Scablands, crossed northern Idaho, Montana. We hit North and South Dakota, and then wound our way around and ended up in Minneapolis. And essentially what we were doing was more or less following the edge of the great ice sheets that, disappeared 12 and 13,000 years ago, studying the effects of the massive meltdown that plays right into Graham Hancock's thesis about a mother civilization and the nature of the catastrophe that erased it from the earth. So I had been studying that stuff for many years, and he's been looking at the evidence for great catastrophes, because what he's been focusing on primarily is the archaeology of these ancient civilizations and the evidence that there have been fairly sophisticated civilizations in prehistory. And of course, he's been savaged by mainstream academics. One of the main charges that they've leveled against him is the fact that, they would usually say, the usual refrain is, well, if there was any advanced civilization in prehistory, and we're talking, 7,000 to 10,000 years ago and longer, even 15 or 20,000 years ago, if there was this civilization, where's the evidence? Where's the hard evidence? Where's the pottery? Where's the statuary? Where's the evidence? And of course, there is evidence. And what's interesting is that, he's now been researching Göbekli Tepe in Turkey and Gunung Padang in Indonesia, and these do appear to be hard evidence for large megalithic structures that are at least 11 or 12,000 years old. And of course, there is other evidence, a lot of evidence that has been out there on the fringes and has not really been endorsed by mainstream academia, such as the weathering on the Sphinx that I think we talked about, and it's kind of been people have been aware of for about 20 years now because of the work of John Anthony West, that the Sphinx has severe water erosion on it, and there hasn't been any major rainfall to cause severe water erosion in Egypt in at least 10,000 years. So the hard evidence is out there, but it's not abundant. But it's, as we learn more and get better abilities to, ground penetrating radar and ability to see things from a higher perspective, we're discovering that there is more and more evidence of a prehistoric phenomena that has heretofore gone more or less unrecognized, except by so-called fringe researchers. Anyways, he's been focusing primarily on the evidence for a lost civilization, and I've been focusing primarily on evidence for catastrophism in the history of the Earth, and including catastrophes in recent human history. And so it dovetails exactly with what he's doing, because what I've been looking at certainly provides an explanation why a culture that may have existed 10 or 12 or 15,000 years ago would essentially have been erased with very little remains for us to discover today. So I was trying to familiarize him with some of the evidence for these amazing catastrophes that have occurred, and also to show him that 10 to 12,000 years ago, when the Great Ice Age came to an end, catastrophically, North America appeared to have been ground zero in the last great global catastrophe. And so that's kind of what the essence of our trip was about. So we were looking at following the margin of the great ice sheets with the objective of demonstrating that the melting of that happened extremely fast and literally created oceans of meltwater that swept over the land, basically erasing everything that was in its path. And
that differs from the mainstream paradigm, because they think it was a slow melt. Obviously,
not so much anymore. Up until 20, 30 years ago, yes. But even going back to the 50s and 60s, evidence was starting to emerge that the whole transition had been extremely fast, faster than anybody had really imagined previous. A big turning point came in the early 1990s when American teams and European teams extracted ice cores from Greenland that provided a year-by-year proxy for climate change. And this was the early 90s. The results of that started getting published in 93, 94, right in there. And the evidence from those ice cores was pretty unequivocal that climate had changed extremely fast, as much as 10 to 15 degrees centigrade, perhaps in a decade or less. If I say 10 degrees centigrade, I'm talking about 18 degrees Fahrenheit. And this is just an enormous temperature swing. And there were multiple temperature swings. So in the early 90s, scientists were becoming aware of the fact that this had happened. But what's been going on since then is the evidence continues to accumulate that, we have to recognize that the history of this planet that we live on has not been a smooth, gradual continuum, changing one grain of sand and one drop of water at a time, but is periodically punctuated by these intense, extreme, rapid events that completely alter the balance of planetary nature. And this, to me, is one of the most important things that we need to come to terms with in our own future, because once we look back at the record now that we can reconstruct for climate change for the last 250,000 years, what we discover is that there are periods of where the world is subjected to these intense glaciations, like ended 12,000 years ago. Bear in mind that when we're talking about this last ice age, I'll use the term late Wisconsin to talk about the last phase of the American ice age.
Okay.
Named after the state of Wisconsin, where the early geologists and glaciologists first studied it. So when I talk about the late Wisconsin, I'm talking about a period that lasted from roughly 26,000 years ago to about 13,000 years ago. And it was during this period that ice reached from the Atlantic Ocean to the Pacific Ocean. It covered virtually all of Canada. It extended into the northern United States. Where you guys are now, interestingly, at Calgary, was situated in between the two great North American ice sheets, the Cordilleran ice sheet, which would have been to your west, and the Laurentide ice sheet, which would have been to your east. The Laurentide ice sheet was the bigger of the two. It was perhaps 4 or 5 million square miles of ice covering Canada, up to 2 miles thick. To your west was the Cordilleran ice sheet that blanketed all of the Canadian Rockies and filled all of the mountain valleys of the Canadian Rockies, thousands of feet thick with ice. And right where you're at in Calgary was the zone in between these two ice sheets. So it's a very interesting place. I understand that you guys went and visited Okotoks, the Big Rock.
You bet.
Correct?
Yeah.
Yeah. Okay, so there you were looking at an 18,000-ton mega quartzite boulder that was transported some maybe 250 miles from Mount Robeson, where it originated. And right there, that rock is a testimony to an extremely cataclysmic event, an event that could quarry an 18,000-ton boulder, transport it over the Continental Divide from west to east, and then transport it another 200 miles south and dump it on the prairie. So that in itself is an interesting mystery. And the only way really that it makes sense to explain it is that it was a multiple phase catastrophe where you had landslide, because bear in mind, remember that rock that you guys saw is only one of a train of hundreds of these giant boulders that reach from the mouth of the Athabasca River, where it comes out of the Rockies near Jasper Park, all the way into Montana. So those hundreds of boulders were quarried off of Mount Robeson, which appears to be the mountain that has that same type of metaquartzite rock, carried over the Continental Divide and dumped in a line 500 miles along the prairie. And if you look at it, did you take pictures of the rock?
Yeah, I did. Yeah.
Yeah, we've actually had a few pictures sent in from various listeners that have gone since the episode.
Excellent. If you look at that rock, you'll see that it's not a typical glacially transported rock, which would grind off the sharp corners on it. You notice that it had edges and sharp corners.
Yeah.
And it was also three pieces of rock that were originally one big rock. And it had to get carried several hundred miles without being typically ground like glacial rocks are, without those pieces being separated until it was deposit it. And there's only one way that you can do that, and that would be to transport it aboard an iceberg. And then that iceberg has to be carried in a flow of water. Now, the iceberg that would be necessary to transport an 18,000 ton boulder is probably on the size of a tanker ship. And the water necessary to carry that size of iceberg would be one hell of a river. We're probably looking at flows that were hundreds of feet deep and would have passed in that corridor down between these two great ice sheets. And then that brings the question of how do you quarry that much rock and dump it onto the ice sheets, then break up those ice sheets into the form of icebergs, and then melt enough of the ice sheets so that you've got enough water to transport those giant icebergs that are carrying the giant rocks. So it's a very, very interesting phenomenon. And I think it, again, comes down to the fact that what it's pointing to is one hell of a catastrophe. So
I wonder if that's what happened out by Drumheller, too, because I went out there again. I took the kids out there, maybe a month and a half ago. And it's like when you're coming up on that town, you don't even fucking know it's there. It's like you can look right over top of it, and then the whole town's built down in that giant gully.
Oh, yeah.
And you can just see all the sediment, all the lines down the side of it.
In Washington, you mean?
No, in Alberta. It's about an hour and a half northeast of Calgary.
Okay.
It's where the dinosaur museum is. It's where they found all the dinosaur bones.
Right. Okay. Yeah, I have not been there. Now, there is a Drumheller in Washington State, which is very interesting because that was part of the Missoula flood flows, what's called the Drumheller channels, where you had one of these meltwater streams flowing across that area that was 10 miles wide and 400 feet deep, and did some interesting geomorphic work. You can see it very clearly going to Google Earth. And anybody who's listening that wants to check out some of this stuff, Google Earth is a tremendous tool. You can go there, and in this area that Hancock and I were looking at in southeastern Washington is called the Channel Scablands. And the Drumheller channels that I just mentioned is part of this Channel Scabland complex, which is this what is called an anastomosing pattern or branched pattern of erosional gullies that are massive. You had water flows coming off the ice sheets that were measured in hundreds of millions of cubic feet per second, which is huge. I mean, the biggest recent flood in North American history was the Great Minnesota Flood of 1993, the Great Mississippi Flood of 1993. And that flood topped out at just over 1 million cubic feet per second. However, it was actually, because of it's a very low gradient there from the headwaters of the Mississippi to the Gulf of Mexico. So the water moves relatively sluggish. The gradients out that we're looking at in Washington and Montana and the Scabland areas are fairly steep. So the water can get moving really fast. Up to 50, 60, and some estimates even 70 miles an hour. Now, bear in mind that in some cases we're talking about water moving 50, 60 miles an hour that's 500 or 1,000 feet deep. So you can imagine that when a flow of water like that sweeps over the land, there's nothing left in its pathway after the flood is ceased. There's nothing. Because in some places, this water has cut, literally quarried, excavated 1,000 feet of bedrock. So imagine you're standing on the land pre-flood, then you come back to that same spot after the flood is over, and where you had been standing before is now going to be 1,000 feet up in the air because the flood has excavated a channel that deep. It's hard to imagine, but these things really did happen.
Yeah, it is hard to imagine. Huh. So, and this was caused by, are you saying it was caused by a meteor or in tandem with something else? Like, how did it happen so fast?
Well, there's the mystery with a capital M. And by default, there are not a lot of triggers for these kind of events short of something extraterrestrial. By that, I mean an asteroid or a comet. At this point, I think most of the evidence is pointing in the direction of a large fragmenting comet. In fact, here's the scenario that at this point seems to fit the greatest amount of evidence with some inconsistencies, because at this point we really don't know for sure really what happened. But the evidence is emerging more and more that, yes, it was something cosmic. I mean, there are what I call fingerprints and footprints. Footprints are the obvious things you can see in the landscape, like I just talked about. If you had a 500 or 1,000 foot deep channel, that's a footprint. You can see it. It's very clear. Fingerprints, you don't see them, but they still provide very important evidence. Some of the fingerprints that have been emerging, like in the last 10 years, is the signatures of an extraterrestrial event. Now, what does that mean? That means perhaps an iridium spike, platinum group metals, osmium, perhaps. These are things. These are metals that are delivered to Earth via asteroids and comets and meteors. Nanodiamonds, material that would be shocked material, microspherules that would probably be the result of a vaporizing event, again, that could happen in the wake of some kind of a cosmic impact. So the fingerprints are emerging that suggests, yes, there was something cosmic involved for sure. And I think that the most likely scenario is that somewhere, going back in that reference to what I said, the late Wisconsin, going back to about 26,000 years ago. This is a scenario that seems to be emerging that's most consistent with the greatest amount of evidence. About 26,000 years ago, an extremely large comet comes in, most likely translated into the inner solar system from the Kuiper disk outside of Neptune, gets captured into a Jovian orbit, which means it's being handed off back and forth between the sun and Jupiter. And during this time, it begins to undergo a hierarchy of disintegrations, meaning that the one giant comet nucleus breaks up and spawns multiple offspring that are smaller cometary nuclei. Very much, if you guys remember, like what happened in 1994 with Shoemaker-Levy 9, remember?
Yeah.
Right, because what we saw there was a large comet nucleus passed within the Roche limit of Jupiter, within the gravitational field of Jupiter, where the gravity field was strong enough to literally rip it apart. The one nucleus became 21 nuclei. Those 21 nuclei then orbited around the sun in a long train, and in the second week of July 1994, those 21 objects successively fell into Jupiter, impacted Jupiter. Now, I think something very similar to that seems to be the most likely explanation for what happened at the end of the last ice age. And in fact, I'm inclined now to lean towards what I would call a bombardment episode, where you might have had this large object breaks up, comes in, like I said, about 26,000 years ago, begins to break up. Now, one consequence of that breaking up is that it strews an immense amount of cosmic dust into its stream. As it breaks up, the material of that stream can range from mountain-sized boulders down to fine dust and everything in between. So if the Earth encounters that fine dust, what it does is it increases the opacity of the atmosphere, which reflects a lot of sun back out. So a lot of heat is lost to space, and that could be part of the reason why around 26,000 years ago, the planet, after it had been warming, suddenly went back to frigid glacial cold. And over the next 5, 6, 7,000 years, the planet just got colder and colder and colder until about 18,000 years ago, it was just extremely cold. I mean, like where I live in Georgia, which is a pretty balmy climate now, it had a climate similar to what you would find up where you guys live, okay? A lot of the mid-latitudes of the United States were actually tundra during that period of time. Now, about 15,000 years ago, the grip of the bitter cold began to alleviate, and the planet began to warm gradually, as you know, gradualist scholars like to picture it. And then around 14,500 years ago, that gradual warming was suddenly interrupted by an enormous spike of thermal energy introduced into the terrestrial system. That enormous spike of energy caused a massive melting of the ice sheet, a rapid sea level rise that is now referred to as meltwater pulse 1A, where the sea level rose many meters over a very short period of time. And then over the next 1,000 years or so, the climate began to just seesaw back and forth from cold to warm to cold to warm. And then around 13,000 years ago, it plunged very rapidly back into the same level of bitter cold that it had been at 18,000 years ago. And this lasted for 1,000 years. And it was during this 1,000-year interval of bitter glacial cold that interrupted the gradual warming when all of the great megafauna disappeared from the planet. The woolly mammoths and the saber-toothed cats, the giant ground sloths and the giant beavers and the camels that inhabited North America, on and on. 120 roughly species of large megamammal disappeared during this interval of 1,000-year cold, which is called the Younger Dryas, named after a polar wildflower, Dryas octopetala, which only grows in the tundra. So it had disappeared for a couple of thousand years in Northern Europe during this gradual warming phase. Then when the cold spike came back suddenly, that was followed by a return of Dryas octopetala for another 1,200 years. And so that interval of cold has been called the Younger Dryas, to contrast it with the Older Dryas, which was a spike of glacial cold that occurred when I was talking about where the climate was zigzagging. So at around 13,000 years ago is now when this interesting fingerprints are showing up, where geochemists and geologists led by Alan West and Richard Firestone and James Kennett and others have been looking since the year 2007 and discovering abundant evidence of nanodiamonds and magnetic grains and microspherules and platinum group metals and all the things that you would associate with some kind of an extraterrestrial encounter are showing up at a horizon that's being dated right at 12,900 years ago. So now we have this cold episode called the Younger Dryas that lasted from about 12,900 to about 11,600 years ago. And 11,600 years ago, there's another massive warming spike, another rapid melting and rise of sea level. This has been called meltwater pulse 1B. And so this seems to bracket this whole transition out of the Ice Age. And after this 11,600 year event, the climate began to finally stabilize, so that about 10,000 years ago, the climate had become pretty stable. Now, bear in mind that the sea level rise, which was 400 feet lower than now during the Ice Age, which is pretty significant if people stop to think about what that means in terms of where your beaches are and where your coastlines are at, and what that does to shallow marine ecologies and coral reefs and so on. You drop sea level 400 feet during the depth of the Ice Age. Now, that sea level has been rising for 5,000 years, but it's not rising uniformly. It's rising in these pulses, where there are these huge pulses of meltwater that go into sea level, rises rapidly, stops for a while. Like during that Younger Dryas cold period, the sea level actually perhaps dropped again. But now by about 9,000 years ago, what we find is sea levels are getting pretty close to their modern levels. And at that point is when we see the first seeds being planted of civilization, settled communities, farming communities, when we see the first cities, Çatalhöyük and Jericho and others begin to emerge. We begin to see the dispersion of languages. We begin to see the domestication of animals. Settled a sedentary lifestyle as opposed to a nomadic lifestyle. So we see these major changes occurring around 9,000 years ago. And I think what the new paradigm is suggesting is that what we're seeing there is essentially the rebooting of human civilization in the aftermath of this whole succession of catastrophic events concentrated into this 3,000-year period that jerked the planet out of the Ice Age and sent us into this nice interglacial warmth that we've been enjoying for the last 9 or 10,000 years. Thing that people have to realize, though, is that what we now know from the record of climate change in the past is that we can see that in the last 250 or 300,000 years, there have been a series of oscillations. The climate swings between the depths of an ice age, comes out of it, goes into this interglacial warmth, such as we're in now. Sea levels come up then. The ice age comes back, sea levels go down. And this oscillation has been going on for now about 2.6 million years. Maybe as many as 30 or 40 times that the planet has now shifted back and forth. Nobody knows for sure, because each time you have one of these cataclysmic transitions, it basically erases the evidence of former transitions. But here's one important point of all this, is that it now appears that periods of the interglacial warmth, such as we're now enjoying, are actually the exception within the last couple of million years. And we've now been in a period of interglacial warmth that's lasted for 9 or 10,000 years. From what we see, looking back at the record, going back hundreds of thousands of years, is there has been no period of interglacial warmth longer than the one we're in now. Most of them are shorter. People need to factor that into their thinking when they start talking about climate change.
Yeah.
Because there's a whole lot here about climate change that's being ignored by the official versions, the Algorian version of climate change.
So at that rate, I suppose we're due for a cool down at any time. How serious of a degree do you suppose that would be?
Well, if it was anything like past changes, what it means is that, what we see is that the ice age has apparently come on in a few centuries or less. And some of the changes, there's going to be a lag between whatever triggers it and by the time all the changes have gone into effect. So, what we've seen, a number of geologists that have looked at this, some of these last periods, have actually coined the term instantaneous glaciarization to describe that the transition into the glacial cold seems to sometimes happen so fast that in a geological sense, it's the snap of the fingers.
Right.
Maybe a couple of hundred years, maybe even a few decades. Maybe the trigger could be as short as a year or two. We certainly see that coming out of the last ice age, is that some of the transitions, rapid transitions, may have occurred in a matter of only a couple of years.
And what triggered those again? What triggered the big melt then again?
Well, again, I think that by default, we have to look at something extraterrestrial, because for 50 years, 60 years, 70 years, now scientists have been trying to explain what takes us out of an ice age, and with no agreement whatsoever. If there's 100 different scientists proposing 100 different theories, right? But for the most part, most of those theories are going to be terrestrial, with the exception of changes in solar radiation due to an effect called the Milankovitch effect, which is that the fact that the Earth's geometry relative to the sun is constantly going through a series of gradual changes. The tilt of the Earth on its axis swings back and forth a couple of degrees. The distance of perihelion shifts relative to the seasonal cycle. The obliquity of the ecliptic shifts. All of these things, these three factors, actually could cause the amount of solar radiation reaching the surface of the Earth to vary by as much as 10%. So most of the early ideas of glacial inception and so forth were based upon these Milankovitch processes, which of course are very slow and undoubtedly play a role. Absolutely. I'm not saying they don't play a role. They do. But superimposed on top of these slow changes are these drastic, catastrophic, sudden, rapid events that cannot be explained by slow, subtle changes in the geometry of the Earth-Sun relation. So I think by default, we have to look at something a little more extreme, such as impacts of things from space, because that can certainly do it. If you had a multiple impact event, and some of these impacts were into the ocean. See, part of the problem with the onset of an ice age is that you have an extremely rapid buildup of glacial ice, right? Okay, so now you got this rapid buildup of glacial ice, which means it has to be snowing a whole lot, right? But it has to be so cold that snow isn't melting. Like right now, up where you guys are, it snows, right? Is it snowed yet this year?
Oh yeah. Yeah.
Yeah.
And it's melted a few times too. So.
And it's melted a few times. It'll come back, and then usually when is the spring thaw up there? About late April?
I'm too new.
Early May.
Yeah, usually it'll thaw like in the middle of, start to thaw in the middle of March. It'll be nice for a few weeks, and it'll fucking blizzard, and it'll be winter for another 3 weeks. And Calgary's like a rare example for weather.
Right. But it does go away. The snow melts away, and you're back to green grass growing and trees with their leaves coming back for a while.
Yeah.
But now imagine this. Imagine that winter comes, but then spring doesn't come for 15,000 years. I mean, that's literally what we're talking about.
Then I'm moving to Georgia.
Yeah. Well, you might want to move a little further south than that, actually. But my point is that's basically what we're talking about. It's like if spring didn't come and it just stayed winter, snow kept falling and it didn't melt. Pretty soon it piles up, the pressure compresses it into what's called firn, F-I-R-N, and that gets compressed into glacial ice. And after 5 or 6 or 7,000 years, you've got 2 miles of ice, right? Okay, so now the thing is it may take several thousand years to get that 2 miles of ice, but the transition that causes the climate to shift so that spring doesn't show up, that might happen in a virtual instant. See, and many of the geologists that have looked at this realize that the transition occurred so fast that they refer to it as instantaneous glaciarization. So it appears that it's not something that comes on gradual over many tens of thousands of years, like scientists imagined 50, 60, 70 years ago. It's now apparent that it comes on really, really quick when it does. Now, getting back to the problem with the inception of an ice age is this. You've got all of this snowfall with this rapid buildup of glacial ice, right? In order to get that snowfall, you have to evaporate water from the oceans. But the water to be evaporated in the amounts that you see in this accelerated snowfall and glacier and ice accumulation means that the hydrological cycle has been intensified, how do you intensify the hydrological cycle? With heat. So this has been the conundrum or the paradox of ice ages that's been very difficult to explain. On the one hand, you've got this rapid ice buildup, this rapid accumulation. But on the other hand, in order to loft this moisture into the air that can precipitate out as snowfall, it requires heat. So you see, this is a major contradiction. How do you resolve that contradiction? Well, I think perhaps, again, we have to turn to extraterrestrial forces. If you have a fragmenting comet nucleus coming into the Earth's atmosphere, some of these pieces hit the oceans. They're going to loft many, many times their volume of water into the atmosphere. And this water lofted into the atmosphere is going to spread out. It's probably going to go up to the stratosphere. It's going to take weeks for it to rain out. Now, at the same time, you notice if you have an oceanic impact, that produces one set of effects, right? It creates tsunamis. It lofts huge amounts of water vapor into the atmosphere. If you have an impact on land, it throws huge amounts of dust into the atmosphere. It can trigger extreme events, wildfire events that can put smoke and soot and particulate matter into the atmosphere. If it's an atmospheric burst along the lines of the Tunguska event of 1908, it can increase the amount of extraterrestrial dust that's in the atmosphere, because what happened in that 1908 event in Tunguska was you didn't have an impact into the ground. That's important for people to realize. It exploded in the atmosphere 5 miles up. That's 8 kilometers. When it did that, that debris that comprised that object was obliterated and essentially dispersed into the atmosphere. Some of that was carried all the way to Europe for about the next week for several, 3 or 4 or 5 nights in a row. Because of that particulate matter in the atmosphere, it caused the whole atmosphere to become luminous. So light, in fact, that in the year 1908, people out in the countryside could read newspapers. So what we have here is that we're really just beginning to sort out the terrestrial consequences of cosmic encounters. But it seems to me that within that mix of events is the formula that could lead to the onset of an ice age. Because on the one hand, you could put particulate matter, soot, smoke into the atmosphere, especially if it's a multiple impact event, which could cause the atmosphere to cool. But at the same time, you've lofted enormous amounts of water vapor into the stratosphere. Rainout requires, every raindrop has a little nucleus of particulate matter. I mean, that's, cloud seeding, how that works. They dump a bunch of, I think, silver chloride or something into the atmosphere to provide nucleus for the water vapor to condense around and form a raindrop. That exact process or similar type of process could happen in the event of a cosmic encounter. It can put the moisture into the atmosphere that would then rain out. It could also cause a simultaneous cooling. And as far as all of the explanations that I've looked at, dozens and dozens and dozens over the years for the onset of an ice age, it seems to me that some scenario such as I just described in the end is going to be what does it.
What about volcanic eruptions? How do some of those bigger ones play into that?
Absolutely. Volcanic eruptions could be very similar in their effects. However, the thing about volcanic eruptions is they generally will not be as energetic. If we go back to Tambora in 72,000 years ago, that was apparently enough to bring on an ice age.
Right.
It does. But that was 500 cubic miles of matter injected into the atmosphere, some phenomenal amount. Way beyond Krakatoa or Toba or St. Helens, what was it? Toba. No, let's see, Toba or Tambora. I always get them mixed up.
Yeah.
Toba was the one in 1818, right in there. Maybe it was 1850. When it erupted, it put so much particulate matter in the atmosphere that basically the next couple of years there was almost no summer in Europe. And in fact, that was helped, I think, to bring on the last phase of the Little Ice Age that only ended in the mid-19th century.
Huh. I got a speculative. Okay, go ahead. Finish off your thought there.
No, that's it. You take it for a minute. I'm going to have a drink of water.
Well, I have a speculative thing. I mean, we keep coming back to this
speculating.
Ice Age and what are the chances, like, if you were to speculate a little bit, what are the chances that we might find eventually signs of an advanced civilization from before the Ice Age? Because obviously, like you said, it was a reboot, right? We kind of rebooted and we survived through that whole thing, but there's areas of the Earth that were somewhat livable, through that. And before that, obviously, we don't know really, did we flourish at some point? Like, do you think that we will find some specific evidence to point in that direction eventually?
Well, I think we already are. I think, what I mentioned earlier, Göbekli Tepe and Gunung Padang.
So that may go back before then?
Yes, it could. Yeah, I mean, the preliminary dating is suggesting a minimum age of 12,000 years. And in the case of Göbekli Tepe, the excavations of that whole complex have just begun. It's been buried. And initially I thought, well, maybe it had been buried during some type of a natural event, but Graham seems pretty convinced that it was a deliberate burial. And thinking about that, it occurred to me that maybe one reason that it might have been buried was to protect it.
Yeah.
If in what I was describing, a multiple impact event where some of the stuff is smaller, lower density stuff, like the size, say, of the Tunguska object of 1908, which is estimated to be about 150 feet in diameter.
Okay.
It was fairly low density. It was a small object, but it was moving really, really fast. So when it came into the atmosphere, it basically blew up at 5 miles up. Now, it blew up with the force of a large hydrogen bomb. Now, if you look at any of the major metropolitan areas around North America, whether it's Atlanta or Washington, D.C., or up in Canada, Montreal, Los Angeles, San Francisco, Denver, any of these areas, what you see is they all have roughly the same urban area within their perimeter highway. In Atlanta, it's 285 is the perimeter highway. And I think it's 35 miles from the north to south, roughly.
Okay. Yeah, yeah.
Within that perimeter highway, there's roughly about 800 square miles of surface area. The amount of forest utterly devastated and wiped out when the Tunguska object exploded in the atmosphere was between 800 and 900 miles.
Yeah.
So essentially what you're saying is that one little object coming in at a high rate of speed, if it came over a major metropolitan area, would essentially be enough to just utterly destroy that metropolitan area, causing millions of casualties. Now, if we're possibly talking about an event or multiple events where not just one object like that is coming into the atmosphere, but a swarm of objects, maybe dozens or hundreds of objects like that. And there's nothing implausible about that. It all depends on where the Earth is relative to that orbital, the orbit of the object that's undergoing the disintegration. If it's, a comet, again, we've seen with Shoemaker-Levy 9 that one large comet can produce multiple offspring. There can actually be a second and third generations where those offspring break up. Every meteor shower that we observe, the Geminids being the current one, the Leonids, the Taurids, the Orionids, etc., the Draconids, every single one of them is associated with the breakup of a comet. And what we're seeing in a meteor stream is one of the final stages in the life cycle of a comet. Now, if the people listening to this are interested in getting into some of this in more detail and how some of this relates to some of the myths and traditions that we've inherited from many, many generations ago, there's a series on our website about the symbolism of the Holy Grail and how it ties in with cosmic phenomena like we're talking about, because it certainly does. And if anybody who's actually immersed themselves into the literature of the Grail, they would know that it's constantly invoking cosmic imagery. And so much of the ancient mythology does. It invokes cosmic imagery. And we know from all over the ancient world, regardless of the diversity of these ancient cultures, all over the ancient world, they all had one thing in common that we're now aware of, and that is that they were obsessed with watching the sky. Right? They were
all the Solarian mythology.
Yes. Why were they so obsessed with watching the sky? Well, I'm sure it had spiritual and religious reasons, but very pragmatic reasons as well, is because it's very likely the scenario that's now emerging is that for periods of time in the history of the human species on this planet, which goes back 150 to 250,000 years of modern humans occupying this planet, minimum 150 to 180,000 years, skeletal remains of modern humans. So if we say 180,000 years of modern humans occupying this planet, there have been times within that span of time where the cosmos in which the Earth is immersed has been orders of magnitude more active than we've seen in recent times. And our ancestors, ancient peoples on this planet, all over the world, would have witnessed things, perhaps comet showers, when there were multiple great comets in the sky at one time, when the heavens came alive with fire, when these things broke up and the Earth encountered the debris streams left in the wake of these fragmenting cometary nuclei. So once you begin to recognize that from the astronomical perspective, this is absolutely not unrealistic at all, then we begin to go back and revisit the myths and stories, the legends, the epic tales, the battle of Zeus and Typhon, for example, that happened in the sky, and all of the consequences, Typhon hurling fire and brimstone at Zeus, and Zeus hurling his thunderbolts back at Typhon. We can now begin to look at that in a whole different light. When the myth of Phaeton, who tried to drive the chariot of the sun, his father, Helios, and he got into the chariot, and the great steeds ran away with the chariot. He couldn't control them, and it left the plane of the ecliptic and descended down to earth and set the earth on fire. And finally, the earth was saved because Jupiter hurled a thunderbolt, which smashed Phaeton and his chariot from the sky, and it fell to earth and into the river Eridanus. And then the Heliades, who were his sisters, all wept over his death, and it caused a great flood. Their weeping caused a great flood. So when we begin to look at these myths, and there are hundreds of them like this, we are now in a position where we can reevaluate and go, okay, now these myths are not the ravings of some pre-scientific, barbaric, ignorant minds. These myths are encoded stories about real events that were experienced directly by our ancestors on this planet. And once we realize that, we make that phase shift in our thinking, it's going to open up a whole new complex of realities to us. That this is actually encoded scientific information that's come down to us in the form of these stories and tales and myths and so on.
So do we know that there's some areas like Göbekli Tepe and Easter Island, for example, that were like, what were those areas like during the Ice Age? Were they covered fully? Like, I mean, it's still shocking when you think of where I live right now, that it was 2 miles of ice not that long ago. Like, really, in a cosmic scale, it's like, a few thousand years ago we were covered in ice. So what about some of those other areas then?
Well, yeah, there were areas that, an ecologist would refer to as a refugium, places, sanctuaries where, like East Central Africa seems to have been a place where life thrived quite prolifically. And in the aftermath of these great catastrophes that wiped out the megafauna all over the rest of the planet, what we would call the Pleistocene megafauna. The Pleistocene being this period that, as I mentioned, started about 2.6 million years ago and only ended 10,000 years ago with these catastrophic events. North America had this incredible fauna of, there were 3 or 4 species of proboscidean in North America. Those are elephants, basically. You had woolly mammoths, Columbian mammoths, Mammuthus imperator, you had mastodons. There were giant camels in North America. There were rhinoceros in North America. I mean, on and on and on, right? Well, these were the Pleistocene megafauna, right? In North America, 3/4 or 80% at least of the Pleistocene megafauna did not survive the transition. In South America, roughly the same percentages succumbed to these tremendous cataclysmic changes. In Eurasia, we see a third, not quite a half in some places, of the great megafauna went extinct, completely erased from the planet. In Africa, only about 10% of the Pleistocene megafauna went extinct. So what happened is 85 to 90% of the Pleistocene megafauna in Africa survived. That's why Africa has the greatest megafaunal bestiary on Earth today. What does that tell us? It tells us that, because the extinction is almost certainly a consequence of habitat destruction, it tells us that the habitat destruction in Africa, at least in the equatorial regions, was probably minimal. And I have suspected that perhaps the Great Rift Zone area, Kenya, Tanzania, it was actually a place of refuge during the Ice Age and during the cataclysm that terminated. And what you would have then had is a repopulation, a spreading out from those sanctuaries of life going into the depopulated and destroyed habitats as they're coming back to life. on this trip with Graham, Graham did not accompany me to this because I was out there a couple of days before he arrived. But I went up and I visited Mount St. Helens, which, was about 300 square miles that was utterly destroyed, completely wiped out back in 1980.
Yeah, I remember seeing the ash. I lived in just east of Vancouver when that happened. So,
the ash?
Yeah. Oh, yeah. We had ash. Yeah.
I wasn't born.
It was weird. It was weird. What? Really?
I wasn't born yet.
Oh my God. You're so young.
Yeah. Well, in spite of the fact that you weren't born, it did happen.
I don't know.
You weren't there to witness it. It did happen. So I went and spent the day there, and roughly about 300 square miles of the area just to the north of the mountain was just utterly obliterated, turned into a barren moonscape. Now here we are 34 years later, roughly, and life is coming back big time.
Thriving.
Yes, thriving. Forests are growing. Another century or two, the mountain will be looking beautiful again. The forest will have grown up. So it does, in the aftermath of a cataclysm, it doesn't take nature that long to reclaim. That's one of the remarkable things. But I think what we need to be aware of here is that what we're talking about 11, 12, 13,000 years ago is a global catastrophe that left huge areas of the planet depopulated, habitats, large scale habitats destroyed. Now, think of this. I try to come up with ways of putting these things into perspective for people, but right now, there's roughly, it depends on how you count the species, but 120 to 130 species of megafauna inhabiting the Earth today. And that's on all continents. If you made a list, lions and tigers and bears and hyenas, moose, elk, wolves, go down the list, you're going to come up with about 120 species of megafauna. Megafauna is defined as an animal that weighs over 100 pounds in body weight.
Okay.
So by implication, I'm assuming both of you guys are megafauna.
I'm double.
I'm a megafauna.
Double megafauna. I'm
double megafauna. I mean, I'm about a. No, I'm not a triple megafauna. But yeah, so we can include humans in that definition, megafauna. Okay, so in the world today, there's about 120, say 130 species of megafauna. At the end of the last ice age, about 120 species of megafauna went extinct. So think about that. The population of megafauna on Earth was halved as a result of these catastrophes. If you were going to perpetuate an equivalent catastrophe today that destroyed as many species of megafauna as were destroyed 12,000 years ago, you'd basically have to eliminate every single animal over 100 pounds body weight on Earth. Now think about that. That's a pretty damn extreme event that can wipe out half the megafauna on Earth. Now, what about the remaining megafauna? Did they come through completely unscathed? Highly, highly unlikely. And in fact, I use this the example of the modern American bison. You know that there were, coming into the early 19th century, there were millions of bison freely roaming North America, right? Yeah. At the turn of the century, what was it, 50, 100 of them? And now you can go into your local supermarket and buy bison burger, right? Of course, what we're doing is we're constraining the number of bison. But if they had a completely open range, an unfettered habitat, they could have easily rebounded to a couple of million by now. Mm-hmm. Now, if we're looking at 10,000 years back in the future, okay, we could very easily miss the fact that the species of American bison came within a fraction of an inch of becoming extinct, right?
Right.
I think the same thing applies to human beings as well. I think we came, not only other megafauna would have come close to the brink of extinction, but so did humans. And there's actually emerging evidence now that we human species did come close to extinction. And we can see that because there was a culture called the Clovis.
Yeah.
That appeared suddenly in the wake of that early phase of glacial warming that I was talking about. They show up on the American landscape, perhaps even on the European landscape. They last about 300 years, and then boom, they're gone. At 12,900 years, they disappear. It's as if the curtain comes down suddenly on the stage, and boom, they're gone. The Clovis are gone. Now, we've got 500 to 1,000 year hiatus where the evidence of the Clovis culture is absent from the archaeological record. And then we see the emergence of what's called the Folsom culture, which has a distinct toolkit, different life ways, easy to distinguish the Folsom from the Clovis. Now, in terms of the Clovis, there were actively quarrying, there were active rock quarries that were being utilized for several hundred years by the Clovis people. At 12,900 years, those rock quarries are suddenly abandoned. There are campsites and apparent, like, settled communities where there's abundant radiocarbon dating evidence of human occupation, and then suddenly that radiocarbon dating is gone. They had a very distinctive toolkit. They used rock like chert and obsidian and other very hard but fragile rock to create these really beautiful spear points, fluted spear points that were very distinctively Clovis. Once you've looked at a few Clovis spear points, they're very easy to recognize. So for 300 years, there are abundant Clovis spear points and toolkits found in the archaeological record. At 12,900 years, they're gone. What happened to the Clovis culture? Well, I think that what happened was they were teetering on the brink of extinction. And so for hundreds of years, human beings were very possibly struggling for the survival of the species. And we have to understand this because I think many of the moral proscriptions that have come down to us from ages of gone have their roots in the fact that, human beings did hover for a short period of time on the brink of extinction. And, we can turn to the religious and spiritual traditions of the planet, and we discover all kinds of indications and pointers suggesting that same thing, our own biblical account. What happens? It opens with the story of Adam and Eve, right? Which I look at as being metaphorical. But at the same time, what's interesting is that when Yahweh gives them their task, their marching orders, and says, here's your mandate on earth, what are you supposed to do? Be fruitful and multiply is the first thing he tells them to do, right?
We sure got carried away with that one.
Yeah, we did. Now, okay, be fruitful and multiply. Well, if you're hovering on the brink of extinction, a species hovering on the brink of extinction, then that probably is a critically important thing to do. When the American bison reached 50 in total numbers, the most important thing was to establish viable breeding populations, right? So if we look at it that way, but then what follows after that? Be fruitful and multiply.
Because you think if that happened today, there'd be nothing left, right? Like when they found whatever bits and scraps of us survived, which would probably be, the tribes in the Amazon and maybe the Australian Aborigines and places like that are going to be the people that pull through, and we just kind of go to the wayside. Like planes, trains, automobiles would all become things of folklore.
God, yes, would become things of folklore. And the thing is that, yes, you're right. You're right. People that knew how to survive basically off the land and survive with primitive skills could, for the most part, unless they were unless they were right in one of the epicenters of destruction, of course, then everybody goes down. But if they're in the outlying areas, in the safe places, which there were safe places, yeah, they could continue on. It is what you can see, but look at our global infrastructure now and how integrated it is. If we have a Hurricane Katrina that comes along and wipes out New Orleans, well, we can rebuild New Orleans because the infrastructure is still intact around it. But I like to think in terms of thresholds and orders of magnitude. Let's say we had a Katrina level event, not necessarily a hurricane, just in terms of destruction and energy release. Let's say you had a Katrina level event times 10, and you had, instead of one major city being dramatically affected, you had 10. We could recover from that, and it would probably take a generation to recover. What happens if you had 2 orders of magnitude, 100 major cities? Now you would see that our recovery capabilities are going to be severely tested. 3 orders of magnitude, hey, we're back in the Stone Age, people. We're back in the Stone Age. And the kinds of events that we're talking about here, extraterrestrial impacts, they're the granddaddy of all natural catastrophes. They can cause hurricanes on levels unimaginable. They can cause global cooling by putting huge amounts of particulate matter into the atmosphere. They can cause global warming by injecting huge amounts of water vapor, which is actually the most effective greenhouse gas, into the atmosphere. They can cause earthquakes on a level way beyond anything we've seen in modern times. They can cause enormous biomass destruction through burning. They can cause tsunamis that would be hundreds of feet high. See, it's like every conceivable natural catastrophe gets rolled into one in a cosmic impact. And what we're learning now is 2 things. 2 things that people need to integrate into their thinking. One is that as astronomers have looked out into space, our neighborhood, our extraterrestrial neighborhood, what we're realizing is that it is densely populated with things. It's not just this empty
space.
No, we're sharing near-Earth space with all kinds of stuff, right? Now, the other thing is, now this is astronomers looking at the sky. Geologists looking at the Earth have discovered that there are hundreds of scars left over from the encounters between Earth and this cosmic debris. And those hundreds are surely only a small percentage of the total. I would suggest anybody who questions this to take a pair of high-powered binoculars, go out on the night of the full moon and take a good look at the moon.
Yeah.
And what are you going to see? You're going to see our nearest celestial neighbor is pockmarked with millions of scars from cosmic impacts. Then think about the fact that our planet, because of its greater cross-sectional area and greater mass, is going to be roughly 80 times more susceptible to impacts than is the moon.
But we have a protective atmosphere, though.
We have a protective atmosphere that will protect us from things that are, say, 10 to 50 feet in diameter. Yes. Look at what happened in Chelyabinsk, February of 2013. A 50-foot in diameter object blew up over that town. Nobody was killed, but 1,500 people were injured, and 1,000 buildings were damaged. Now,
that was school bus or something, right?
No, 50 feet. And you were saying the other one in Russia there.
150.
150, yeah, wow.
Yeah. Now, yes, the atmosphere did protect the surface of the Earth in the case of Tunguska. Yeah, the thing did not reach the surface of the Earth, but actually a detonation in the atmosphere, if it's low down enough, can be more devastating than an impact into the ground. This is why when the United States dropped the atomic bombs on Japan, people in the crude conception of it might think this bomb falling, it hits the Earth and blows up when it hits the Earth. No, what they did was they detonated those bombs in the atmosphere because the destruction of an atmospheric detonation is going to be greater than if it actually hits the ground, and a lot of that energy is absorbed by the ground. So, yeah, the atmosphere will provide us protection against the smaller stuff. But once you hit 100 feet in diameter, no, the atmosphere isn't going to do much anymore. 150, 200, 300, 400 feet in diameter, what you're going to be talking about is extreme devastation in the area where the object penetrates the atmosphere. Now, another factor that you have to bear in mind is that density and composition of the object coming in plays a role too.
Right.
Most people, I think, that are somewhat scientifically literate have seen pictures of the Barringer crater or meteor crater in Arizona.
Oh yeah, I want to go to that. That's is that the mile wide one or?
It's about a kilometer. It's about 4,000 feet wide, and 650 feet deep.
Okay.
Now, that's an example of where an object actually struck the ground and created the classical bowl-shaped crater.
Right.
The Tunguska object didn't strike the ground. So it did not create a crater in the classical sense. Okay. What's interesting, though, is that the object of Tunguska was about the same size as the object that created Meteor Crater in Arizona. The difference being one of composition and density.
Right.
The Tunguska object was a lower density. If you imagine this, you go out and you pick up a typical rock next to a stream, typical sedimentary rock, sandstone or whatever. You pick it up, limestone. It's going to weigh 3.5 grams per cubic centimeter, maybe a little more, maybe a little less, depending, right? Now imagine that you pick up, in the other hand, the same volume of cast iron. It's going to be much heavier, much denser, isn't it?
Yeah.
Okay. In the character and nature of these cosmic objects, you go all the way from low density, almost snowball-like objects, which are comets, up to iron asteroids and everything in between. Now, a predominantly iron, high-density object is what hit Arizona. So because of that higher density, because it was a much harder object, it was able to penetrate fully through the atmosphere and strike the ground. The object in Siberia of 1908 was lower density, but roughly the same size, but it did not penetrate the atmosphere fully, blew up, and then devastated 800 and some square miles of old-growth taiga forest. So the consequences of the surface consequences, the consequences down here below are going to be largely dependent not only on the size of the object, but the velocity that it's moving, its composition and density, and also the angle at which it comes into the atmosphere. Now, you know that if the object is coming behind the Earth, it's more like a rear end collision, right? So you have to basically subtract the velocity of the Earth from the velocity of the incoming object, which might be 20 or 30 miles per second.
It might make all the difference, yeah.
Yes. On the other hand, if it's coming from the other direction and it's head-on collision, you have to add the two velocities. And now, because the energy release, the kinetic energy, is going to be the velocity squared, you can see what happens.
So sticking on that topic for a sec there, people sell this jewelry like tektites. They call them tektites, and moldavite is supposedly this rare comet that landed in Czechoslovakia. So is that what you're talking about? It's kind of ends up being at a certain density where it ends up breaking up right before, and it could scatter tektites all over the Earth? Or?
Yeah, tektites are interesting, but they're probably the result. Most tektites appear to be a mix of the cosmic material and terrestrial material. So in other words, if you have an object that comes in, strikes the Earth, there's so much heat release that it literally liquefies the Earth in the immediate area of the impact. It turns molten, and this molten material splashes out. And the molten material is comprised of both the terrestrial target rock and the composition of the object that came in. So that stuff gets mixed together in this boiling stuff that gets thrown up in the atmosphere. As it rains out, it forms these elegant aerodynamic shapes, teardrop shapes, cone shapes, dumbbell shapes, sphericals, etc. And that's what falls back to the Earth as tektites.
Oh, interesting.
Yeah, and so your moldavites, they are the consequence of an impact. Yeah, I think you're right. I think it's in Czechoslovakia. But one of the many hundreds, actually thousands of times, Earth has been impacted by stuff from space. In fact, we are now getting to the point where it's becoming apparent that extraterrestrial phenomena like that is probably the dominant geological factor, the dominant biological factor. Everything from plate tectonics, to the climate change and the oscillation between glacial and interglacial ages, mass extinctions, volcanism, the creation of magmatic hotspots like Yellowstone, all of this, reversals of the geomagnetic field, the list goes on and on. Probably all of those things can be tied in to cosmic impact.
So what do you think we should do then about that as a society, as a culture? Should we just invest a bunch of money and really try and have some sort of defense system against that? If that's like the number one thing that's going to affect us.
We got to get to the moon, buddy. Makes you wonder why we don't have fucking moon bases. I mean, NASA must know this shit too.
You know why we don't have moon bases?
Well, you'd think
Kuiper
they
Belt.
would. You would think they do, but and they do. There are scientists and engineers within NASA that are very much keen on this, wanting to do something about it. But there's huge political inertia there. We're spending so much of our natural resources on other things, what I think of as the inessential things, that there's basically nothing left over. NASA's been basically starved for funds for decades now. We started out, with this vigorous moon program, space program in the 60s with Mercury, Gemini, and Apollo. We created this tremendous fleet of Saturn rockets that was, at the time, assuming that this is now the beginning of our migration and colonization into the solar system. Well, basically, our space program of the 1960s was a casualty of the Vietnam War. When Nixon needed more money to fight the war in Vietnam, he gutted the space program. And all of these Saturn rockets that we had built at tremendous cost to the taxpaying public were put out to rust. And, right now, the government itself has become one of the biggest obstacles to us actually responding in such a way, because, there's a whole burgeoning private sector space program underway. And, again, they're trying to do it on a shoestring. But what's interesting is that the government has created tremendous regulatory roadblocks. Had similar roadblocks been in place back in the early 20th century, there would have never been an aviation industry that got off the ground. But yeah, clearly what we need to do is, and I think what it's going to take is a couple of more Chelyabinsk's, or it's going to take an object actually killing a couple of thousand or 10,000 or 100,000 people before people finally go, oh, wait a second. It's going to take that to get people out of their trance.
And then what would you do then? What would you suggest we do?
I would suggest that we basically pull out the stops and move forward, which basically means we become, in the next generation or two, a cosmic civilization. I heard one of you guys mention, going back to the moon. Well, I think it would be very sensible to begin to colonize the moon. Going back, resurrecting some of the ideas of Gerard O'Neill and his graduate students at Princeton back in the mid-'70s, where they began to explore the possibilities of resource development from space. Some of the things, like down here on Earth, we've been trying to get viable solar energy in place for decades. And, I think we're constantly making strides in that direction, but we're still beset by a series of problems, which is that, the day-night cycle, clouds, the weather, the fact that solar collectors do take up a whole lot of real estate. But if we go 5,000 to 10,000 miles outside of the Earth's atmosphere and set up a solar collector, that solar collector is going to be able to collect solar energy, unbroken, unmitigated, 24 hours a day, roughly at this intensity, about 10 times what you would get if you set that same solar collector in the middle of Death Valley on a clear day at noon in the middle of the summer. See, it's once we begin to transplant our industry into space, we will be able to viably run factories with solar energy. Now, this sounds science fiction-y to people, but, and especially people who haven't been around since the 60s, because I was, when President Kennedy gave his speech and said, we're going to get to the moon, et cetera, and we're going to do all of this stuff, I remember well the pace at which we were able to proceed. There was a vision and there was a national will. Hey, we're going to do this thing. And by God, we did it. And then what happened is people got distracted. And what I kept hearing in the 70s when I was proposing, I remember how excited I got when I first realized that asteroids that could strike the Earth were loaded with resources, the various kinds of things that we were destroying terrestrial habitat to mine, right? There were hydrocarbons in asteroids. There are precious metals. There are basically everything that we can extract from the Earth exists in space, right? In some form or another. And, what's ironic here is that asteroids, which are incredible sources of wealth, in terms of the precious metals that they contain, in terms of the hydrocarbons they contain. Interestingly, the more dangerous they are, which is a function of how close they come to Earth, right? The easier they are to access. And we're in a position now where it's no more unrealistic for us to be mining asteroids a decade from now than it was for us putting a man on the moon in 1960. I mean, we could literally be doing that. But, it's going to take something. It's going to take a slap upside the head before people go, wait a second. You know what? We really are shooting ducks in a cosmic, sitting ducks in a cosmic shooting gallery.
Right. So
we really are.
What would you recommend then, as far as that's one thing to leap off into space, but how about protecting us? Like, is there anything we can do? Is there anything we can do?
Absolutely. We're the thing is first of all, taking a census of the things that are out there. We're doing that right now, which is ongoing, and we're learning that there are large objects out there that could someday impact the Earth, but are not a threat to us in the next century or two. There are some objects that look like they could potentially be threats within the next century, but we have to refine their orbits with a little more precision. However, I think that really the issue is the things like Tunguska and Chelyabinsk that are the smaller things that might sneak up on us undiscovered.
Right.
Now, those we might not be able to do anything about, really, at this stage. However, once we get out there and we have industry in space, and we have cities in space, and we have ports on the moon, we're in a position now where we can essentially protect the planet from this point on. I mean, if we look at 4 billion years of planetary history, what we see is that great planetary catastrophes have been as much a part of the normal sequence of things as the slow, more gradual, incremental changes that certainly do go on. We know, though, that the biological clock has constantly been reset. And there have been several events, the Permian-Triassic boundary, the Cretaceous-Tertiary boundary, the Silurian-Ordovician boundary, where life itself on the planet has hovered on the brink of extinction. Now, you could say, well, that's part of the natural order of things. Perhaps. I tend to think, though, that nature, in her infinite wisdom, has evolved a species with big forebrains because she wants one species to be able to have foresight. And perhaps, it has been said by a number of astronomers and geologists who have been looking at the record of, mass extinctions and unbelievably powerful catastrophes in the history of the Earth that, well, hey, now Earth has one species out of all the millions of species that could actually do something to prevent those kinds of future catastrophes. And I think what that does is it puts a whole new moral context into the human species on Earth and what our role is. And yes, we have destroyed some of the environment to extract resources to build this industrial base. People have to look at that as an interim phase, though. It's the interim phase that gets us from the Stone Age to the Cosmic Age. The Cosmic Age, where now life is now become invulnerable because it's no longer confined to the surface of a planet. Where if something doesn't intervene, whether it's 10,000 years from now or 1,000 years from now or a century or next year, something from space, the windows of heaven will open and something from space will come in and the whole order of nature will be completely disrupted. When the last ice age came on, think about this. How horrified would people be if the logging industry went out there and clear cut every tree in Canada from the Atlantic to the Pacific and from the northern United States to the Arctic Circle and cut every single tree, right? We'd be horrified, wouldn't we? Well, that's exactly what the last ice age did.
Yeah.
Right? It completely wasted, wiped out 6 million square miles of land from the Atlantic to the Pacific, from the northern United States to the Arctic Circle. Do we stand idly by and allow that to happen? Meanwhile, beating ourselves up because we might be doing something which, by contrast, might actually be relatively insignificant. This is not to say, I'm not in any way meaning to imply that, hey, we should with impunity go and destroy the environment. No, because we absolutely must become caretakers of the terrestrial environment. But we also have to be realists and understand that, wait a second, yes, as significant as that our own impact has been, excuse me, people, but nature has some pretty big surprises in store for us if we think that we are now the dominant force in terrestrial nature.
Yeah, interesting. So can we switch gears a bit and get into you're going to start a webinar, I think, in early 2015. So what is that going to, I mean, there's so much information to cover here. We could talk about your sacred geometry and how that gets into the time scale of things. Like it's not really a coincidence that 26,000 years we keep talking about it, and that seems to have some sort of connection as well. But what are you guys going to be teaching in your webinar? Well, the webinar is going to basically delve into symbolism. It's going to be symbolism. We're going to draw from multiple sources because I want to elaborate on two things. One, what we've been talking about is, in a sense, the negative side of the equation, right? The cataclysms, the destruction. There's another side of the equation as well. And a lot of the symbolism and teachings and stories, myths and archetypes that we've inherited from long ago, I think are pointing in the direction of a type of technology, if you will. In the series of articles that I've got posted on the Sacred Geometry website, if people would go there, read those articles, what I'm talking about there is essentially my interpretation of the Grail mythos, which is this. It's a way of encoding information about a lost technology that can be employed to replenish and resurrect the planet in the wake of a cosmic catastrophe. In other words, to accelerate the recovery of nature in the event of a cosmic catastrophe. But not only that, to be utilized to enhance the viability of nature on Earth. So this is what it's going to get into. It's going to get into a lot of the ideas about why did ancient humans build this incredible infrastructure? And why did they place structures where they did? And what is the connection between the ancient infrastructure of these archaic peoples and the geology of the Earth and the cosmos above? Because as we mentioned earlier, all of the ancient infrastructure all over the planet has certain elements in consistency, such as an orientation to the sky. Well, I suggested that one reason for that was to actually be able to monitor events in the sky, thereby giving a measure of predictability. Yeah. But I think it goes further than that. I think it also is that they understood that that Earth, there was a constant exchange of energy between the Earth and the cosmos. And by building buildings in a certain way, placing them in certain positions on the Earth, orienting them in certain ways to the sky, the interface of cosmic energy and terrestrial energy could be amplified in such a way that it could now be beneficial for the proliferation of life. And that's kind of what we're going to be getting into. So it's based around the symbolism of the Grail. So if anybody's interested in learning more about it, and this idea that perhaps the same forces that could cause massive destruction can also be utilized for recreation. I think that's a very powerful idea. And I think that that's how archaic peoples looked at it, was that you see, when an object from space encounters the Earth, it injects all kinds of very interesting exotic materials into the biosphere. Platinum group metals, for example.
platinum group metals may turn out to be an important catalyst for evolutionary processes. They may be very important for causing rapid genetic change in species. We're already seeing that with the end of the Cold War. Once we started getting access to a lot of the research of the Soviets on Tunguska, we began to see that there were actually profound biological implications to that event. There were genetic changes that occurred in those forests. There were species that had never been documented before that suddenly show up. So there's this whole other side of the equation where, again, what I'm suggesting here is that our ancient ancestors were very much into this idea that there was this exchange and interaction between terrestrial life here below and the cosmos above. And so they attempted to harmonize their own cultural life and individual life with the forces and the cycles of the cosmos, not just the seasons. Those are the obvious ones. I mean, to any agricultural civilization, obviously one has to be immersed in the seasonal changes and the cyclical changes, clearly. But I think it went beyond that. I mean, because for one thing, it's probable that we now know, based on the architecture of the solar system, that alignments of the outer planets are critical for transferring cometary objects from the Kuiper disk to the inner solar system where they can become Earth crossers. And so it's very interesting that the patterns and forms that we look at in sacred geometry are recapitulated in the solar system. Yeah, and
that kind of gets into what Ed Nightingale was talking about at the symposium with the Giza Plateau sort of being some sort of star map that's saying when these alignments happen, fucking hit the deck.
Yeah. Or conversely, when these alignment happens, exploit the enhancement of energy that is the byproduct of that. I mean, there's so much interesting work out there that's emerging now. The Dragon Project, Paul Devendorf, in his work. Devereaux, sorry, not Devendorf.
Oh,
Devereaux.
I've heard his name before. Yeah.
Yeah, really interesting work, and he and I did a joint interview a couple of years ago. Paul Devereaux has been basically documenting and showing that many of these megalithic sites in the British Isles are oriented towards the geological fault lines in the crust. Okay, which to me brings in a whole other dimension to understanding what our ancestors were up to when they were building these structures, because they weren't just randomly placed on the landscape. They seem to be clustered around zones of telluric energy, which is whether it's geomagnetism or what it is, there does seem to be forces in the earth that can actually be measured. Prior to an earthquake, there are geomagnetic forces that occur that can actually induce ionization of the atmosphere. Ionization of the atmosphere can in turn have direct effects on the hippocampus of the human brain, which is known to induce dreamlike states, prophetic states, visionary states. Also, there's been interesting studies done showing, germination of seeds, how is rapidly accelerated when placed in some of these force fields. And what it appears is that many of these structures were positioned with respect to the underlying geology, the fault lines, the ore deposits, the minerals, the precious metals, and so on some level. Like Paul Devereaux says, it appears, and John Michel said this too, that our ancestors were not only sophisticated astronomers, they were also sophisticated geologists. And I think that what we see there is essentially the literal manifestation of the alchemical dictum, as above, so below. Because what they were doing was they were recreating the map of the heavens on the earth. But what's interesting is that these patterns that they were laying out on the earth were also related to the underlying geology, the structure of the lithosphere below. So I think what we're seeing here is a type of alchemical science where the energies of the earth are fused with the energies of the cosmos. And there's a consequence to that I think can actually be exploited technologically. And this might be what they were up to. So a big part of what this webinar is going to be about is exploring some of the basic principles there behind and how they have been encoded in symbolism. And I've chosen the Grail symbolism because it seems to be quite apropos in terms of the things that they are talking about there. Because you remember, if you remember the Grail story, what happened? Remember, the king was in decline, whether it was King Arthur or Anfortas or several of the other kings that are named, the Fisher King that is laying up in his castle, unable to move because he's debilitated with this unhealing wound. And whether it's Galahad or Percival or whoever the knight is that goes out and eventually finds the Grail, what happens? He brings the Grail back. The king is restored. But while the king is in decline, so is the land in decline. The kingdom is suffering from this same debilitating infirmity that the king is. The Grail becomes the object that represents the means of restoring vitality and fertility and health, not only to the king, but to the land as well. And now, when we realize that the Grail mythos has its roots in the mid-6th century, in the stories of the Arthurian stories, Arthur is killed by Mordred at the Battle of Camelot. And the date of Camelot is usually given as around 540 AD, 540 to 542 AD, right? Well, dendrochronologists and other scientists have now documented that around between the mid-530s and the mid-540s, there was a major environmental catastrophe that affected the entire globe. Not on the scale of what we were talking about before, but enough so that forest growth in the northern hemisphere for 10 years almost came to a halt. This happened. And this was the onset of the Dark Ages. Okay. And what we now know, not only from proxy scientific records, but from the historical record itself, was that the Dark Ages was not just metaphorical. It really was dark for a long period of time. Now, the evidence is accruing that, yes, there was some kind of a cosmic encounter event. There's Dallas Abbott and her colleagues have documented that there may have been a major impact into the Pacific Ocean around that time. There's more evidence that perhaps there was another impact event off the coast of Norway that caused a 10-year environmental downturn. Okay, and it's this 10-year period that the Holy Grail stories are placed. That's their historical context, right? With this environmental downturn, one of the things that happened was there was multi-year collapses of agriculture. These multi-year collapses of agriculture caused famine to come on people. With people not getting nourished, their immune systems got weakened, and in 542 AD, you had the Justinian plague that wiped out half the population of Europe in some places, third the population overall, but in some places half. In some places, whole areas were basically depopulated by that plague. And so what we see there is that was just a minor environmental blip. Now, what we see with the Grail mythos is it's placed within that historical context of this environmental collapse. When you read the stories about the wasteland, the Arthurian knights traveling over the wasteland, seeking the Grail, which is the antidote to this. Well, we have to realize now that large parts of Europe, probably North America, were for about 10 years rendered as a wasteland. So what I'm getting at is the Grail is a symbol for the means by which vitality and vigor is restored to this debilitated landscape, you see. Now, the same technology that could help to replenish the earth in the wake of a catastrophe may be actually the secret of the Philosopher's Stone itself. It may be the alchemical secret whereby we fallen angels can be restored to perhaps our rightful place in the spiritual hierarchy of things. Because one of the universal traditions from all over the ancient world is this tradition about universal destruction. Okay. But another one of those traditions is also the idea that there was another higher order of humanity, right? I mean, the biblical lifespan, the Bible is not the only place where this vastly extended human lifespan shows up. Traditions, they're not as ubiquitous as the Great Flood traditions, for example, but they are very universal. This idea that there was a higher order of humanity that lived on a higher plane, and we are now in a fallen state. Well, I mean, the hardcore scientific reductionist is just going to roll his eyes at that. But I think that, again, what I'm trying to suggest to people is that we take a new look at these traditions that we've inherited from our ancestors. And there may be just unbelievable riches to be mined from the small fragments of ancient traditions that have survived the vicissitudes of the ages, both because of direct intentional destruction and just things being lost because of collapses of civilizations and cities and so on. But the small amount that we have obtained or retained could be immensely powerful and valuable in trying to come to terms with what we really are as human beings on this planet, where we've been, and what we're capable of in the future.
Huh, that's fascinating. Yeah, Harold was just commenting on that in the chat room about whether that information was passed down from a lost civilization, and we have just lost the knowledge today, and it sounds like you had answered that question. Yeah. Huh.
Well, I think a large part of it has been lost, but enough of the pieces remain. These little specks that I think that by a careful and assiduous study and research by enough people, we are connecting those dots.
Yeah, there's so much to talk about. Like the guys at Paradigm Symposium, some of the presenters there, we've been talking about, Darren, who's that guy that was talking, the Irish guy that was talking about the ancient sites?
Barry Fitzgerald.
Yeah, Barry Fitzgerald was talking about, these ancient sites that have special archaeoacoustic properties and really basically change your consciousness there. I mean, there's all kinds of stuff that I think you're really going to enjoy next year, presenting along with these other people and being able to pick their brains. There was a lot of crossovers between all this research, and there's really a lot of dots being connected. So speaking of that, what are you working on from between now and Paradigm Symposium, and do you have any ideas of what you would be presenting there? Because obviously you could do this for like 2 days straight, but you probably only have a slot that's going to be an hour and a half. So,
I honestly don't know yet. I guess I'm going to have to see where the next year takes us. I'm trying to do a lot of writing. I've been threatening to write a book for years, and I have been doing a lot of writing, posting these things online. And I need to get it into a coherent form where it's all in one place.
Right.
I'm still a believer in the print media.
Yeah.
There'll always be a place for that. Listen, when I'm at the beach, I don't want my laptop. I want a book. I can brush the sand off of my book or magazine, no problem. But yeah, and when I curl up in bed at night before I go to sleep, I want a book. I don't want to be sitting there with my computer.
Same goes with the bath for me.
Yeah, say in the bath. Yes, exactly. And that's something I have actually I started taking baths again. I didn't take baths for years and years and years. But I did take showers. I just didn't take baths, okay?
I'm on strike from either.
I've rediscovered the bath. And so I like to get in the bath. I've discovered I've got an ozone generator, and I put it in there. I don't know if it does a damn thing, but it sure makes me feel good. So I put that in the bathtub with me, and I sit there, and I have a book or a paper, and I read it. And sometimes I even fall asleep. Anyways, where we go the next year, I hope to get in some more expeditions. I'm very much leaning towards an expedition to the Azores, which links us, to the whole Atlantis story, which is something I've been following keenly for a lot of years. And I have a lot to say on that. Probably not today in this, because I don't know how much time we have left, and you need to give enough background. And I talked about it on Joe Rogan's podcast. So if somebody goes online and listens to Joe Rogan's podcast 501, I do get into the whole Atlantis thing for a while on there.
Yeah, yeah. So what about I would like you to review then for people that they can go online on YouTube and see a summary of the DVD set that that you guys are making. But could you summarize that for people? Because that truly blew my mind when I watched that. I'm going to have to order the DVDs as soon as you guys get them ready. And that's just, I think that's something worth telling people about.
Yeah. Okay. There, what I'm trying to do is to show that all of the stuff we've been talking about, the links between that and sacred geometry and how sacred geometry fits into the scheme of things, because sacred geometry had multiple purposes. One, it provides a very potent symbolical vehicle for the perpetuation of information, because of the fact that math, geometry is universal. The relationship between the circumference of a circle and its diameter is going to be the same no matter what culture you're from or what language you speak or what ethnicity or religious beliefs. None of that matters. It's a universal language, right? Sacred geometry is a very potent symbolical system that's come down to us from ages ago, and it's one means of perpetuating teachings, which I think not only can reveal to us ancient patterns of thought and belief and art and architecture, but also give us some powerful tools for the way we shape our own civilization from here on out. The idea is that there are principles of harmony, and they can be uncovered and revealed through these processes of sacred geometry, linking things into a system of symmetry, balance, proportion, and ultimately harmony. And this gets us back again to the idea of the Grail, which is about restoring vitality to basically to a decimated landscape. And sacred geometry would be a very powerful tool for that. By profession, I'm a builder. We have a design build company. So I'm trying to segue as much as possible into creating a market of people who want to experiment a little and try creating structures that utilize some of the ancient principles.
So you use this in your business too?
I've developed a system of modular building design that's based upon sacred geometry. I don't know where I'm going to go with it yet, but I've basically developed the working elements of a system of modular construction that would integrate a small number of unified components into a harmonious whole.
Nice.
And perhaps even do it relatively economically. So that's something I've been working on. The DVD basically tries to show how sacred geometry integrates with all of these other traditions. So I begin by looking at the Platonic solids and the numbers, the canon of cosmic numbers that cascade out of those forms and patterns of sacred geometry, and how they can be linked to the architecture of the solar system, the galaxy, how they can also be used to understand the unfolding temporal periodicities that we see manifested within these patterns of change that we've been talking about. Because it certainly seems like the great catastrophes don't come totally randomly. There's definitely a temporal pattern, just like you mentioned the 26,000 years.
Yeah.
26,000 years is one precessional cycle. Most people have heard of, the age of Aquarius, the age of Pisces, and so on. What these are, of course, is the time that the vernal equinox transits each of the 12 successive signs of the zodiac in turn. And if we go backwards from our own time for the last 2,000 years, the vernal equinox has been transiting through the star cluster of Pisces. Before that, it was Aries. Before that, it was Taurus, right? Before that, it was Cancer, Gemini, and then in Leo. Interestingly, these things that we were talking about that occurred, the Younger Dryas and these catastrophes and all this, they were all concentrated in the age of Leo. This fingerprints of this cosmic event that we were talking about, 12,900 years dated to. That was a number I'd come up with 20 or 30 years ago by looking at the traditional models and realizing that the traditional models were pointing directly to that episode, directly to that time period. So I was really quite thrilled in 2007 when the first hard scientific evidence started getting published that, something cosmic really did happen at that window at that cusp between the age of Virgo and the age of Leo. And so,
is that a common thread at the turn of the ages?
Hancock and Robert Bauval and John Anthony West were doing, noticing that the orientation of the Sphinx was to the eastern sky during the age of Leo, and pointing, saying it seems that the whole Sphinx symbology is pointing to something important that happened at that age of Leo 12,000 years ago. So that was tremendously gratifying to me. And now the hard science is converging totally with the more fringe interpretations of traditional accounts. So this DVD is going to get into a lot of that. It's going to show how the 5 Platonic solids that were so-called because they were so important to Plato, that in those Platonic solids, we find the cosmic numbers manifested that influence the unfolding of these cosmic cycles, right? And so what we see, in one of the important insights that I try to convey to people when we're talking about sacred geometry, because, most people think geometry, they think space, they think patterns in space, right? Sacred geometry is also a way of measuring time. So there's a sacred geometry of space, a sacred geometry of time, and the same canon of cosmic or sacred numbers that we find prolific in one, we find in the other. So that's a large part of what the DVD is about.
Yeah, it sounds fascinating. Yeah.
Is there any way to use sacred geometry in your day-to-day?
We're on this end, my business was thriving for years, and then when the recession hit, my business, like woolly mammoths, it was tottering on the verge of extinction for a while. I managed to hang in there, and now it's coming back, and we're getting some good projects in. I hope it keeps up for a few years, but we're always working on a shoestring and can use all the help we can get. Cameron spends many hours working on this stuff, virtually without any compensation at all. So it would be really great if a little bit of help could go a very long way. But we're getting to a position where I think what we've got is something that is of immense value, and as people begin to realize that, and as we get some more marketable commodities out there, whether it's books or DVDs or whatever, we should be doing fine. But in the interim, it's it's just getting over that critical hump that we're at right now. I not had to watch my business almost evaporate during the recession, 5 years ago, I thought we were well on our way because I was doing great. I had $1 million projects going on, and literally within a couple of months, it all evaporated.
Did that help with the genesis of what you're doing now?
Recovery mode. It's just like we're talking about here. It's it's like what happens on the grand cycles can also happen on the individual level as well. Yeah. There is this parallelism that goes on. Catastrophes on our own personal life can be echoes of catastrophes that happen to the life of the planet.
Well, I think your time is here, and you're getting some focus here with from a lot of people. I mean, and I did that downturn help you help the genesis of this new path you're on?
If you look at the credits, you'll see everyone who contributed to that is listed, and anyone who's bought the DVD before the updated version is produced, just know that you're enabling this great work to move forward. And the version of the film you receive, it's completely adequate. It's just that we hold ourselves to a higher standard, and because of lack of funds and stress, it wasn't, when we did the punch out, checking out the work, we didn't actually feel that it was the best product we were capable of. But of course, paying the bills, keeping the lights on, those types of things are an internal stress we all can relate to. And so if people want the information, it is there. There's nothing wrong with the DVD. It's just that we now have a better, faster computer, so some of the edits that were clunky can be refined. The graphics that I produced, I've switched the format. If you look at the version available on our YouTube channel, the first 2.5 hours are given away at no charge. There's mind-blowing information encoded there. You have, evidence of the size and shape of the Earth being encoded in the Great Pyramid and the Parthenon. You've got the sacred geometrical connections to the cycles of time being presented with the huge revelation at the end, which we're not putting out there just yet. But for people who do purchase the current version, you will be at the front of one of the greatest revelations of all time, bar none. Randall doesn't like to promote himself in that manner. That's kind of my job, but I have to eat and I have to have computers at work in order to get this information out there. It took us 6 years to get him on Rogan again, because I introduced him to Rogan in 2008 at the Punchline Comedy Club, and that's on our YouTube channel. So I don't want to sound bitter or anything, but it is a struggle. And if you order the DVD, when the updated version is ready, I guarantee you'll get a copy of it, either the download, or if you pay for shipping, I'll pay for the cost of the production of the DVD, the new version, and the Blu-ray, and send it to you. But that money is essential in keeping the lights on. That's where the lion's share of any money Sacred Geometry International makes each month, and it's not a lot, comes from. So thanks for letting me interject. Just wanted to get that out there. And I guarantee anyone who watches that film, you're not going to be the same. Prepare for the red pill, shake down, come down.
Oh yeah, I could tell the quality was great on the YouTube channel.
So I'm going to check out now. Sorry for the interjection. Thanks for having Randall on the show.
Hey, no problem. Yeah, no, that's great. I can vouch for the quality of that YouTube channel, and I can just see the DVDs will be good. So, Randall, can you hear us okay now?
Oh yeah,
everything's
loud
good.
And clear.
All right. Well, that's good. I mean, I wanted to get your take on that on the DVD to summarize it, and now we got Cameron's as well. So people donate, buy the DVDs, all that stuff is good. Is there anything else you guys want to say before we start wrapping it up?
I've said quite a bit. I think there's enough for people to digest. If you've got any final questions or whatever, I'm sure as soon as we sign off, I'll be thinking of a half a dozen more things that I should have said.
Yeah, I mean, we want to kind of avoid the whole global warming thing and all that. I mean, there's so many things to talk about it, but we just really appreciate your research, and we appreciate your time coming on. I mean, like I said, we're going to link to everything in the show notes, and we're looking forward to seeing you again in Minnesota at Paradigm. I mean, I think you're going to have a great time with all the other researchers and hanging out.
Oh, I know I will. Absolutely. Well, I did last time. So, yeah, I'm sure it'll be even better next year.
Yeah, this time hopefully you'll be here the whole time. So,
yeah, we had some fun. We did. I think stepping outside.
Yeah, stepping outside of the box.
Yeah, stepping outside of the box.
Those are the best times.
Well, it's what's wonderful about these things is they're serving to bring people together from all over. And that's what's going to really. That's what's going to catalyze this paradigm shift. What you guys are doing and what so many people are doing, and it's great for me to finally start getting a little bit of recognition. But Graham has been doing this for 20 some years, pushing the envelope. And he's been a pioneer because when he started putting out some of these ideas, mainstream academia just savaged him. Very, really not in a responsible way at all. But I think what he has done is definitely held the test of time. And Graham, like a lot of us researchers, we're trying to look at so much information and pull so many things together that, sometimes you're gonna say something or put some information in that later proves to be wrong. But it doesn't discredit the whole thesis that there's another way of looking at history.
Yeah.
But what these guys do, what the critics do, is they will seize upon one little thing that in no way discredits the whole thesis at all, but then they will try to put the complete focus on that as if it does, as if the whole idea of there being a lost history is completely discredited because, somebody makes one misstatement in a 500 or 600 page book. That's just amassed a tremendous amount of material, and to the uncritical thinker who might read a review, where it's basically just this smarmy attitude about, oh yeah, well we know what the fringe researchers think. They'll fall for that, and they won't. I don't want to get into the global warming thing. You brought it up, but perfect example of how you get some information out there and there are critics of that. And what happens is that the defenders of the Algorian orthodoxy will seize upon the fact that perhaps one guy who made a critical remark about the global warming consensus once, got $1,000 from some tobacco-related industry. And then that discredits every criticism about the Algorian hypothesis.
Yeah.
But it's the same thing with a researcher who's going against the grain. But now I think that there's enough people out there and enough information and young academics and young scientists who are more open-minded and don't have a vested interest in protecting the establishment paradigm. We're willing to look at this and go, you know what? There really is another version of this story of the human presence on Earth. There is a deep history and it has been lost. And we need to know why it's been lost. And what are the implications of knowing this for our own future?
Have you got any pushback yet yourself? And if not, are you prepared for it?
Oh, yeah, it doesn't bother me.
Yeah.
I've gotten some pushback. I noticed when I did Rogan's and I had some rather critical comments about the global warming consensus. Most of the negative feedback that came in was addressed to that, because what you heard repeatedly was, well, who's this guy? There's a 97% consensus.
Yeah.
Never mind. Look, if you took 10 minutes to look at the source of that so-called 97% consensus, you would realize that it was totally contrived and totally bogus. And I would be glad to spend an hour sometime with you guys exposing what a fraud that consensus really is.
We actually, synchronistically, we just finished talking with Ben Davidson right before this interview, and we were talking about exactly that.
I'm not familiar with Ben Davidson. What did he have to say?
He said that the reason why he basically debunked the whole 97% thing, right? He does this mobile observatory, goes around looking at the solar activity. So he's looking at the solar connection with global cooling right now, as opposed to it's very, very much along the same lines as you were saying. And he basically debunked the whole 97% thing, basically saying that it was 97% of the people that were already part of the IPCC already sort of bought into the climate change and global warming thing.
Yeah, and well, it's like this. If you ask, I'm surprised it wouldn't be 100% consensus, because if the question is, are humans influencing the climate? Well, yes, of course humans are influencing the climate. But that's not really what the consensus is about. It's about something else altogether. So,
yeah.
And, I could go on about that, but I won't in this venue today.
Yeah, no, that's good. It's probably better we don't. So anyways, let's start wrapping this thing up. We'll link to everything in the show notes, and we'll see you hopefully in person again in October. If you come by Calgary to visit Okotoks and anything in Banff or whatever, make sure you look us up. Well, actually, that's one of the trips I really would like to do next summer. I would like to actually follow the erratics train right up to its source. Nice. And then move on up, because I'm looking. What I want to do is build a case that the source of these tremendous floods that Graham and I were looking at in October was actually up in British Columbia, and potentially examine an area up there that I think potentially is a good site for a possible impact site. Nice. Yeah. So, who knows? Maybe we'll hook up and you guys can tag along. Yeah,
we're in. Yeah. We could be your Sherpas.
Yeah, that's what I'm saying. I always need somebody to carry my gear.
That's awesome.
And perhaps if we get up on the mountainside, to carry me back down.
Right on. All right. Well, give us a little bit of heads up so we can get in hiking shape.
Okay.
Yeah.
Well, I'll be working on that myself all winter.
Right on. And thanks a lot for your time, and good luck finishing your book off there. Hopefully you get some time to write.
I'm making the time. I've been writing regularly. I've kind of gotten into the habit, but ironically now my business has really started going strong again, and I'm looking at some pretty significant projects, but those projects should basically finance my upcoming expeditions.
Nice.
As they did in the past.
Nice. Right on. All right, Darren, you got anything else?
No, I'd just like to say thanks again, Randall, for coming to Grimerica. we'll have to keep in touch, and we can you can keep us up to date with any new details, and before, let us know before the webinar is coming up. Give us the dates, and we can push it as far as we can reach.
Absolutely.
Yeah.
Yep.
Right
Yeah,
on.
it's a lot of fun hanging out with you guys, both over the internet and in person.
Yeah, right on. Thanks.
Okay, Randall, enjoy the rest of your weekend.